You have to bounce from something, to another. The race has to bounce. So I
we're
mean,
not
if
assuming.
you end up with a triangular shape, it's your problem. It's not mine.
We're trying to. Okay, you have a beam, right, and it has a certain size. Do we agree on that? Do we also agree that
Yeah,
the
I
further away
agree.
we get from the laser, the diameter of this beam is going to grow? Yeah. Make sense? The diameter of the dot that we are seeing is going to grow.
Yeah.
Okay, so the diameter of the beam is what we're going to call, that's what I call 2x. That means that the radius of the beam is just x. Of the beam out to the edge. That distance is going to be half the angle of the spread, 0.04 millirads, to get the radius, as opposed to the diameter. And once I calculate that, I can multiply by 2 to get the actual spread.
If you're not spreading, is it by default double the angle?
What I'm doing is I'm just making. We can do this. We can calculate it without doing all this halving. This is just basically an easier way to do it. If we have to do it the other way, we're going to have to use the law of sines. You can use that as well if you want. It's just a question of which triangle calculator you're using. If you prefer, we can just go into a triangle calculator and just do it. But then we don't see that the math works. I feel like we should actually do it ourselves, right?
That's Nike said.
You can go into a site called coastsyncalc.com. I'll just give you a link, and you can just type everything in there if you want.
No, seriously though, I'm just messing with you, But is this like a V-ray calculation, Because I find it amusing, interesting.
Just a calculation of how
listening. I'll read you from the from a book called 13.8. The Quest to Find the True Age of the Universe by John Gribben.
We're talking about something else now,
I'll start off with
the Big Bang, I guess. Yeah.
It starts off introduction. The most important fact. Now get this. This is the fact, right? And the origin of everything we see about us, stars, planets, galaxies, people, can be traced back to a definite moment in time, 13.8 billion years ago. Now that's a fact.
April the 1st.
Is a heretic. Fact, okay? Theory.
Which book are you reading from here?
Let's not argue then.
13.8, The Quest to Find the True Age of the Universe and the Theory of Everything by John Gribben.
Okay, so what's your point?
It's a fact. It's a fact. The universe is 13.8 years ago old.
Right, billion
years old is a fact.
According to him, sure.
Because John said so. Or,
this is what you guys are selling to the public. This is what you're selling.
What distance are you guys solving for the spread? What's the distance to the object? The 41 or the 21?
This is what's peddled out to the public.
14?
This sort of fact.
You said?
Lies.
Robert?
I don't really care what John Gribben writes. We're going to calculate this stuff now instead.
Yeah, what's the distance to the object that you're using for the spread? Calculate the spread.
40.14 kilometers.
Okay, 40.14. Okay, cool. Gotcha. Thank you.
So, are we good with the spread?
I'm still trying to figure it out, dude. Give me like 5 minutes, all right? Give me 5 minutes. I'll be back.
I'm gonna run the math myself right now.
I'm trying to figure this out, dude, because I don't know how the I think it's kind of strange that you're trying to cut the millirad to 4 and then add it later. I don't know. I think that's kind of just messing it up for me.
He's just dividing the triangle in half, Jose. So he's solving for the like a 90-degree triangle to make it easy. So he doesn't have to use the law of sines and cosines.
Exactly. I can use the law of sines instead if you want.
Right.
It'll be the same result. I'm being lazy. But anyway, while we're waiting, 5 minutes, I'm happy to talk about something else.
Excellent. Can we talk about space?
Oh.
Is that okay? Can we talk about space?
Sure, as long as we get back to this FE core thing.
Yeah.
I'm fine.
5 minutes, and you have a quick chat about space, yeah?
Sounds good.
Excellent stuff. So you're really into space. Obviously, it's your job. It's what you do. You look at lights and sky and tell us what they are. That's brilliant. You've obviously been talking, as you said, you've been talking to quite a lot of flat earthers over the last however long. So you've obviously come up with the thermodynamic problem, air pressure and vacuum, yes?
I've heard that before, yes.
Yeah, so we are breathing air pressure said to reside within a vacuum with a vastly lower pressure system. So thermodynamic, when we're talking about energy transfer, especially air pressure, the air pressure would fill the void unless acted upon by a physical container. Where we have air pressure, we need a container. Unless you start asserting unless you start asserting two gravities, both of which you have no scientific evidence for. So what is your retort to this issue?
We are not in a pressurized system because the pressure drops when we go up.
That's a pressure gradient, though, isn't it? Still a pressure gradient, still has press in it, still needs to press.
Pressure gradient goes to zero.
It's a pressure gradient. Sorry?
Pressure gradient goes to 0, and then you're in a vacuum. There's no problem.
No. Nothing's pressure. Yeah, we have air pressure. It should fill the void. That's what it would do. Exactly what it would do. Just because we have a pressure gradient doesn't negate the air pressure needs to press upon something.
Well,
does
if that were the case, then there should not be different air pressures at different heights. So you're missing something.
Why not? We have different gases. We have different gases. We have energy coming into the system. We have a dynamic pressure environment, a dynamic weather environment, a dynamic environment all told. We have different heat sources around the world, all different types of things. Yes, we have a pressure gradient, but the necessary antecedent for a pressure gradient is something to press upon. So the air is not going to the air is not going to contain itself unless you would like to demonstrate to me gas pressure without a container.
So you claimed that the reason that there is different pressures at different heights is because there are different gases, right?
Different gases, different pressure. Yeah, loads of different things. So loads of different things.
The problem is that's not true. It's the same atmospheric composition up a mountain that there is down here.
Yeah, and you go higher up into the atmosphere and you get different gases. And I'm not saying it is not a pressure gradient. Of course there is, but that's got factors to do with moisture in the air and temperature. And obviously it gets colder the further that you go up. That's why we have snow on the top of mountains. My point is this, regardless whether it's a pressure or pressure gradient, that pressure still needs something to press upon. It's not just going to shade out and eventually reach 0 and turn into a vacuum. The gas would fill the space.
That's a claim, and you're wrong.
It is. You're just going to say that I'm wrong. You are literally going to fly in the face of the second law of thermodynamics and say that I'm wrong. I'm quite surprised you haven't turned around and said gravity yet.
Of course it's caused by gravity, but the fact is that this is
which one? Which gravity is it caused by?
Gravity that exists.
Which gravity is it caused by?
There is only one gravity, my friend.
And which gravity is this?
Robert, did you say that there is a place in space with 0 pressure?
I said there's a vacuum. I'm not saying there's a perfect vacuum.
You say there's somewhere in space that has 0 pressure?
0, but incredibly close to 0.
You say there was somewhere in space with 0 pressure?
No, there's no space with 0 pressure, but you get something which is so close to 0 that it doesn't matter. Anyway.
But you said that. You said there was a minute ago. I heard you.
Fine, but that's an approximation.
You said it goes up to 0 pressure.
That was an approximation because there's practically 0 pressure, but thank you for correcting me. Anyway, yes, it is gravity.
No.
Do you want which gravity?
Tap, Chad. I'm going to do it again in a minute as well.
Hey, Robert.
Thinking.
I'm sorry.
Please, can I finish this conversation, guys? Please.
Oh, for sure. I'm sorry. I didn't mean.
No problem. Because I've just been told there's only one gravity. I want to know which one that is.
Ooh.
We're talking about. I'm assuming you're referring to the Newtonian model of gravity versus the Einsteinian model. Is that what you're doing?
Don't know. There's only one. So which one are you talking about?
I'm talking about the effect that we see. We see that there is a force. We can take it as a force. You can describe it as a space-time curvature if you want. It gives the exact same results. But let's just keep it simple and describe it as a force. And we do see there is a force.
They're mutually exclusive. One's in 3D space, the other one's in 4D space. Mutually exclusive.
It gives completely
yeah, because things fall down. So yeah, we have the exact same result. Doesn't matter which idea you come up with. Yeah, things fall down.
And also air falls down. Therefore, there's a pressure gradient.
Yeah, we have a pressure gradient. Yeah, it should disperse into the vacuum. My question is this: what scientific evidence do you have for, this gravity that you're asserting? What's your scientific evidence for it? Because you need it to negate a natural law.
And things fall down with an accelerated speed. That's why.
Yes, hold on. Hold tight. I said scientific evidence, not a mathematical calculation of things going down. No one's disagreeing with you that things fall at a certain rate. I want your scientific experiment proving your gravity. Very simple. I don't want your maths.
That you need a force to create an acceleration. Is that
no. I want your scientific experiment. I mean, when we started talking an hour and a half ago, 2 hours ago, did have to tell you the scientific method and tell you how you weren't doing it. So now I would like your scientific experiment that proves gravity, not that things fall down a road.
I have one experiment.
We have
one scientific experiment hypothesis.
So
first we need to. Okay, please go ahead.
Okay, thank you. So Neptune. Neptune, the planet. Yeah.
What?
Neptune, the planet. You know what? Neptune. And you?
Neptune.
Yeah.
Why the fuck are we talking about Neptune now?
Coming in throwing googlies about Neptune. Get out of it.
Go ahead.
So let's get back to the
scientific experiment that proves gravity. I don't want maths.
Okay.
I want your scientific experiment that proves.
Okay. So do you accept?
You know you haven't got one, don't you?
I know I've got one. I just don't know that you're going to listen to it. That's a different question. Do you accept measurement of acceleration as a measurement of force? Yes or no?
Sorry, I've got something in my mouth. Don't mean to be rude. I don't want to talk with my mouth full.
That's fine.
I agree that you can calculate how fast things will fall, depending on their relative, density falling through a medium, for example. So if I was to drop a ball through the air couldn't support it, so the ball would drop. But if I was to let go of a helium balloon, helium obviously being lighter than air, it would rise. So yeah, I would agree. You can use a little bit of math to calculate how fast something is going to fall through a relative medium. But I'm not asking for your math. I want your scientific experiment that proves cause of an effect.
Let's try again. I didn't mention calculations at all. I asked you, do you accept a measurement of acceleration as a measurement?
And I expanded on that. So
we accept a measurement of acceleration is a cause of force.
Yeah, exactly.
Force. Do you accept the measurement of acceleration? Do you accept that we can measure acceleration?
Measure acceleration. What are you talking about?
Do you accept that acceleration of an object can be measured?
We can measure things.
So you can measure acceleration, right? We're not calculating anything.
Yeah, you can measure acceleration, yeah? What?
Yeah.
An effect on a cause.
Acceleration is caused by a force.
Okay, can you prove that force?
Just asking
what's causing the universe to accelerate outwards? What's the force?
Let's stick to one thing at a time. Do you accept that a force?
No, you said there's is the universe. Yeah. Well, I'm giving you an example of something that doesn't require a force to accelerate.
Maybe you could give us an example of what is relative to. So dropping something relative to a non-stationary moving plane, right? Or two cars are going at 60 kilometers an hour, and then one car goes 70 kilometers an hour and passes them. Like, we could measure that. But so what would gravity be measured in relation to what? Like, maybe
we're getting to gravity, but we just need to make sure that we actually accept these measurements.
Here's the thing. We accept that things accelerate at 9.8 meters per second squared. What's the cause of the acceleration is what we're debating.
That's a great question. But you accept that there's a force. You accept there's a force.
Oh, we do not accept there's a force.
My God.
You accept acceleration, though.
Yeah, but we don't know the cause.
Lovely.
Einstein said it wasn't a force. Now shut up.
Yeah.
By the way, your math is pretty shoddy, bro. I ran the math. It's only 3 meters. Total divergence is 3.15 meters at 40.14 kilometers. Your trig is way off. And I snapped a picture of it and posted in voice text for everyone, so you can double check my math yourself. I mean,
I think you used 0.04 degrees and not rads. I think you made a
no, I converted. No, buddy, I converted the rads to degrees, man. What are you talking about? I used 0.04 millirads to degrees, okay, and then use the tan of that, the tan of x over 40.14. Go ahead, just check my math yourself, please. I drew the triangle. Let me know what I did wrong.
Just check it again. Hold on.
Well, what I think could happen with maths is, considering it's a language and there's different ways for people to learn said language and then being taught said language, it's like saying I write out do not and you write don't with an apostrophe. I mean, that's really what it sounds like is happening.
Nope, that's not what's going on. So what do you get the tan of the angle to? Just the tan of that half angle.
I got you. Okay, the half angle. How much is the half angle, right? All right, so I'm going to just go millirad right now, mrad to degrees.
I think you're right. Hold on.
Yeah, it's 0.00225, roughly, an estimation. That's the half angle.
Right? I have you.
Did you?
It seems that you have to type degrees to make it calculate in degrees. I do apologize.
Did you? Can you see my work? I took a picture of my work and I posted in voice text for everyone. Can you see it?
Yeah, and you're right and I'm wrong. I calculated using Google calculators and I simply used, you have to type something in. I apologize, you're right.
No problem. Thank you, sir. It's not a right or wrong. I'm just saying, clarifying for everybody, at 40 kilometers, the total beam divergence from a point source, yes, I assume the source is a point, is 3.15 meters.
Accept this. Cool.
All right. Cool. Carry on.
Are we talking about the divergence thing again? Or are we talking about the force?
Wait, I think Dem had a point.
Yes, you can go and talk about the divergence beam because you are not going to give me a scientific experiment, are you?
Okay. You're not going to listen to it, so that's probably.
No, he needed 5 minutes. Don't dismiss me, my friend. I'm going to let you carry on and talk to these other people, but you know, intellectually, honestly, that there are no scientific experiments that prove either of your gravity ideas unless you start asserting math. Now, you know that.
I don't, because we can see, objects directly.
This isn't a scientific experiment, though, is it? I mean, if it was, it would be an adherence to the scientific method, wouldn't it? There would be a naturally observed phenomena, wouldn't there? There would be a hypothesis where you presume your cause, wouldn't there? You could then go and do the experiment, wouldn't you? And then you could validate it, couldn't you? Yes, so you don't have a scientific experiment, do you? No, then exposed, I don't.
Well, you can deny it all you want. It's fine. It's just I do. It's quite simple.
Yeah, no, it's fine. But the thing is that you don't have a scientific experiment that proves gravity. So therefore, you can't overcome the second law of thermodynamics with something you can't prove. You just assert it to be true without actually any evidence behind you. Just a little bit of maths can things fall down. That's my point. You can carry on talking about your laser test now. Now somebody's corrected you on your math.
Okay, so let's go back to the laser test.
All right. Jose, where you at, man? You said you needed 5 minutes granted, sir. Math solved. All you, bro.
Okay, so it was.
I'm going to do a 5-minute warning here too. I'm sorry, I really have to go. I'm not trying to run away.
Yeah, that's fine.
I can come back and talk about all the rest of it later, but I do have a life as well. So let's just do the last 5 minutes on this divergence.
Okay.
So we found out
that
we have a
divergence is about
3.25 meter.
Yeah, it was about
at the end of this.
spread.
Okay.
I said 2. I was close.
If we assume a point source.
Right.
Agreed?
So now where are we at? How does that work on the oblate spheroid model? Even if it's the WGS84 model, which predicts that the shortest target you can hit on that oblate spheroid has to be 90 meters. And if we gave you the 7.6 arc standard refraction, which is being generous to you, it shaves it down to 85 meters. How are we hitting a 1.5 meter target from that distance with the beam divergence being 3 meters?
Oh, am I back again? I hear nothing.
I could hear you. You're good.
All right. So, as I say, did you hear my 5-minute warning that I have to run? And I'll come back if you need to go to me. Okay, cool. So we are agreeing that we have a 3.5 meter divergence.
Yep. 3.15. So just call it 3 meters.
Okay, cool. And if we look at the measurement, it says that the blue laser points were placed at a height of 2.92 meters. Yeah.
Yes.
Okay, great. That causes a problem because we can now calculate at what distance the laser beam will strike the surface of the water. The 40.14 kilometers, yeah? Because the divergence is more than 2.92.
Can you go more in depth on that? How would that be a problem exactly?
Because then we have reflection off the water.
Yeah, but where would the reflection be? Think about that. This is 41 kilometers I'm speaking of.
It'll go down on the surface of the water, then it'll bounce off it at the same angle. And that means we can measure it direction as we expected it to be. There's one issue that I'm just pointing out would be a problem here.
Again, that's the full beam width at 40 kilometers. The full beam width would be 3 meters. Okay. All right. Assuming a point source. All right. Cool. And we are roughly 3 meters above the ground. So that's centered. You got to divide that 3 by 2. So you'll be only 1.5 meters from the center of the observer height to the water. Thus, you would still, what's the height of the object? 2 meters above water, or what was that?
2.92.
I don't know. I don't have the paper in front of me. But you assume the full 3 meters. You got to take the half of it, bro.
Of course.
Right? Because you're dealing with a conical beam. Half triangle again. Yeah? So it'd be only 1.5 meters.
I get that. There would be no issue if there was no atmosphere. But now we have atmosphere, which means diffusion, which means refraction, which means all kinds of things. We're getting pretty damn close.
Yep. Yes, exactly. We're getting close to touching the water, but we did not. We did not.
You would not touch the water if there were no atmosphere. But you have diffraction in the atmosphere.
Here's the thing. We've already assumed the 7.6R, which it's not the 7.6R refraction you're going to invoke. Give me what refraction model you want then. Because even if we use your 7.6R, it goes down to 85 meters.
I'm going to invoke scattering.
And now the refraction you're talking about, there's obviously meteorological data. You can take a look at that. It's in the PDF. To temperature, pressure, tide levels, everything's in there.
But I'm
so yeah, like all that is taken into account. It's not like it's not taken into account. And I'm even giving you the generous Mick West curve calculator, the Metabunk one, the 7.6R. So like, you saying refraction isn't changing the results?
I'm asking you.
Jose, let's give him this. What if the beam actually touched the water, and now where is it shooting? Around the curve or up into space?
It would bounce off.
If the beam hit the water, it wouldn't so much reflect to the target. It'd be impossible, in my opinion, especially on a globe.
Let's assume the water is a mirror. We'll give him another one, Jose. Water is a mirror. It's going to reflect. Where's it going to reflect to, bro? Around the curve or up into space?
Okay, listen, that is the whole problem. The water is definitely not a mirror. It is not a specular highlight you're going to get.
You said it's going to reflect. That's why I gave you the mirror, man. Of course, it's not going to reflect like that off the water.
It's going to reflect off all the angles we can get. It's going to reflect off all the angles we can get, which means some of the light is going to be thrown downwards. Space, and it's going to be thrown downwards. That's how a diffuse reflection works. So we're going to easily get. But have we taken diffraction? No, sorry. Have we taken scattering into account? That's what I'm asking. You're saying that they've taken refraction into account. That's great. Have they taken scattering into account? Atmospheric scattering, Rayleigh scattering.
I do not have the PDF in front of me. Actually, I never took a look at the PDF. I just know my math. Know my trig works. Trig is solid.
I just need to know how to use the calculator I was using. That's quite embarrassing. But
yeah, that's why I go old school, man. Paper and pen.
But I'm glad that you checked it, because that's the whole point. But we have a measurement 6. We have stuff like the vacuum wavelength. We have the air temperature, humidity, wavelength, refractive index, all that kind of stuff. But we don't seem to have any scattering taken into account. So we need to look at the Rayleigh scattering of this beam.
Okay, but before actually look at the scattering, you have to run the math on this. At 40 kilometers, let's just call it 40 flat, 40 kilometers, what distance below the curve is this object supposed to be?
I checked it while you were gone. I can't remember
how many meters.
I can't remember. It's definitely below the horizon, clearly.
How many meters below the horizon? Of course, it's below the horizon. How many meters?
Let me just check again. I can't remember. It was very clearly below the horizon.
For that, you just use a calculator off a meta bunker.
Yeah, I'm going to do that. Yeah, I'm not going to do the math there. I'll use the math. Okay, let's say 40 flat, as you said.
Yeah, let's call it 40.
And we have 3 meters in height, I guess. Then we have something with refracted hidden, something like 74 meters.
Awesome. 74 meters.
Yeah.
And the total beam width is 3 meters at that distance. Okay, total beam width is 3 meters in a conical shape. Okay, above the surface of the water. As we said, we're getting close to touching the water, but we did not touch it actually. All right.
Well,
see what I just posted? Hold on, guys. I just posted this for the document. It's 90 meters. What we're talking about.
Well, according to that document, at the end of the document, there's technical data you can look at with details of what
That's without refraction.
Is.
Oh, thank you. I'll check that later. But anyway, you're wrong if you say that it doesn't touch the water. It definitely touches the water. It only does not touch the water if there is no atmosphere.
That's awesome. Does it bend around the curve?
Definitely.
How does it touch the water?
Because you have scattering and you have refraction. It's definitely going to scatter.
Yeah. Are you going to claim that the scattering that's water is the light that's being seen from 41 kilometers? Is that going to be your next claim now?
You need to look at the picture because the smoking gun here is the target for observation location. You need to look at that.
No denying what you're saying, but it sounds like it's not a good excuse to claim that that's the beam that they're seeing. They're seeing a direct line of sight.
So it's scattered downwards around the curve to hit the object 70 meters. I'll give you your 74 meters. Okay. So it's scattered 74 meters downwards.
Of course. It's bouncing off the edge of the water and it's being scattered in all directions. But if you look at the
scientific,
so we're going to lose intensity.
Evidence that light. So here's the thing, are you claiming it's refracting or scattering? What's the difference between scattering? I'm not that familiar with scattering. Like, you mean the light? How it bounces around? Do you mean that type of scattering?
Losses to the atmosphere.
Robert, you don't
really to the molecules or whatnot.
I answer it, or are you just going to yell at me? The scattering happens when you have polarly charged molecules in the atmosphere, and you have Rayleigh scattering, which basically means that it's absorbed and re-emitted, and it gets scattered out in different directions, and it's wavelength dependent, strongly wavelength dependent. And if you look at the picture, which is called target,
isn't that scattering that diffuse light source a lot, like big time diffuse it?
Yeah, all light sources get diffused by this.
Exactly. So what we're seeing here is a direct line of sight where the light doesn't seem to be nothing of diffuse. If anything, it might be spread out to 3 to 4 meters.
I don't see any.
And for you to claim that the scattering is I don't see how the scattering is helping you. To be honest, scattering is probably taking place, but the light source that is being seen, it's not being diffused.
Okay. Let's just make sure that there is no picture that I have found in this document which shows a direct line of sight. What we see is the target for observation location. Are you seeing that picture? It's on the measurement 6. It's from 2:19 a.m. It's all that stuff. These temperature and humidity things. It's like 2 pages after all the data we've been working on. If you look at that light point, a direct line of sight laser point, it is so unfocused and scattered. It is clearly diverging upwards.
Is that, sorry, Robert, is that the picture under technical data with a 3 meter surface?
So wait. So wait,
at the end of the document under technical data.
Is pretty much in the middle of the.
So this is the part that I'm going to
the end of the document. Scattering or data. 3 meter thing with a light shining on it. Light that's next to it.
So here's the thing I'm still confused about. Like this, let's just say it's scattering, right?
I misled you. Sorry about that.
So this scattering, the part that I don't understand is like now you're claiming that not only is it scattering, but it's going around the bulge, this 90-meter bulge that should be in between.
What I'm saying is
right.
The light.
Like you have to think about it. It's like not only is it going to scatter, the light has to go around a bulge now that is 90 meters. That's what you have to believe if that's what you're claiming.
What happens?
The light is not only. So the light is not only bending up again, but it has to come back down, right, for it to be observed. What kind of refraction is that?
Well, the magic refraction, Jose, where it just it diverges and yeah, exactly, magic.
That sounded like a lot of mental gymnastics just to make it work, Robert.
Well, can I explain, or are you just going to yell at me?
Oh, no, go ahead, please, man.
Is this the new standard globe argument where people complain about being yelled at because it's kind of boring?
I'm not complaining. I'm just saying, can I talk? Because I'm
not yelling. I'm sorry if my voice
yelled at you, dude.
I'm triggered.
Hold on a second. I understand that. Earlier we had a guy complaining about being yelled at.
You guys are dumb ass.
No, Robert, please, man, get to your point.
Can I just say this though? Yeah, we're not really into concern trolling.
Sorry, I don't associate with niggers.
Right. Cool. So yeah, just get on with the science. No one cares if you feel like you're being yelled at.
I'm not giving you the option to actually answer any of the questions. I'm getting lots of questions thrown at me, and I'm just not getting the airtime to talk. That's all. I'm not pissed off with anime at all.
You understand our point, though.
Yeah, I completely see that you find that strange. So I'm trying to explain what's going on. You have this 90-meter bulge.
Yes, just crack on.
This 90-meter bulge, right? And then you shine a divergent light across it. Some of that light is going to hit the surface of the water, right?
We do not know that. If we are sufficient height above the water, we shall not hit it. And if the height of the starting height was roughly 3 meters above the surface of the water, and at 40 kilometers, the beam divergence, which we already know, which is 0.08 milliradians, right? At that distance, 40 kilometers, we should just start to touch the water. Okay?
There was no atmosphere.
What I don't get, I'll give you it refracted, it bounced, and it got absorbed, all that. How did it recollimate and hit the object?
It does not recollimate. That is the whole point. If you look at the photo, if you look at the target observation, it's not collimated at all. It is a huge smudge. It is a huge smudge. Have you looked at the picture? It is nothing like a light beam.
Send me the picture. Or just post
2 pages after. Wait, hold on. I'll just click it. Just get it.
Yeah, just give me a snapshot. Just get it over with.
So
I really have to run.
Keep going back to between these two aspects here, refraction and scattering. Okay, now refraction. Can you give me evidence that light refracts down at night?
Sure.
Especially if you looked at the weather conditions for this type of measurement right here. They took the meteorological data and they showed that there was negligible refraction. Like the way they could test this out too is by hitting those points. If there was any type of refraction, there'd be a big. I'm not done. There'd be a big deviance from the 1 meter target that was 6 kilometers, 12 kilometers. That's why they did a horizontal pan and managed to see it in all 3 points. If the refraction was there that you're claiming, it would not be visible from all 3 points. It'd be different. So, like, really what you're doing is mental gymnastics right now. And I get it. Like, you don't want the FE core to be you need to find something wrong with it. But the problem is that it's not, it can't be explained with the globe. It really can't. Because now it's not just 1 meter, 41 kilometer meter mark. It's 3 points that are seeing the same observation with the horizontal pan. So now what type of refraction is it going to not happen in the 2 first points, but now you're claiming it's happening on the 41 kilometer mark? Which I do agree. There'd probably be a little bit more refraction because it's a longer distance.
I'm saying scattering. Okay, have you looked at the picture I sent you?
Yes, I have, sir.
Yeah,
yes, I have.
You see that is not a color.
My question to you, that divergent beam that refracted and it got absorbed and all that, sure. Okay, how did it fly around the 90-meter bulge? Did it follow the curvature of the Earth because of the magnetic field or what? I would like to know your answer.
There's absolutely no magnetic field. There's nothing forcing it around the globe, obviously. But it means that every time it strikes the surface of the water, it's going to have a diffuse reflection. It's not going to be a mirror. It's going to be spread in all directions.
I am 100% with you.
What is it reflecting off of?
The light is going to be bounced off
the surface of the water.
So it's bouncing off the front of the hump or the back of the hump.
Some of it's going to go back.
So the angle of incidence equals the angle of reflection, right? So if it hits the front of the hump, it's going to reflect into space. If it hits the other side of the hump, I don't know how that happens either because it just did a U-turn.
Impossible. It's impossible.
And how you're getting this idea.
You would never be able to hit your target.
Seem to think that when light strikes
water, obviously the beam is blurry because it's 25 miles. It's quite a long ways away. That's far, right? So of course it's going to be blurry and it's not going to be crystal clear. That's not feasible.
Can we give him 60 seconds to just respond? Because he has to leave. Yes, so I think we all understand that we want to keep him here, right? But he has a life, so let's just give his 2-minute closing or whatever, and then let's just let him go because we're gonna have to agree to disagree here, guys.
We're never gonna convince each other, and I think actually it's kind of cool. Can I just say?
I want to know your math. I want to know your science behind this. It's not about you're gonna make me agree with you. It just show me how you can do that. Like it's gonna reflect off into space, right? Just show me how. It's gonna come back around. Okay. I assume that the water is a mirror. I gave you that. Water is a mirror at point of tangency. No problem, bro. Now what?
All right, stop now. Let me talk. I need to leave, okay?
All you, sir.
The first thing I like to say is I feel like the FE core measurements are actually really cool. I think it's important that it gets done. I'm not trying to fight you on this one, and we're never going to agree on what they show us, but I think it's important that you're actually doing actual science. So great for that. What I'm trying to say is
science is an observation. Jesus.
Okay, just let him finish, please.
When light strikes the surface of water, it is not like a mirror. You can't see a reflection of the sun in the ocean like that. You see a long, stretched out thing because that's how the reflection on water works. It throws light in all different kinds of directions. It does not work like a mirror. So when you have light touching the surface of the water, the light beams are going to go in all kinds of different directions because of the diffuse reflection that's going on. Some of that's going to follow the edge of the curve of the Earth. Some of it's going to go into space. We're only going to see the stuff that follows the curve.
How is it going to follow the curve, bro? That's what I'm saying. By me, assuming that I gave you water as a mirror, which is impossible, I'm helping you out. Now you have to explain to me how is it going to follow the curve. I gave you a way out with the magnetic field, but show me your way out. How are you going to do this? How is the light following the curve, like you just said?
Well, can I say one thing? The refraction would have to be 100 times larger than standard refraction. 100 times. Okay, this would only work on an Earth that's a 65,000-mile radius. You understand that?
Not talking about refraction. Okay, so yet again, when light hits water, it gets scattered in all different kinds of directions. Some of it goes up, some of it goes way up, some of it goes horizontally.
Cool.
Great. So that means when you hit the surface of the water, some of that light is going to go horizontally.
Okay.
And the atmosphere, and then hit the water again. And a little tiny bit of it is going to go pretty far around the curve.
How is it going to go around the curve?
Skipping like a rock around the curve of the Earth. Skipping like a rock. The light's just going point, 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 and then going into the, is that what you're saying? I mean, I don't understand.
That a tiny little piece of it, yes.
It is. It is.
Really?
That's an interesting light, bro. That's very interesting light.
If you think I'm saying that the entire light is doing that, then you're not listening to what I'm saying. I'm saying that.
Well, how much
you said? I heard what you said. You said a tiny bit of the light would skip like a stone across 25 miles. I think you're going to have to demonstrate that.
And would that be enough to illuminate the object with that same luminous intensity? Now we're speaking science, dude. Right? Now we're on the same playing field. With this scattered skipping stone of yours, would it illuminate the object with that same intensity? Now you're gonna have to do some math.
I don't know what the intensity is, so I can do that. But we can predict how much of the intensity that would be.
Let's go. Well, let's go. Whatever software you want to predict it with, I'll fire it up. How you want to do this?
But I'm going to have to go, as you know. As I said, I'm not trying to.
I know, man.
We can do it, but I have no idea what the target is. That in the document? How much intensity we get back? We know how much of the. Do we know how much of the laser when we get back?
If we start out, if we know the laser intensity that we're starting out with, we can work some stuff out, man.
No, I mean,
we need to get the sensor size, then the beam diameter, and then you take that cross section of the divergence at that point, and then take the, that little area that the sensor would be. Well, actually, the lens. Then you could figure out how many photons would fall onto the sensor. I mean, Jesus, do we really need to be that particular?
Get that part clearly, but do we have a measurement? Do they have measured how many photons they actually got? Because that's what we need to test my hypothesis, because that's what that is. What happened? If we don't have that data, we can't test it.
Your skipping stone hypothesis isn't real. Just, you know what I'm saying? It is not real. We gave you that for free, but it is not real. It's not observed.
You can deny it if you want. That's how how non-specular highlights work. That's how diffuse refraction works. That is how light bounces off something which isn't shiny.
Around the curvature, but if you have the mass in between, you're going to reflect behind the mass somehow. This bulge, you got this bulge of water in between you and the target. Now this is going to scatter around. How much? And what is the losses of scattering to distance?
I have no idea.
To the inverse square law or what?
Inverse square. It's going to be pretty intense. That's why we need to know how much.
Right. You're not going to get any light, man. It's just like, dude.
90 meters is like a 30-story building, right?
It's a big curvature. I agree with you.
It's just like a 30-story hill, man, like that you have to get around. You're saying you can be on the other side of the hill, and there's a light source on the other side of this 90-meter hill, and somehow you can see that light. I don't know that that's ever been observed ever in the history of mankind.
Well, agree, like some kilowatts, man, of power to illuminate something.
I mean, and isn't water disruptive of blue light?
Hold on, I'm just checking if this distance is even plausible. Where is the targets here? Anyway, as I say, I think it's a fun experiment. I think it's fun to look at. I would like to have known the target intensity. That would have been useful, but we don't have that. But it's cool. So with that, I'm going to have to run. I've been here for way longer than I thought it would be.
Thanks for stopping by, Robert.
Thanks for
Appreciate your time, man. Come back anytime you want to get schooled, bro.
I'll get the WMAP data for your next time you're on here, bro. I got you. Don't worry.
Yeah.
All right. Have a good day. All right.
Yourself, you too, bro.
Peace out, bro.
Peace.
DL came in at the end there. They're trying to measure how much of a laser light will deviate over 40 kilometers.
We only have one shot at this guy. Okay, a little left. Okay, now factor in the spin. No. God damn it, man. Okay, what direction are we? East, west, north, south, northeast? Factor in everything. We need to know exactly the direction, the spin of the Earth, and how to combat it, or else we're going to miss. There's no spin of the Earth. Take the shot, retard. But that would mean Neil deGrasse Tyson is wrong, and you miss every single shot when we do this. If we miss this shot, our location will be blown. We've been here for 4 days shitting in little cans. Tell me the spin of the Earth. Like, okay, down to the left 16 inches. No. They saw us. I missed a shot. I guess it was spinning a little faster than I thought. Oh. Globe, Earth, sniper. I can see the mirage. No, that's the target. Must be a mirage. Well, I've done the calculations. 8 inches per mile squared. I wouldn't be able to see him. It's a mirage. I'm not taking the shot. It's him! Like, every sniper just shoots people. That's a fucking mirage, or that means Neil deGrasse Tyson, the bike thief with the answers, is somehow misleading me. Globe, Earth, sniper. Okay, if you factor in the curve. This is clearly a mirage.
And ye shall know the truth, and the truth shall make you free.
Welcome back to Smarter Every Day. Now, a lot of the pictures you see from the International Space Station come from the cupola on the inside here, right? So the cupola is on node 3, is that correct?
Node 3.
Node 3. All right, so this is astronaut Don Pettit. You may know this guy. You've done all the, city tracking.
Yeah, I've done a lot of cities at night, and then the nighttime aurora and time-lapse sequences of Earth. Many of those that you see have been done in this module when I was at the helm of the camera.
He's the junk. Let me just say it that way. You're the junk when it comes to space photography, right? Can you say that? Say I'm the junk?
No, I can't say that because I get too embarrassed.
I'm going to meet you on the other side, okay? So, seriously, he's the junk. Like, all the really cool aurora stuff, Don's the guy that took it.
Now this is a cover.
Okay.
So we call it a shutter, and it protects the windows from micrometeorites.
Okay.
The shutters are closed, the windows are protected, and also thermally insulates the windows from the radiation environment of space.
So can you shut these things from the outside?
No, you can open and close it from the inside.
Oh, okay, wait. On the inside, you're throwing a lever or something.
Yeah, you're turning a knob.
And it's
open. Yeah.
On the outside.
On the outside.
How do you do that and maintain a pressure seal between them?
O-ring type seals.
No, you don't.
With a rotating shaft. All our hatch seals are O-ring type seals.
Yeah, but how? My brain's
up here. Let's go inside. We can see it.
Okay.
Watch your head. All right. Oh. Oops, thunk. So you have a whole series of O-rings in here, and a shaft that you rotate.
So, I mean, like on the space station, how many of these would you have?
7, because we have 7 windows.
What happens if you get a leak on that?
Then you have a leak.
You just have a leak.
And what you would do is
lose air.
Yeah, you would probably seal the whole cupola off. And then there's probably a plan, I don't know off the top of my head, but there's probably a plan for replacing the mechanism. It might require a spacewalk.
So my question is, how can you operate a lid on the outside of the space station by manipulating something mechanical on the inside of the space station without losing air pressure?
It's called real good engineering. It's called real good engineering.
Look at this. Somebody come and look at this. Look at this.
What happens if you get a leak on that?
Then you have a leak.
You just have a leak.
Okay, one more.
Then you have a leak.
You just have a leak.
And what you would do is
lose air.
Yeah, you would probably seal the whole cupola off. And then there's probably a plan, I don't know off the top of my head, but there's probably a plan for replacing the mechanism. It might require a spacewalk.
So So here we have a astronaut who has flown in space 3 times, but yet he doesn't know the procedure. He doesn't know the plan off the top of his head. If there was a leak on the ISS that he's traveled on 3 times, he doesn't know the procedure. Come on.
And then there's probably a plan, I don't know off the top of my head, but there's probably a plan for replacing the mechanism.
The reason he don't know the plan is because it's all fake. He was caught by surprise with the question. Thanks for watching, and God bless.
let me ask you a question, Paggis. Let me ask you a question. Let's say you got home and I don't know, your wife is banging the next door neighbour.
Yeah.
Do you think it would be sufficient if your wife said, "Oh, I've got a model that explains how I didn't cheat on you"?
So technically,
no. Yes or no?
Most likely.
Why is it whenever I ask Lopez yes or no questions, I never get a yes or no answer?
Because the world isn't that simple.
He's about to explain how technically his wife could come up with a model that may be possible, and he'd have to consider it.
It could. One possibility.
Either yes or no.
But it isn't a yes or no answer.
Are you serious? You're saying that your wife can construct a model to explain how she didn't cheat on you after she banged the next door neighbour?
Yes.
This is the level of sophistry we're dealing with.
So, let me tell you this. My wife, let's say...
seriously, you're going to justify this?
My wife went on Amazon and she found this amazing new thing, which a sex robot.
This is the ultimate cuckery, my friend.
You're not, but you guys are not letting him finish. I'll finish for him though. Because
he's talking about sex robots.
Hold on. But here's the conclusion of his argument. The next door neighbor has been proven to be a sex robot and is not a human being that is made. Because no, that's not our next door neighbor. That's a sex robot that lives next door.
Clearly, if your wife is banging the next door neighbour, she objectively cheated on you. The end. There's no model that can explain that away. Can't be done.
I think his wife is banging the next door neighbor right now.
Probably. She's probably sick of his obfuscation. She's like, Maggie, so are you going to have sex with me tonight or not? And he's like, well, technically I could, maybe, possibly, maybe I could build a model. And then she's like, fuck it, I'm going to just do it. Can you construct a model to explain away the fact that your wife banged the next door neighbour?
Yes.
Target quickly. Tell us what you imagine that model might be.
So one possible model that it might be is that she went onto Amazon and there was one dude who had invented this new sex robot who conveniently looked like the next door neighbor. It was like an exact replica. But then she buys it, she gets it, and she's having sex with the sex robot. Then I enter the door. Then I enter the room. And I see she's banging something which resembles and is in every way looking exactly like it. So,
I mean, this is what they call in America the good old college try, right?
So then look, but when I am looking at the thing, then I see, she's banging something. It couldn't be the sex robot, but it could also be the next door neighbor who just walked over and is banging her. And they have no way. It's just impressive. Like when I enter the room, both possibilities are true. But as you said, which one is more likely? Yes, more likely that my wife banging next door neighbor, but there's still a small, very, very small possibility that it was the sex robot. But then I go over and I look at if the next door neighbor is in his house, and then I see, oh no, he's not at home. Oh, yes, this model is false. Then I have proven that model was false.
You enter that room, and what you see is your neighbor banging your wife, and you're like, holy smokes, it's my neighbor banging my wife. And then that moment goes through your mind when you're like, wait a minute, there might be an explanation for this. And you start thinking about Amazon, and you start going through the price range, you start thinking, how much money does my wife have? Is that even possible? But for that initial view, you'd be thinking, well, I'm going to be going with what I see. And what I see is that my neighbor is banging my wife. So that would be the logical assumption at that point, wouldn't it?
No, what?
Occam's razor. It looks like your neighbor. Whether or not you think it's some high-tech sex doll from Japan, it looks like your neighbor. So you're going to be thinking, oh, that's my neighbor. And then it might come into your head, but, oh wait, my wife, she's kind of loaded, she was really looking into those sex dolls, there's a small possibility. But the most logical assumption would be what you observe directly, which is your neighbor, right?
So, you can actually just verify whether it's a sex robot. You can just go up to it and go, oh, here's a battery. Or, oh no, it's a human.
So, what I am observing when I enter the room, if I start with that is not actually, I don't observe my neighbor. I observe something which looks like my neighbor. I observe something which looks like a flatter.
Something that it is a robot.
When you get
please, like, I can't convince the whole sentence.
Sorry, does that mean that when you wake up in the morning, you see whoever you live with in your house, you go, well, that's not actually them. It looks like them, but that could be something else entirely. Is that how you think?
Technically, yes.
Technically,
right. So, any talk of robots is stupid. No one ever mentioned robot in the example. I know that because I gave the example. There are no robots. Let's leave the robots to one side.
And
I'm sorry, man, but you sound like one of those people that, like, even if you walked into the room and neighbor was banging out your wife and you realized it wasn't a sex robot, you'd be like, well, the neighbor would be like, well, I'm sorry, man, I just fell. And somehow I just happened to wind up inside her. And you'd be like, oh, shit, that makes sense.
Yeah, we can make a model for that.
That makes sense to you. I'll have to get that step from the front door removed so it doesn't happen again.
So, yes, that is true.
Yes,
I agree with
true?
that statement.
Brother man, you need to go get your man card back. I don't know where it went.
This would have been much easier for you if you'd have just said at the start, you know what, yeah, if there was a dude banging my wife, I'd be pissed. This would have been over 20 minutes ago.
Yeah, this is in the area of progress fallacy.
But I'm trying to explain my point.
I think it, to be fair to Pagas, we should let him explain how the neighbor could be a sex doll when he gets the shit off.
Robots fucking exist, and we've experienced them.
There'll be another model, then we know the old model was wrong. But then you have a new model.
Wait, this I need to get for Pagas, right? You check the battery is not there, it is a human. Now you're saying there's potentially another model, could you tell me what that model would be?
So then that model could be like, oh yeah, he fell. He fell out. Well, actually, that's decided. So, yeah. But
It's not even Italian.
Pagas. So he fell.
He just repeated exactly what I said.
Pagas, I need you to be serious. Pagas, I need you to be serious. What is this other model? After you check the battery pack, it's not a battery pack. What's the model that could explain it?
I think your example, as you said, was very good with the folly. But then I look, what is most probable? What is the most likely? And I say, oh, it's very unlikely that they fell and that happened. So therefore, I choose to believe and I choose to use the model which is the most likely, which is that my wife banged the next door neighbor, and therefore I am divorced. I can't know that she's objectively having sex with the man next door.
Wait a minute.
We can, because we verified it.
No, but to verify it, there might be another explanation.
What the fuck are you talking about? We verified it. We checked that the battery pack isn't there. We checked that the penis is in the vagina. It happened. Yeah?
Yeah.
And now we're constructing a model to make the cheating go away.
So the fundamental way of what I am saying is that I can't technically give you an exact model, because the whole premise of this is that it is something which is beyond my understanding, beyond my knowledge. It could have been, like say, an otherworldly, all-powerful being, like a demon or something, which then altered the visions and my memory, as well as my wife's. And
you can't see evil demons, right? Okay.
And then we look. Oh, this monster. It's an explanation. It's actually likely, but it's very unlikely. It's extremely unlikely.
Yeah,
therefore we don't focus on
Go ahead. Pagus, you're embarrassing yourself now.
Hey, Pagus, I just have one question, okay? Very simple.
Go ahead, please.
Do you believe there is such a thing as objective reality?
No.
There you go, folks.
That's it. Nail on the head.
Yes, I believe there is, but I don't believe we can actually. We can't figure it out,
bro. Dude, are you objectively on Discord right now talking to us?
I can't actually know that. And as Roger, as you said,
then you're a psycho. Well, then you can't objectively know if I mute you. So I'm just going to do that.
Yeah, that's a good place to put a pause on that, I think.
Oh yeah.
And really.
It's in the debate text. He literally is just going off right there.
Oh, I gotta go see.
Space is defined as a region beyond the Kármán line, where the atmosphere is too weak to support the winged flight.
Hold on. Where did he post that?
He replied to my "You have no proof of space." Just up a bit. It's 31 after the hour. Literally replied.
Oh my god, dude. He must be a kid. Okay.
He said he wanted to debate, but I can't.
Space is defined as the region beyond the Kármán line where the atmosphere is too weak to support winged flight. That's wrong. The Kármán line is a political designation developed at the United Nations that's an arbitrary place where they're just going to say space exists. Scientifically, outer space is where the aerodynamic control surfaces no longer control the aircraft. So that could be any altitude, depending on how shitty of an airplane you make, right? So my car is in space because its aerodynamic control surfaces don't produce lift, and I can't steer based upon, the aerodynamics of the car. Right? It's touching the road. So technically, that's in space. So if I'm like falling out of an airplane, I'm in space no matter what altitude I'm at because my arms, my aerodynamic control surfaces won't control where I'm going and won't produce lift. It's just an arbitrary designation. It has no real definition, which is why we have a political definition where they just say 300 kilometers or whatever they say it is. That's space. Big setback here is the existence of gravity, I suppose. It's hard to explain how it's real when you respond that it's fake to everything I say. This is difficult for me, Okay, so hold on. I'm gonna search the word fake.
I know, right?
I'm gonna search the word fake.
I couldn't.
How many times fake?
Isn't it like up to 56,000 for the Earth is round?
Oh God, I've been looking like a week. 56,000. That would be crazy. The last time I looked, it was like at 37. That was only a week ago.
I know.
Halt chanting.
Yeah.
Now we're at like 32. Earth is round is at 32,000.
Okay, I was gonna say.
Thank God. Well, let's figure out Earth is a sphere. Oh, that's only 7,000.
Oh wow. Oh, okay.
7,000 mathematicians. There's a ball. That's like 6,000. It's a donut.
I just realized my mic was off. Hey!
There he is.
Hey, ho.
That's him. He's the one that talking about the.
Yep, I'm the guy.
Did you hear what I said about the definition of space?
No, he didn't. He wasn't in here. He just joined.
I just joined.
Okay, okay. So the Kármán line is a political designation from the UN. It's an arbitrary political designation where they said this altitude is above here is what we're going to call space. It's nothing to do with anything other than a bunch of people agreeing that that's an arbitrary thing. Okay, that's the Kármán line. Now, the scientific definition is when the aerodynamic control surfaces fail to produce lift, you're in space. But that applies to anything. So applies to you, me. Apparently, I'm in space right now because my aerodynamic control surfaces fail to produce lift. It's just the definition of space, right?
I mean,
there isn't enough.
Think about it like that, then yeah.
Listen, this is what I've looked up, and this is what it says. It's not my opinion; it's their opinion.
Fun way of looking at it. I'm going to say that to I'm going to say that to my friend now. Hey, you're in space.
Yeah, like if you flap your arms to fly to the moon, right? It's not going to happen because your aerodynamic control surfaces fail to produce lift. If the air was a lot thicker, right, you probably could. Like if it was like thick like water. Technically, I guess you'd be swimming to the moon, but you could produce lift if the fluid is viscous enough. So, when you say gravity is real, what do you mean by that?
Good night, boys.
Good night.
Good night, sir.
Night. What do you mean by gravity is real? The word, the description.
I'm sorry, my mic is. Why is it? Okay, hold on, wait. I'm gonna go into a different No, wait, it's working now. Okay, my mic doesn't cut out randomly. I'm sorry.
Yeah, it is a little.
Yeah.
I can only talk, but I cannot hear.
Whoa.
But have a good night, regardless.
All right.
Okay. And what?
Earth.
Good night. If you can't hear, why are we responding to that?
Well, I can hear it now, but I get muted all the time.
Yeah.
You
do understand why, though, right?
You get muted because you complain about, getting muted. If you would just stop talking after you're done saying something of any substance, like I do, then you won't get muted. Can you govern yourself, sir?
Yes, I will do my best. Can you teach me how?
No, we don't want to teach you how. You should learn how on your own.
And your parents should have taught you.
I thought this was a place to learn.
Oh, can we stop, Earth, please?
This is a place.
Is this a
This
place
is a
of
place for
knowledge?
higher learning, right? We're not here to teach you how to operate, like common
Your
sense.
fingers.
Right? It's uncommon sense, right? It's not common sense. If you don't have uncommon sense, then there's not much we could do for you. So instead of complaining about getting muted, just try to govern yourself, or at least don't complain about it when you do get governed from the outside, okay? Because it makes you sound like a whiny little bitch when you do that, okay?
Please don't swear.
Oh, very sorry.
What, the whiny, was it the whiny little bitch part?
Weren't you leaving?
Was it the whiny or the bitch part?
Hold on, wasn't this guy leaving? Let me help him. Disconnect.
I was going to do that. Fuck.
Beat you to it.
See, all he had to be is, all he had to say was, yes, sir, no problem.
I know exactly where he's going to come, so.
The other guy. So he's just getting in the way for the other guy. So, other guy, gravity. What do you mean by gravity's real? What does that mean?
Well, I meant like I kept hearing a lot of people in the lobby chat saying that gravity isn't real, and I don't even know like exactly what they meant by that, but I was just like,
okay,
yeah.
When we say gravity isn't real,
Huh?
Okay, so this is a description. So if you ask a Glober what is gravity, you're going to get a bunch of different objects falling. Some will say it's like things being pulled to the center of mass. Some people will say mass attracting mass. Some people will say it's the bending of space-time. So, like, you'll get all these different answers. So when we say it isn't real, we mean specifically one thing. The cause, right? The cause of falling objects. What the causal mechanism is not known and has never been proven by experiment. And can't be proven by experiment because there's no viable independent variable to prove the cause. Because when you drop two objects, they fall at the same rate. Okay? And that fact alone means you cannot figure out the cause. Because so the idea is mass attracts mass, and that's what's causing the gravitational attraction, right? That's why objects are falling, mass attracts mass.
Yeah.
Okay. So if I take a school bus and a bowling ball, they're a bit different masses, but they both fall at the same rate. So I manipulated a so-called independent variable, the thing that's supposed to be causing this attraction, but I didn't measure any change.
What do you mean?
That's how
change?
Because they both fell at the same rate. I didn't register a stronger gravitational attraction using different masses. Because the idea is a larger mass will have a stronger gravitational attraction, right? Between two objects. If I have objects with one, so say I have object A with a fixed mass, and I have two different objects with object B is a large mass, object C is a small mass. Object B should collide with object A before object C because C has a less mass, so the force is less, right? So we should be able to measure that in an experiment, but we can't. Any excuse is, well, the Earth is so big, you're not going to measure the Earth doing the thing, but that's not our problem. It's not our problem that you can't do the experiment. It's your problem. I'm not the one saying it's X causes Y. That's what they're saying, and they need to prove it with experiment. Just saying it doesn't mean anything.
Well, I do have an idea of how you could perform the experiment, but it would be like really, like you would need like a really, you would take like a really, really smooth sphere. This is like working in my mind, like on the spot, me thinking of a working experiment. You take a really smooth couple spheres of different masses and you put them on a really flat surface in a vacuum chamber and see how long it takes them to move. But it's like friction.
So what falls in that experiment?
Well, what falls? Well, they would be moving towards each other, but
how do you get so how do you get from I see two things moving towards each other? How do you extrapolate that to that's the same thing as falling objects? How do you make that leap of logic? How do you logically connect those two things? I observed two balls going. How do you logically connect them? I observed two balls going towards each other in a vacuum chamber on a table, and then I drop something and it falls to the ground. How are those two phenomenon, those observed phenomenon, how are you connecting them as the same phenomenon?
Because, well, in the globe model, the Earth and whatever you drop are both attracted towards each other. And similar to how balls are attracted toward. Oh.
Similar, but you need a logical connection. You can't just say, "Yeah, I want it to be the same."
They're attracted by the same force.
But that's just the assertion that you're trying to prove, right? So just like reasserting the same thing that you're trying to prove in the first place through the experiment, and just saying, "Yes, it's the same because I said it's the same because I said it's the same," doesn't mean anything.
I'm pretty sure that follows the scientific method where you have a hypothesis and you run an experiment to prove it, and then if it supports that hypothesis, it gains more weight as being viable.
God, I hope Huey isn't listening. You're lucky.
Oh, yay! I want to hear his hypothesis now.
Okay, so hypothesis is, and I got to channel Huey right now without the swearing. And actually, he doesn't swear that much. I probably swear more. So I covered the experiment part. To determine the cause of a phenomenon, you need an independent and a dependent variable. You manipulate the independent variable and observe a change in the dependent variable, right? And when I covered that, your causal mechanism is that mass is attracting mass. So you should be able to manipulate the mass, right, and get a change in the dependent variable, the rate of fall.
Yeah, so
But that is not happening in the actual experiment. There is no change in the rate of fall.
The independent variable is the mass of the objects. If that was what you were asking, I mean, I don't.
Yes, well, I mean, theoretically, yes. I mean, I'm not going to get into like defining mass and how that's a convoluted bunch of bullshit. But but the thing is, even if we do this manipulation, we drop a bus, we drop the frickin' 747, we drop the Empire State Building, we drop the frickin' the Mount Everest, and I drop something else, man. They all fall at the same rate. We can change the mass all we want, and we still get the same rate of fall.
And wait, when you say rate of fall, you mean like, for example, the rate of fall for objects on the Earth is like...
The agreed upon, the convention is 9.8 meters per second squared. And that's not an actual measured value. That's by convention. It was agreed upon in 1908 by the Committee on International Standards and Measurements or something.
Good night, everyone. Have fun debating.
Night.
All right, peace.
We haven't been debating this whole time. Nobody's brought any evidence for the globe.
So we can if you actually measure, you get a gravitometer and you actually go all over the world, you'll measure all different accelerations. Of course, the difference is very small, but there is a difference. Sometimes that acceleration isn't even straight down. Sometimes it's sideways. Well, not exactly sideways. There's some pitched angle. The point is, when we say gravity is fake, we mean there's no experimental evidence to support the so-called theory of gravity, and that there is a physics description of things falling, meaning there's a model. But a model isn't a theory, right? Models are based upon just data fitting. We take a bunch of data, we come up with some mathematical terms, and then we okay, what fits this data? We come up with some equations, a formula, a function that fits this data. That doesn't mean we know anything about it. We're just doing a mathematical operation. That's all we're doing. We don't know the causal mechanisms. We don't know anything. And mainstream science admits that they don't know the causal mechanism. NASA themselves, they have a webpage for children that says, what is gravity? And the first word answer is, I don't know. We don't know. So, and I didn't even get into like Newtonian gravity or Einstein's gravity, general relativity, where all the definitions are different, where the mass is defined different, the propagation speed of gravity is different, it's in a different geometry, everything is completely different, right? Completely different. So, like, listen to this. I'll show you how absurd it gets, right? So, mass is defined under general relativity as resistance to acceleration. So you probably think mass is the amount of matter in a substance. That is the Newtonian definition. The amount of matter in a volume is the definition of mass. But in general relativity, it's the resistance to acceleration. Now, let's think about this for a second. So resistance to acceleration attracts resistance to acceleration. Does that make any sense to you? Think about it for a second. If you most people that come in here, they're using Newtonian idea of gravity. But as soon as you switch to like general relativity, it gets crazy. It just totally gets batshit crazy. That means mass is a resistance to acceleration. That means the more unmovable it is, the more it attracts other things which are unmovable, and the more unmovable they are, the greater the force is to move them. It makes no sense at all, in any logical sense at least. So when we say gravity's fake, go ahead.
Sorry, with all due respect, Indio, Newtonian gravity doesn't make much sense either, because how do you play tetherball without the tether? Sorry, go ahead.
Yeah. Yeah, good point, right? So when we say gravity is fake, we mean very specifically, yes, there is a description to describe things falling. Yes, you can use, but even that description, like if you use F equals G M1 M2 divided by R squared, that's not what we use in the real world. We just put in the gravitational acceleration. We put in little g. We do all our equations that way, and we totally disregard the quote unquote mass of the Earth. So I mean, this is why we say gravity's fake. It's just a mess. And if you knew how Newton even came up with it, you would just be like, it's even more of a mess, because Newton didn't come up with it from doing any experiments. He noticed from Kepler's second law that, I don't know what you know about ellipses, right? So ellipses have two foci, and Newton noticed if the force was directed, if there was a force only to one of the foci, that force would always be inversely proportional to the square of the distance. Right. So this is Kepler's law, but we now know that it's admitted that Kepler fabricated all his data, but that's not important, right? He noticed from these elliptical orbits that this was a mathematical fact, right? And then he came up with this inverse square law, and then they went out and searched for, the what would you call it? The constant. They go for big G. Searched and searched and searched until they came up with a big G number that would, just match whatever they said it would match, right? So they did Cavendish. Someone 75 years later came up with big G, and they go, okay, this ball is falling at 9.8 meters per second squared. Let's insert big G into this equation. Okay, so the mass of the Earth has to be this, because this law, in order for this planetary orbit law to work, that means when this object drops, G has to be that, and now the mass of the Earth is this. And you just build a whole bullshit model around it, all the day. Well, all a couple centuries. I think you guys go. I don't mean to go on this crazy rant, man, but you guys think this shit sprung out of nowhere. There was a bunch of scientific discoveries, and they discovered this shit. They already believed it. They believed it at Copernicus. Copernicus had circular orbits that couldn't work. Galileo had circular orbits that couldn't work. We now know that Kepler faked all his data. They believed it then. Okay? And now we know Newton's laws are wrong, but they still believed it. So for 400 years, they're already believing it, right? And they're telling everybody, even though we know now that everything they thought then was wrong, right? But they talked about it then the same way everybody talks about it now. The Earth has to be a globe. We have all these models. They work. Blah, 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 blah. But we know now that they actually didn't work. A kind of closer examination. They don't work. They don't match observation of reality.
Yeah, when you look up the cosmological constant problem, aka crisis, they'll tell you straight up.
Hank got someone with a hammer. That's the absolute hammer. Go ahead, sorry.
It's all right. So the cosmological constant problem, it says that when we observe gravity and we compare it to theory, you match the observation to theory, it's off by an order of magnitude of 120.
Orders of magnitude. That's 120 zeros, man.
Gravity, that's dark energy. That's the expansion of the universe that's off that much. Not gravity.
Right. what I'll say about that is how much matter is missing? Hey, how much matter is missing?
It's not matter that's missing, it's dark energy.
No, but there is matter missing, right? That's dark matter. Right?
No,
So how much
missing?
So how much matter is missing?
I don't know, 75%?
What's 75% between friends? I hope you don't do banking where like they have a 75% error.
Okay. My point was, he said it was gravity that was off. It's not gravity that's off by 120 orders of magnitude. It's dark energy that's off.
Well, I mean,
that's due to gravity, by the way.
No, it's dark energy that's off. It's the expansion of the universe.
That's not what happens. It doesn't have enough gravity to hold all the galaxies together, so they must make up dark matter to fill up the rest.
It's dark energy that's expanding the universe. That's what's off. It's the vacuum energy that's off 120 orders of magnitude.
Yeah, dark energy is the thing that's accelerating the expansion, and dark matter is the thing that's keeping all the galaxies in groups, even though it doesn't make all the sense. Like as you said, it's like 75%.
So it says dark energy is the hypothetical form of energy that exerts a negative repulsive pressure, behaving like the opposite of gravity. So saying it has nothing to do with gravity is silly.
It's the opposite of gravity.
The opposite of gravity. Anti-gravity?
Okay. I mean, if you want to say up, does up have anything to do with down? I guess it sort of does. It's the opposite of up, down, but whatever.
So anyway, it's anti-gravity.
Okay, we'll go with
I
that.
guess it behaves like
anti-gravity is off by 120 orders of magnitude. But if you actually read the articles, most of them will specifically say it's dark energy, or they'll use the term vacuum energy. They kind of interchange those. That's the actual term that's off by 120 orders of magnitude. They don't really use gravity in the explanation. I mean, if you want to, whatever, but that's not what they're saying.
Okay, so have you read it from my Harvard link?
No,
because you're saying it's not about gravity. Is that what you're saying?
I'm saying the thing that's off by 120 orders of magnitude is dark energy or vacuum energy. That's what I'm saying. Do you have the Harvard link?
Oh, okay. Yeah, sure. Give me just a second. So while I'm looking it up, it might take me a second, I do want to explain where this dark matter comes from. So according to Michio Kaku, the galaxies spin 10 times too fast, right? And the stars should fly off. Like if you put kids on a merry-go-round and you spin it till they fly off, right? And then put them back on the merry-go-round and spin it 10 times faster, right? So it should fall off, right? Hang on just a second. I'm looking up that link.
Yeah, and did you see what Dre's posted? Take a look at that. Okay, so if you're familiar with the theory of general relativity, there's a mass-energy equivalence. They're indistinguishable.
That's correct.
So they're indistinguishable. So the thing is, this energy, this vacuum energy, is supposed to have an attraction. It's supposed to have a gravitational effect.
The vacuum energy?
Yes, because energy is mass. They're equivalent. The mass-energy equivalence principle. Yeah, that's right, man. If you had a lot of energy compact in a very dense area, it would attract, in your model, planets, stars, etc.
All right, just let me know when you're done.
Well, I mean, what Dre's posted, I mean, it says it right here. Quantum field theory predicts a very large energy density for the vacuum, and this density should have large gravitational effects. However, these effects are not observed, and the discrepancy between theory and observation is an incredible 120 orders of magnitude, and there's no generally accepted explanation for this discrepancy, although numerous papers have been written about it. As usually stated, the problem requires the knowledge of quantum field theory and general relativity, topics not normally studied by undergrads. We tried to make the problem accessible to undergrads, blah, 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 blah. Clarifies how basic is the conflict between quantum theory and gravitational theory.
So how did you get that they're not talking about gravity? right? Because if you look, let's just use a little context clues, right? The first sentence ends with gravitational effects.
Okay, I'm wrong. You win. You're good.
Okay. Fair enough.
Well, he just didn't know about Einstein's mass energy equivalence principle. Remember, E equals mc squared? Remember that shit? The shit they print on T-shirts? And everybody thinks they're smart because they're wearing a T-shirt with E equals mc squared on it. A fucking bunch of tools. The only thing more dickish than wearing a NASA T-shirt is wearing an E equals mc squared.
I know. That's what you got to do to be smart, though. You got to wear a T-shirt that has some print on it.
Dude, listen, I'm a nerd. And the only thing, nerds hate fake nerds. I hate fake nerds, dude.
It's just posers in general.
So the article from Forbes says...
Posers, man. Posers.
The article from Forbes says there's 85% missing. Time says there's 96% missing. A couple other ones say there's half missing. Which one is it?
Yeah, India must hate me because I was a jock up until the 9th grade.
Well, listen, I was the only one that was in honors classes and getting suspended from school and kicked out. And
nerds don't hate jocks, by the way. Nerds hate fake nerds, like he said.
Yeah, fake freaking nerds, dude.
And jocks protect nerds because they like their car to start and shit like that. I'm telling you.
I always wanted to challenge the stereotype and be like a muscular nerd.
I played sports. I was a nerd. I didn't I didn't fit in any category.
Yeah, I didn't either.
I hung out with the burnouts. I was a nerd, and all my friends were in sports.
Yeah, I didn't have a place to sit in the lunchroom. I would just go sit at different people's tables and just blend in. I never sat in the same spot with the same group of people. Even though I had a clique, I just didn't always hang out there.
My lunchroom clique was, we're going to beg everyone from change and not even eat lunch. You got a time for lunch money? Got a time, we leave with pockets full of change. And then go buy soda.
Yeah, everybody's been, trained to believe that gravity works, right? Because when you drop your cell phone, right, then you need a new cell phone, right? Because gravity, right? Gravity works, right? That's what the little bat said on Fern Gully, So because they believe, Fern Gully and everything, right? It's everything that they say about gravity is automatically true. Right, and how dare you tell me that there's two separate gravities? Right? How dare you? You don't know what you're talking about, flat earther. There's only one gravity.
So, Travis, I saw the link you posted. I'm actually aware of that. Before you posted it, I'm already aware of that. So the guy that did this study, he isn't an astronomer. He works for CERN. And basically what he did was he went back over all their data, their supernova data, and there's the other thing. Oh, what the hell is it? The two things for expansion. supernova data, maybe redshift data. Anyway, he reanalyzed the data, and he used what we would think is more statistically rigorous methods. And basically, their conclusions, their measurements, their conclusions of their measurements are within the error of the instrument, meaning there's a possibility that they actually observed nothing. They observed no expansion. If you read your article, it says 3 sigma and then immediately 5 sigma, which is like, you know, there's a 1 in 1,000 probability of, you know, it being random noise. That would be 3 sigma. 5 sigma would be that the odds are 1 in 10,000, 100,000. Noise, that it's just a random noise versus an actual observation. Not that those things even mean anything. They're kind of, you know, you can get pretty funky with statistics and make things mean whatever you want them to mean.
I think the saying goes that figures don't lie, but liars sure can figure.
Yeah. I mean, listen, like, how about the polls they do, the political polls? You know, so-and-so is leading by 10 points. We have a margin of error of 10 points. The government does stuff like this all the time. They make the margin of error so large and they can say anything. We have 100% confidence that we're exactly right with our 100% margin of error. Somewhere in that 100%, the real value will fall. Aren't we geniuses?
I think that's kind of like, you know, dying with a bad haircut and dying from a bad haircut. And you can make figures say anything, right?
How would you die from a bad haircut?
Well, if Fauci says it on the news 100 times a day for the next, I don't know, like 500 days, people probably start believing it.
Hey, I have a question. Have you guys ever done any of your own experiments before?
Yes.
Ooh, what'd you do?
Such as what? Like, what kind of experiments? Like in chemistry class? I mean...
No, I mean, like, any... Okay, well, what I'm basically...
Flat Earth related or, like, other stuff?
Yes, Flat Earth, global...
Okay, Flat Earth related. Okay, yes, I have. And quite a few people in here have. DJ, for instance, was at a double laser test that was done in the UK by a PhD in spectrophotometry. They took two different color lasers, a red and blue one, something like 550 nanometer and 700 nanometer, I think. No, infrared. Yeah. So, and they went from 6 inches and showed them across, I think it's 10 kilometers, 12 kilometers. Anyway, the globe model predicts that the laser should be, if the Earth is a ball of 3,959 miles, that the observation point, right, of 1 foot, right, there should be a hump. You know, the Earth should curve in between those 2 points. Right, there should be blockage. You know, you ever heard that ships sail over the horizon?
I've heard.
So you heard the ships sail over the horizon. This is the same idea. The ships ship sail over the horizon. So I take a camera and I stick it beyond the horizon, so it should be like below the horizon, like the ship sailing over it. And then I shoot a laser at that camera and see if the camera picks it up. So they did this simultaneously in two directions, live stream from both ends on the YouTube. And you could see both the lasers, no problem, when neither one of them should have been visible from either side. And that's not even like the longest laser test. So CJ was at that. I personally, in Boston Harbor, I observed the boat go from 6 miles to 30 miles. And if you do the math, from my 15-foot elevation height, I was 15 feet above the sea level, the boat should have been 430 feet below the horizon. It should have sailed over the horizon. But it didn't. I watched it just sail off into this, sail off. And fade and fade and fade. It was actually still visible even when I left. But it takes a while for a boat to get out that far. So I got bored and just left instead of continuing to watch it. I have it all documented and shit. So that's what I've done personally. And it's not like I like picked a day to do it. I just went up to Revere Beach, just happened to be up there killing time, and just okay, I'm gonna just watch this boat. And I tracked the distance on it's called marinetraffic.com. You can track boats. And this particular boat tells you what the tracking station is. This tracking station is a radar station that's in Marblehead, which is up the coast in Massachusetts a little bit. So it tracks the position of the boat. You can look on your little graphic and see where the boat is. Punch in the latitude and longitude coordinates, where you are, where it is. Do the math, figure out the distance, yada, yada, yada. Boom. It's supposed to be 30 miles away. It's supposed to be 420 feet underneath the curve. Now, I'm pretty sure, now don't quote me on this, but I'm pretty sure there is no boat on Earth that is 42 stories high. I think that's pretty safe to say. So the only way to see this boat is if the boat was 42 stories high. Tall. Above the sea level. In actuality, it was a tanker ship. It was only 4 stories high.
Nuh-uh.
Nuh-uh.
So I got a question for the guy who asked that question. Can you find anywhere on YouTube where a baller has measured curvature?
Me?
Yeah, can you show us where someone on YouTube has actually measured the curvature?
Not right now. That may seem like a weird answer, but I am not really situated for sitting down for a long period of time. I mean, I might leave it any minute. I just asked that question because I was about to leave it. I haven't.
You know what? You don't have to believe what we say. You can just go do your own test. You know that, right?
Yeah, that's what I was about to say. I have an idea for an experiment that involves the moon.
Not in the sky.
What does the moon got to do with the Earth?
Well, I mean, it'd be hard to explain with just my words, but I'll try. So, I saw, I didn't see, but I thought in my brain, people on each model of, either a flat Earth or a globe Earth, tracing their lines of sight to the moon. For example, on a flat Earth and all the lines of sight traced to a single point, if the flat Earth became a globe Earth, then those lines of sight wouldn't trace to the same point. They would be offset from each other, and they wouldn't all align at the same place. In fact, since it's three-dimensional, some of them wouldn't even cross at all. And vice versa, if you had all the lines on a globe Earth pointing towards the same point, which would be the moon, and it turned into a flat Earth, then they would point in different directions. So I thought, okay, I'm pretty sure this is how it works. So I had the idea for an experiment where I took a couple of people in different parts of the world, and I they had a compass, and they knew 45 degrees, 90 degrees, 90 degrees straight up, 45 degrees halfway there, the degrees of a circle as heights in the sky to where the moon, I don't actually know how to record actual positional coordinates in the sky, so I just came up with the idea of a compass and the angles of 45 and 90, so forth.
Well, typically what they do is they measure up from the horizon.
Yeah, and then they also
So if you get a sextant, you would measure up from the horizon.
Yeah, that was my plan. I would use the compass and the height to figure out positional coordinates, like makeshift coordinates of where the moon would be.
But don't you have to assume that there's just a line of sight? Don't you have to assume something you can't actually prove?
Well,
that the moon is like a common object that everyone's looking at in the same line of sight, like we're all looking at the same thing at the same time. I mean, there's just like a ray of light that just projects straightly right to that thing. We actually know that that's actually not the case. We know this already, that this is not the case. It's not the case even in the globe model, because in the globe model, they claim that light is bending all the time, all over the place. So like nothing that you see in the globe model is actually where it is. So they tell two stories at the same time. That's the thing. Well, this is in sky, but then there's other anomalies, right, that they can't explain. So they say, well, the light is bending. And if you take, you know what time and date is, or sun calc, those websites. You can look on the sun and moon, where the sun and moon are, right? So that's the globe model, where the sun and moon are. So if you take two locations on the Earth, right, and you take that data, right, the azimuth and elevation angles. The azimuth is how many degrees from true north, and then the elevation angle is what it is above the horizon. And then you take multiple locations, and then you map that to a globe. Those lines of sight don't intersect at a common location. And it's kind of like, you're probably thinking, that doesn't make sense. Well, you're right, it doesn't make sense. So we're not looking at the same object in the exact same place. We're I'm off a little bit, there you're off a little bit, and the more you add, the worse it gets. And this has been demonstrated a bunch of ways. This is, first of all, number one, it was modeled in AutoCAD using something like 13-digit precision, right? So took the time and date data, did multiple, based upon the data, intersect to the sun, and some of the values turned out to, using two locations. I think it was Johannesburg and maybe it was Brussels, Belgium, or something, because they're on the same longitude. So you take these the same exact time on time and date, and then you model it all out geometrically, and those lines of sight didn't intersect. Another person did the same thing using sun calc, except for they used Blender, and that even turned out even worse. So that's why when we go Justin's nothing in the sky, because you have to have an assumption about how that light reaches you, right? The path that it took to reach you.
Well, I do have an assumption on how the rays of light work. It is...
Yeah, but we can avoid that. Why do that when we can actually avoid that by measuring the Earth itself? We don't need to look up. You can just look down. That's the place in question, right? And if you think about it, even at a logical level, if you had a table, right, and you could measure the dimensions of the table, they'd have a value, right? I could take a tape measure. I could measure the table. I could say, hey, it's 36 by 36, 48 by 48, whatever it is. There's nothing of whatever's happening above that table, light, sun, moon, stars, whatever, that are going to change the results of those measurements, right?
Well, that's why my experiment is focused on the moon and not the Earth. Because it's I was like, oh, I could try this.
You're not getting. It doesn't tell us anything about the Earth. That's the point.
Think about it like this. We take you to a place and we say that we're going to have some baby seal custom leather boots, right, made for you, right? And they measure your forearm. You think you're going to have a snug fitting shoe?
I understand, but I'm trying to figure out in a flat model how high the moon would be above I'm a part of a different Discord server than this one. It's how I got here. They advertised it in the announcements section, and most of the flat earthers in that server said that the sun and moon are small and local above the Earth. I don't know if all of you believe that story.
The basis for that, listen, there's a basis for that. The the basis for that is Thales' theorem. So if you take a stick and a shadow and you measure the angle, same way that Thales measured the pyramids, and we came up with Thales' theorem in the first place, the sun and the moon are somewhere between, I think it's like 3,000 and 4,000 miles away and 42 miles in diameter. Okay, listen, but we're not saying, okay, that's right. Okay, that's the basis for it, is that. We don't know. We can only speculate about the celestial bodies. Ultimately, they're a speculation. We look up and we tell ourselves stories for thousands of years about what the fuck they are. Like, what's up there? Yeah, we're going to tell ourselves stories. And somehow we got to, like, people that told the best stories about the shit out of now, the smartest people that ever lived. I don't know how that happened. It was a great con. Whatever. The point is, they can never tell us anything definitive about the Earth. Ever. Because that is something what you call an indirect measurement. Right? An indirect measurement is when you're measuring something, you measure something. I'll give you an example, right? So if I measure time times speed, I can get a distance, right? If I'm going so fast for a certain period of time, I can indirectly measure my distance. You follow?
Sure.
Okay, so that's an indirect. But I could also take a tape measure and stretch it between those 2 points and directly measure the distance. Right? So that's the difference between an indirect versus a direct measurement.
So if the road
hold on,
is
Hank,
sorry,
hold on, just let me finish real quick because I'm trying to get to the point. Now, the fact that we don't know, like, we're making some assumptions about what's in the sky and using an indirect method of measuring the Earth, it's just more certain, right? And it's actually proof of something if you just measure it is what you want to know about. We can just measure the Earth. It's accessible to us. We know how it works, right? We are on top of it. We freaking move dirt. We run around. We live on it. We dig holes in it. Like, we know about the Earth. It's accessible to us, and we can just measure that. And we don't have to make assumptions about what the lights are doing. I never understood this with the Globers. It's like, why you guys are obsessed with shit in the sky. It's like a sick obsession, man. To me, at least.
Well, it was hard to explain with just my words, but...
Well, I listen, I'm not trying to harp on you, but it's a thing with you guys, right? Whenever we talk to Globers, we start talking about, okay, let's measure the Earth, and they always want to talk about stuff in the sky. Like, I understand, because in the heliocentric model, that's the basis for the heliocentric model, is the objects in the sky and drawing conclusions about what the Earth is based upon looking up, which is stupid because, yeah, I want to know what's beneath my feet, so I look at what's over my head. I mean, that doesn't even make logical sense, right? This doesn't even make sense. To measure what's under your feet, right? That's what you want to know about. Go at it. But I mean, I understand where you're coming from. But we can measure the Earth. You don't need, it's not expensive. You can go buy a $6 door mirror from Walmart, find a large body of water. Because we use water because, a couple reasons. You don't have to account for terrain, right? Is the terrain sloped? Is the terrain bumpy? Is the terrain whatever? You have water. And in the globe model, water is supposed to be curving around the ball. And in the globe model, the Earth is 72% water on its surface, right? So the water has to be curving. Has to be. It's a logical necessity. It can't. There's no other two ways about it. It has to curve. And it has to curve at a certain rate because they said that the Earth is a globe of 3,959 miles. So it has to curve at a certain rate. We can make a prediction of what that rate's supposed to be, and we can go out into the real world and test that prediction quite easily. In the results of all our tests, and Hank asked you, do you know of any Cobra tests? Well, so all tests so far is that the surface of water is not curving at all. So if the surface of water is not curving, it is a logical impossibility for the Earth to be a ball of 3,959 mile radius. Now, Clovers will sometimes say, maybe it's a bigger ball. Yeah, great, fantastic. Well, how did they get to the fucking moon? Because that would mean the moon's further away and it's bigger. And then all the other planets are bigger and everything else is bigger. Because everything, the entire cosmic distance ladder and the size.
Uh-oh.
On December 12, 1901, Guglielmo Marconi received a transatlantic radio transmission at a distance of 2,135 miles. With the transmission tower height and elevation added in, at that distance, nearly 640 miles should have been hidden behind the Earth's curvature. 640 miles is enough to hide the United Kingdom if it were standing straight up. That is a very tall shadow. In my previous Flat Earth Fact number 11 video, I described how the World War II German Knickbein bombing radio guidance system was not initially investigated because English scientists, including Churchill's scientific advisor, stated the curvature of the Earth would block the VHF beams, and so the targeting system could not exist. The advisors were mathematically right, but English lives were lost because the Knickbein system in fact existed, proving there was no Earth curvature. Likewise, naysayers told Marconi that it would be impossible to send a radio transmission over 200 miles, let alone 2,000 miles, because the curvature of the Earth should have blocked the transmission. Again, the naysayers were mathematically correct, but Marconi accomplished the feat and has been repeated many times at much further distances. Because of Marconi, the ionosphere theory was then fabricated, claiming that the radio waves bounced off of the ionosphere. For Loran, the explanation is that the radio waves hugged the surface of the water. For Knickbein, since the beams were VHF, the issue has been avoided entirely, as Wikipedia and others have simply lied about the math and said that the Earth's supposed curvature wouldn't have been an issue at those distances. Do you see the pattern here? Repeatable scientific evidence proves the Earth is demonstrably flat. In response, new pseudoscience nonsense is discovered, somehow justifying why the Earth's curvature somehow always evades detection and disappears without a trace. Marconi's 2,000-mile transmission is another proof of the flat Earth. In my last video, I discussed Marconi's 2,135-mile radio transmission that was supposed to be impossible under the globe model. Based on the globe math, that radio signal should have been approximately 640 miles over Marconi's head, but it wasn't. We talked about Knickbein and how English lives were foolishly lost because English scientists erroneously believed in the Earth's curvature that was supposed to be blocking German VHF bombing beams. According to the globe math, those German VHF beams should have been 100,000 feet above the German bombers, but they weren't. We have also talked about Loran and how Loran was used as a navigation system that could pinpoint the location of a boat 1,000 miles away from the station, again demonstrating there is indeed no Earth curvature. In addition to these examples, sonar also unequivocally proves there is no Earth curvature. In addition to finding enemy submarines, sonar can be used for mapping the ocean floor. Ridges, hills, trenches, and sunken vessels are all easily mapped with sonar. Despite the detail of modern sonar mapping, no one has ever mapped or detected the Earth's curvature using sonar. When a Navy ship actively sends out a sonar ping, it will generate an acoustic shadow, where the sound waves are blocked by underwater obstructions, like boats, rocks, hills, and ridges. You can see the acoustic shadow produced by these sonar images. These shadows are sometimes used by submarines to hide from detection. However, as confirmed by former Navy sonar technicians, which has not been challenged by anyone, sonar has never produced a globe curvature acoustic shadow. If the globe were real, modern submarines, operating at a depth of 1,600 feet, could remain hidden from surface ships at 80 miles by hiding in the curvature shadow. Depending on the varying depths, a submarine could remain undetected from another submarine at a mere 25 miles by just hiding in the Earth's curvature shadow. However, no submarine has ever hid behind the Earth's curvature to evade detection, proving there is no curvature. That brings us to another U.S. government proof of the flat Earth, which is called SOSUS, the Sound Surveillance System. SOSUS was a once classified passive sonar submarine location system used by the United States to locate Soviet submarines. Essentially, underwater listening devices called hydrophones were anchored to the ocean floor at key locations. These hydrophones could detect low-frequency sound waves emitted by submarines thousands of miles away. Once the sound waves of the submarines were detected by multiple hydrophones, the location of the submarine could then even be triangulated. Think about it. Could a submarine's very distant location be triangulated on a ball where there are supposed bulges of ground 100 miles tall between it and the hydrophones? At a curvature drop rate of approximately 8 inches per mile squared, the Earth's curvature should be easy to measure and detect in many ways. However, above water or below water, radio signals, sound waves, and VHF waves, high-altitude balloons, or just simple long-distance photography and lasers, the alleged Earth's curvature always seems to disappear without a trace, and that should cause any independent, thinking, reasonable person to realize there's a major problem with the globe. Regardless, the sonar flat Earth proof is pretty simple. Because there is no Earth curvature acoustic shadow, there is no Earth curvature, and that's a fact. On October 14th, 2012, Felix Baumgartner officially reached an altitude of over 128,000 feet. His ascension took approximately 2.5 hours. His launch site was here, and his landing site was here. He landed 44 miles east of his launch site. According to the globe model, at the equator, the ground is allegedly rotating at 1,037 miles per hour. At the 33rd latitude, where Felix was located, the Earth is supposedly rotating at 867 miles per hour. So, if the ground was rotating at 867 miles per hour, then Felix should have landed roughly 2,000 miles to the west in the Pacific Ocean. Obviously, he didn't land in the Pacific Ocean. He actually landed 44 miles east of his launch site. That's the same direction as the Earth's supposed rotation, and absolutely the wrong direction. The alleged rotation of the Earth did not affect Felix's 2.5-hour ascent to that extreme altitude 1 iota. The globe propagandists want you to believe that the rotation of the ground somehow transferred all of its motion to the air above it, as though air constitutes a solid block stuck to the ground. They also must claim even the thinner upper layers of the atmosphere miraculously speed up to keep up with the ground below, as though the air can be connected to the ground like spokes on a bicycle wheel. The globe claim is patently absurd. In reality, the ground cannot effectively transfer its motion to air. Moreover, the layer of air close to the surface cannot then transfer its motion to the air above it, and so forth. If the Earth did spin as claimed by the globe model, this would result in a 1,000 mile per hour westerly wind, making life impossible. According to Dr. Carl Schofer, but we know of no body the parts of which have much less connection with each other than is the case with the air. The air layer next to the Earth, really dragged along by the communicated motion, would not be able to communicate its motion to the layers above it, for the simple reason that it stands in no connection with them. These upper layers must therefore remain in their place, or, which would signify the same thing, would apparently flow westward with the same rapidity with which the Earth is said to rotate to the east. Now, since the point on the equator, if the Earth rotates on its axis in a day, must move eastward at the rate of 1,250 feet a second, the air would similarly move 1,250 feet westward in a second, which would more than 10 times surpass the velocity of the most fearful hurricane, We cannot perceive the rotation of the Earth in any way. We cannot demonstrate it. There are no air currents which we can justly regard as, or even supposed to be, consequences of this rotation. These facts ought to be proof enough against the existence of the rotation of the Earth. Must it not appear almost absurd in us, preoccupied by what they have taught us in school, to accept a theory of the rotation of the Earth which neither is nor can be proven? Must we not wonder at the readiness of the learned of nearly the entire world, from the time of Copernicus and Kepler, to accept the conception of the rotation of the Earth, and then search afterwards, now for nearly 3.5 centuries, for arguments to maintain it, but of course without being able to find them? Without reasonable question, the Earth is stationary, and Felix Baumgartner proved the same.
Okay, we're told the Earth rotates at 15 degrees per hour, 1 rotation per day. If a plane were taking off from the North Pole at a distance of 1 mile from the geographic North Pole or literal axis of rotation of Earth, that would be a 6.28 mile circumference. That circumference would cover 6.28 miles in 1 day, or just about a quarter of a mile per hour. If a plane takes off from that runway and heads south towards the equator, it must, by mathematical fact, by physics fact, somehow accelerate its angular momentum that as it was taking off from the North Pole was only just about a quarter of a mile per hour, must somehow, when it's going to land at the equator, have accelerated over 1,037 miles per hour of angular momentum. It has never been proven physically that planes do this. There has never been an instrumentation, reading, or measurement provided to prove that this is what airplanes do when flying from north to south towards the equator. And vice versa. A plane taking off from the equator is carrying 1,037 miles per hour angular lateral momentum and must somehow lose over 1,000 miles per hour of that angular momentum in order for it to land safely at the North Pole, that is again only moving at a quarter of a mile per hour. This proves the Earth is stationary, and as many NASA and other government documents proclaim, when doing flight tests, they assume a flat, stationary plane. Globe proponents will tell you this is just because it's an easier way to test things without making it complicated, and so the pilots don't have to do all the difficult math. I would submit to you, because there has never again been any physical proof of their mathematical claims of rotation and conservation of momentum, much less acceleration or deceleration of angular momentum that these planes carry, that it is more likely that the Earth is just flat and stationary, and that's why these government documents state this. Until someone can provide mechanical measurement of airplanes either gaining 1,000 miles per hour of angular momentum or losing it going from the equator to the North Pole 1,000 miles an hour of angular momentum, this is proof the Earth is a stationary level plane, just as the government's own documents state. Thank you for your time. The Earth is flat and stationary.
According to the globe model, the surface of all standing water must have a certain degree of convexity. Based on the alleged globe circumference of about 25,000 miles, the Earth must curve away from you at 8 inches per mile squared. The formula is simple and accurate over all visible distances and has been proven by engineering software. At just 10 miles, there should be a measurable curvature drop of 67 feet, 20 miles, 267 feet, 60 miles, 2,400 feet. To calculate what amount should be hidden behind the alleged globe bulge, you can use an online calculator like this one. We can prove that this curvature does not exist. For example, in this video I filmed the opposite shore 21.03 miles away. You can see both the laser source and its reflection on the water. That laser in the opposite shore should have been between 218 to 223 feet below the globe horizon. No curvature is present. At a different lake in freezing conditions, the source of this distant laser should have been 168 feet below the curvature. No curvature is present. If the Earth were a globe with a curvature drop roughly equal to 8 inches per mile squared, and the surface of the Earth and its atmosphere allegedly rotated at approximately 1,000 miles per hour at the equator, as claimed by the globe model, you'd assume those claims would be vital to NASA and the military for modeling and building aircraft. Instead, you'll see through declassified documents that government agencies and their contractors repeatedly assumed a flat and stationary Earth. For example, this NASA document assumes a flat, non-rotating Earth. Georgia Institute of Technology, on behalf of NASA, the model used is a flat, non-rotating Earth. Technical memo from the NASA Langley Research Center, flat, non-rotating Earth. NASA Technical Memorandum, flat, non-rotating Earth. NASA publication on the derivation and definition of a linear aircraft model, flat, non-rotating Earth, and flat, non-rotating Earth. NASA contractor, flat, non-rotating Earth, and flat Earth assumptions. NASA Ames Research Center, non-rotating flat Earth. Army Research Laboratory, flat Earth. Army Research Laboratory, propagation of electromagnetic fields over a flat Earth. Army Research Laboratory, a flat Earth approximation provides the best estimate. NASA Technical Paper, stationary atmosphere over a flat, non-rotating Earth. NASA Technical Memo, a non-rotating Earth. MIT Department of Aeronautics and Astronautics, flat Earth, flat Earth. NASA Memo, flat, non-rotating Earth. NASA Contractor Report, assumption based on the Earth is flat and non-rotating. NASA Technical Memo, flat, non-rotating Earth. NASA Technical Paper, stationary atmosphere and flat, non-rotating Earth assumptions. NASA Technical Note, flat, non-rotating Earth. NASA Langley Research Center, flat, non-rotating Earth. Army Research Laboratory, these equations assume a flat Earth. Even the Soviets made their assumptions based on a flat Earth. If the Earth were a ball and rotated at 1,000 miles per hour, you obviously would not see the repeated engineering assumptions that the Earth is flat and stationary. According to the globe model, there is a point on the globe where the alleged curvature of the Earth begins to obstruct distant objects. Under the globe, this point is referred to as the horizon and is marked by an X on the diagram. One can determine the distance to the alleged globe horizon in miles by taking the square root of the observer's height in feet and multiplying by 1.225, or you can simply use an online calculator like this one or this one. We can prove there is no globe geometric horizon and therefore no globe. In this test, infamously referred to as the Black Swan, with a camera height of only 1 foot, the globe horizon would have to be closer than a mere 1.2 miles. 1.2 miles would be the maximum distance to the horizon under the globe. But the closest platform on the right was 6.2 miles away, and the platform on the left was 9.4 miles away. As you can see, the horizon is miles beyond, 9.4 miles, belying the globe model. In this video, with an observation height of 105 feet, the globe horizon would have to be closer than 12.6 miles. But the horizon is well beyond the third platform, that's 26.4 miles away. Again, there is no bulge and no geometric horizon. The globe fails. For this test, filmed by an engineer, the globe horizon would have to be closer than 8.2 miles. Instead, the apparent horizon is well beyond 14.6 miles. The globe fails. For this test, filmed by a PhD, the horizon would have to be closer than 2.3 miles. Instead, the apparent horizon is many miles beyond 11.2 miles. You can even see a boat further away and perspectively higher than the base of the wind turbines, proving there is no curvature whatsoever, not even an inch. The globe fails. In this video, the globe horizon would have to be closer than 1.9 miles. As you can see, the horizon is beyond the bird rack that was 11.2 miles away, proving the globe faults. Again and again, the globe geometric horizon is proven to not exist. Therefore, the globe cannot exist. As I have proven and will continue to prove, when visibility is high without miraging, we see way too far in total contradiction to the globe model. Because of these repeatable observations that anyone can perform, the only counterclaim the globe propagandist has is refraction. as though refraction has this fairy tale property that inexplicably removes all evidence of giant bulges of Earth curvature. The globe claim is patently false. As shown here and in countless examples, refraction is real. It compresses, it stretches, it distorts, it obscures and mirages. You can see it with your own eyes. But the globe propagandists have hijacked the term refraction and took this observable reality and deceptively changed refraction into an imaginary Earth curvature removing device. In my last video, I shared this footage proving the Earth is flat. The globe horizon was supposed to be closer than 2.3 miles, but the horizon is many miles beyond 11.2 miles. The globe bulge was supposed to be blocking 25 feet of the first turbine and blocking 53 feet of the furthest turbine. Instead, you can see the base of the turbines getting perspectively higher instead of sinking below the supposed Earth bulge as the ball would require. The globe propagandist's only counterclaim is that refraction caused the Earth bulge to disappear without a trace and then reappear miles beyond 11.2 miles, all without affecting the 6 turbines in between. I hope you already see that the refraction claim is without merit. I filmed this footage as my wife walked from the top of the beach all the way to the water's edge where she placed a 4-foot mirror into the water 6.3 miles away. I filmed her the entire way, but the globe curvature was supposed to be hiding 12 feet. But look at this still from the video. There is absolutely no distortion of the distant shore. But this 12 feet here should be behind the curvature of the Earth, like this. Did that 12 feet hop the curvature without causing a cascade of distortion? If 12 feet jumped the curvature, wouldn't it then overlap the 12 feet above it, causing manifest distortion? Are we to believe that every inch up to at least 100 feet uniformly arced perfectly over the curvature to present this flat, non-distorted distant shore? Ridiculous. In this example I shared in my Flat Earth Fact Video 1, the distant shore was 21.03 miles away. You can see the non-distorted distant shore. 223 feet should have been hidden behind the Earth curvature, but none of it is. If 223 feet hopped over the curvature, where is the manifest distortion, as that 223 feet would then overlap the 223 feet above it? There is zero evidence of this refraction distortion, and the mountain behind evinces the same. At the same spot, I then filmed my friend's laser that should have been 218 feet below the horizon. Not only did I film the bright laser source, but I also filmed the reflection of the laser source on the water, which would have appeared somewhere around here on a ball. Think about that reflection on the water. Bear in mind that the reflection would have been angled away from my point of view, but the giant bulge supposedly just disappeared, and everything in the distance wrapped around the Earth curvature perfectly to keep the image intact. Furthermore, if that nonsensical refraction event happened, why didn't the bulge itself jump up and still continue to block the laser? How did refraction affect everything but the closer giant bulge, but instead made the bulge disappear? To the honest and reasonable thinking person, the refraction argument of the globe propagandist is utter nonsense and should be shunned as such. According to NASA, there were no pictures of the Earth from space from 1972 until 2015. 43 years without a photograph of the Earth from space. Quoting Robert Simon, who is NASA's lead visualizer, NASA's website reads, "The last time anyone took a photograph from above low Earth orbit that showed an entire hemisphere, one side of a globe, was in 1972 during Apollo 17. We'll talk about the fake Apollo moon missions later, but 43 years is still shocking to most people. This is the 2002 blue marble that hangs in many classrooms and was even the wallpaper on your iPhone. It certainly looks real, and most people would think it is, but it's admittedly a fake image created by NASA. According to NASA, then we wrapped a flat map around a ball. My part was integrating the surface clouds and oceans to match people's expectations of how Earth looks from space. That ball became the famous blue marble. So, this phony globe was designed to match people's expectation of how Earth looks from space. Yet, it looks as real as anything produced by NASA. In fact, faking space seems to be an admitted NASA standard. According to Wired magazine, in this article titled, "How NASA Visualizes Stunning Worlds Without Really Seeing Them, Making Space Seem Real." Images sure don't come straight out of Space Telescope looking press release ready. Each visualization is the result of artists and planetary scientists collaborating to convert blips on a data readout into something that looks like a planet, all while remaining scientifically plausible. Making space seem real. Matching people's expectations. Scientifically plausible. I don't care how you whitewash it. This isn't science at all. This is propaganda designed to make you believe in outer space. After the admitted 2002 Blue Marble fakery, NASA claims that they took an actual photograph of the Earth from space in July 2015. That's the first alleged photograph in 43 years. Here it is. Of course, this alleged 2015 photo doesn't look much different than the admitted fake globe image of 2002. NASA artists can admittedly create fake images of the Earth that look real, and so why would anyone believe this one is real? If flat maps can be wrapped around a ball to create a fake globe, then why couldn't they even wrap weather radar data onto a globe in real time? That's exactly what they do. But let's take this first supposed photograph in 43 years, rotate it, and zoom in. The word sex is spelled in the clouds. What's even more strange is the fact that it closely resembles a Greek 666. You know, the mark of the beast from Revelation. Again, this isn't cherry-picking one of thousands of images. This is the first supposed photograph of the Earth from space in 43 years, and it just so happens to have either a sex or a Greek 666 spelled in the clouds. Regardless, NASA's admitted standard of fakery to making space seem real is enough for any sensible person to reasonably doubt anything produced by NASA and its subsidiaries.
It is photoshopped, but it's has to be.
On May 27, 1931, Auguste Piccard became the first man to reach the stratosphere at an altitude of 51,775 feet. That's much higher than the maximum cruising altitude of all existing commercial flights. In this Popular Science article, Piccard described the Earth as follows. It seemed a flat disk with upturned edge. Then in 1933, Russian aeronauts reached an altitude of 62,304 feet. That's higher than the maximum cruising altitude of the Concorde jet and higher than the alleged commercial flights of the MiG-29. This is how Popular Science described the aeronauts' experience. Looking down, they tried in vain to detect any curvature of the Earth's horizon. Of course, Piccard and the Russians should have seen the curvature of the Earth at those altitudes, but they didn't, even though they wanted to. Kudos to them for their honesty. Although I will be sharing high-altitude balloon footage at much higher elevations proving there is no curvature and no axial rotation, these testimonies from these unbiased aeronauts in the 1930s evince that no one you know has ever seen the curvature of the Earth belying the claims of the globe propagandists. LORAN was a naval navigation system that was originally developed during World War II and was allegedly used until the 1990s. In short, it worked by two radio towers on the coast that would transmit radio waves across the ocean. Using the LORAN system, a boat then could use the difference in the timing of the radio signals to calculate the vessel's location. These two LORAN stations, Sisconset and Bodie Island, for example, were 482 miles apart and could be over 1,000 miles away from the vessel. Using the distance between the Sisconset and Bodie Island stations as an example, the Sisconset station was 625 feet tall, with an added elevation of approximately 10 feet. At that height and distance, according to the dimensions of the alleged globe, that would make a target hidden height of 135,000 feet or 25.4 miles. That means that the Bodie Island Tower would have to be 14,000 feet higher than this weather balloon to have a line of sight with the Sisconset station. But the Bodie Island station was only maybe 150 feet tall, and these signals reached vessels over 1,000 miles away. Furthermore, look at the angle of the tower. The radio waves would be pointed towards space under the globe. There was no Earth curvature shadow blocking any signal from the LORAN system. The official explanation is that the radio waves, traveling at the speed of light, mysteriously hugged the surface of the Earth and wrapped around the curvature, inexplicably jumping bulges of water and Earth dozens of miles tall. Defying logic and reason, globe claims always include some extraordinary, unproven tell why the Earth curvature simply disappears without a trace. Simply stated, the LORAN system is another indication that the Earth is indeed flat.
In the middle part of the 19th century, a man named Christian Doppler noticed that objects that emitted sound would produce either a rising or falling pitch to an observer, depending on the movement of the object relative to the observer. For example, an object which was producing a sound when moving toward an observer, such as a train, would produce a higher pitched sound as the object approached an observer. Likewise, a lower pitched sound would occur when the sounding object moved away from an observer. We know this today as the Doppler effect. Late in the 20th century, we merged radar technology with the Doppler effect, and we came up with Doppler radar, which is currently on your screen. Moisture shows up on Doppler radar much like it does on traditional radar, with one large exception, which makes Doppler radar superior. The Doppler radar unit detects the direction in which the moisture is moving relative to the Doppler unit itself. For example, moisture heading toward the Doppler radar may appear green, while moisture or precipitation heading away from the Doppler unit may appear red. The different colors tell meteorologists much more information than traditional radar can produce. In fact, it is the only tool that can be used outside of direct human observation to detect a funnel cloud or tornado. That is the hook image you see highlighted in this Doppler radar image. It is important to note that Doppler radar has no computation or compensation built in for the direction in which the signal is returned. In other words, an object moving toward the radar unit will shift the image towards green if the precipitation is moving toward the unit itself. It doesn't matter if the returned image is to the north or to the south or to the east or west. The Doppler radar unit is stationary and treats all returning signals alike, regardless of the directional source of the returned signal. And thus, with the spinning ball Earth that we are told exists, we've got a big problem. You see, if the Earth is rotating at somewhere between 750 to 1,000 miles per hour to the east, depending on the latitude of the radar unit, the Doppler effect would be totally negated by the Earth's rotation. Any echoes from the west would necessarily be moving away from the Doppler unit at 750 to 1,000 miles per hour, plus or minus the actual speed of the moisture that's moving itself, while echoes to the east would be rushing toward the radar unit at the same speed. All the other angles in between would create an almost infinite and nightmarish computation for the radar unit to sift through in order to make sense of the echoes received. The bottom line is, there is no computation or correction for any Earth movement whatsoever. The radar unit interprets all echoes the same, regardless of the compass direction. Doppler radar would be a total impossibility on a moving Earth. It simply would not exist. It would not and could not work if the Earth is a spinning ball.
Before the start of World War II, German scientists developed a blind landing navigation system for aircraft. Essentially, aircraft tuned in to a certain frequency would know the location of the center of the runway by using a radio beacon as a guide. After World War II broke out, German military scientists soon realized that the same technology could enable German bombers to locate specific targets in England even in the darkest of nights. This secret system was called Knickebein. In short, the radio beam from a single transmitter would guide the German bombers on a line towards the target, but one beam could not tell the bomber when they were over the target. A second transmitter was set up so its beam crossed over the target, indicating when the airplanes should drop the bombs. British intelligence, led by R.V. Jones, slowly became aware that such bombing beams may have existed, and presented the information to Frederick Lindemann, Winston Churchill's leading science advisor. But Lindemann and others said such a targeting system would be impossible, because the supposed curvature of the Earth would block the high-frequency beams, because VHF waves do not even allegedly bend around the curvature of the Earth.
Dr. Jones took the message to Professor Lindemann, his old tutor and now scientific advisor to Winston Churchill, and tried to persuade him of the serious threat posed by the Knickebein beams. But Lindemann was not convinced, pointing out that at the high frequencies necessary for an accurate beam, the curvature of the Earth would prevent its being directed against targets in Britain.
Lindemann was conceptually and mathematically right. VHF beams would require a direct line of sight with the German bombers, and England was simply too far away. The first of these Knickebein transmitters was set up on Stolberg Hill near Denmark. Another transmitter was set up at Kleve in western Germany. Stolberg Hill was located 443 miles away from Derby, England. The hill was only 142 feet high, and the transmitter was 152 feet high for a combined height of 294 feet. Based on the globe math, the Earth's curvature would hide 118,425 feet. The other transmitter was in Clava. It only has an elevation of 39 feet combined with a 100-foot tower. 139-foot height with a distance of 331 miles means that the curvature of the Earth would hide 66,722 feet. In other words, under the globe, a German bomber would need to be higher than 118,425 feet to be within the line of sight of the Knickbein system. But the maximum cruising altitude of a German bomber was only 19,200 feet. Without question, it was impossible under the globe for those German bombers to be within line of sight of the Knickbein towers. But Knickbein did work, and English lives were lost as Churchill's scientific advisors couldn't believe in the VHF Knickbein system when the Earth's curvature should have made it impossible. Very high frequency requires a direct line of sight. Wikipedia confirms the same as it reads, as the transmitters were more or less in line of sight to high-altitude bombers. This article here confirms it as well. But as I just showed, Wikipedia lied, as German bombers would have been nearly 100,000 feet below the globe's geometric horizon and certainly not within line of sight of the towers. There you have it. Only under the Flat Earth model could the Knickbein system work, and the globe propagandists have no counter-argument but to lie and claim that the bombers were somehow in line of sight of the Knickbein towers when that would have been mathematically impossible. German bombing beams proved there is no Earth curvature.
is knowing enough about a subject to think you're right, but not enough about the subject to know you're wrong.
These large flat areas were called the Sea of Tranquility. Okay, that's where it gets its name.
Nice.
And all the seas were named after psychological states or physiological states. So there's a Sea of Fecundity. There's a sea.
Oh, all right.
Right. Yeah, right. So there's anyway, but so they're flat because lava in liquid state flattens out. Right there, you go.
Okay.
All right.
When Alan Dulles brought in all the Nazi scientists and so forth, they went to two places. They went to CIA and they went to the National Aeronautics and Space Administration, which in our world we call it not a space agency.
And
as Kathy O'Brien has said so clearly, that's where the bulk of the mind control has been done.
Why has nobody been to the moon in such a long time?
That's not an 8-year-old's question. That's my question. I want to know, but I think I know. Because we didn't go there, and that's the way it happened. And if it didn't happen, it's nice to know why it didn't happen, so in the future, if we want to keep doing something, we need to know why something stopped in the past that we wanted to keep it going. But I think I know. Because we didn't.
I remember my parents waking me up, and we went down and we watched you guys land on the moon.
No,
which
you
was
didn't. No, you didn't.
What?
Because there wasn't any television. There wasn't anybody taking a picture. You watched animation.
What is gravity?
You have no idea. Okay, next question.
I don't know.
Nobody in the entire world knows why that falls.
So what is pushing this?
Here. Why does that fall?
Newton didn't know.
We can describe it pretty accurately, but no one knows why.
We can describe gravity. We can say what it does to other things. We can measure it, predict with it.
I don't need a computer to get a kid interested in that. To spend a week playing with gravity and trying to understand it and come up with reasons why.
So what is pushing this?
Nobody knows why.
So Newton simply threw his hands up and said, I don't know. So I'm going to invent something called gravitational pull.
Science, we always say that you make observations, you have a theory, you go make more observations, and it's a very, very tedious process. Wrong. Nobody that I know of in my field uses the so-called scientific method. In our field, it's by the seat of your pants. It's leaps of logic. It's guesswork. It's guesswork. It's guesswork.
The internet. In almost every case, I'm talking about the universe, black holes, the Big Bang, time travel, God. But what I'm going to do in this masterclass is teach you how to think. The goal here is to train your mind how to see the world differently, how to question what others say. Oh, by the way, you didn't ask, but I'm going to tell you. Do you know how high up above the Earth he was?
No.
So if you take a
63 miles.
Oh, yeah, say right. So take a schoolroom globe and ask how high above it is he? So he's about 2 millimeters above the surface of a schoolroom globe. So nobody has seen the curvature of the Earth from that height. I just want to make that clear. Earth is slightly flattened at the poles and slightly wider at the equator. We might have said this on another explainer. Right. So we're oblate. We're sort of hamburger shaped rather than prolate, which would be hot dog shaped, stretched pole to pole.
Okay, so who wants to talk about weather manipulation?
What did you say? Market manipulation?
No, weather.
Can be curving at 8 inches per mile squared and have lasers being shot over it at 25 miles and have it hit the target at the other side 2 meters above sea level. That can't happen.
Okay.
That's the whole point. That's the crux of this whole thing. So if you do have that, I'd be interested to see it.
Well,
if you don't, that's fine, because no one else does. No one else has that. So you wouldn't be the first. Don't worry.
Yeah, I know, because, I don't know how to explain it to you, but,
Well, what? What do you mean?
Okay, okay, you're right. You've done your own, and okay, so you're saying you've done the experiment.
No, I didn't personally do
not you. Yes, I know. People done the experiment.
Yeah.
And they say, well, this happened, and so the Earth is not curved. But other people have done it, and it worked for them. So it's like,
who did that? Where? Who? When?
Yeah, that's what we'd need to see. But you're right. If that were the case, then we would have to compare the two and say, right, which of these bodies of evidence is stacking up and is legit? Because both of them cannot be true. So if you think someone is doing the same thing that we're talking about, and it is actually showing 8 inches per mile squared, remember it has to be a very specific rate based on the size of the ball they tell us, then please post it. It'd be very interesting. We're all waiting for this one.
Okay.
Because that would shut the whole server down, bro. Be careful. But let's see it.
You can go and get it.
Well, I don't have I know people have done it, and they have videos on YouTube. No, they have videos on YouTube on both sides, whether it's flat, whether it's
so
not.
There's a couple on YouTube like Discovery Channel, National Geographic that claim to have done this, but when you examine the videos, you can see where they've misled. And also, the videos that you'll find on YouTube are like 5 to 10 minutes long. They're little reality show puff pieces. They're not scientific papers. They're not academic studies or well-documented experiments.
But look, not everything in theory works. You should know that, right?
No. But this is different because this isn't supposed to be a theory. This is supposed to be reality, remember?
Yeah,
in reality, it's supposed to be curving at 8 inches per mile squared. So, in reality, as you agreed, a laser would be able to evidence that. A high-powered laser, when referenced against the surface that it's being shot over, would demonstrate convexity of 8 inches per mile squared. That's very measurable.
Yeah, and you'd also have to tell the militaries of the world to use laser targeted devices from vessels at sea.
But where's...
I haven't finished.
Okay.
I'll start again. So you'd also have to talk to the militaries of the world who use laser targeting devices from vessels at sea, using lasers to target ground-based targets at over 100 miles away. Now, the laser aiming device is only 40 to 60 foot above the surface of the water, shooting a beam at over 100 miles to target something that they can shoot the shit out of. So we can use lasers to hit targets at 25 miles, but practically in everyday use by the militaries of the world when they want to blow shit up, They use laser targeting devices from vessels at sea, over 100 miles. This demonstrates the practical use of a flat surface. Otherwise, the militaries of the world wouldn't use this shit.
You know that they use satellites, right?
No, they... yes. Right, you didn't listen to what I fucking said, so I'll restate it.
No, okay, I've listened.
Laser targeting devices, beam pencil lasers, RDF, requiring a direct line of sight from a targeting device from a vessel at sea. The targeting device is no higher than 40 to 60 foot over the surface of the ocean, hitting targets over 100 miles away that are ground-based. This requires a direct line of sight from the targeting device on the vessel. Nothing to do with satellites, mate.
Okay, I see what you mean. You're saying that people, cruise ships, and other military things are shooting weapons
Laser
from the ocean.
Targeting devices requiring a direct line of sight at over 100 miles from a vessel at sea, no higher than 60 foot above the surface of the sea. It requires a direct line of sight. You're not going to get a direct line of sight over 100 miles from 60 foot above the surface of the ocean hitting the ground-based target because the curve of the Earth will get in the way.
What did you say at the end? You cut off.
The curve of the Earth will get in the way.
Okay. So this is what I understood from what you're saying. Tell me if I understood something wrong. So you're saying that military are like they're using lasers to aim from more than 100 miles away on a ground-based target. That is correct, right?
That is correct, yes. Laser targeting device.
Okay. And do you know what's the height that they're using?
The height, yes. For the fifth time, no higher than 60 foot above the surface of the ocean.
No higher than 60.
Yeah, think how big a boat is. I mean, I could literally give you 200 foot above the surface of the ocean if you want. It's still not going to make a goddamn difference when you're aiming at targets 100 miles away, mate.
Okay. So I don't know how to reply to that. I'll be honest, okay?
Yeah, that's absolutely fine. What I'm trying to demonstrate is the practical use of lasers by if they use them to blow shit up or help target things to blow shit up, then they wouldn't use this if the curve of the Earth was going to get in the way, would they? Wouldn't work. Because there'd be a finite limit to how far you...
Okay, I see your point. I see your point. It's impossible to use that type or to use it in that way unless it's a flat Earth, right?
Require a direct line of sight. You won't have a direct line of sight
if the Earth is curved. Okay.
No way.
So the military is not using the curvature of the Earth into calculations to make their laser work. So they're thinking in a level plane, in the level water.
What? What do you mean leveled water?
There should be a mile of curvature at 100 miles, over a mile of curvature. It's not there.
Okay. I also don't know how to. I don't know how to respond to that. I'll be honest.
Yeah, it's a big thing. It's a difficult concept because this, if true, what we're telling you, and you should check this for yourself.
Yeah,
literally destroys the ball.
Definitely. I guess
they both can't be true. They both cannot be true. The surface cannot be being measured flat in the way that it is at the distances that it is if it's curving at 8 inches per mile squared, which is what they tell us it is and has to be if it's the ball that they tell us it is. Like I said, this is the crux.
Yeah, my only point of the sun was you guys asked, like, how does it work? Like, I don't think anybody knows. We can tell you its path, what it appears to take, maybe from one location, but from multiple locations, it becomes more uncertain where it is. I mean, it's within a range, you know, like it's not like way off, but it's off a little bit. So it's hard to draw conclusions when you, with a certainty, geometrically position where it is at all. This is
What
in the
about-
gold model. So
Yeah.
people have done this in AutoCAD. Seriously, people have like taken the winter time and day in SunCalc and took those elevation angles and tried to intersect at where they said the sun was supposed to be, and they could never get it to work in AutoCAD, which is like 8-digit precision.
What about like the moon?
The moon?
Yeah.
I don't know.
You don't know?
I don't fucking know, man.
Hey,
these are things we can never really know the true causes or what they do. They're intangible to us. All we can do is look at them.
But there's an explanation to it already.
I mean, but they're not really scientific explanations.
They are, actually.
So why are they better than the stories that they were told, what the moon and sun were before? Why are those worse stories?
Wait, what?
Before the Copernican model, right? They told stories about what the sun, moon, stars, all that shit, where they had convoluted stories about what they were. So why is that any different? They couldn't touch the sun. The only thing they've done that's different is they've said, this is mathematical. We can make predictions. Our story's right because we can make predictions because we've attached to the variables, we've attached names, places, things called physics. You know, there's a guy named Oliver Heaviside, and he was a self-taught mathematician. He invented vector analysis, and he tells it. He starts one of his books with this little story. Says it was once a joke upon a mathematician when he took his symbols for realities as S for the sun and M for the moon, meaning the variables and equations are not the realities. We can predict things with, you know, motions of bodies, motions of objects, and all sorts of physical events, but it doesn't mean the underlying theory which we attach these variables to is correct or true.
But like at least,
and I can give you a literal example of this with the Mayans. Now, the Mayans predicted the transit of Venus better than the Copernican model, better than any other model. But their story that went with their prediction was Kukulkan, who was a dragon, right, was going across the sky. So because their predictions are better, should we believe the Mayan story of why Venus is transiting the sun at this particular time?
Wait,
you see what I'm saying? Do you understand what I'm saying? Like, they had a story, they had math, they had predictions. They had a different story, which we find implausible.
But what do you have? You just say like you don't know, and it's like that's all you're saying basically.
Because I'm taking a position of natural philosophy.
Okay.
But what about
the only thing you can say that is empirical and really know are things you can deduce from systematic experimentation and determining cause and effect relationships.
What about solar eclipse? How is that possible? Yeah.
Well, what do you mean possible? It happens, so it's possible.
No, how is it possible with like the flat Earth grid? With
what makes you think that the solar eclipse is associated with the geometry of the Earth? What is the connection?
I'm confused.
What makes you think that is connected to the geometry of the Earth? What is the connection? What's the logical connection? Okay, there's just the sun's in the sky and a black thing goes over it and it turns black. Where's the logical connection between that observed phenomenon and the shape of the Earth you are on?
That's what I'm asking. Like, what are you trying? What point are you trying to make?
It's like on.
I'm trying to make the logical connection, dude.
No.
You're
on the
acting
model.
like the shape of the Earth has to have some relationship to that event. Why does it have to have a relationship to that event?
I'm trying to explain it. Okay.
Okay.
So in the model, you see like the moon and the sun circling, right? And they like never get near each other or nothing, right? And how is it possible for like the sun to like overlap the moon if it's like that?
Okay. Let me ask you one
Listen,
thing real
I don't
quick.
know if Retch, are you on?
Why doesn't everybody see the eclipse at the
Hold
same
on.
time?
Retch actually has. Listen, Retch actually
Because
has
you're
a model
different
that
places,
demonstrates it.
and it's a globe. And if you're on the other side of the globe, you're like, you can't see it because,
Exactly.
you know, yeah.
I'm just trying to argue my side of the story. So, if you're saying that the eclipse is a thing that somebody controls, why doesn't everybody see it at the same time? I don't know.
What are you talking about? Nobody said that.
Okay, well, you were talking about
Are you
the
on
eclipse.
drugs?
I'm
Are you
definitely not
drinking?
on drugs. Nope.
Are you drinking?
I am not.
Then where the hell did you get that from? You can't even answer a simple question on the logical connection between the object in the sky that you see, an observed phenomenon, and why it's connected to the shape of the Earth. It's a simple question. You think it's a foregone conclusion, which is obvious. I'm saying it's not so obvious. So tell me, what's the obvious connection? What would lead you to that conclusion?
You have a good point. No, I'm saying you have a good point, right?
What was the question again?
We don't know. We might not know what it is. We could be assuming everything. I don't know.
Listen, do you think, even Copernicus, wrote, we can never attain the true causes. We can only make models and make predictions of past and future events.
Mm-hmm.
Okay, so even he said that, and you're talking about the Copernican model. You can't attain the true causes of events like eclipses, solar eclipses, any of that stuff. Seasons, because they are visuals, right? They're visuals. You just look at them. Can't manipulate them.
How are
They're not
seasons
tangible.
visuals?
They're visuals, so you just see them.
Right.
Have you done anything other than see the moon? Have you done anything other than look at the sun? Have you done anything other than look at Mars, Venus, Jupiter? Have you ever done anything other than just look at them?
No.
Okay, then. So they're just visuals.
Right.
Okay, so with the Earth, we're talking about something that's tangible.
Like seasons.
The Earth is certainly tangible.
Seasons are not. They're not.
Right.
They're not visual. Seasons are not visual. You can actually like.
Seasons are a correlation theory, and there's two things of seasons. So there's meteorological seasons and there's astronomical seasons, and they're loosely correlated depending on where you live.
Okay.
So meteorological seasons lag what's called the astronomical seasons by some amount. Could be 2 months, could be 3 months. It depends on your climate. So there's a loose correlation there. Right. It's attributed to the tilt of the Earth, but that's probably in doubt because it could also be the length of day. So the exposure to sunlight, the angle of the sun is irrelevant if the day is 3 hours longer, right? So saying it's the tilt and it's the angle that the sun hits the Earth, how is that proven if the sun is actually in the sky for 3 more hours? See, these are like little stories. It's like it's your interpretation. These are philosophical issues. They're nowhere even near scientific. But to get to the matter, the real crux of the matter is what's the shape of the Earth, right? It's not even a science question. It's only a question of measurement. Just like what's the shape of your table? What's the shape of your house? What's the shape of your head? Right? You don't need a scientific theory for that. Do you?
Well, because
what's the shape of my table? Well, we come up with this theory.
Well, we know, right?
That's different because
it's different, right?
We know the shape of my head.
It's different than science. It's different than science because it's a different type of question. It's a what is this question? It's not a why is this question.
Okay.
So we can do that with the Earth. We can solve this what is question by just measuring it directly without appealing to theories and hypotheses and just say, hey, let's take a tape measure and figure it out.
Mm-hmm.
People have like.
So we've done that. That's what I don't think you get. We've done
They
that.
have measured it, and like people don't do.
We've measured significant portions over large bodies of water, and there's no measured curve. Multiple times in multiple countries by multiple people using multiple methods.
Okay. Well, I think that there's no measured. Well,
No, there's measured curvature. I guess it's just like depends upon the way they interpret the data that they get.
Yeah.
Well, I'll tell you how they do it.
There's definitely curvature. No, they've measured curvature for sure.
You think so?
Oh yeah.
Measured curvature. Oh, here we go. I knew I was going to wake your ass up.
Can somebody explain to me what's going on with that picture?
Any Globers come in with information claiming that Earth is a ball? Or, yeah, just any claims that Earth is a ball? Because it seems like all the science that we have is pointing to Earth. Well, that's not science. Measurements are showing across the entire plane that it is indeed a plane. I like what someone put here about the Doppler effect. Yep, I knew someone would drop that. Drace, good job. I was talking about Doppler effect yesterday. So you would not hear anything the same as we hear it now if Earth was curved and in motion. Nothing would be the same. So that's what I want to hear. Is how the Globe Earthers, please present your claim as to how things should be different than they actually are on your globe, because they're not that way anywhere.
Good morning, Sonny.
Good morning.
From the globe. So we could just say that it's a belief that you have from the measurement, right? That you trust whatever source gave it to you, that you're saying, okay, well, it's legit, right?
No, I could go out right now and test it if I wanted to, but
Right, but
now,
you haven't, right? But you haven't, so it's still a belief at this point, right now.
Well, sure, but I mean, I'm listening to like the biggest scientists on the planet. They're not just lying to me.
Yeah, no problem. I'm just gathering what you know. So point number one, the Earth's curvature being measured would be just a belief in your mind for right now. So we'll move off to point number two, which is axial rotation, either being measured or tested to be true. Is there any way that you know that axial rotation is a reality that can be measured, like that you know that the Earth is spinning?
Well, we know the Earth is spinning because it spins at 15 degrees per hour. We already know that because of Bob.
Oh God, I knew that was coming.
Yeah, hang on, Bob. Hang on, Bob. I know you're in the chat. Just hang on. Let me get through here with this guy. So
because
said he's not new.
Okay.
well, I'm in high school, so I should know this now.
You name dropped somebody you didn't know was in here, but Mickey's gonna finish the conversation with you real quick. Please just be honest and concise.
Well, I didn't know this was filled with like the biggest flat earthers, but whatever.
Let Miggy do it.
Just let me. Okay, so you said that because Bob presented some information, and you didn't get this from any source like a textbook or a teacher told you. This was strictly from a Netflix video that you saw. Is that correct?
From multiple sources, yeah.
Okay, so what would be the primary source of your knowledge from the axial rotation of the Earth spinning, Spooky?
Well, from the textbook, first of all, I already knew that from
right.
class.
So you read some. I'm sorry. Go ahead.
I was laughing at from the physics class. My bad.
So a teacher told you this, or a physics class that you took, some information that you gathered that the Earth is spinning on its axis is how you obtained the understanding that it is spinning on its axis, right?
Well, I'm just saying, like, your model, it doesn't really work out with day and night.
Model? Sure.
See, the sun...
Yeah, one second, guys.
See, the sound...
One second.
The sun
Go ahead,
is...
Spooky.
the sun is round. And in your model, it only shows half the Earth illuminated, which doesn't make sense because the sun is a ball. And
all right, cool. I understand. But we're sticking to, like, what you know and information. Just give to me what you know from how you got the understanding that the Earth is spinning on its axis. That's all I care about. I don't really care about anything else but what you know, the information that you can give me, how you know the Earth is spinning on its axis. And from what I gathered, it's from some physics class that you took, right? Is that correct?
Yes.
Okay, so not any direct measurement that you have done, but somebody somewhere on that you got told from your physics class had gave you the information that you know that the Earth is spinning on its axis. So what I'm alluding to here is that it's a belief that was given to you that you haven't verified thus far. So right now, the understanding that the Earth is spinning on its axis was given to you from a teacher, through a textbook, however you got it.
Yeah, but those were done through experiments from other people. They're not.
Sure, right. So what you're doing here is you're taking information, on face value that they've done their due diligence and they gave you that information via some kind of experiment or something. So right now you're trusting these sources, correct?
But why wouldn't I trust these sources?
No, I'm not.
Scientists.
Yeah, I'm not. Hey, I'm not disputing that. So the information that you're gathering right now to you, as far as you're concerned, is just a belief because you trust them. It's a whatever you want to call it, justified belief or whatever. But the root of it would still be considered a belief because you trust whatever.
No, it's a known fact.
No. I'm talking about what the information that you've gathered is a belief.
The information that I gathered is a known fact.
Okay, sure, whatever, but it's still a belief because you haven't measured it. You haven't verified it yourself.
That's what I'm verified. 10 other people besides me verified.
Right. Yeah, I'm not, like I said, I'm not debating with you on this point. I'm trying to establish is either it's verified by you or it's a belief that you have. So right now it's just a belief because somebody else did it. So that's all I'm getting to right now, just the information that you know. Spooky, I'm not debating with you. I'm just saying,
stop trying to debate him. He's not trying to debate you, man.
Yeah. I'm just getting the understanding that from what you know, it's just all belief right now. It hasn't been something you verified. That's all I'm just getting to right now.
Yeah, I guess so because I don't have 15,000.
All right, cool. Yeah, thanks. No big deal. No big deal. You don't need a reason. It's all good.
All right. So point number 2.
Let Mickey do it, will you?
Point number 2 is that axial rotation is just a belief you have because via whatever information you gathered that you think it's spinning on its axis. So point number 3 is that the vacuum of space is a medium that we could travel to, or that it actually exists. Now, is there any information that you could give me? Remember, no right or wrong answer, just what you know as to how far you can verify that when you look up at your night sky, that it's actually a vacuum that you're staring at when you look up.
Well, we could see that because we're not talking about a vacuum cleaner here. We're talking about vacuum means emptiness in our case. So there's nothing there.
Okay.
Yes, so it's a physical place we could travel to, yes. Because there's nothing, no air, no oxygen molecules, no nitrogen molecules, nothing like that.
So. None at all?
All right, so everything
maybe 1 or 2, per 1,000 kilometers, maybe.
Sure.
Around.
So all this information is verified by you. You said, like, you verified it to be true that when you stare up in your night sky, that's indeed a vacuum. Absolutely, 100%.
Yeah, because I have a telescope, like one of those 10-inch wide telescopes, and I've watched the International Space Station fly past the moon. I'm just saying it's
So
not
you're
fake.
Right. So you're seeing things from the ground, and you're believing that the sky is a vacuum. Look, what I'm saying is, have you verified that it actually is yourself?
Well, geez, I haven't been to space, so no, I can't.
Okay. So no would be
you can't either.
Right. Well, I'm not disputing. This is the thing, Spooky. I'm not debating you. I'm just gathering the information honestly from your point of view as to what you know. So yeah, you conceded. You said I don't know. So right now, the vacuum of space being a reality to you is just a belief. So it could be that you're trusting sources or astronauts or whoever it is, but it's just a belief that you have that the vacuum of space is a reality and it's a medium that people can travel to. So I'm going to go ahead and round off the 3 points that I propose to you right now, that the curvature of Earth being measured either in ancient times or now is just a belief. Axis rotation, that you trust some sources.
But now you're twisting my words. Now I didn't.
No, I'm not twisting.
Hey, he's talking, man.
Let me finish real quick, Spooky. So this isn't, like I said, this isn't a debate. It's just gathering information from what you told me. So that's all I'm doing, repeating it back to you. And I'm kind of making it to where you can see all 3 points together. So the axial rotation point you told me is also something you learned from a physics class, and you trust those sources, so it's a belief. And the vacuum of space being a medium that we could travel to, or that it actually exists, is still just a belief. So the paradigm of the globe Earth as presented to you throughout your whole life has been a belief that you held strongly to, but it doesn't have any basis on known reality. As in, it hasn't been measured, you haven't detected it, and you haven't been there. So there's nothing that you could actually say right now that would justify a belief that you have in your mind.
Well,
so when you would move forward in the conversation, because we're going to open it up so you can ask any questions you'd like about flat Earth. But if when we open up the conversation and you revert back to trying to justify it, we're gonna let it known that what you're trying to do is assert your belief once again when it's already been known that you just believe it to be true. You follow me, Spooky? So it's not something that you could test and verify because you haven't done it yet. So you're just asserting a belief. So when we get into a conversation, which I'd like you to have with us, don't revert back to like, well, what about pictures from space or something? Because all these things are just rooted in your mind as just beliefs. So,
well, I have a couple. Yeah.
Go ahead. Yeah, no, I'm just going to open up the conversation now, but just to let it be known to everybody here that you did concede and said it was just a belief. But so if you cannot, try not to go back and try to justify these things as if they're actual known reality, because just right now you conceded to yourself that it's just a belief that you carry. That would be it. So I'm going to go ahead and open it up, and you can ask any questions to people here who would take any questions for Flat Earth. And if you want to know,
you mentioned Bob. Why don't you start with Bob?
Yeah.
Sorry.
I have one question only.
I didn't
fast
mean to
question.
Bob here.
I only have one question fast. Fast about Bob.
Yeah, I think he's right. We should let Bob cover that attack on him if he wants to.
I'd be more than happy to cover it.
Without interruption, please.
That's exactly what I was going to suggest. This is going to be awesome.
Okay, so obviously you don't know me, right? You only know me because of what you saw in Behind the Curve, correct?
Yeah.
Okay, and from what I said in Behind the Curve, you took that and interpreted it as, what I was saying is that the Earth was spinning, right?
Yeah, you said 15 per 1 hour and 15-degree drift.
That is correct. That's exactly what I said. And you know what? I wasn't lying. That's exactly what we registered. The problem is what the producer interpreted that and actually cut the editing to make it look like. So would it surprise you if I told you that, I completely agree with everything you just said. I absolutely did say that. But unfortunately, because of the way the producer twisted that around, I was not seeing 15 degrees per hour of Earth rotation. Now, do you want to know how I know that?
Because your gyroscope, your like $40,000. What was like? How much was it?
Well, first of all, it wasn't my gyroscope, and second of all, I didn't do the initial test, but I got credited with that, so I'm just gonna wear it, okay? But we took that gyroscope, and like I said, when we first plugged it in, we got a 15 degree per hour rotation, and actually, it wasn't specifically 15 degrees per hour. It would be an interpolated value, taking the sine of the latitude times 15 degrees per hour, which would kind of equate out to that. Okay, so let's make that perfectly clear for one thing. But secondly, when I was in the movie, at that time when I stated that, I had no idea. I was just as surprised as anybody else, and I was very reluctant to accept it because I was trying to interpret, exactly what we were seeing. And I came to find out later on, and by the way, I did tell the movie producer this, exactly what we were seeing had actually been measured and discovered over 100 years before in what was called the Michelson-Gale experiment, right? The rotation of the luminiferous ether. So at that point, then what we were faced with is we had the challenge of, well, how do we prove that it is not Earth rotation and was in fact the luminiferous ether? Now, some people, and I'll even say even in this panel, don't believe necessarily that the luminiferous ether exists, but there's also a lot of Nobel laureate, physicists that say that it does, and it's, there's a big debate on it. Let's just put it that way. But by using that very same gyroscope, whether you believe in the ether or not, we actually devised a way to tell us whether or not it was in fact Earth rotating, okay? And it was really pretty simple, right? So first of all, do you understand at all how the fiber optic gyro works, how laser interferometry works?
Well, not really, but I mean, I get the gist of it. I get how a gyroscope works and how the gravitational pull works on it. And then when there are spins, there's different, it marks one spot and then it calculates the time interval it takes. Then it calculates the angle, how much is the angle is like changed.
Well, that would be for a gyroscope, yes, but a fiber optic gyro works a little bit differently. It works on something that's called the Sagnac effect. And the Sagnac effect is basically, it goes under the assumption that if light is traveling through a medium, right? In other words, they speak of light as a wave, right? So you have to ask yourself, well, what is a wave? What is it waving, right? What is it traveling through to cause that wave? What is the medium that light is actually waving, right? Well, scientists have been saying for centuries that it is in fact this luminiferous ether. And that is what I actually wound up claiming that it was that was actually rotating, the luminiferous ether. Now, here's how and why I came to that conclusion. So we went back and we looked at these experiments from over 100 years ago and the assertions about the Sagnac effect and laser interferometry. And it turns out that what they say about the luminiferous ether is that it rotates very much, or it behaves very much like a magnetic toroidal field. Are you familiar with a toroidal field in a magnet?
Yes.
Okay, so the ether very much behaves in the same way. It actually is moving. It's not a stationary thing. It is moving, and believe it or not, it propagates vortexually, right? And it just so happens that vortex rate is about 15 degrees per hour. Now, again, how is it that we were able to figure that out and that it was not Earth rotation? And the answer is really quite simple. So if I'm taking, and this is, by the way, exactly what we did. So we took the fiber optic gyro and we went to a place in Colorado called Pikes Peak. And Pikes Peak is at 14,125 feet above sea level, okay? And we did our measurements there and we got essentially our equivalent to the 15 degrees per hour rotation rate from Pikes Peak. Now, again, whatever you want to call it, you can call it the ether or you can call it Earth rotation, whatever you want to call it, that's fine. But what we're trying to prove here is that it was not Earth rotation that we were picking up. So we did that measurement at Pikes Peak and we got a value for it, okay? And then we went down to eastern Colorado following the exact same line of latitude, right? And why we followed the exact same line of latitude, I'm going to tell you here in just a second. But we went directly east in Colorado on the exact same line of latitude down to just over 4,000 feet. And then we did another measurement, okay? So would you agree that if I am measuring something that rotates, or that measures spin, right, or a rotational rate, that it should not matter whether I take that rotation rate at the bottom of a device or at the top of a device, especially a spinning ball. It would be the same whether you took it right on the globe or an inch above the globe. Would you agree with that?
Yes.
Okay, and you would be absolutely correct. It would not vary at all because it doesn't matter where you would be, high or low, on that same latitude line. It is going to rotate at precisely the same speed. Well, here's the problem with that. What we found was that when we did the measurement with the fiber optic gyro at the 4,000 foot elevation, we had about a 1.3, 1.4 degree per hour variance from that done at the 14,125 foot elevation on Pikes Peak. Okay, so we thought, well, that's pretty interesting because that actually equates to be 26, 27 degrees per day, right? That's a huge number. So we did it again at a different place, Guanella Pass, and again, and again, and again. And we did it in several different places in Colorado. And again, each time we then went to its corresponding latitude line at a lower altitude. And every single time we got a greater than 1 degree variance on the two measurements. Well, why would that be? Well, if you think back to what I just said about how the luminiferous ether was always said to propagate, and this comes from the people that coined the term, Newton, Maxwell, Clerk Maxwell, all these people that talked about this originally, then all you have to do basically is visualize it as a vortex, i.e. like a tornado, okay? So if you are looking at a tornado and you look at it on a z-axis, right, then at the top of the tornado, right, it's rotating fairly slowly. And as you go down that z-axis down towards the ground, it rotates faster and faster and faster, right? So you have a considerably faster rotation rate at the ground that you do, from high up in the air. Would you agree with that?
Yeah.
Did I lose it? Okay,
Yeah,
good.
no.
All right. So that, again, is exactly what we are saying that the luminiferous behavior is propagating as, right? A vortex. So the problem here for the globe is that when you get a 1.3, 1.4 degree per hour, which equates to 27, 28 degrees per day, something like that, difference in rotation, then that pretty much tells you unequivocally that what we are picking up is not Earth rotation. And it is more commensurate with that vortexual behavior that science has always told us that the luminiferous ether actually behaves in this vortex, right? So we did this multiple times, and every single time, we weren't expecting such a huge variance. But, when you're talking 1.3, 1.4 degrees per hour, that's actually huge for 10,000 feet. So we can only imagine that number grows even greater if we were able to go higher and lower. But the most important thing is what it proved unequivocally is that what we were picking up was not Earth rotation. And do you see the logic behind that as to why we know that it wasn't Earth rotation?
Yeah.
Okay, so that's it. So whether or not, anybody wants to accept that it was in fact the luminiferous ether, as I claim, and as other people claim, that's up to you. But the primary goal here is to prove that what it did pick up was not Earth rotation. And in fact, when they did this over 100 years ago in the Michelson-Gale experiment, they had to do another experiment called Airy's failure to try and determine what exactly it was that was spinning. Was it the Earth or was it the sky? And so what they did was they devised a very simple optical experiment called Airy's failure, in which they measured the rotation rate optically with the telescope, and then they filled it, full of water. And, theoretically, that would slow down the propagation of light through the telescope. And then the idea is that if they had to tilt the telescope further forward, then the light would not be coming in at the correct angle. However, if they didn't have to tilt the telescope forward, then the light was already coming in at the correct angle of 15 degrees per hour, indicating that it is in fact the stars that are rotating and not the Earth. Well, guess what? Airy's failure, same conclusion. It concluded that it was in fact the star. So now not only do we have the FE Core's version of testing whether or not it was Earth rotation, but we also have Airy's failure from back in antiquity. And to this day, you still have people saying, well, we built these gigantic laser interferometers that are stationary and sitting in one place. And of course, they are going to be picking up a rotation, just like we did. But the problem is there's no way to falsify that if you cannot move that detector up and down on a z-axis to see if whatever it is that you're measuring is changing velocities at different altitudes or different z-axis. Okay, so that is how we know unequivocally that what we were not measuring was Earth rotation. And of course, because the producers of Behind the Curve did not want that information to come out, they skewed it and made it look like, wow, dummy flat earthers, they proved it, with their own equipment, and then sit there and keep denying it. Well, they didn't include the rest of the story, and that's kind of the problem that we have with Behind the Curve. And that's all I have on that, unless you have any questions.
No, I'm just wondering why. I mean, it's just weird why they wouldn't include it.
I'm sorry, it's weird why they wouldn't what?
Include it, because lots of people, I don't think you've told this to many people.
I have told this countless times. It doesn't get any press. And I told it to them, and I'll tell you why. And the producer even said it himself. They were all for giving Behind the Curve a fair representation until they went to the 2017 Flat Earth International Conference in Raleigh, North Carolina. Okay. Then at some point, I don't know, either primary or junior high school kid got up, expressed his beliefs in flat Earth, and he said, Clark, whatever his name was, Mr. Clark, that did the documentary production, said that he and Caroline decided at that point in time that this was too serious and they had to stop it. And they decided at that point in time that they then had to change around the theme of the movie to make it more of an anti-flat Earth propagation piece. Now, they said this in their own words. Daniel Clark, by the way, is his name. He said it in his own words, and he said the same thing to us. It's like, okay, now this isn't funny anymore. You've got kids taking this in, thinking that it's serious, and so now we're going to turn this around on you, and that's why they didn't include it. That's exactly what they told me, and that's what they are actually in public saying. Okay, so in other words, this flat Earth idea, this paradigm is so powerful that it will change lives. It will change everything about this world, really, that you ever thought you knew about it, and it exposes a lot of things, to a lot of people that they simply are not ready to handle yet. And so that is why they decided not to do that, and that's exactly what they told us.
All right, Spooky, Elon, did you have any questions for Flat Earth that we might want to engage any discussion on, or?
That was awesome.
Yeah, I really enjoyed that. Thank you for that.
You're very welcome.
Yeah, guys, thanks for letting him talk uninterrupted.
We get that all the time. You see how crazy that is, bro? Like you said, your instinctual response was, why would they do that? He explained their little story for it, but isn't it interesting that you came in here having a complete misrepresentation of what the actual stance was? Because if what they told you about it was true, which is that it's archaic, unfounded, and just preposterous, stupid, then they would never have to do that, right? And you've now got the context of just one of the misrepresentations, which was a Netflix film. Firsthand, you couldn't have got a better explanation, but this will be a reoccurring theme. This is because there is no debate against Flat Earth. Flat Earth is objective.
Yeah, the one thing I wanted to ask Spooky Elon is, If what Bob said is 100% true, and I completely obviously believe him, why did they have the opposite reaction that they should have had? So if this is true and it's serious, why would that force them to make it anti-flat Earth? Surely, as a well-meaning producer, when you discover that something actually isn't a joke, you should want to push it out more.
Well, I think a lot of that goes back to, people's cognitive dissonance. I mean, let's face it, flat Earth is an explosive subject. It completely screws with people's realities, and they simply, I hate to coin the term, but, it kind of goes back to that movie where Jack Nicholson says, you can't handle the truth. Well, a lot of people can't handle the truth. I mean, because this, what flat Earth actually represents is a change in paradigm that is so severe that it literally wrecks everything we've ever been taught for our entire life, And as flat earthers, we, it's much easier for us to understand things like, that these frauds are going on, like Sandy Hook being a fraud, like Boston bombing being a fraud, like 9/11 being a fraud. We see it over and over and over again, but this is a big one. When they're talking about, wow, we're not in outer space, we're not on a spinning ball, that there had to be somebody that actually created this place for us, which is a very logical and sound conclusion. It's just something that a lot of people can't handle. And by the way, there's a lot more evidence, to kind of support, not support, there's a lot of evidence, period. In fact, all the evidence pretty much supports the flat Earth position. I always talk about what I call the preponderance of evidence. And, when you look at the preponderance of evidence being that, we cannot measure curvature anywhere, we cannot measure spin rate anywhere, we cannot measure these very slight changes in inertia between perigee and apogee. People will say, well, of course you can't feel that with your senses. And maybe you can and maybe you can't. But one thing that they neglect to say at that point is that we have instrumentation that is absolutely capable of measuring those very, very subtle changes, right? They're called accelerometers. You have one in your phone, and they are so sensitive. Look into them. They are incredibly sensitive. And so we have all the instrumentation. It's not just the fiber optic gyros that are giving us this information. We have several pieces of test equipment that are, giving us this information. And going on behind that, then when you look at NASA and all of the frauds that they do, all the CGI, the fake pictures of the globe, the fact that we didn't even get a picture of the globe until like Apollo 17, right? You'd have to ask yourself, why in the world would that be, right? Why would NASA, admit to making CGI composites and not even giving us pictures of the globe when, if you and I went out to outer space, the first thing we would do is snap about 1 billion pictures of every leg of the journey, I mean, everything that NASA is doing is completely non sequitur. It doesn't add up. And when you start looking at it through the paradigm of, well, maybe because we can't go into space, and that the Bible just may be accurate in that there is a firmament up there. And I am a person that believes, that there is a firmament up there. And I say that not because of any religious belief, because I'm not a religious person necessarily, but because of the evidence. When you look at things like sprites and elves and discharges, and everything seems to cap off at this 100-kilometer or 62-mile limit, and all kinds of strange things seem to happen around there, you really have to begin wondering. And then, of course, there's also the NASA and the Army documentation that talks about the firmament that, of course, the ball earthers will want to, completely set aside and dismiss. Great, so set that aside, dismiss that, whatever you want to do. But there is still a mountain of this preponderance of evidence to follow to prove our position in flat Earth. And we can take apart the globe argument at every turn. So this is why. Yeah, exactly. Yeah, gas pressure without a container. Well, obviously there is a container. It's called a firmament, and the evidence for that container is quite abundant, frankly, and I've done several shows on this. So, there you have it. And that's just my take. I'm going to let some other people talk about this, but, that's just, my take on why I've gotten into this.
Bob, can I ask one question?
Sure, go ahead.
Do you know that somebody in human history made some similar or the same measurement you do on that movie, and if you understand, my English is not good.
Hey, Pagus. How you doing? Did you meet the sex robot?
Hooray. Hello.
Hello. Good morning or afternoon or
Good
evening.
morning.
Buenos dias, señor.
Yeah. You can hear me?
Yes, we can. It's been a long time. How are you?
Perfect.
Loud and clear,
Yeah,
brother.
it's fine.
Yeah, nice to hear you. How's it been since
Yeah.
we've seen you?
Yeah. Lockdown and everything hasn't been too nice. But it's starting to become easier. I wish I had more time to research. I feel like I can't really add anything to the debate right now because I
Right.
haven't had the time to actually do my experiments and such.
Okay. Well, it doesn't really take much experimenting. All you got to do is go out and measure. Oh.
Yeah. Yeah, we'll see what I find.
Measure across the lake somewhere. Yeah, it's easier said than done, right? I know.
But Pagus, have you taken the time to listen back to the recording?
Yeah, I've listened to it a couple of times. It's very fun. I like it.
So where have you been? Hiding out? I was talking to Pagus.
Hello?
Curious, like where he's been. You haven't been around. Where you been, buddy?
Yeah, it's sorry, my internet is kind of bad. So if it has disappeared, then you know why. But yeah, nothing really. I've been studying for school a lot.
Oh, I see.
This is the last semester, so I haven't had that much time, to be honest. So yeah, that's my life in a nutshell. But yeah, I was wondering a thing. If you might enlighten me, because I'm preparing to do the Cavendish experiment, and I remember someone disputed that and had a problem with it, and I don't remember what. And if you would be so kind and enlighten me.
There is no hypothesis for Cavendish experiment. That is not experiment.
Yeah. You just look at the scientific method and ask yourself, what is the naturally observed phenomenon? What is the independent and dependent variables? And what are the control variables? And then you'll know that that's not an experiment.
Well, just because you don't have a hypothesis, you don't have to have a clear hypothesis to be able to create a theory or a to get some kind of result out of the thing Cavendish was doing.
You have
The
you
thing
need to
is
have
with
the
the hypothesis.
variables. You need the controls to control the variables.
Yep. But with the hypothesis, the problem isn't necessarily the hypothesis itself, but what it links to. Like, for example, let's say you walk outside, right? Unless you see a weird thing or like a certain phenomenon that catches your eye, you're not suddenly gonna wake up one morning and be like, yeah, these are the results. It's a step-by-step process. You can't just skip a whole step. First, we need to observe a phenomenon, try to understand what it does, and yeah, like separate a dependent and independent and controlled variable, and then you can move on. You can't just skip a whole step because that's not logically sound at all.
Yeah, let me help you out a little bit. A scientific experiment is a hypothesis test. So if you don't have a hypothesis, you don't have any science.
Yes, so what is the effect that you're trying to prove the cause of with the Cavendish experiment? What effect are you seeing that you're trying to prove the cause of?
If I have understood the Cavendish correctly, you're not really trying to prove a cause. You're just trying to prove that the phenomena exists. Because the thing is, you've seen that, well, the Earth and an apple, like if an apple falls to the ground, the Earth and the apple attract, or at least the apple
doesn't.
to the.
Why apple falls on the ground?
Yeah, exactly. For some reason, the apple falls to the ground. They go toward. Yeah, we don't know.
We know.
But then, like,
we know.
Correlation is not proof of causation. The electrostatic force is 37 times stronger than claimed gravity, and you have not isolated for electrostatics with your so-called non-experiment.
Apple will fall because it's going through the air. Is that true?
That might be one explanation. I don't know. That's
because if it's water there, apple will not fall. It will float.
Yeah, but if you would go down, that's what we do now with the apple. But then if you would see, it might be because of buoyancy. That might be why the apple falls to the ground. That might be one explanation. Another explanation is that masses attract each other in some weird way. We don't know how. But that could be an explanation.
Listen, do you see apples falling down in real life?
Yeah.
Really?
Yes.
How?
If I go out on the...
when you look apple in the tree, let's say, how long need apple to fall from the tree?
Depends on the height.
Depends on the height, you are saying. Apple is growing on the tree, you know.
Yeah.
And now, how time need apple to fall down?
It is... that's just like classic mechanics. That's... if you have the height from the ground, that is equal to the acceleration times square divided by 2.
I'm telling you only that apple it's stationary. It's not falling down.
Yeah,
It's
Pagis,
growing.
he's not talking about the drop. He's talking about how long will it take for the apple to fall off the tree? Why is it falling off the tree? When it's
That's because
attached to the tree.
that's biology. That's
Okay.
because the apple grows old and the tree drops it because it wants to spread its seeds.
Ah, so you got the cause then.
That means the tree is doing that.
Yeah.
That means the tree dropped the apple, and apple it's now falling through the air.
Yeah.
That's the explanation. Because apple is more dense and it's falling.
Yeah, when I pick up a rock, I am the cause of the rock moving up, and when I drop it, I am the cause of the rock dropping.
What they need to start calling gravity is the stillness in between time and space. The mass between time and space that is still. That's what they need to call gravity.
No.
Hey guys, sorry, 2 seconds. 2 seconds. I've only got a couple of minutes. I just wanted to welcome Pagis back to the server. Pagis, good to see you. It's been a while. Everyone, be nice to Pagis.
Yeah.
Hello.
Pagis, there's a ladies' night tonight in 5 hours or something. So if you could join around then as well, the ladies would love to speak to you.
Yeah.
Just
I
letting
might
you
see
know.
if I'm up then. Yeah, thank you.
Cool.
Very
Welcome
kind.
back, bro.
Thanks. I'm glad to be here.
That depends if he's a ladies guy, if you know what I mean.
Yeah, no, he's legit. Pagis is good people. Anyway, I don't want to interrupt, but yeah, keep it chill.
Yeah.
Ladies, man.
Well, so
can I tell you simple? That apple, let's say that's on the ground. That apple, and now you're moving that apple. When you take that apple, you will move that apple through the medium, through the air.
Okay.
Because you're and that's the less dense things, You will move the apple from equilibrium because apple will not go through the ground because the ground it's more dense than apple,
Yeah.
And then you are taking the apple and moving through that air, what is less dense. And of course, if you now drop the apple will fall down because you move it. The medium it's in. Yeah, that now apple it's in the air, because you picking up the apple and you are dropping now apple. You don't have any phenomena here.
So, if I understand you correctly, the reason why the apple goes back to the ground is because it seeks equilibrium again. It wants to go back to the ground, to the equilibrium point.
Yes.
Okay, yeah. That could be one explanation. I don't deny it. That could be why stuff works. But it could just as much be because there's a force between masses.
No. Well, listen this. You can explain this with the how to say bucket, empty bucket. Drop the apple in the empty bucket, and it will fall down. Of course. Now fill the bucket with water, and drop the apple, and it will float.
Yeah.
Now take out the water, and apple will fall down again.
Yeah.
What I am doing in this case?
You're changing the equilibrium point.
I'm changing the mediums of.
Yes. And indirectly the equilibrium point.
Is that reasonable to understand why it falls?
Yeah.
That's
I agree. That works.
Pagis, do you understand how he manipulated the independent I forget which one is which. He manipulated one of the variables, just like in a scientific experiment, to show what caused the effect.
Yeah, but here's the thing, which I was trying to
the Cavendish
point
does
on.
not do. The Cavendish does not manipulate the variable it claims is the cause of the effect. So it is not scientific. Meanwhile, he showed you something experimental scientific, and you wanna wave it away.
But this was something I was trying to get to in the robot argument way back when. That just because we have manipulated a variable in some way and shown that we do this in this scenario, we got an effect. We can postulate and have a theory that is the reason why stuff is happening, but we cannot guarantee that is the truth. We cannot know.
We can show every time through experimentation, repeatable, measurable, every time show that the results are the same. You would need to show that there are exceptions to that.
Yeah. What I'm trying to say is that you can increase the certainty that our explanation is the true explanation.
It's not explanation, man. It's a demonstration. If I show you water boiling with the heat, I cannot speak after that water can boil also with if I put ice inside.
But one thing you could do with that,
because theoretically, if I put ice, also water could boil. Theoretically.
Yeah, theoretically, but that's kind of but one thing is, like, if you do something once, then maybe there is a correlation. If you do it twice, there's a greater chance of a correlation. If you, as you say, repeatable experiment, if you do it a bunch of times,
like with bucket, with water, you can repeat it every time, and every time it's happening. That why we need explanation for that is something else happening when we have proved that this is happening.
Yeah, so like we can, but to be guaranteed that the reason.
Because of that, I told you about water, how water boils. Why we need to speak now about maybe water boiling? That's good. Yeah, we can show that with heat, waters boil, but maybe that's not 100% true.
Yeah. So maybe the medium thing, maybe gravity.
Yeah, but maybe infusion.
You're not understanding, Pagus, that scientific method does not deal with correlations. We proved that heat under nominal conditions boils water. When we change those conditions, like we change the pressure, we notice that we can also boil water. So that is just an adding to our information that did not change in any way the fact that we established via the scientific method before.
Okay, yeah, that's try. I feel like I'm not explaining myself properly. Because then we can say in this, if we do let's say we put the water on my stove, and I put heat on, and I see that it boils. We can now say when I put heat on my stove, the water boils, and we can basically guarantee that. But we cannot say a certainty that is the only reason water boils. And we can't really say how it happens either. We can only see that I do this is the consequence, the result.
An effect.
Yeah, exactly. We cannot really talk about then we can postulate theories and different things, why it happened. But we cannot, through the experiment, definitely say that one of these theories is correct. We can only talk about cause and effect.
Yeah, but the theories themselves, if they're going to be scientific, they must be based in experimentation. They cannot be based in non-experimentation or pseudoscientific gadgetry that has nothing to do with science, and then claim it's all science. It's just pseudoscience.
Yeah, but isn't Cavendish more about saying a fact, stating that a certain effect exists, and then nothing more?
No.
Because the real thing that it does...
The effect of the Cavendish is only within the contraption. It is not existing outside the contraption. There is no attraction between gas molecules. There's no attraction between fat people. There's no orbits around them. It doesn't happen.
How do we know that it doesn't?
Because we observe that every day, all day, at all times. It's only within the contraption that they conjure up something that, by the way, if you're going to be doing it soon, so take note of that when you do it, it is as likely to move apart as it is to go together. So take note of that.
Okay, yeah, maybe I'll see that result. It will be interesting when I do it, because I haven't done it yet, so it's hard to speak about it. But
besides, it's a torsion balance twist. It's not actually. It's just the twisting of the torsion balance. It's not showing you anything that could be even related to attraction, because you're not controlling any attraction. You're not manipulating the attraction between these balls, showing that they attract when you put it on and don't attract when you take it off. You're not manipulating the variables. It's not an experiment.
Well, you are manipulating.
It's just someone creating a magic trick, and then telling you this is what it is when they don't have any control variables to control for effects that are far greater and stronger than the effect they claim is happening.
Well, there is one control variable. There is one variable which you change. It is the distance between the balls.
Yeah, you're not changing any variables and controlling any of the variables there. The electrostatic force in charge of the objects can make them attract and is 37 times stronger than gravity. It can also make them repel each other. So you have no way of isolating and controlling this known effect. So to try to equate gravity to it is preposterous.
No, I'm not saying that we're trying to put gravity onto it. I'm saying that we're trying to see that if there is a force between two masses, and if there is a force, does that depend on the distance between them?
You cannot just claim that there is a force when you have no evidence of there being one.
But isn't that the whole point of Cavendish, to show that there is a force by showing a motion?
Cavendish's point was to try to calculate the density of the Earth, and from that the weight of it. It's nonsense. It's pseudoscientific. It's not an experiment.
Yeah, but regardless of what Cavendish is doing with it,
I cut this from the someone else did, but I saved it. This is from his paper, from Henry Cavendish.
Yeah, okay.
Essentially, people talk about this and use this to try to confirm their bias because they believe in Newton and the gravity that was taught to them as children. But later on, when they go on in school, they learn that that's wrong and they need to replace it with Einstein. So this whole kerfuffle doesn't make any sense, isn't scientific, and isn't logical. So when you are going to do this in school, like you claim you're going to do,
no, I'm not doing it in school.
Be very aware of it. Are you you're not doing it in the school?
No, I'm doing it by myself.
Okay. That's interesting.
I have one question. Is that Cavendish very important? Very, very important or not?
Depends. I'm trying to do the experiment.
No, I'm asking, is that important for educational things that we understand the globe?
Doesn't have to be.
Is that one of the best, let's say, proofs what we can understand the globe?
I don't know. The only thing I will get out of it.
I think so because people are repeating that years and years and years now. But I have one interesting question. I never learned about that. You know, you need to search for that. You need to be in special, I don't know, school maybe to learn about Cavendish or blah blah blah. But we don't have that in basic education, you know, about sphere, because that will be so great, because we have one man who proved the globe, and he is Cavendish. You know, that should to be in the first class in the school, in my opinion.
Okay.
But it is not.
So
why we something what is proving and explaining so good the sphere we don't have in basic education? That's my question.
I don't know. I can't tell you that.
I don't know also. That's strange.
Perhaps.
Why? Perhaps we will have something what is good, keep it in secret, and it's good for educational system for kids, for example. Cavendish, like we learned about Einstein, like we learned about Newton, like we learn about Pasteur or Maria Curie or whatever.
Bagus, so how are you going to set up this Cavendish experiment that you're talking about? What is your setup going to be? Where's it at? What are all your controls that you're going to have in place?
I'm still like developing. I'm quite far from doing it. I know that I can borrow a space in one of the universities, where you can lock all the doors and the airflow and such and such. So that's good. So then there will be less airflow. I will try to check like magnetic fields. There's any like of that going on, and also like magnetic polar, like the magnetic strength of the object, to see if that's something that could be influencing. Yeah. I don't know.
So let me ask you a question. In the setup of the Cavendish experiment, I posted something in the live stream voice text right at the hour. Do you see that with the torsion bar and the 4 different masses?
Yeah.
So let me ask you a question. If there's any movement at all whatsoever with the apparatus or wind flow or anything like that, would you expect the smaller mass to move anywhere but towards the larger mass?
Well, with wind flow, it could move either way.
Yeah, it can move either way, right? So if you look at the setup, there's 4 different balls. This is how it's set up. You have two larger masses that are stationary, and then you have 2 smaller masses that are on a torsion bar.
Yeah.
So those larger masses are in the circumference of the swing of the 2 smaller masses, right?
Yeah.
So what movement within that apparatus would not be towards one of those masses, one of the larger masses?
Well, it can go two ways,
point
right?
Being any type of movement, the ground shakes a little bit, the apparatus shakes a little bit, you have any type of wind movement at all whatsoever, you're going to get the result you're looking for, because the only place for those 2 smaller masses to go is towards the larger masses, regardless of what direction they move in.
True, but it could go the long way around or the short way around, right? It could either, let's say it's 10 centimeters towards one of the balls, and then it has like 2 meters of swing to the next. And if I see that it moves like the long 2 meters, do a full swing, then I know that it's fake. And it's some other, then the wind or the ground shaking or anything, then it's not a force between the objects. Because
But if it moves the other way, then that's definitive proof that it's some sort of mass attracting mass?
No, it's not a definitive proof.
Then what are we trying to prove with this apparatus? Because that apparatus is always going to have a smaller mass going towards a larger mass, regardless.
No, if it goes the short way, and if we can see that the speed of the smaller mass increases, and if we can see a correlation, a effect between the distance of the masses and the acceleration, and if we can repeat, and if we can see that the same cause and effect holds true, we can then with quite high certainty say that there's some kind of attraction going on. It might be the electrostatic force, I don't know. Something is attracting them to each other. If that happens, if it follows the same curve, if the distance correlates to a certain acceleration, then I know. And if I can repeat it like 50 times or something, then I know.
So if you have a very weak wind current that you can't necessarily pick up, right? You're trying to control for it, and you have a very weak wind current that over time will eventually move those balls. If that is not completely eliminated, you will get a consistent result every single time.
Yeah, but then when I try to do the same experiment again, but with another starting position, another distance, and I see that the speed is the same, the acceleration is the same, then I know something funky is going on. Because it should change.
Not if you have the same wind current they had before.
Yeah, exactly. But if the speed is the same, then I know it's the wind current, and that's the reason.
Pagus, have you heard of convection currents due to heat?
Probably, but not in the English language.
Temperature.
I don't know. If it might be the thing I'm thinking about, then yes. But if it's not the thing,
essentially because the sun heats the building on one side, or there's a pipe that runs with heat in the ground or in one wall, it heats the air around that area, which causes movement of the air in the room.
Huh? Yeah. Well, then, what I'm trying to say, then I will see a movement, and it might be towards the short way. Then I will note down.
How are you going to isolate for that?
I can't isolate for everything. Hopefully, I will be able to, but I can't be certain. But then this is the way I will be thinking. So I look at the distance, and then I can see the speed, the time it took for the ball to go towards the bigger mass. And then I do the same with another distance. And I can plot this on a graph and see the correlation, the cause and effect between the distance and the speed. And then, if I repeat this...
Causation correlation is not causation. They teach you how to say 11th grade physics class.
Oh, no, I'm not talking about causation.
Well, you just said it.
Oh, then I said wrong, sorry. It's not my main language.
Okay, well, I mean, it's something that at least in English-speaking universities, they teach you that correlation is not causation.
No, obviously. I know that. I'm sorry if I said wrong.
Yeah.
I don't think you could ever tell an outside force by using this type of mechanical apparatus. I don't think it's possible.
How do we account for the failures?
We're losing you, Indio.
No, we use something like what?
You're fading.
It's really windy where I'm at. Sorry.
Okay, no problem. Try again.
I said, how do we account for no results? And how do we account for anomalous measurements such as if you use something that is so light, nothing should happen, right? So like Christmas bulbs. Let's say, Christmas bulbs that you hang on a tree, they're so light, nothing should happen, but there's a demonstration in the so-called Cavendish experiment where this happened. And I'll actually post a link to a video where this is tested and observed.
Yeah.
I don't know.
I don't know how you would ever control different contraction rates of materials due to convection currents, like the temperature changes. How would you even monitor that, let alone separate it? And then also, listen, Pagus, how would you separate the electromagnetic and the electrostatic forces that are inherent in all materials?
That is not what I'm trying to do. That is not the goal.
Oh.
The goal is to see if there is some kind of consistent attraction between masses. I don't want to discuss the reason why, but I want to see if it exists.
So it's not an experiment. So it's not an experiment because if you're not testing for cause and effect, then it's not an experiment. So you cannot have a valid hypothesis. So you're just playing with a mechanical device. That's fine. You can't claim that it's predicting or showing a result that's caused by some external force through this mechanical apparatus. It's not possible.
As I've said 100 times now, I'm not trying to prove the cause. I'm just trying to see if there is a effect, and if I do X, does Y happen? And if I can repeat that, then that's some kind of result.
Yeah,
Right?
that's cause and effect. If you do X, then Y happens. X is the cause of Y here.
Yeah. That's what I'm trying to see.
You're contradicting yourself.
Oh, yeah, sorry. But when you said cause, I thought you meant like the reason why. I don't want to explain it. I want to just state the fact if stuff happen. You get me?
Yeah, I get what you want to try to confirm. It's your bias. But the problem is...
I also want to see if it doesn't work.
The problem is you can't actually confirm your bias through this because you're not actually proving that mass is causing anything. You're not showing mass doing anything. You're just assuming that mass is causing something and will therefore do that on a larger scale. You can't even define mass, so it doesn't work.
Are we talking about Cavendish?
Yes.
Yeah. So what was he varying, man? I'm just wondering.
Well, hold on a second. We'll get to that.
All right.
So the point is, you're arbitrarily assigning the variable you want as the mechanism that's making the observation happen, right? So
no.
Yeah, you're just arbitrarily picking. Oh, mass is the property of matter causing this to happen, where it could be any property of matter that could cause it to happen, because that's the only consistent thing you're using. You're using a chunk of matter.
Yeah, I'm completely in agreement with you.
Yeah, but so why is the property called mass the causal mechanism?
I don't know. I don't know why people have done that. That's not what I'm trying to do when I will be doing the experiment. That's not what I'm saying. Cavendish might have said that.
I think it would be more interesting. I think this would be more interesting for you to set up the apparatus, do the experiment, record your result, tear it down, set it back up, record the result, tear it back down, and actually record the no results when nothing happens. But it's well known that the Cavendish so-called experiment fails a lot.
Yeah, that is what I will be doing.
What happens in science? You generate value. See, it's greater than chance, right? Yeah, I got a shit connection. It's windy as fuck here too. So
all right, you're good now, though. Right now, you're pretty good.
So
go ahead.
We generate a p-value to see is this greater than chance. We don't even know. We don't even know if it's just anything because of the amount of failures.
Yeah. That's exactly what I'm trying to get to.
I swear to God, if Cat published his stuff today, he'd never get published.
Mm-hmm. He'd be making toys for kids, for toy stores. He'd be making toys.
Yeah, but that's what I'm trying to get to.
Before you go on, I just want to add a little anecdotal thing to Cavendish, because before Cavendish made all this stuff, he also he was one of the people behind what we call Newtonian gravity, even though Newton didn't want that. He didn't postulate his theory. It was Cavendish and CV boys who pushed it and created it.
He was trying to figure out the density of Earth by weighing it. He wasn't trying to prove that mass attracts mass at all. Yeah.
And his number was wrong because he got the density of water wrong.
He did?
So it wasn't even correct. I think he used a value of 1.3 instead of 1.5 or something.
Okay.
Uh-oh.
Yeah.
So you got the weight all wrong then, huh?
Good 20% off or so.
Yeah, but I might be converting to you guys depending on what I find. I do not know what I will see. I might find that.
Bro. Go ahead. I'm sorry.
I might find that Cavendish is just like it's random depending on how many times I set it up. It will just show me a random result, and then I will note that down, and I will try it in a different location, and then I might say, oh fuck, it doesn't change in a different location, and then there is a high chance that Cavendish doesn't work. But if I see that it does work, then it might work. I don't know. It depends on the result.
What does it prove? What does it prove when you get an oscillation in the string or in the torsion bar? And if this is an experiment, what's your independent variable here? What are you varying?
My independent variable is the distance between the masses.
Distance? Well, are you manipulating the distance between the masses?
Yep.
With what?
I place the masses a certain distance between them.
There you go.
With a certain distance, and then I will note down the acceleration and the speed during the experiment to see how it moves, and then I will do this again with a different distance, and I will continue to do this.
But for pages, for this experiment, can you use bricks instead of metals?
Bricks?
Bricks. I think he said bricks. Yeah.
Bricks. Yeah. I could do that. I will change my my types of materials, because if it doesn't work.
Can you explain? I have a question in regards to this Cavendish so-called experiment. Did he assume that lead has no magnetic properties, or what?
I don't know. I don't know what Cavendish did. Yeah. I haven't read his report, and I don't care what he did. Because I will do it myself.
Do you know what lead magnetic properties are?
Well, you should care what his results were, what he was trying to do.
Well, I think we should encourage him to do his own test anyway. You know what I mean? I mean, that's nothing wrong with that.
What was that, bro? I didn't catch that.
I said we should encourage him to do his own test regardless.
Cut out again. Fuck, you cut out.
How about now?
I can hear you now.
I think he said we should encourage him to be doing his own tests. That's a good thing that he's doing.
For sure. 100%.
Yes, that's what I said. 100%.
Okay.
Yep.
Oh hell yeah, man! Do it. Change the materials. Change your distance. Stay methodical. Record everything, and man, share the results. I would like to see it.
Yeah.
If you get it to work.
Helium balloon.
But it's just as interesting if I don't get it to work.
See if
it's a non-Newtonian fluid. See what happens.
See if a lead ball is a helium balloon.
The problem is when you read literature advising you how to perform the Cavendish experiment, they explicitly tell you that it works the best with iron weights or lead weights, these two metals.
I wonder why, man. How come?
Yeah.
Why does it?
Because they have magnetic properties.
Exactly.
That
Electrical.
might be true.
Might be, yeah. It might be true, yeah.
Yeah. Lead has two opposite magnetic properties in the same time. The lead atom is diamagnetic, and the metal lead, when you have more than two atoms together, yeah, it becomes paramagnetic, slightly attractive and slightly repulsive. And because of these two opposite forces, the magnetic, the lead, the metal lead, is always attracted to itself.
Yeah.
Oh, okay, check this out, man. I can pull up I have an article, I believe it's from Popular Science, from like 20s, I think 1920s. It was a dude that built an apparatus. He was trying to prove emission theory of light from your eyeball. He built an apparatus with like hanging like metal like foil or something like that. It's inside of a glass evacuated tube, a big jar. And every time you would look at it, you would get motion, you'd get movement. You know, so people really thought it was emission theory. Now I don't know what the cause of the movement is of the hanging metal foil, but it moved.
Yeah.
You know, and it was published in Popular Science. You know, so there's a lot of interesting apparatuses out there, but we don't know how they work, what the cause is.
Yeah, and that's the same with the boiling water thing we talked about earlier. Like we could say we see a cause that it is that we put heat onto it, but it might just as well be that we put heat into it, have a certain pressure, and that we look at it. That it's also observed. That could be a thing. It's hard to disprove, and we might find out there it just works on Earth, and then it doesn't work on Mars because there might be different rules on Mars. We don't know because we haven't tried it there.
You'll never be able to either.
Yeah, but like we don't know, and that's one of the most annoying things, that we can't like be certain about anything.
Mars is the imaginary.
The idea is to try. You know what I mean? Try to be certain.
Mars needs women.
Nothing wrong with that. What? Mars what? Needs women? Yeah.
Needs women.
That's right.
Yeah.
So
Of course Mars needs women.
Why they don't go to Venus?
Well, that's where you get them from Venus. That's where you get all the hot chicks. Yeah, pick them up from Venus. You go party at Mars, right?
Send them out early so they can get a head start.
What can you find? What can you find in on Uranus?
It's usually very brown.
If you think about the Cavendish apparatus, man, like by hanging weights and varying the distance between them and observing acceleration, what can you conclude? What if it is the electrical attraction between the two metallic objects that's causing them to come closer together and oscillate?
Yeah.
What are you gonna do then? Because I can do that with electricity. I can 100%. I can pull metal objects together just by using electricity, no magnetism, just the electromotive force.
Right.
Will yank electrons out of atoms, no problem.
Yeah,
that's how strong it is.
You would have to separate that out too. If you were not measuring for that, you would have to be able to remove it.
Yeah, but as I said before, I'm not measuring for gravity. I'm only measuring to see if there is between masses, for whatever reason. It might be the electrons inside the masses, but between two objects, is there some kind of force? That is what I'm trying to see.
That's kind of a problem. If you're trying to determine any outside force, you are not going to be able to manipulate enough to determine that.
Well, that is
That's why I said
I
non-Newtonian
might
fluid.
be able.
non-Newtonian fluids, when force is applied to them, get more dense, become more rigid.
Mm-hmm.
So if there is a force, this oobleck would become more rigid.
Yep. And anyway, a determination of force, you have to be a force is a force because it's shown to be able to do work.
Yeah.
So here's the question: has anybody done Cavendish using different materials, right? So like steel ball and a lead ball, or like
Wooden
stone ball and like a bucket of water.
Styrofoam.
They don't advise doing that.
Just similar metals.
They advise
They're
you
gonna have
to
an
use
electrical attraction.
lead and iron. Yeah.
Yeah, but if I
What
have
if
the
things that
time,
are similar properties are just attracted to each other? What if like lead is just attracted to lead, etc.?
Yeah, lead is attracted to lead because of its magnetic properties. The lead atom is diamagnetic
Well,
and
what
the
if it's
lead
an unknown
metal
property?
is paramagnetic. So it always attracted to itself slightly.
hopefully I will be able to test this. But if I have the time,
You don't need to test this. This is knowledge.
yeah, but hopefully I can see the results myself, and I can see that how it changes between some materials. And
The
it
physics
might
of
be interesting.
magnetism already sorted out the magnetic properties of all the elements.
Yeah, but then I can see if it adds up.
Yeah, I just wanted to clear up. I think what Indio's point was actually not to do with magnetism. Just so I can understand from you, Indio. It seems to me like you were arguing that it could be that like attracts like is a separate thing from magnetism and from gravity and from everything else. Was that kind of what you were saying?
Yes, exactly. Like likes like. Did you hear me?
It's gravity, though.
Yeah, I don't know what it is, but it might
Statement
be.
by Feynman that for some reason, if you take water and there's and part of the water is ionized, it'll actually form like a barrier, even though they're supposed to be repelled by opposite charges. Be like two layers of protons, protonated water. Yeah, it's pretty nuts.
Are you talking about easy water? Oh, I think I know what you're talking about. But I don't know. It's not. It wasn't
it's like an
Feynman.
experiment you do if you put water between two charged plates, right, plus and minus. There will actually be a layer. So all the electrically charged water will go to one side, and all the positively water will go on the other side. But between that will be a layer of like charge. When they shouldn't be there.
Okay.
Yeah, I'll find the post. It's in his lectures on physics. It's pretty crazy.
Yeah, but I actually have to go right now.
Yeah, Pegasus.
It was very nice.
I'm sorry, Pegasus. I just want to tell you, I sent you a DM with Brian Mullins from Balls Out Physics about the Cavendish. I suggest you go ahead and watch that when you get a chance.
Yeah, thanks. I'll do that.
And sorry to interrupt your parting.
No worries.
I'm just slightly upset that I didn't get to talk to Pagus again, my old friend. But I hope you're doing well, Pagus.
Yeah, you too. Well, it was lovely talking to you, everyone. And hopefully we'll get to talk more soon.
Yes.
All right, man. Take care, bro.
Thanks, Pegasus.
Great day.
Nice hearing you today. Yeah, that's pretty awesome. Interesting.
India, what you were talking about with the water, isn't that called like a Gaussian field or a Gaussian barrier or something like that? Can be demonstrated like within a capacitor?
I just remember from listening to his lectures, him talking about it. I posted a link which talks about it as well. I can't remember what. I think it's the lecture on electricity and magnetism. So there actually is a webpage for it. I'll try and find that and post it too.
Cool, thanks. I'll take a look.
I heard that song in the background. Reach out and touch faith.
I don't want to know what this is. So there's people riding exercise bikes outside in this little courtyard to this gay music. Here, I'll take a picture for y'all.
Did anybody see I forgot his name. I'll pull it up. I think he had a TED talk about water and the interesting new discovery or whatnot. He calls it EZ or something zone, electrified zone or something like that. Where he made a pretty cool discovery. If you have like I think it was a hydrophilic, but if you have a hydrophilic material like a tube shaped in a tube, you drop that in water will actually start flowing. I think one of his buddies or something was playing with a UV light or something in the laboratory one day, and when the light came across the experiment or whatnot, the flow sped up, right? So anyways, he concluded that the UV light interacts with water and anyways makes it like flow. So in your veins, like your veins are hydrophilic. You know, they're not hydrophobic. They like water. They're not water hating. So just by having like those properties, you'll actually get flow. And if you give it UV light, the flow will increase for some reason, which was pretty fucking cool. I like shit like that.
That's interesting. Is that maybe why UV light can support cancer or help with cancer growth? Because cancer growth strives or lives on the blood flow to the cancer. So the more the flow, the more the cancer can grow.
Here, yeah. All right. So I don't think I've watched this lecture, but this is the guy, yeah, Jerry. Okay, copy link. He calls it the fourth state of matter. I'm sorry, of water.
Yeah, that's in the same website, isn't it? I just saw that. Semantic Scholar. Is that you're looking at the same thing?
No, I'm on YouTube. I know the guy Pollock or whatever his name is. Yeah, I've watched this lecture, or we'll watch a lecture about his work. Like, I don't know, 5-6 years back. So I haven't seen this one because it was posted 2 years ago. But his discoveries are pretty cool, like water-based batteries and shit like that. You know, that's where like his research can go.
Yeah, I heard about this years ago. I'll definitely watch this.
Yeah, man. Let me see if I could find something shorter. That's not an hour long. Yeah, here, the TEDx talk. Let's do this. Share this one. A lot more views and a lot shorter. So why not,
like
right?
Longer, the more.
Oh yeah, the nerdier fucking videos. But yeah, once you get hooked, yeah, you're like, where's the 3-hour lecture at?
Yeah.
But this one is decent. Like, yeah, it's pretty cool. Mainstream published shit, so it's nothing, on the fringe or whatnot.
I don't know. I'm just rather astonished at we're in modern ages. We've talked about high-speed interferometry. We've talked about over 100-year-old testing that was done with interferometers like the Michelson-Gale, Michelson-Morley, Sagnac. And I just, it eludes me why we have modern-day folk with supposed modern-day education coming here talking with us about sticks and shadows and parlor tricks from the 1700s. I'm flabbergasted.
I like that. Are you talking about Cavendish? Parlor tricks. It has to be Cavendish, bro.
It is parlor tricks, man.
It is, man. I agree, dude.
So what are you going to be determining with that apparatus? Mechanical phenomena. Great. That's not in the realm of natural science. So have fun with that, whatever you're doing over there, playing with your toys.
I mean,
That's what I'm doing.
I'm cool. I'm fine with that as long as like your outcome is legitimate. You know what I mean? Like it's directly correlated to the whatever it is that you're observing, right? Or the effect.
Yeah,
that's fine.
It has to have a cause and effect relationship somewhere. I mean,
I mean, like I said, man, I like the dude, like the emission theory stuff back in the days. Like, it was cool stuff, you know. It's interesting. Look at people built, you know, apparatuses and shit too. So you'll find a bunch of weird apparatuses that do shit. Doesn't mean that, you know, we know how it works.
Right. Like you can take an apparatus that's turning and then turn it into a reciprocating motion. So why does that happen?
Because you have a crankshaft that turns linear motion to circular motion.
It's a mechanical phenomenon. That's it. That's what it does. It's actually, that part is not a phenomenon. We actually know the nuts and bolts of why mechanics work. That's how we can use them so well, right?
Yeah.
Can anyone think of any kind of, well, let's see. I might be missing something.
What?
So what can you determine from mechanical devices? Is there any outside force that can be determined with mechanical devices?
What's the device and what's, like, you know what I mean?
Well, I'm just leaving it wide open. I'm just anywhere. Is it possible to do with any kind of mechanical device to determine an outside force? You can measure outside force, but can you tell what an outside force is? I don't think so. Not with a mechanical device.
Wow, what kind of force? Like electromotive? Yeah. We have actually galvanometers, named after Mr. Luigi Galvani. He used frog's leg tissue, like muscle tissue, as the electrical detector. You know, and you can just walk around and detect the different electrical activity in the air. And whenever you have thunderstorms, shit just starts flopping.
Wow.
The needle.
I never heard of that.
Oh, dude, Google it. Galvanometer. Cool, that's the first voltmeter ever. You know,
I've heard of that name, galvanometer, but I didn't know that's what he was actually doing.
Dude, Luigi Galvani, man, started all this shit.
I'll use frog legs.
Yeah, because that's what he noticed, right?
Who would have like?
You know, the frog's legs, like during electrical activity, like thunderstorms, they would actually move on their own without him like dissecting them, touching them. So he's like, okay, all right.
Something going on there.
Ghosts. Yeah, we got ghosts in the frog, which is electricity.
Mm-hmm. I don't know.
It's interesting because you can conclude from that alone that muscle tissue will respond to electrical stimuli at post-death. Like your muscles will still respond to electrical stimuli, which of course has nothing to do with the realm of what he was after. But that's something cool.
Mm-hmm. I'm more talking along the very thin, razor thin line of force, like
F equals ma. What's force, man?
What do we determine force with? How do we determine force? By the work it can do, right?
Pressure, which is force divided by area.
Buoyant force, yeah. There's one. I don't know. I'm just kind of spitballing here. You know what I mean?
Yeah. I don't mind Newtonian mechanics, so I like it.
I mean, you can take a helium balloon. You put a big enough helium balloon with enough helium in it, it can lift thousands of pounds, right? Tons. You know, the same thing with the buoyant force. You put a balloon with air underwater, it can lift things off the bottom. Hundreds of tons. Ships, as a matter of fact. Lift them right off the bottom with balloons. So, no, the glober's always coming in as, why does it go up? Why does it go down?
Man, honestly, it's a cool question, but it's a question of polarization in my mind. Like, why is it polarized this way? It's like, fuck, man, we found it this way. Like, we really did. So that's hard to explain.
Yeah, we just see it here all set up, working the way it does. I mean,
Magnets. Wow, why does the North Pole of a magnet attract the south of another? You know what I mean? That sort of shit's like, I don't know, man. And it's always towards each other. You know what I mean? It's like, I don't know. What the fuck? Why doesn't that change?
a lot of a lot of things with electricity that are very odd too, right? Yeah, that you could ask lots of questions. Why does it go? Why does the current go positive and negative? And then we have cases where in vacuum tubes it doesn't. Electrons flow the opposite way. Through my guitar amp, it goes the wrong way. AC is flowing opposite direction, away from negative towards the positive, all the way out through the speaker transformer. Wrong way.
Well, AC or a sinusoidal wave is just it's a circle expanded, really. If you know what that is, it's a what is it? Function of the circle, or what was it? You studied it in geometry. It has a name. All it is just you're plotting out where you are in the circle. You're taking the sine of that angle. That's why it's called a sine wave. There's also a cosine wave, right? Yeah, it's like there's a sine wave, cosine wave. It's just the mathematical plot of a circle, pretty much. Really, it's a circle expanded. That's how I understood it. I did well with that understanding. Like I aced all my classes, so it's fine.
So how is it possible that a smaller AC signal can be traveling from negative to positive against a high voltage DC current going from positive to negative? AC flows in there and flows the opposite direction.
I've got no idea. Ask Nikola Tesla.
Exactly.
I don't know shit.
I'm not an electrical engineer, but doesn't charge always flow opposite of like your current? Like you have a directionality to the current, but then the charge flow is always opposite of that.
Yeah, but by charge flow, you're not exactly talking about interjecting a AC current into a vacuum tube where there's already up to 400 volts DC, positive to negative, grounded. Then you interject an AC current, it flows the opposite way. I've never heard any good explanation why, but it does happen.
Yeah, don't. Explanations in electrical realm I shall not give at all. At all. Zero.
That's like
100%.
saying, because it can't be determined, because honestly, electricity is just like the sun. We don't know actually what it is. We have no idea.
But it's like words. You stick your finger in the socket, shit will kill you. Like you don't have to speculate anything. Touch it and see. Touch the invisible stuff. See what happens.
Yeah, we definitely know what it can do. Yeah.
Crazy, man.
But we don't know where it came from originally.
I don't know. You can say it all comes from the sun.
From the
sun worship.
All electricity comes from the initial source.
Comes from the one. Sure. Yeah.
Well, there's an energetic basis to everything, right? Like all matter is comprised of different varying charged particles, right? So, or various charged potentials. So everything is really energy.
What is energy? Yeah, I know. Yeah.
There's one of those unanswerables.
It's unanswerable. Yeah.
I feel like the realm of energy is where you start to blur the lines between the physical and metaphysical.
Absolutely. We can only kind of get an inkling of this, though. We've never really been able to touch it.
I think electricity is like the bridging gap in my mind. Like, okay, if we just use thermal energy, heat, okay, just to make energy simple for us, okay, unit of heat or a quantity of heat. Okay, cool, or an amount of heat or whatever. Well, it's not true because it's the amount of energy, but whatever. If you think of it this way, then electricity bridges the gap because with this invisible stuff, it carries energy in it. and I can transform the energy into like heat, mechanical, like motion, whatever I want. So electricity is like the true other side for me. It's like, fuck, we work with the stuff from the other world and we don't know what the hell it is. We don't know what it is. But we can manipulate it, but we don't know what it is.
Yeah. It pops its
You know?
little head out here and there. It's like the physical representation of something, of all these invisible things. That there's a couple things that we can just, we can tell what the effects are. Like they are causing effects in the physical world, but we don't know the initial cause of
Like
what.
back in the early days, when they strung up the AC system, alternating current and whatnot, and they were trying to work around Tesla's patents, shit was just blowing up because it was Steinmetz that found this out. There were transient waves, so there was electricity of different forms that hop into the grid, and we can't see them because they come in and out. They're frequencyless. They don't have a frequency. Wow. So, and they would hop in and out, and they would like, dude, with DC, and this was common on DC ships back in the days, and a lot of people got blasted. Once you close a circuit and you're flowing a lot of power through those DC wires, don't you ever dare to open that fucking circuit because it will keep going. You open that circuit, it's going to arc, and the arc is going to get bigger, and it's going to blast the fucking hole into existence somehow. So when you do that, electricity just comes out of the ether from nowhere and just, it's like, all right, let's hijack the system and blow it the fuck up.
That's
and
amazing.
Shit was blowing up everywhere, man.
Yep. Yeah, like even like it'll go through your arm and come out your elbow, you know?
Yeah, because you'll be the shortest path. Like, oh, thank you, sir. You're shorter than the air, so let me grab your arm right here off the knife switch, and off we go, you're dead. Boom, done. Yeah, DC stuff is... DC's interesting. A lot more interesting than AC for sure. Well, like high voltage pulse DC or chop DC or whatever you want to call it is very interesting.
Pretty wild.
Not to get too much into the metaphysical, but the terminology always reminds me of biblical stuff as well, like archangels, right? Energy arcs. And there's always the search for the Holy Grail, and it's described as a chalice, which would be something similar to a hyperboloid, which is the inverse of a torus. And we know that magnetism flows in a toroidal field, and you have the inverse of that, which is the hyperboloid. I don't know. These are just weird things that pop into my head when thinking about electricity.
Oh, no, the conic section does come into play for sure when you're talking about electricity. 100%. The hyperbolas and all, they're all conic sections. No, I love electricity. I've been trying to understand that stuff ever since I was a kid. Why? Because, almost died from a 400 volt capacitor, aka condenser, that I didn't know was a capacitor at the time. So I was just a 10-year-old child taking shit apart. And zap! All right. Shit gets serious, So I let it go for a little bit just due to fear.
Mm-hmm.
And then came back with an education. Like, all right, gotta know what just fucking almost zapped me out of existence. So, what is this stuff?
Good thing you made it through that experience.
Yeah, dude. I was a small kid. Like, it just my physical size was like just 10-year-old kid. So 400. Lucky me, it was a small capacitor. That's it. So I got a lot of voltage and decent amount of joules. Pretty quick. So it hurt a lot and it thumped right in my chest, but. Luckily, the capacitor wasn't big enough to deliver enough joules to kill me, because the voltage is definitely there, more than enough volts to,
high voltage, low amperage.
Yeah. Oh, it's actually, so the amps, that's the thing about capacitors, because you can discharge them in such a small amount of time. So you'll have a peak discharge. So, okay, think about it like this. Now, this is where we need energy. because amps isn't enough. We need this inner energy concept. So if you have a battery, okay, like a voltaic pile, a DC battery, 12-volt battery from your car or whatever. Let's say it has heat energy. So we'll say it has 10 cups of energy inside or whatever. But due to the resistance of the circuit one, I could only deliver it if you short it. So if you just go with zero or like zero resistance across and you short circuit the thing, it could only deliver so many amps per second due to the internal resistance of the circuit and all of that. Capacitors, no. You give it a perfect conductor, and theoretically, if it's the perfect, theoretically, you can't do this, but theoretically, it will dump it in such a small amount of time that T approaches like zero. Time approaches zero. But that's, of course, that's something we want to achieve in the electrical realm, but, it's hard to do. It's hard to dump something in zero amount of time. It's impossible. Right. But anyways, that's an impulse electricity shit. And that's the sort of current that flows through your nervous system. It's impulses. It's like a train of direct current, but they're pulsed. It's like pulse, and a pulse train that has a frequency.
Dots and dashes. It's almost like
yeah.
zeros and ones.
Exactly, like that.
I mean, that's such a trip, man, because people don't think of themselves as electrical beings like we actually are, and we're receiving all these impulses. They're being turned into something else that causes us to make actions with our muscles, which are physical, like biological parts of us being controlled with this electricity, which we have actually a lot more control over it in ourselves than we think we do, because we've never been taught about electricity, really, like how it lives it's in us also. We've never been taught how to like manipulate, or what, I don't know if it's manipulate, but I think we actually can manipulate the electricity in our bodies.
So it's about my analogy. Go ahead, bro.
I got a question for you, Cyrus. So, what's the speed of propagation of a change in potential difference?
The speed of propagation? Oh, I don't know. No way.
Neither does anybody else.
That's the work of time amps that no one finished, right? According to Eric, that's what he said.
Yeah,
like the speed of propagation of the magnetic field has never been determined outside. Like, you know what I mean? When it emits out of the wire, nobody ever.
The change in the static field has never been determined. It's the speed of that change. Like if I have a capacitor. Like say I was like I had a giant capacitor, and I changed the charge on one side of the capacitor. How long does it take for the other plate to feel that change? This has never been tested.
I see. Yeah, no, fuck.
According to Gauss's law, it should be instantaneous.
Yeah, it appears.
Gauss's law has no time in it.
Okay.
Yeah, that's really.
So you can also there's actually a paper written on this where this is kind of like the thought experiment, right? So you have a copper sphere, right? But it has a hole in it. And you shoot an electron through the hole into the center of the copper sphere, and it hits the inside, right? So the charge that's on the surface should change instantaneously, right? Because the conservation of charge.
Okay.
So theoretically, the speed should be instantaneous. There should be no speed of light or anything like that. And I think this just has some relation to the longitudinal wave theory, because transverse waves, they're transverse to the direction of travel. So you could think of that, as Dollard said, as like a drag through the ether, right?
Mm-hmm.
But the longitudinal wave, there's no drag. And I think the longitudinal wave is connected to the voltage potential. Like there's like imaginary rubber bands connecting electrons to electrons.
Right? Faraday tubes. Yep. Or the lines of force.
Faraday tubes. Yes,
exactly.
Yeah, and there is no delay between this. This is. Waiting for this. This is like a social rabbit hole. Electricity. It's crazy.
I love it, man. It's Dude, like Dollard said, whenever there's a new discovery in this realm, my God, like there's big consequences. Always. It's insane. Electricity's it's fucking interesting, man. For sure.
You guys were talking about that guy was on the other night about the satellites, ionosphere, and all that stuff. And you guys have been talking about that for a couple of days. I wanted to chime in, but I didn't really want to get into it because sometimes I'm just not in the mood to get technical. Still not in the mood exactly, but plasmas exhibit negative refraction. So listen, yeah.
Okay.
So they bend away from normal, and that's not the only property. The phase of the wave can actually be superluminal or subluminal. So it's like I said, it's so technical. I don't want to get into it because it'd be like a 30 minutes just to tell everybody just so they fucking get up to speed on what the fuck I'm talking about. But this is like, I wouldn't say it's well known, but they've known it when they first came up with this ionosphere theory, right? Of course, the military came up with it because that's the military always coming up with the communication stuff first. But it's vital to war, right? So this is what they came up with. Like, this isn't what, like, if the Earth's evolved, this is the only way this can be happening. So, yeah. So even though they had no examples of negative refraction existing, this was their excuse to how radio waves could propagate around the globe. And I wanted to bring it up but the thing is, you wouldn't. The point is this: you wouldn't notice like a signal degradation or anything, because you know how you can look in like a certain type of lens and the object will look further away than it really is. You would get this same type of effect. Like you would have the signal loss as if it was 1,000 miles away, even though the transmitter was 50 miles away.
Okay.
Because the focal point is in a different location. Because of being refracted, it changes the apparent position.
Yeah, dude, that is sophisticated shit now. Now we're getting.
I didn't really get into it that day with that guy. Like, let him believe what he wants to believe. I don't really. Sometimes I just don't care. Like, let that satellite do and believe whatever.
Oh, dude, I feel it, man. Sometimes, like, I just hop on here, got off a fucking 30-foot ladder. It's like, I'm not gonna argue anything right now. I'm just gonna chill. Like, fuck this.
That's why Pagus is like, I'll convert. Like, and I heard you say like convert. Like that's me too. It's the same feeling, right? It's like fingernails on a chalkboard. I'm like, what? Like, no one's trying to convert you to do anything.
Right.
I'm trying to give you information. You're welcome.
Yeah, exactly. Like, convert, man. It's like, I hate that word anyways. People use it with like religions too. I'm going to convert. It's like, bro, you can't convert. You're a human. You can only converge or diverge, man. Become one with or away from. That's it.
That's the whole thing, because they actually, even unwittingly, they know they're actually living in the realm of belief only. So they're talking to us in language that's relating to belief systems.
Yeah.
Yet they deny that it's a belief system. When we tell them that it's religious, what they're doing, they'll deny it at all costs. They'll hold on to that it's not for dear life, which is what happens with somebody whose belief system is being threatened, and they're being they're stubbornly holding on to it beyond any proof or anything like that.
Because the atheists think that they think that if I don't have a belief in a supernatural being, I am Ubermensch, because science is the highest form of knowledge, and because I don't believe in God, I am one of the highest beings that ever existed. They don't even realize that they actually have a belief. It's crazy to. It's just crazy. It's so funny. They don't
They'll say that, and then out of this other side of their mouth, they'll say that science doesn't prove anything.
Yeah, it's so funny. People are walking contradictions.
Yeah, man. I tried to not do that, man. It's tough. You know what I mean? You got to really watch yourself. It's like, all right. That's part of being like, I could call it just honest or whatever you want, woke or whatever the fuck you want to call it. Just be honest with yourself first. Don't lie to yourself. You know, have you ever seen curvature? And you know, when I was like, I know I said this a lot, yeah, because I've flown a lot. I was like, yeah, I've seen a curvature from a plane, but however, did I actually see curvature, or did I just parrot what I'm, supposed to say? It's like, yeah, I did actually. I never saw a curvature. I never even tried to measure if there was curvature there. So how the fuck did I determine that I can see curvature? Huh? And then it's like everything starts to click. It's like click. It's like fuck.
You can't trust your senses, but I saw curvature from an airplane.
Somehow. Yeah.
Can't trust your senses, but you can trust random strangers on TV saying they went to the moon.
Well, their senses are better than yours, Indio, because they're professionals. They have. Well, you're not as smart as Don Petty. I can just tell you that. You don't have duct tape and did you see his invention, his patent, his coffee cup, his space coffee cup.
Chugga.
Yeah, dude. So he can drink his chugga in the morning. Oh yeah, the capacitor thing. Shit. No, okay. I remember again. Better example, okay. So if you have a cup of water that you're trying to boil, right? And we're going to go two ways. We're going to boil it with like a cap or whatever, or we're going to boil it with a battery. So you need the amount of joules you need to raise it from ambient to 100 C. It's going to be the same, right? However, there's heat loss and whatnot. So the time you deliver this to the water, well, it does actually matter because heat transfer needs time for sure. It's not instantaneous at all. So check this out. So if I have a heating coil, I hook this shit up to, whatever, battery, measure the current, I know how many watts, which is how many joules per second are flowing through, boom, cool. So now I charge a capacitor with the same amount of joules. However, let's build a theoretical heating coil that has no resistance, right? And theoretical for a reason. Now if I dump that capacitor, theoretically, it will dump all of its energy at once. At one fucking shot, it will deliver it, which will just make the wire, the coil, just explode. Just boom. Because the delivery time was so short and the energy was so high, it just turns into vapor. Shit just turns into vapor. Metal just turns into vapor when you do that. Just boom, instantaneous, just vapor. It's like, holy smokes. Because it's just the energy delivery over time is so high, it's insane. Shit gets blasted out of existence. Cool. That's the difference between capacitors and batteries, condensers and batteries. It's just they go at once. If you have the right, if your resistance is low enough, it will dump everything at once. Batteries, no, they don't. They have internal resistance, right? It's high, so.
That's why your skin and your body is such a problem near those things. Like if you touch that one contact, that's it. That's an open circuit to that charge, that potential.
I keep my big ass capacitors shorted all the time in storage because they can't just get charged from the air. Oh, I short them, buddy. I play no games with caps.
I make sure they're yeah, I have some pretty ones in my amps here. Yep.
Oh yeah, they'll give you a nice jolt, bro.
I've never been jolted, except one time I was untying my amp and I had a bungee cord and I let it loose and it went whack and it broke one of the tubes and I thought I heard a break and I don't know, my instinct was like stick my hand in there. I don't know why that was the instinct. It could have been really bad. All I got was a little zzz, just a little tingling. I'm like, holy shit. That tube has a lot of power. I mean, it's got 385 volts DC running through it.
Yeah, you don't want to touch that, bro. And plenty of current to kill you, so you don't want to touch that.
I don't know why. I must have touched the grid or something. I must.
You don't want to touch that
instead of the plates. If you touch the plates and there's, it's going right to ground. Hopefully that's not going through your heart region. That's why they say whenever you check it, you put one hand behind your back in your pocket, and you only work with one arm.
You know the superconductors, how they when you cool them down in liquid nitrogen or liquid helium, and they float on the magnetic lines of force, right? And so theoretically, if you have the perfect conductor in the world, right, which is something like that, right, which we don't have, but even better, if you have the perfect conductor in the world and you have current flowing through it, so you have magnetic fields, right, magnetic circles around the wire, right, because you have current flow, right, some devices attached or short. Now, theoretically, if you were to take that wire and loop it onto itself, creating a circle, right, just right, magically, of course, this is theoretical, the magnetism would be trapped there forever and not get chewed up by resistance. So you would trap physical jelly, this magnetic jelly that we all played with. It would be trapped between just a piece of copper that does not exist, that has no resistance. So that's, I don't know. I hope you guys understand. Well, because
I kind of do.
Magnetism is a concept of it's an archetype of space. You need physical space to store it. These lines of magnetic force, but the electrical lines of force in a capacitor, like capacitor is just two pieces of metals separated by a dielectric. So two conductors separated by a dielectric, something that's not conductive. The thinner you make the dielectric, and that's where the storage is at. The thinner you make the dielectric, the more charge it can hold. What is it?
That's counterintuitive.
The conjugate, it's a conjugate to magnetism, right? It's the opposite, direct. It's one denies the other, sort of thing. You know what I mean?
Well, this gives me some really good ideas. Listen, because we're traveling through ether, right? When we're moving around, so like I ride a bicycle all the time, so I've often thought, well, why can't I capture? There must be some way of capturing this, and I've had these different, like I've had little dreams and visions of how this might be done. I don't know why. Dragging a little copper sled attached to a copper wire. What if I had some kind of screen going through the ether as I'm moving? Shouldn't I be able to capture some charge?
I think NASA did that, but I'm not going to believe the results they got. They did it in like how high up.
I want to power the bicycle with that. That's what I want to do.
Well,
and then I want to make it fly.
Well, I don't know if a copper plate will do it. You're going to have to build. You're going to have to invent some shit, man, on some new level. Because
I know.
I know.
I'm not worthy. I don't know enough about the technical aspects of it.
Experiment and see.
That'd be some cool stuff to test around, though. Like maybe
they did space tether or some shit like that. Tether. NASA did some horse shit like that. See if we can create charge or whatever.
Well, there's obviously a potential, right? So if whatever you have is continually grounded and you have something going out into the ether, I don't know. That's just as far as I've gotten.
The furthest, like I've gotten, I mean, J.J. Thomson, the Faraday tubes, I subscribe to that. I just like that theory. Okay, I prefer, and it works just fine. Same, you know what I mean? It works just fine.
Good. So help me build the apparatus.
Oh, no, that's, I have to go to J.J. Thomson or something like that. I like vacuum apparatuses myself. This is where this is the research that has stopped in the vacuum apparatus world. And because we went silicon, okay? And now, so there's a lot of in my belief, and this is a 100% speculation belief of mine, there are many tubes that have never been invented yet. It's like, we don't know yet. Because vacuum tubes can do a lot of fucking shit, including give you images. So, yeah, it really can. Like, the cathode ray tube. So, You know, it's an interesting little device that when you read old, like Eastern mythology, it describes a lot of the demons or whatever they describe from the other realm, because they have this saying, you know, a blue demon in a bottle. It's like, excuse me, like, I know exactly what that is.
The
It depends if you got argon or if you got an inert gas in your vacuum tube. It depends on what gas, if you know, is in there. Will give you like reddish glows, blue glows. You know, if you want a blue glow, just stick some argon in there.
So you think the genie might have been talking about the genie in
Plasma
and the electricity?
Plasma. Yeah, exactly. Electricity in a bottle, vacuum tubes. So,
what about the flying? What about the flying carpets?
I also believe in that. Yes. And the only reason, look, bro. Oh, look at the discovery. look at silicon, and look at the internal combustion engine. Please, bro. Please. Fuck, man. It's 300 years fucking old. Whatever the internal combustion engine is, piece of shit. 20% efficient garbage. Rockefeller.
I'm fully with you there, bro.
Yeah.
I totally.
Yeah, I know. So what if Rockefeller never existed, or not this way, and the research in this field was open? Yeah. And I don't know. And the electrical research was also open. It's like, or a lot of money was spent in, like, you know, funded towards that.
Yeah.
Maybe we will have a small little thin, like, whatever piece of like 2 foot by 4 foot piece of plywood in the beginnings where you stand upon it and it will take you places electrically. And this is my belief would not be heat. Of course, that's a heat device, but not from gasoline or not from, you know, these fuels, liquid fuels. It's powered by electromotive forces.
Yeah.
That's my belief. Yeah. And just a belief. Speculation shit.
Well, you know, there used to be many dozens of small companies and shops here and there throughout, even just in America, but all throughout Europe and as well. In the early days of automobile, were manufacturing automobiles with different types of motive force, you know? So electricity, steam, there was different things out there. So there was lots of different things being done. Then all of a sudden, boom, there's only like 2 or 3. Eventually,
steam is still more efficient than gasoline. Still. Always was and always will.
Yeah. So is diesel, quite a bit more. Plus, if you can run peanut oil in it, or banana, or throw bananas in there, like almost.
Because it's not exactly because it's not a diesel engine. Look up the patent. It is not the dude is Rudolf Diesel. That's the dude.
Yeah.
He invented a multi-fuel engine. Oh, okay, thank you, sir. Diesel. He said, put any fucking oil in there, it works. All right. You know, because it's compression ignition, not spark ignition.
Yep. So that's a good way to do things. I mean, why aren't there like these small, super efficient diesel engines could be running?
There are
everywhere. Yeah.
They're just they don't come out. They're always in research phase. Like I said, I think it was Mitsubishi, and that was when I was back in college. That was more than 10 years ago. Mitsubishi had a 40-to-1 compression diesel. I forgot what the efficiency was, but it rivaled that of turbines. I was like, damn. A diesel engine, and because turbines are really efficient because of the speed. You need the RPM. You need speed.
I mean, and then if you had combinations between steam turbine and diesel, like it's almost unlimited there. Charge batteries, but
the cool thing about gas turbines is most of them in most power plants, because like the curriculum I studies is actually more towards, in Europe they call it energy engineering. It's not so it would be like a mechanical major in energy, and more towards the energy realm than the heat energy, right? So all the turbines you can run, most of them are configured in power plants to run on natural gas or diesel. Just if something happens to natural gas, they can always flip to the diesel. No, just flip the valve. Nothing fancy. You know, so they'll run also on multi-fuels, you know. And if they can run on diesel, you know, kerosene is also an oil, and that's what they run for aviation, or on A1 kerosene, if I'm not mistaken. You know, aviation fuel or whatever you want to call it. It's just fucking kerosene in my world. Look up the calorific value; it's still kerosene. Like that's it.
Yeah, it's a fascinating topic actually.
So I like both, man. Like I like heat and the conventional sledgehammer approach to the world, where let's just burn it, get work out of it. But I also believe in other methods that are better, cleaner, more efficient, and they all belong in the electrical realm, which kind of got chopped, So.
Yeah, so I think there's amazing things we can do with magnets and coils and.
There's a story out there with Tesla, right, and his Pierce Arrow, his car. However, it's a story, so I think it's the first time I brought it up, or maybe the second time I ever brought it up on the server ever. The story goes like he had a box full of like 12 tubes, and he took the batteries out or whatever the fuck. He put an electrical motor in his. He took the engine out. He put electrical motor in there, and he had a box of tubes, and he powered it off the ether, supposedly. He took it up to 80 miles an hour. Back in the days, that's unheard of. 80 miles an hour. Yeah, that's pretty quick, man.
This is Tesla's Pierce.
You never heard that story? Dude, yeah, just Google Tesla's Pierce Arrow. Let's see what comes up. However, it's a story. Like the car, where's the car? Right? There are stories around that shit too. It's like, where's that fucking car? Because the keys in the circuitry, like, what's in that box? How did he configure these tubes? There's another story about him putting light bulbs in the ground and lighting them up. Well, I would say that's true. I've never witnessed it. However, based on his stuff and the stuff that he was working on, then yes. That means like he concluded his work, and yeah, you can just the monopolar thing, right? You just stick it anywhere in the ground, and you can extract power because he's transmitting it from somewhere else. You see, and he's using the Earth to amplify it, supposedly, right? That's what he wanted to do. But the thing about him lighting up a field of light bulbs or whatnot, yeah, he used to do shit like that. He'd go on stage and light himself up and shit like that. Like he did actually stuff like that back in his day. So I don't know. That's another cool story where, you can go really far away because you can do this electrostatically today. Like any fluorescent light bulb that's burnt out is not burnt out. You can still ignite it using field emission or cold cathode, but you just have to up the voltage quite a bit to get to the field emission, right? Because they're all hot cathodes, So call it field emission stuff. Anyways, so with that, you can create a strong electrostatic field, off a coil, and it will ignite the light bulb using the RF. However, it's very close. It's it's right around the coil or your high voltage apparatus.
This stuff is wild because it sounds like did you say RF?
Yeah, RF also ignites plasma. Yes.
Yeah,
correct.
So RF to voltage conversion. We can do that. Huh?
Oh, like radio. It's the propagation. Exactly. Like you can take the radio that's coming from the 50,000 watt transmitter. However, it's so far away, so you can't really extract power, but you can. Right. You actually can. It's not that much, but you can.
Amplifying it, right?
Now, if you're right next to the fucking amplifier, the transmitter. No, this is a different story. You can really suck some juice off of them.
If you're far away, you could amplify it, right?
Amplification is you taking the signal, pumping power into it to make it bigger, and sending it out the other side. So we want to know. We want to harness it. We want to suck it. Like we want to absorb it. I don't want to absorb the signal, then pump it myself, because that pumping you're paying for in units of heat. For sure, gasoline getting burned somewhere to amplify anything.
Yeah.
So, yeah, you know what I mean. So it's like, okay. So Tesla was on some other shit, for sure. Some other shit. It wasn't RF like that, no. Sorry for the Tesla talk. Didn't mean to kill the chat.
It's okay. Just a lot of that, what you talk about, is over most of our heads. It's over my head, but that's okay. I understand.
No, man, it shouldn't, man. Why?
No, I understand the concepts.
I don't understand it either.
I mean, like some of the things you talked about, I have never delved into, but a lot of the basics I have. Like
It's Tesla, bro. The stories around that guy are interesting.
Yeah.
And like that's one thing I haven't achieved yet, and I will. But let me get better equipment. He noted that in field emission, the cathode and anode, one would heat up, one would refrigerate. So I'm yet to get condensation built up on my anode. So that's one thing I want to achieve. It's like, okay, let's do this. How the fuck did you do this? Right? Because that's an effect he noticed. Well, play with any hot cathode tube all day long, you're not going to get that effect. It's actually hot. It becomes hot. The whole thing becomes hot. Like, so he noted, no, one would get hot, one would get cold. One would refrigerate. Like, oh, okay, Mr. Tesla. Did anybody else notice this too? It's like, I don't know.
So I'll read this from his article. It's about his car. So in his 1901 patents, patent 685, let me read it. 685957 and patent 685958, Tesla discloses a natural cosmic energy collection method and an artificial one in which vacuum tubes were utilized to produce high voltage electrostatics plus a small electromagnetic field flow. From other reference documents related to the car, we extrapolated that in the Pierce Arrow 12 vacuum tubes were utilized. There were 9 tubes of an unspecified type and 3 tubes identified as 70L-7GT tubes. A small electromagnetic field flow from the 3 70L vacuum tubes. The integration of the electrostatic with the electromagnetic flow from these 2 types of vacuum tubes is accomplished with a converter unit as a part of the conversion system. The special vacuum tubes described in Tesla's 1901 patents were called X-ray tubes, which is a misnomer since they were actually electrostatic tubes.
Oh, hold on. What's the patent number for that? The X-ray tubes? I'm sorry. Does it say it?
It's either 685-957 or 685-958.
685-957. 57.
And
okay.
958.
958. Thank you. Okay, cool.
And so the tube is a 70L-7GT.
70L-7GT.
Yeah, 7GT. And so the other one is unspecified, which we don't have information about. So the last part of this is they utilized only positive polarity into an anode terminal which is directly connected to a hemispherical aluminum emitter with one end of the tube. An electrostatic beam is emitted from the opposite end of the tube. Wow, that's some weird shit. Wow, that's a trip, man.
I'm telling you that I've been looking for free energy for more than 10 years. So it's like when I read these stories, like I was really hooked, man. When I was a kid, I was fucking hooked.
Pretty complex.
I was like, it's like, okay. It's like we were that advanced 100 years ago. Huh. Why did we de-evolve?
Yeah,
Our technology.
so dumb. I know. The technology got better and better and smaller, but we got dumber and dumber.
How could like Edison and Tesla, just a couple other guys invent all this? Or, everything that we use today, it kind of fucking sucks.
Yeah, so what did they know that we don't? I think a lot of that information of what they knew to work with has been removed.
Why are we so fucking dumb, man? That's because, like, you know what I mean? Like, obviously, I'm born today. I'm alive today, not in their era. So it's like, fuck. What the hell were they eating? Why? What were they eating? Those guys, they were just on another level.
We certainly have evolved. We live in a slave system.
People that lived during the Victorian era are probably the smartest people that ever lived.
Yeah.
They were fucking, I mean, you could just go down the line of things that were invented at the end of the 1900s, beginning of the 20th century.
Crazy, man.
I mean, just pick something. I mean, just randomly pick some so-called technology. The people were fucking geniuses, like beyond. Have you ever seen that test, that 8th grade test? It's like an 8th grade graduation test. Like, listen, I mean, dude, it's so hard. Like, it's like ridiculously hard.
Okay, all right.
There's like a video on YouTube of a chick that's like going for a PhD in mathematics, and she can't even fucking do it.
Damn!
Hold on.
Wow.
Hold on, I'll show it to you. Yeah.
Oh my god. Okay, it's that bad. 8th grade? What do you mean, man? So the education system really did de-evolve, huh? The devolution of the education. Yeah, man, everything was invented then. All the fluid mechanics, the thermo, it was all during that era too. It's like all the smart people lived then, man.
So this guy named E.V. Gray in 1973.
Oh yeah, Edward Gray.
Edwin Gray, yeah.
Yeah.
So it looks like he knew a lot more. It says in the
motor, or
yeah,
did he?
Motor. He had his own motor. When he only used 3 tubes.
All right, bro. You want the best guy, in my opinion, out of all of these? You like free energy? All right, you can actually. We got pictures of this shit running. Okay. T.H. Murray. Thomas Henry, I think Murray. Just T.H. Murray, Morray. Bro, we got pics of him with his fucking apparatus, alright? Standing in the street. Lighting up dozens of light bulbs that are like 250 watts a piece off an 80-foot antenna and a box. And it's been verified he had no batteries, no capacitors in that box. Oh no, you should read his story because he's got patents and he's documented. He's in the 1930s. He's in the 30s. Of course his lab got shot up and shit like that. Of course, got burnt down, research stolen. Of course. But he got somewhere. He got somewhere real good.
Wait, how do you spell that last name again? Morray.
A-Y.
Morray.
Murray. Just put T.H. Murray. See what comes up.
Can I relate it to anything in particular? Electrical something?
Just go on images, bro. And
how about device? There we go. Let's try.
Sure, device. Go images, and you'll see him with like a panel of bulbs.
Oh, here we go. Murray valve, got it. Morray. I found it. Here we are.
R-A, okay, just one R? Okay, cool.
Here's a diagram. Trippy. Wait a minute. Save file. No. Let's see if that's a dead link or not. I'm finding so many dead links now. It's amazing.
Wow, man.
Okay, this one.
I read this stuff a long time ago.
Forum. Here we go. Radiant energy device.
Yes.
Free energy planet. Biz.
He's got books where I have his books, and I think I posted them on the server in the section below, actually.
Oh, wait.
The Sea of Energy. Sea of Energy, I think, is one of his books.
Yes, I just passed by.
Yeah.
I swear to God, like I'm reading something and you mention it. I'm reading something.
But dude, yeah. You're a water sign, if I'm not mistaken. So am I. So you can transmit thoughts easily. That's my theory on that.
Radiant energy device, energy from vacuum, free energy planet. Not the planet though. Measure it to be a planet first, so that part we're going to take out.
Don't be a flat earther. Come on, this is free energy talk.
Don't be a flat earther. Damn, flat earth seeps into everything.
But Murray, man, Murray is a gangster, man. Is post in the live stream if you see a picture of his like apparatus on the street, with like 12 light bulbs.
Let's see. I probably there's a bunch of images in this article. Let me see. Hold on.
There's plenty.
I'll find some more.
Yeah.
I'll just go to images. Yeah, here we go. Like he was doing this public demonstrations.
30s, yep. Public demos.
Radiant energy. Let me take some images.
80-foot antenna, and off we go, bud. It's like, really? Like, so, you know what I mean? Like, yep. Not just that. You want a modern dude? How about this? I forgot his name. The inventor of the floppy disk. Okay? All right. I'm selling him out, but his house is very interesting. The exterior wall of his house is it's not a photovoltaic cell, but it produces electricity. Okay, all right. So and he should be still alive. I think he's the inventor of the floppy disk. Just chase that down, and you'll find that rabbit hole. Like I know the free energy rabbit holes like quite well. Studying those.
So
that's a good one.
Here's a plan review for the Moray generator. That's a YouTube video. Scarmorno.com, whatever that is. Find some weird stuff.
Let me see if I could find something
like this. Moray generator plans. Here's the actual plans. EnergyLiberationArmy.com. This is the storm which the energy companies were afraid of. A horde of lawyers is attacking this as we speak. Here, let me put this. Interesting.
Here, bro. Here. I found the image that I wanted. So here he's got on inductive load. Like he's got plenty of inductive. Oh no. Okay, copy image doesn't work on my phone. Okay, so I have to do it this way, the dumb way. Here, boom. Ta-da! He's got a heater. He's got, I think these bulbs were like 250 a piece, 250 watts.
You didn't see that I had just posted the same exact image. What the
Did you really? Where, man?
It was a couple minutes before. Bro, what's going on?
Oh my God, no, on my phone. Yeah, man, you did.
I mean, how was that possible? Because I was looking at a bunch of different photos. I mean, we picked...
I just Googled it right now.
Yeah, but why did we pick the same one, bro?
Because... Here's another one. It's the ether, bro. Come on, man, you already know. There's plenty of him, man. Plenty of them.
Tony, you said you're not familiar with any of this. What you should read is Tesla. He gave a couple like lectures in front of, I think it's called the what is it called? The Benjamin Franklin Society or the Edison Society, like in England or something. So there's two of these, and both of them, like, they'll like lay. He's very like I think Tesla's underestimated about how well. That's exactly what he's doing because he uses a lot of analogies. So he often uses the analogy of plumbing. It really blows my mind that people don't understand like what he was doing. He spells it all out, like in plain English, black and white. I don't understand. Like it's like, and it's like the more education they have in mainstream physics, the less they understand, which blows my mind.
Yeah, the more blockage you have to understand.
Yeah, exactly. that kind of goes to like what you were saying. Like, how did these people all invent like all this stuff? They had less preconceived notions. They didn't have biases. And blocked their thinking.
Another part that people miss on that is they had access to tools and things like that. Shop space, like that was ubiquitous everywhere. There were little shops everywhere around any little town or village. Probably several people had shops that were working with electrical stuff because it was brand new. People were fooling around, making radios, like all kinds of things. So there was access to shops and shop.
He had Westinghouse generators, this motherfucker. 3 of them, I think. It's like, what? Alternators, I'm sorry. It's like, holy smokes. Like, dude, you can run cities on this. And he's like, yeah, he's got 3 of them chilling in his lab.
In manufacturing, like tools to do manufacturing with. Machine tools were more available, you know?
I also think that there's variables that have never been conceived of before. For instance, I think like the actual geometry. So say you have like some circuit design and you want it to do something. People look at it as strictly in terms of voltage, current, amperage, resistance, those factors.
Right.
But I think that those things aren't affected by purely the material. I think that the actual geometric design of circuit, like where is the inductor in relation to the capacitor? How far is it away in relation to
that kind of design.
Right.
Exactly. The actual geometric layout of where everything is. I think because when I'm going to go back to it, the thing called negative index of refraction, we know that if we design things that has a certain geometry relative to the wavelength, that we will get the electromagnetic radiation to refract in the so-called opposite direction. And it's purely geometry. It has nothing to do with anything else. It's just the geometry, the size of the elements compared to the wavelength. That's it. So you can do this in 2 ways, right? So there's one way you can do it. You can take a PCB board, right? And on the PCB board, you can lay, you can make like little capacitors. So like the letter C, right? If you have that in copper, right? That gap, that's the C, right? That is a capacitive gap. So if you send electromagnetic radiation for it, you'll get a little buildup of voltage in this gap. So if you make a whole bunch of these, that's 1/16 of whatever wavelength you're using, this capacitive gap will cause negative index of refraction. So here's the funny thing is, instead of using metal on insulator, you can just take an insulator and have cutout. So instead of it being something embedded in it, you can have a hollowed out part in the shape of a C, and it'll do not the exact same thing. It'll do nearly the same thing, but it'll do it at a different frequency with less loss. So like this negative refraction is frequency specific. So you like, if you vary the size of this capacitive gap or you vary the size of the geometry, you get different effects. And it's purely the changing of the geometry of the elements, nothing else. It has nothing to do with like current, voltage, anything like that. It's just the relative physical location of the elements. That's it. And I think this variable is just completely neglected, because Tesla actually talked about this. Whenever he's talking about tuning something, right? I'm tuning a circuit. How is he tuning a circuit? He's shortening or changing the size of one of the elements in the circuit. That's how he's
physical geometry.
The physical geometry. Because
like a musical instrument talked about them.
Exactly. You can shorten the wire and get a different harmonic.
Exactly. That's what Dollard was saying. It's so hard to build the true Tesla tertiary coil, right? The one that plugs into, you know what I mean? Like, so you can transmit to the Earth by plugging into counter space or another dimension or whatever you want to call it. That tertiary coil, like the one he built back in the days, he said that was magical because you have to get the physical geometry right, you know. So if you can build it like a piano, where you can tune, because it's a flat square coil, right? And so the gaps, the more like if you can achieve mechanical perfection in the geometry, that gets you even closer to whatever your desired goal is. Yeah. Yeah, it's good that you bring that up, man.
You're aware of like harmonics on a guitar, right? You play the guitar.
Yeah. No.
So where
I'm
you
aware
play,
of the electrical realm.
Yeah. So how you shorten the string determines what the harmonic is, right? But you could think of that harmonic as something like, so say it was a current. So say it was a current carrying wire. You could put something that on that wire that changes the way, like if you're using pulse DC or AC, right? You can change the way the waves propagate down the wire. You can do like a parametric up conversion or down conversion by putting something that basically is parasitic, not parasitic in the way of like resistance, but it just changes the way it propagates down the wire. Now, say I had a wire that's carrying a current, and like along that wire, I put like a piece of metal. That piece of metal is going to, or an inductor, right? So say I took like a coil of wire and put it, parallel to the wire, that current flowing down the wire, that inductor is going to change the way that current flows. And where I put it along that wire is going to change exactly how that happens.
Right. Where in space that happens.
This is like almost an infinite variability. And I think this might be one of the reasons that this field is so hard to decipher, because somebody gets an effect and they're saying, well, you just do this with this current and this with this voltage and this, you have a resistor of this.
Yeah.
And they completely neglect that the geometry that they use as a factor. So someone goes to replicate it and they don't get the exact effect. They get something like it, but it's off a little bit. And then it's hard, it makes it almost impossible to engineer something useful because you're using the wrong variables to engineer it.
Yep.
So that's why you got to sit there and do trial and effect. Trial and error, I mean.
I don't know if you read about Stanley Myers, the HHO, the water disassociation guy. He drove his buggy.
Yeah, I'm aware of Stanley. I think it has something to do with resonance. Some resonant tunneling effect. That's what I think is.
The problem, the fucker is lying in his patents, so that's another. He says it's a resonant circuit, but he's got a diode in his circuit. It's like resonant what with a diode? Nothing. You got, it's a choke. And he calls it a choking diode. It's like, yeah, dude. It's like that's you have no resonance like that. So it's like interesting. So a lot of people say it's on the pulse DC side of the world, but the best theory was like it's the mechanical. Again, he built it like a musical instrument where you can tune the position of the tubes relative to each other. Like the geometric spacing is like, like the first order of things. You know what I mean? Like it has to be mechanically perfect.
Yeah. Well, I also also probably the purity of the elements too, right? So if you use like impure copper wire, or say like magnetic coated copper wire, or like silver wire, like those will all affect it on top of it. So you would have to alter the geometry depending on the conductor used. So and the insulators, right? So the insulators also have electrical properties.
Not the magnetic, electrical world. It's fucking complex, man.
It's uber complex. It's like beyond complexity. You're probably just better off like doing some freaking machine learning on this shit and let the machine figure it out. Who cares if it's a black box?
As long as it works and sucks energy from the ether, and I got my internet off grid, I'm cool. I'm happy.
I was looking yesterday. I was looking at some machine learning stuff, and like it's great for vision. I should like code up a neural network and feed it like a bunch of images and have it tell me what it thinks the shape of the Earth.
It's flat, you idiot.
The thing's gonna see. Yeah, that's what it says. It's flat. Is that another machine learning program coded slightly differently? We'll say refraction.
That's what the Globey made it, right? For Zanuck programmer or some shit. I think you can, but that's sort of thing.
Zanuck is the AI.
We'll just call him Zanuck, right? Hey, Zanuck. Oh, yes, sir. No. Like Jarvis or whatever. Iron Man.
What are you doing, Dave? Hal 9000. Zanuck 9000.
Reference frame. Reference frame. The Coriolis era. I remember that shit. Coriolis.
It astounds me, like the Gulbers that come in here, and they'll come in and they'll say, how do you explain X, Y, and Z, right? And the thing is, X, Y, and Z doesn't exist. They just think it does. Like, they'll be like, how do you explain a plane flight from here to there, right? And they think that plane just like flies right from there to there, right? They have no idea that planes actually go to like a flight corridor and then fly to the destination in the corridor and then leave the corridor at some place and then fly to wherever. You know what I mean? They think they're going point to point. So I don't understand like why they believe these things. They literally don't research anything, and then they come in here and demand that we explain their freaking delusion, right? Explain my delusion.
Too much TV, man. I think that's the best conclusion for me. So I haven't watched it since I was a teenager.
Explain my ignorance and factual error. Okay.
You don't read. You don't read, sir.
That's my explanation. You're lazy.
Yeah.
You couldn't take the 3 seconds it would take to Google it.
Right.
I mean, they don't think about it for a second. Okay, say I'm flying. I'm a pilot. I'm actually going to take off and fly to somewhere. Well, different airports have different taxi times. You take off different ways. You don't land the same way. Sometimes you're taking up into a headwind. Sometimes you go in a direction, you're flying against a jet stream. There's so many factors that affect flight times, right? A total flight time, right? How fast are you climbing, right? So you have to climb faster in some places than other places, right? If I'm taking off from frickin' Tibet, I'm already at like 8,000 feet. Right? And plus they have a really fucked up runway, like the hardest runway to land on in the world. So you have to come in at the exact right angle. Probably got to circle like 50 times before you even land. Right? So how do you count for that time? Like, it's just silly that they have these like almost childish notions about how like an airplane flies from point A to point B. RC, I'm a pilot. How do I calculated my fuel and reach this freaking area? Like, dude, do you like fly with just enough fuel? Like, what are you like? Oh, I calculated it, and if the Earth's not a globe, I'd fall out of the sky because I only bring just enough fuel to get there.
Durr.
It's just silly stuff, man. Like, it drives me crazy.
They're using aircraft as a measuring device.
Yeah, RC said, well, I flew from here to there and I calculated the fuel. Why didn't I run out of fuel? Because you don't bring exactly enough fuel, you moron. Because you fill the tank.
You fill up, man. You fill up, dog. Just in case you fill up.
I had someone on here disagree with me. I said,
I don't miss RC, bro. I don't miss him at all.
I said aircraft of any type are not measuring device. I had someone disagreeing with me over and over, disagreeing. Yeah, it is. Yeah, aircraft is a measuring device. No, it isn't. How so? Yeah, it just is.
An aircraft is a measuring device?
Instrument.
Yeah, that's what they think. They think it's a measuring instrument.
Damn. What does it measure?
They think it's measuring their ball, obviously. They come in here and say aircraft, therefore Earth is a glob.
It's a ball measuring device.
Nice. Wow, that's pretty cool.
Yeah.
What's the patent number on that apparatus?
Really?
Let me see. Let me read it. I'll read the patent myself.
See things
ball measuring device?
You see things flying around in the sky, therefore Earth is a glob.
Here I was asking. There was someone in debate text today. I was like, he's talking about space. They go into a spiral as soon as you tell them space doesn't exist. So I'm like, okay, dude, settle down. Was space discovered or invented? And he was like, discovered. And I'm like, okay, who discovered it? Somebody. I don't need to know that. I'm like, we know who discovered America, right? Christopher Columbus, but we don't know who discovered the universe. So that makes a lot of sense, right? No, dude, it was invented in the minds of a man. And we know who invented it.
Who did?
They never asked Epicurus. Epicurus is the first person that came up with outer space. He also invented atoms, so that should tell you something.
Oh, okay.
He invented that's kind of the foundation of all of modern physics is the Epicurean idea of matter and void.
Yeah. Damn, it's that
there's either matter or there's an infinite void.
Pretty old. Yeah. Right?
And he was dude, what a good guesser, right? He guessed the entire universe in 325 BC.
Yeah.
All of physics, dude. He guessed it with no information. Before the number zero was even invented, he guessed it.
Prophet Epicurus, yeah. All hail Epicurus, yes, that is it.
No shit, dude. All hail Epicurus, the progenitor of the entire universe.
And that's
Sir, that's peace be upon him. That's Epicurus, peace be upon him.
That's right. and that's not archaic.
That's crazy, man. Wow. Yeah, they stand on weak ground.
Well, how many of these concepts, these globe concepts, were discovered versus invented? I mean, like nearly all of them. They said, Earth's a globe, what are the consequences? Blah, blah, blah. It wasn't like they were doing something they were like, holy shit, I keep missing with this bullet, man. Why is that? And then they researched it and they're like, wow, this correlates with the rotation of the Earth. It didn't happen like that. Like it was like, man, if the Earth was a ball and we were spinning, we should see this. Let's run around and look for that.
Yeah, when have we ever seen a ball or a sphere in nature?
There you go. There's another one.
Sphere in nature. Well, let me get you. I'll get you one. Pearls. I got you.
A Zulu sphere.
Man, that's some cherry picking. You need a lot of pearls to get a perfect sphere, man. You're combing through tons of pearls.
You are 100% true. You're right. Most of them are sphere. You're right. You're right. They're cool. They come in all colors. Pearls are fucking badass.
We have the Congo sphere. We have the Native American sphere. We have the
every here and there you'll get a ball. Let me see. What else? Oh, man, all the crystalline structure. I'm thinking of crystals, right? That's why it's like, I'm going crystals. Like, I'm going to prove you guys wrong. Let me find a sphere in nature. What has spherical crystalline formation? Nothing of that I fucking know of. You know, they're all, cubic, rhombic, that sort of, like.
Hey, just remember, this conversation is an example of science denial. We're science deniers.
Oh, sure. We? Talk about crystalline structures. What are you talking?
Us pointing out that they're using ancient Greek metaphysics as some form of superstition and doing 2,000 years of confirmation bias is science denial.
Yeah, we're denying their
for sure, because you're denying the existence or the truth of their messenger, Epicurus. So, or their prophet. He saw the future. So, yeah, how dare you?
The thing is, this isn't like people might say, well, nobody pays attention to that. I can show people many presentations given by physicists now, talks or lectures, the Royal Society lectures. They still talk about this guy. Okay? They're still talking about him. It isn't old shit. They're still talking about him. You go to any lecture on atoms, quantum physics, or any of that, they'll usually start with the history. And when they start with the history, they talk about Epicurus and how he came up with the idea of atoms. Something that's indivisible. But guess what? That he was wrong about that, we know now, right?
Yeah, we can divide. Well, I guess that's not an atom then, that thing we divided, yeah, or we can, yeah?
Well,
is that an atom?
Atoms divisible? Aren't they made of electrons, protons, and neutrons? Aren't those made of quarks, leptons, gluons, and a bunch of other stupid shit?
And then guarantee you, those, when you keep on cracking, you'll find they're made out of other stuff too. Until our technology,
then when you get below that, it's not even material, right? It's a quantum field. Like it's not even elements anymore. It's not even discrete chunks. It's a field of shit. So at the bottom of everything is just a field.
Yeah. Nice. Mind-boggling. This is my kind of morning talk. I like this.
Like, there's no difference talking about this or talking about like some fantasy series that about Middle Earth or something. Like, there's no difference. You might as well they could just ship this. If someone took all this gibberish and put it in the fiction section at the bookstore, nobody would even notice.
Mm-hmm. Einstein's work in there, no different. Novels.
Well, Star Wars is based on that.
Fairy tales and unproven pseudoscience.
You ever smoked dilithium crystals?
No, I bet that's some good shit.
Warp 10, brother. Warp 10.
Warp 10.
Go back in time and save the whales.
I think somebody's snorting some globe crystals.
So, Sirius, what do you think about quantum tunneling?
I haven't read enough about it to really grasp any quantum anything, really.
Well, it's actually it's observed macroscopically too.
Okay, explain to me the effect.
Well, according to them, this is them, right? So,
okay.
I'm trying to think about how to describe this without being fucking try to decipher their gibberish into English. Hold on, let me get my translation machine going. So everything is according to them, right? So because of the fact that, well, I'll give you the quantum version first. So because quantum particles cannot be localized, right? And where their location is actually a probability amplitude, the wave function, right? Spread across space. Could be anywhere in this space. Part of that wave function overlaps the barrier, right? So say you have, one material and then a barrier of some material, and then, another material on the other side.
Yeah.
Some of that wave function, when it comes to the boundary, overlaps, and there's a non-zero probability of it being on the other side. So sometimes it spontaneously jumps through the barrier to the other side.
Okay, that's when the material is obviously thin enough, extremely thin and whatnot, yeah.
So this is the explanation, but this is another one of these things. In this case, quantum tunneling was not invented, it was discovered. And it's been discovered, and the explanation is ex post facto. So there's something called a PN junction, right? So you have something that's electropositive, a material that has an excess of electrons, and a material that has less electrons than it could possibly hold. So if you sandwich this, we put a semiconductor in between them, this will jump this gap, right? And what they say is there's electrons and electron holes in one material. So the P has excess electrons, the N has too little electrons. Sometimes, if you apply a voltage across it, right, this bias will give a little extra boost, and some of the electrons will jump into the N material And then there's a flash of light, and this is how we make LEDs and light-emitting diodes. This is what a light-emitting diode is. It's a PN junction.
Yeah, okay.
So they work by so-called quantum tunneling. So there's actually a bunch of different models for this. I actually seen one model where it was actually modeled as just like a regular current, just as a regular electric current, and that the semiconductor has what do they call it? Band gaps. So there's I don't know if you ever heard the band gap model, that at certain energy levels, it's as if this material is transparent and the electrons can just travel through it. Right? It's a semiconductor, right? So in specific voltage ranges, it will carry a current. So this is one of the ideas. Here's the problem. Not actually a problem. It's been observed macroscopically. So the Navy, they were doing sonar tests, right? So they're shooting out sonar. And there's supposed to be a mountain under the ocean. And they're picking up something that was like very far away. What they found out was their sonar waves actually tunneled through the mountain. So this is an actual. So it has nothing to do with the wave function. It has nothing to do with the probability, amplitude, or anything like that. It's just a property. It's my personal opinion. I think it's a property of just matter generally.
Material.
That if you have a let's call it a material, right? And this material is homogeneous. It has to be kind of like one thing. Could be whatever. It could be wood. It could be
pure.
Freaking stone. Pure. So just one thing. It's just one thing. And if you have like a medium on one side and a medium on the other, somehow that things can just like jump this material as if it's not there. And this kind of goes to this like thing, right? That for some reason, I think materials that are the same thing like to be together. And they'll actually repel things from being inside of it. So if I shoot something at a material, it might be energetically more favorable for it to just teleport to the other side than it is to be inside it. And the material just repels it because it just wants to be together. This is my pet hypothesis, I guess you'd call it.
Nice.
Which makes a lot more sense to me than mass attracts mass or fucking, spooky action at a distance or teleportation or freaking quantum, probability amplitudes and causal quantum erasers and silly shit, dude.
I'm not into spooky action. I'm not Newtonian. I'm very J.J. Thomson when it comes to that. Action in this, there's the tubes of force connect everything.
Doesn't have to come up with stupid, like, literal contradictions, like superpositions, that things can be in the same place at once. And this is just accepted as if there isn't a problem. Listen, 200 years ago, if you said, my theory involves things being in two places at once, they would call you a fucking crank. They'd be like, something's wrong with you.
Yeah, they would.
But their mathematics, right, shows that.
Wait, are you trying to tell me that I'm not in two places at once right now?
How much weed you got?
Apparently not enough.
What's the strain, bro?
You got the mainline weed to fucking get that fucker.
I'm just kidding. But seriously, there's like 4 of me on Earth, so you'll never know who you're talking to.
Sure.
So this is their thing, man. Like, look, it's almost like in this quantum tunneling, you have a particle that has no specific location. That's some smeared wave function, an electron cloud, right? Mm-hmm. And it's on both sides of the barrier at the same time. It's in both places at the same time in the mathematics. So to them, this is plausible. Then they come here and say, the Earth's a globe. It has to be a globe because science. Like, well, why don't I just say it's flat and a globe at the same time? Because you guys think that frickin' things can be in the two places at once. Why can't it be a globe and flat at the same time? I mean,
that's a good one. Start applying superposition on their ass.
Yeah, we're in a superposition of geometries. Because this is what children think when they're told it's a globe. They're told they actually come up with a two Earth concept that they think it's flat on the ground, but if you go far away, it becomes a ball. So, like, let's just go with this. Let's think like children, and we'll go through reality like that. How about no? How about no instead? But it's just this silliness that is completely accepted, right? That the mathematics says whatever, that you can be in two places at the same time. But I find it more interesting that this has been observed macroscopically. And what's interesting is it's superluminal, that the dwell time in this barrier is 0.
How dare you use that word, superluminal? Sir, the speed light is the limit. The speed of light. No, wait, the speed of light is the limit.
Blasphemer! Burn him!
So wait, is there light past the firmament? And if so, how do we know how fast it's going?
Firmament?
I'm just kidding.
I know. It's fucking brilliant, but it's all good.
Does light move faster inside the snow globe or outside?
So here's the funny thing. Here's the funniest thing, right? Now, they say that the distance, right, the barrier can be some length, right? And that length falls off exponentially by the wavelength of the light, whatever. So the funny thing is, here's the funny thing. The formula is identical to what the distance is for near field radiation. So that's non-transverse radiation, right? Near field coupling. So if you get too close to something, you'll electromagnetically couple to it.
Yeah.
Like a big antenna.
Yeah.
So this barrier distance is the same way.
Well,
it's the same distance.
High power.
So with this quantum tunneling, this is a DC. This is a non, because you in a diode in a LED diode, it's a DC bias, right? So it's not alternating current. It's a DC bias where you're just creating kind of like a little tug on it. And in diode, I don't know if how much you know about LEDs, but they only work in a very narrow
way.
But they only work like in a very narrow voltage, right? So you got 5-volt diodes. They only work pretty much like from 4.99 volts to like 5.01 volts. There's a very narrow voltage.
Yeah.
And if you're outside of that range, they just don't work.
Right. You smoke them up pretty easily too.
Yeah, exactly. And if you don't put them out, they just don't work. It's not like they're not bright. They just don't work at all.
Are those, I think they're called Zener diodes? I'm not sure. They're like tiny-ass vacuum tubes. They're like little glass bulbs.
Oh, yeah. Zener diodes.
Zeners, right? Those are pretty cool.
Well, the point I'm getting at, this is another thing where, like, the geometry, how far away these are, is directly relate. Like, do I want quantum tunneling? Well, I gotta take the geometry into account, and then I gotta correlate that geometry, that distance, to the amount of energy, right? So different energies mean I have to use a different distance, right? Different wavelengths means I have to use a different distance. Like there's an intrinsic geometry built into how electromagnetism works.
100%, because it's archetypal of space, right? Magnetism, 100%, and electricity. You know. Like the antennas, you know, it's the physical length of the antenna will determine, like, you know, what wavelength, what band it picks up.
Exactly.
You know?
Exactly.
You can make it into a snake. Yeah. Like it doesn't matter. Like as long as the length of the wire is the same, you can like compact it in different configurations. It will have different properties, right? If it's flat and like circular, it'll have low capacitance. You know what I mean? If it's like a coil, it'll have higher capacitance. It's like shit like that. You know, it's like a coil, like a 3D coil, you know, not a flat coil.
Well, and then you have the impedance, right? So I have a wire hooked up to the antenna, right? So the impedance mismatch of the wire versus the antenna. When you think about what is the actual difference between, say, copper and aluminum, right? It's actually the geometry of the atomic particles. In that material.
The molecular structure of the crystal and fucking stuff. Yep.
Exactly. So it all comes down to geometry. It has nothing to do with anything else.
Music.
I mean,
that's why I always felt the musical world, like not music like it's just musical. Like Tesla and those guys built their apparatuses like a musical machine. You have to tune it. It has to be perfect, right on. Like, you know what I mean?
Yeah,
we do that
because
today.
when you hit that frequency, when that big lady be singing, next to a bunch of them wine glasses, that big lady be singing, and the wine glasses go, she got to hit that frequency dead on.
And that's exactly what I'm talking about. Electromagnetic coupling is the exact same thing as that, right? So if a woman sings at, say, a C, and the glass's natural resonant frequency is also C, if she sings loud enough, she can bust that glass through destructive interference.
Right. Yep. Sympathetic vibrations, yeah?
Yes,
right.
Yeah, exactly. And this happens in anything that exhibits waveforms exhibits this property. The things that will can resonate at that frequency will resonate at that frequency if they are close enough to that the emitter, whatever is emitting it.
And to us, it causes destruction, but it shows the power of the frequencies lining up. Right? To us, it breaks the glass. To reality, it's just doing what it's doing. But for us, it's violent. It can get really violent.
The glass breaks because of like the deflection in it, right? Because it can't hold tension. You know what I mean? Because it's starting to wobble though. Because now.
Yeah, the glass can't hold the tension of the vibration itself. The glass is really weak compared. The vibration is like infinitely strong.
Yeah, well, because now you're in the right band, that narrow ass band. That now once you hit it, now it can absorb power. Now it can transmit energy way easier. Now you have very efficient energy transfer. The glass busts.
So if it were like bulletproof glass, it may take longer to bust, it'd have to be a different frequency anyway. But you know what I mean.
Plastic, I don't think it'll have the same effect. However,
and the thing about glass, it can't dissipate the energy. That's the thing. It's intaking more energy.
That's what I'm trying to say. Yeah, would the plastic actually absorb the energy? But I mean, you could eventually break so it would just melt the plastic.
Well, and if you look at the molecular structure of glass, it makes sense why it can't dissipate the energy because of the way the molecules are shaped.
Yes. Again,
it's not held together in a regular crystalline form. It's called an amorphous crystal.
Don't tell me the crystals are fucking triangular shape, bro. Don't tell me that shit.
Oh, bro, I like metallurgy, so the crystalline structure and like the phase diagrams. Oh, dude, they're critical. It's all about the geometry. Like it's essential, and we did forget about that in the electrical realm and shit like that. The alloy, the metal, like everything matters, man. Everything matters. So cool.
Yeah, everything's got a frequency, and so that's how people get afraid. Deep down, people know that it's possible for radio frequencies to travel through your body and disturb shit, mess shit up. Everybody's like, no, hey man, the 5G thing, that's just, it's just distraction. Well, what if it's not? Just real quick. Like, I've never seen so many towers of anything put up before. For the 4G, they didn't need many towers. For this, it's like, oh my God, it's everywhere. How's that not going to affect you?
We can map out your motion in 3D space,
Yeah.
With that many, I really think that's what they're trying. So, I mean, hey, if it's your device is capable of doing this, why not? I mean, just as a scientist, like, why the fuck not? Let's see if we can actually make this work. Hell yeah.
True.
Map everyone out in 3D is like, yep, right through the walls.
Oh yeah.
So fun story. I was walking in the city, like I think it was a year ago, and there was a skyscraper being built, and the only thing that was completely finished was the tower that they put on top. That was the only thing that was finished. The rest was all in scaffolding, and the only thing that was working was the tower on top.
Well, we need 5G to finish building the building. I mean, it's how every building is built from now on. Top down, 5G first.
How else are they going to control the workers, man?
Mm-hmm.
Sure.
They're controlled by a beacon. They pick up the signal and they just start hammering and nailing stuff.
Seriously.
You just send out the frequency, they all start fucking hammering.
That's right. Keep the drones going. Hey, it's not too far from the truth. That's the scary part. I got my 5G phone. I have to pay for it. Let me go to work and hammer a nail.
Hey, wait a minute. What's wrong with Steve over there? Oh yeah, it looks like he's trying to screw in a nail. We better change his frequency.
Yep. Yeah. Exactly.
Why not? I mean, look, man. If I had access to the switchboards, listen, I'm just gonna play. I'll be honest, and I hope that's not what they're doing. But I'm sure there's some nerds out there that want to test
talking about energy and frequency. I heard they are using that shit now in Australia and Canada. LRADs.
Was that the sound device, the LRAD?
Yeah.
Yeah.
Mm-hmm.
The thing about 5G is that it's multipath and highly reflective. So it's not like you're like swimming in it. Like you're taking a bath in it. It's like coming at you from every possible direction because it's reflecting off of every surface. So there'll be little focal points and little nodes where it's concentrated. And maybe that's where your desk is at your office, right? So you're just sitting there at your desk, just getting pummeled by electromagnetic radiation.
That's messed up. Because I hear
Faraday cage. I'm gonna buy a Faraday cage next round. Just drape copper mesh.
Aluminum suit, bro. Let's get the Faraday suit. No, here we go with the tinfoil, right?
Yeah, it is fucking tinfoil. I know. It is whatever, man. It works. It works, bro.
I'm gonna cover the whole inside of my apartment with tinfoil.
Dude, I'm experimenting with like different materials. I don't know.
What do you the Globers try to stick an antenna on their head? That's the fucked up part. You want more?
Collect that shit, right?
Yeah, lump it right in.
It's free.
Just wire it right into my spine.
Yeah, we'll just place the antenna inside of you internally.
Well, you couple, right? Like at least, so, all right, the glass, back to the glass thing. That's one harmonic that you can do this on, right? That's not the only harmonic you can do this on. Because like, let's say, whenever you play a note on the piano, like the harmonics, the other strings on an even division of that, they're also vibrating, but at a lower amplitude. And they all add up together to create the sound that you hear. It's not pure. You know, so whenever you like the glass, like it's picking up. It's not a pure tone at all. It's picking up many harmonics. It's like, and it's called additive and subtractive synthesis. And so it creates the waveform. When you zoom in, it's not so smooth. It's many waves added to each other in this envelope that gives you this, right? So Tesla supposedly, right? He tuned his coils to the fourth harmonic, which means like, let's say if it's a coil, whatever, 100 hertz or whatever, just arbitrary numbers. He tuned it to like the 400 hertz harmonic, right? Depends on whichever divisions he was working off of. But like the second harmonic would be 200 hertz, third 300, and so on. You know. So I don't know what harmonic, but he said to the fourth harmonic he was tuning like. It's like, wow, okay, huh? Like the length. So the length of the antenna, right? Let's say I want to pick up a microwave band. That's what, 2.4 centimeters, something like that. Quarter wavelength antenna. Boom, I know how big that is, right? Or 10 centimeters, I'm sorry. 10 centimeter band, I think, is microwave. So you just measure that out, but that's like the first harmonic. And somehow he can tune that like 3 more levels in. It's like, whoa, huh? Fine tune it. It's like he built musical instruments, pretty much. Electrical musical instruments. For radio propagation, or wireless propagation, I should say, of electricity. Which is interesting. I don't know how to do that. He had no oscilloscopes either. He had light bulbs.
So I should eventually be able to get into my vehicle, plug in my guitar, and start strumming it and power the car. I don't see why not. Why not?
No.
No, you would need one of would it be Brenda's space-time donuts?
No thanks.
You know what I mean? To change the guitar tone into a usable fuel for a vehicle.
I have a real donut shop down the street if I need one.
Got it. Yeah. Yep. So does the diabetes inside of that space-time, is it different than the space-time outside the donut? Or yeah, well, anyway. I miss Brenda.
You would have to ask Brenda.
Yeah, I miss Brendan.
Oh, hey, Indio, are you still there? Have
you guys talk about important stuff. That was not important.
Yes, I'm here.
The Tesla, the hairpin circuit. Hairpin. Sorry, I'm eating.
Yeah, someone actually made a replication of that on YouTube. Have you ever seen it?
Yeah, see that guy, bro, lighting up light bulbs with a thin-ass wire across the room. Yeah, I've seen he was like lecture/demo sort of thing. Like, wow, some old video I watched. Wow, it was old 10 years ago. You know?
Yeah, exactly.
Yeah. That's something very cool for the Tesla fans out there. Hairpin circuit. It's an interesting apparatus. Yeah, I remember. I remember a guy with a bulb sliding it up and down like these copper conductors too, and doing all the demos like Tesla said. Right? It's like, yeah, okay, interesting.
In one of his lectures, he talks about some sort of communication device
placed in the pocket.
Really weird, man. It was like it looked like a bulb. Something like that.
Or no, that's a prediction.
He didn't really go into it much, but he had a diagram of it. The diagram in the lecture, it's like the shape of almost like a vacuum tube, but in the bottom is like chips of nickel shavings or something. Really freaking weird, dude. I'll find a picture of it. It's bizarre. Like he doesn't describe it but he said you'd be able to talk to people like around the world and no one would be able to eavesdrop on it. But I have to find it. I'll find it. Give me a second. Or a minute or two, actually. Tesla stuff's hard to find now that dumbass car company exists.
I think that's why they did it, man. I think that's why they named it. So it kind of drowns out the real Tesla because a lot of people were picking him up. Because I think like 15 years ago, my dad is the one that taught me about Tesla. He didn't know shit about him. He was like, Edison is the thief, but Tesla is like the real inventor of electricity. That's cool. So then I started my Tesla journey. So it's like so. Anyways, people were picking him up with the flat Earth thing quite a bit.
Real quick, you guys need to check out and save to your devices the latest Ladies' Night advertisement by the lovely KJ. She did a second one here, and I just posted it in the voice text. Spread it round.
All right. I'll try to. Okay. Get some shit done.
It's funny. It's like I don't speak on Ladies' Night, but I plan my Fridays around being here for it, so I can hear it.
Yeah. I need to change my schedule so I can be back in time to listen to it.
Virgo Greg, can you hop on voice? Because I'm trying to do shit, and I want to put my phone in my pocket and do stuff.
Is he DMing you?
Uh-huh.
Yeah.
About the Stanley Meyer thing. Because if you're listening, I'll show you my generator. I brute force, I just wanted a torch. I wanted the gas, high output. I didn't care. I wasn't going for a water device for like an HHO device to put in my vehicle. I just wanted a hydrogen torch. So I built, how many watts? My fucking thing. It can easily suck 160 amps at 12 volts. Easily. So,
I will assume that that's impressive.
It's just a lot of heat. If it's just, it's not very efficient. So most of that starts boiling the water, which you don't want that because you get water vapor then in your gas stream. So, of course, you can put a water trap and whatnot, but yeah, it's not efficient when you do that. So, however, I just wanted the gas. I didn't give a fuck.
Well, the water stream stays separate from the gas, right? No matter what it does. You can't merge them.
The vapor? No, the vapor will all flow up the tube with the gas from the, because you're, okay, so if you have a closed bottle and you put two metal plates and enough voltage, right, you get electrolysis. And on one plate, you'll have hydrogen formation, and the other you have oxygen. And it's always like that, and it'll never, unless you reverse the polarity, then yes, you'll reverse it. But as long as your polarity is the same to each plate, so that rule is not going to be broken. So in that, if you want to isolate the gas, then you can put that plate, shroud it with a glass envelope that's open from the end, and then goes up into one tube. That way, if you want to isolate the hydrogen from the oxygen, or you can let them combine and go up from your jar or whatever, your vessel, from the end through a single tube. And that will have the hydrogen and the oxygen combined, which is quite explosive because it has the perfect amount of oxygen for combustion and needs nothing from the air. So it's extremely dangerous to store. And because the flame front of hydrogen, the wave front of that flame is so fucking fast, it just blasts. It just blasts shit.
Is it faster than the speed of light?
No, it's not.
Let's ask a Glober.
It's not superluminal.
Okay.
Hey guys,
all right.
can I interrupt
Quite retarded.
real quick to ask a question?
Go ahead, bud.
I'm wondering, how do I get permission to upload documents into the chat?
You need link image perms.
Oh, yeah.
And I cannot give those out. I don't think Cyrus can either.
Okay.
Why not? Why
oh, no, you're a mod. He's a mod. He can do whatever the fuck he wants.
I'm on my phone, though, so I don't feel like doing it on my phone. Someone else can just click with a mouse. Any other mods are in.
Well, if anybody could do that for me, I'd really appreciate it, because there is some documents that I have that I'd like to share with people in chat once in a while that I find are pretty interesting.
You have the Flat Earther tag. You should already have that.
Yeah,
doesn't go with the Flat Earther tag anymore.
Oh.
Because people were because someone snuck in and porn bombed the channel that had the Flat Earther tag. So, but I'll give you the permission. How long you been here? More than 3 minutes, right?
Well, I just jumped on just now in the last 5 minutes, but I've been around.
How long have you been on the server?
For a couple years. I'm sorry, what?
Okay. Yeah. Okay, that's fine.
Yeah, I've seen him around too.
Yeah, I was introduced to it by a guy named Robert Pisano, and then he got me in contact with Jose, and Jose verified me in.
All right.
So that's how I got on a couple years ago.
Bird name.
I already believe you. Yep, for me too, man. It worked. I was like, yep. He dropped the right names.
A lot of people have seen it, and I actually got this document from Robert. That was prepared by NASA, and the title of it is "Optimal Guidance Law Development for an Advanced Launch System," and it's a pretty interesting document. If you go to section 1, page 2, under using simplified models, it states in the very first sentence, Chandler and Smith have developed an IGM for the Saturn V vehicle. It is based on a flat Earth, no atmosphere model, and is further simplified with linear angle steering guidance. That's pretty interesting statement.
The Saturn V?
They're trolls, man. That's all. I don't believe anything.
You're good on the perms. You're good on the pick perms now, but you said Saturn V?
Yeah.
Yeah, I believe. Yeah, so Saturn V.
Why they used a flat Earth model to fly to the moon?
I'm telling you, they're trolling us. They're trolling us, man.
Yeah, that's got to be.
No, I'm not trying to.
Come on.
I'm not trying to.
No, not you. The fucking document.
NASA.
Oh, right.
Yeah.
They're trolling the world, man.
Yeah, dude. It's everyone.
And it says it multiple times without in the document that all these systems and I even have some other documents about how they develop missiles and guidance systems, and in them when they create them they're using flat Earth model, and they admit it in all the documents that it's not, they don't create them based off their sphere model that they give us, which I thought the debate was over. I thought they proved it was a sphere. So how come they can't use their own model to create their own guidance systems? They have to go off a flat Earth model?
Because their model was purported prematurely.
Yeah.
Sorry, go ahead.
No, I know the answer. It's just I like playing devil's advocate and putting it out there for people that are new to the server, that you could go and find these documents yourself online and look it up and read it, and and ask yourself, what are they saying? Why are they saying this?
Yeah. And there's that 35 documents link too. So, so just in this conversation, 36 documents that we both know of, that why would they ever use flat Earth or non-rotating or level or stationary at all with the Earth if it were any of the opposite things, curving, moving, etc.? Why would you ever once, let alone 35 plus times, have to fucking say, well, just in case it's flat, we're going to use it for flat for this experiment? No.
They're using flat because it's a refraction.
You're right. The globe refracts to a flat plane. Correct. Yes, you're right.
That is the only place. Yeah, that's the only place that curvature exists, is within refraction fantasies.
Yeah, so after refraction, Earth is flat. Before, it's a ball.
So how do you crash a rocket into a refracted horizon?
It just refracts around the ball, doesn't it? It just keeps on. No, it will skip across the water, like the skip and stone hypothesis from that one. It's gonna bounce.
It skips across.
Yeah. Like he said, that's what the laser was doing.
That SpaceX, that recently SpaceX launch they did, where it looks like the rocket, when it reaches a certain point, it almost sort of implodes, and you see it almost looks like it's skipping across some sort of barrier. Are you guys familiar with what I'm talking about?
Yeah. So like if you skip a rock over a lake, from your perspective, it's bouncing on top of it. Well, this looks like it's upside down, right? It's bouncing on something upside down that way. Yeah.
Light skips across water. You didn't know that?
Light does?
Ask a PhD in cosmology that teaches at the University of, University of Britain?
Something like that. He's British dude, right?
I feel like I could just take your word for that.
It's on my channel. You can listen.
We have it. It's recorded, bro.
There's a reason why we record things.
Yeah, for sure.
It ain't just because we want to spy on people. It's because, we want to get these people on record. Because they don't know what the hell they're talking about.
True cosmology.
We literally said Epicore test happened and was successful because light skipped across water like a rock.
And I think the entire chat just lit up when he said that. Like, it's just like.
So did it?
I know he made us spiral.
Wait, did it skip up to the Sagitta and then skipped back down from the Sagitta?
Yeah, like a skipping stone, man. You want
to know the reason why they don't use spherical geometry for any of these things? Just look at how difficult it is to do rotations in computer graphics. Because you get things like gimbal lock, like in the mathematics itself, it's very difficult to do.
It's like this, man. If I were to go start training to be a pilot, and I would be telling them, okay, but when do we account for Earth curvature or spin? And the whole time they're like, dude, we need you to stop asking that question. You're wasting our time.
Because when you're using a ball as the basis of everything, you have to do rotations to figure out anything. So, you need the orientation of the craft, you need the orientation of the Earth. So to figure this out, you have to do rotations. And rotations are mathematically notoriously hard. So they need to actually use multiple methods. They need to jump between linear algebra, matrix algebra, and quaternion algebra, just to be able to do anything depending on the relative positions of like the crap to the Earth. This is like a known problem in computer graphics. That's why they don't do this shit in computer graphics. And that's why astronomy is a point, because they keep, listen, people, math is reality. Well, that math can't really model certain parts of reality, especially when you.
You know what math is? It's utterances from a being. That's what it is. Math doesn't exist.
It's a tool. Quoting Heaviside, he said you could come up with any mathematics you want, as long as you can trace your way backwards. You're good.
Hey man, can you explain mathematics to a cat?
That's like one of the lead fucking mathematicians of all time. Like, that's Oliver Heaviside.
I know, but what I'm saying is math is just is like an opinion and then communicated with utterances. But the opinion, it only exists in our head. I can't explain math to my motherfucking cat, but I can explain to him what food is and what's different about these foods.
With numbers, mathematics is a language. Like English and Spanish.
Oh, the language is a contrivance. That's what I'm trying to say.
Right. Yeah.
It's a way to compactify concepts into symbols, right? And then use like those symbols and use like certain operations of those symbols instead of writing it all out in words, because you don't have to use symbols. You could write it all out in words, right? I could write out the number 1 in a word. I don't have to use the letters and all the symbols, right? And all those would have definitions, and I can use those like. Man, you think mathematical equations are long now with just numbers and symbols. Write out the whole word, man. You're going to be writing down shit forever.
Done.
you write down 20 pages of equations just became 2,000 pages.
Yeah.
Isn't mathematics also like coded in nature? Isn't there
Fibonacci sequence?
You're cherry picking. Listen, it's cherry picking. Just because certain types of mathematics can model aspects of reality, you know how many models failed?
Right.
Like, oh, let's use these mathematical. Oh, that doesn't work. Let's try this one. Oh, that doesn't work. And eventually, through trial and error, they came up with one that actually does work to a degree, right? It's never 100% precise. That's how you know a Glober's a propagandist when he says, predicts things perfectly. You know he's full of shit. Right. Mathematics doesn't predict anything perfectly.
Not only that, postdictions.
Yeah, exactly. Data fitting, right? So you can take a bunch of data and do what's called a least squares regression and figure out what the average is of all those data points. But you know what they say? There's no such thing as the average man. He doesn't exist.
Right? So are you saying that even to like if you try to use mathematics to prove creation, that you're still in a way kind of cherry picking because you're just throwing multiple equations at something until you get the answer that you want, so it doesn't necessarily prove creation, like DNA, human DNA, for example.
Yeah, but rules prove deliberation.
Like intelligent design and code inside human DNA. So if that alone, doesn't that prove intelligent design?
Let me say this real quick. So patterns are deliberate, right? Patterns don't happen naturally like they think it does with evolution and stuff. So since rules and patterns are put in place, something had to put them in place. That's my opinion.
Yeah.
Now, let me give you something a lot of people don't know about. There's something called the problem of measuring a coastline, right? So if I want to measure, and this applies not just to a coastline, any surface or boundary that is undulating, right, that changes direction. So a rough surface, a coastline, it could be anything, right? The surface of the Earth, right? So it's got mountains, valleys, all that stuff, right? That's an undulating surface. It's not smooth. It goes up and down. So if I wanted to measure the distance between point A and point B on this surface or a coastline, the length will change depending on the unit of measure that I use. And the smaller of unit of measure you use, the longer that surface becomes. So like if you try to measure like the coastline of England and you keep like, I'm going to use miles as a unit. Oh, I'm going to go down to half miles. I'm going to go down to meters. I'm going to go down to inches, millimeters, nanometers. The coastline will get longer and longer and longer and longer the further you go down in units. And it'll get shorter and shorter and shorter the more you go up in units. So something as simple as measuring the length of something, right? Because there's nothing actually smooth in nature. You can't even measure the length of something actually.
Mm-hmm.
We can pretend we do. So it's this long if I use inches, right? But if I use nanometers, it's actually longer than that.
It grows and shrinks too with temperature, man. It expands and contracts.
Oh yeah, then you got all those. Yeah, then there's just the variability of nature itself.
You gotta fix the temperature to have length. You know what I mean? Otherwise, you're all over. Like, okay, accurate.
Wasn't there some recent study done by a university too that they actually measured one of the states? I don't know if it was like Kansas or Nebraska or something. Then they made the assertion that that state is actually flat as a pancake.
Flatter than a pancake.
Oh yeah, flatter than a pancake. You know, I don't know how they did that and what form of measurement they used, but I thought that was interesting too.
They compare they compare the ratio of the height of like the height differences versus the length difference.
Okay.
Right. So if like you have an average height of say 1 inch, but the average distance between those 1 inch differences is like a mile, right? But if you had a whole bunch of those, it's really the difference between a roughness of a surface. You're just taking it's just the really thing how smooth it is more than how flat it is.
And with those measurements, you basically obliterate the sphere because there's no what is it supposed to be like 8 inches per square mile or of curvature or whatever it is, a mile.
8 inches per mile squared.
I mean, yeah, regardless of how big the surface is, you should be able to calculate that and physically measure it, but nobody has. You know, it's.
Well, yeah. Well, we tell Globers that all the time. That it's like they'll come in here. Oh, the Earth's too big to measure. Like it should be easy, super easy.
Yeah.
According to their numbers, it's easy.
Right? How can anything be too big to measure? If that's the case, how did they measure and give us those measurements of the sphere? Even, I mean, how did they do that?
BC or
where's the? Yeah, I mean, come on, it's silly.
If you can do it then, we should be able to do it now. Yeah. Sticks and shadows.
When I get frustrated too with people that say, "Oh well, the Coriolis effect," and how come snipers they need to account for curvature? They don't. That's not true. That's a total lie. Nobody that I know that target shoots and uses long range rifles, nobody's creating equations for curvature when they're shooting at targets miles away. Nobody I know does that.
They would need to know their exact latitude and the direction they are pointing. Right.
Yeah, you do like elevation things and like wind
so complex. It's not like it's windage and elevation. It would be so complex, man. Like, fuck, you'd be there for hours and the target already moved.
And you would need your elevation too.
Yeah. You're done, man.
It's funny though because there are actually Globers out there with rifles. I mean, I don't know how many of them are in the military. Probably not many, if any at all. But there are Globers out there with sniper rifles that actually think they're accounting for the Coriolis effect. They think that.
Yeah, that's the magic, right? That's a magic trick that they're fooling themselves.
Look, it's one of these things where like, okay, say I'm shooting at a target, right? And like the accuracy of my bullet is going to be like a 6-inch spread. And the Coriolis effect predicts a deflection of like 1 millimeter. I can't tell the difference between the so-called Coriolis deflection and the natural spread of the shots. Right? I can't distinguish. Did Coriolis affect this or not? Because the natural variation of the flight of the bullet is larger than the deviation from the Coriolis effect. So it's like, what are you accounting for? Like, you have to be accurate within a millimeter when like your shot spread is 6 inches. Like, stop it. You're just being stupid at this point.
Well, they're talking to idiots that think bullets fly in like laser beam. Bullets are laser beams, you know, and that never spread, of course. You know, that's what they think.
Yeah. So like the what was it? The USS Iowa, the frickin' battleship dude with the 16-inch guns. They're like, this thing has to account for curvature and the Coriolis effect. Well, if you look up the firing chart at 30,000 meters. the Coriolis effect deflects it something like, I think it was 90 feet, right? Okay, but the spread, the randomness of where that thing lands, it was tested, and the mean spread is 250 yards, right? So you have, if you don't know the accuracy within 250 yards, what the hell does 90 feet matter?
Right. Yeah.
90 feet is a basketball court, and 250 yards is 2.5 football fields. So I don't know where it's going within 2.5 football fields, but I need to know where the accuracy of 90 feet. That makes no sense.
Right.
And just because
You're a science denier,
because it is in the firing table. It's in the firing table. Like they have the firing table. Like, yeah, this is what you're supposed to do. But if they don't do it, it doesn't matter. Like, it has no practical effect. They're not missing if they don't account for Coriolis.
That's why you're not a great shot, bro.
Anybody that knows about, and if you listen to people like, so I know some people that were like in Vietnam, right? So I know a person, he operated the radio, or he was a radio person in Vietnam. So he would get calls in, right? So he'd be like, we need artillery at XYZ spot. So he would call the artillery and say, hey, they need artillery. Now they know exactly where the people are, and they have all their firing tables. They would have to walk the artillery in because they don't actually know where it's going to land. They know within a certain range of where it might land, but they don't know exactly where it's going to land. So they would start short, right? And they would walk the artillery rounds in. Be like, okay, you're like, they would call, hey, you're still like 1,000 yards away. Go forward, another 100 yards or whatever. You know what I mean? And they'd make their call, and then they'd call, and then they'd call. They would coordinate where the artillery rounds are landing. They didn't just sit there and look at a calculator and go, this is where the bullet's going. It doesn't work like that. This is why I swear to God, Gulliver's never actually built or do anything in their entire life. Like, seriously. Or at least the ones that come around here. They've never done anything.
Internet trolls, man. That's what most of them were. Not all of them, but
I built a PC.
Well, I did that when I was like a kid, man.
Yeah, exactly. You plugged the parts together. You didn't build shit.
Fuck. 8 parts. 8 parts. You plug them in, the slots.
You can't even plug it into the wrong spot.
A lot of them can't for some fucking reason.
I want to see you try to plug an IDE cable in wrong. Go for it. I want to see you do that. You're going to be pushing for a long time.
They're the kids that bought like the snap together car, the little model cars.
Oh, the snap-on
models. The ones where you had to buy the glue and you had to buy the paint. They were buying the ones where you just snapped all the pieces together instead of actually having to glue every little piece meticulously to put it together.
The rich kids had them.
They wanted to.
Us poor kids, we had to glue it together.
I'm curious about
way more expensive. Anyway, just a side note. No, go ahead. Sorry.
I was thinking about something else the other day. I was talking to somebody and they asked me a question about mountains in the peaks of mountains all around the world, and if the sun is so local, how do we have all that snow on those peaks of the mountains? Because they're closer to the they should be closer to the sun. So why doesn't it, when the sun goes overhead, warm that and melt that? Which I couldn't give an answer because I'd never even thought of that before.
In either model, it's the same, bro. Even on the globe model, mountains are still closer. So it's irrelevant, actually. It's very stupid of them to ask that. Because that inverse relationship exists in both models. So it's kind of quite
you're right.
I mean, to me, it's irrelevant because that's what it does anyways. So according to their theory, well, how? We're getting closer, aren't we?
Mm-hmm.
But of course, they'll say the height of the mountain relative to the distance of the sun is nothing, right? Just like India saying the accuracy, if you're 90 feet within your 250 foot, range is nothing. So it's the same thing, really. And I don't know why it's like that. So if someone knows why, that'd be awesome.
It is interesting getting back to the gun thing because I had an uncle in law who he worked for the FBI, and this guy was a crack shot. I mean, we'd go hunting with him, and we could be driving in a car, and he'd be like, "Hey guys, watch this." He'd roll the window down on the car and like shoot something from just a ridiculous distance out of a moving car with like his revolver, and he'd be like, "What the fuck? How did you do that?" You know what I mean? He could just shoot the flies or the wings off a net. It was ridiculous, and it doesn't matter what gun you handed him, he could hit the smallest target, whether it was moving still or whether he was moving. It was unbelievable, and he never had to sit down and do no calculations. Say, "Well, hold on, let me figure this out." No, he just pull that gun out, aim and shoot, and he would hit it every time.
But that's because he was accounting for Coriolis every time, and you didn't know about that.
In his head, he was calculating in a split second.
Well, you don't know. He was very smart, man. He was government trained. You know, he can do this stuff in his head. You're not. Gotta troll you a little bit, man. Why not?
No, yeah, we gotta laugh and keep a sense of humor about it. Otherwise, we go insane, right?
Oh yeah, man. Gotta have a good time.
Hey, if you guys want to look at something kind of funny, yesterday I was downtown handing out those QR code cards, with the Discord server QR code on them, and I ran into a woman who was handing out these pamphlets for Scientology. I just posted a picture of the front of it. I just thought it was kind of funny, interesting. I was asking her, like, doesn't that religion have something to do with planets and like aliens coming here to seed us from outer space and stuff? And she was like, I don't know what you're talking about. She I guess didn't know anything about that, but I was like, oh, maybe there's more than one type or something. Or maybe I heard wrong. I don't know. I just thought that was nice, though. Maybe she didn't know her own religion that well. I don't know.
Yeah, she's not privy to the secret doctrine yet.
Yeah, John Travolta made a whole movie about that. It's a horrible movie, but great for a watch if you hate horrible, painful movies. It's really hilarious. But he made an entire movie in that whole
Battlefield Earth.
I don't remember what it's called. Yeah,
Battlefield Earth.
Yeah, that's all that. That's what they believe. That's their religion. That's like the backstory. That's their Passion of the Christ, if you will.
I knew he was in that movie, but did he like produce it and direct it?
Oh yeah, he I think he paid for it, and it took him years, and he spent a ton of money on producing that film, and it was a huge flop. But yeah, you can look all that up. It's he had a big hand in that because he's like a god in that religion. Him and Tom Cruise.
There was some funny stuff also on the backside. I'll post two pictures of it. It's kind of hard to get in one picture, but it like had all this weird stuff having to do with like personality tests and feelings or something. Some stuff I didn't understand. But I'll show you guys the back of this thing.
Yeah, they talk about that in another film they made about L. Ron Hubbard. It's got Joaquin Phoenix in it, and I want to say Philip Seymour Hoffman plays L. Ron Hubbard, but I'm not sure. But they show that he goes through those tests, and it's pretty interesting and bizarre, but it's also really stupid. It's a boring, painful movie, but if you're into that, you might want to check that out. I don't know how honest the film is about how the tests go, but I don't know, it's interesting nevertheless.
Yeah, I'll also post a little YouTube clip. I actually recorded me talking to this woman because I thought it was, kind of funny, like someone being like, "Hey, Scientology, the planet was seeded by aliens or something like." Well, even though she wasn't saying that, but part of that religion, And then like I'm handing out these cards that are saying the Earth is flat and stationary, and the necessary antecedent for gas pressure is a container, which means there is no vacuum of space, which means there is no place for these aliens to come from. Just thought it was kind of funny. I'll post the video.
It's interesting too because I don't know how true this is, but they say that L. Ron Hubbard was actually just a failed, basically science fiction writer who was trying to make it big, and with writing science fiction books and trying to develop movie treatments and stuff and become famous, and it never worked out. So he just invented basically this crazy kooky religion, and that's what a lot of people say how it all started.
Close buddies with Walt Disney and Jack Parsons. The list goes on.
Oh, that I didn't know. That's
Did you know they were doing sex magic out in the Mojave Desert with Disney?
No, I did not. But
L. Ron Hubbard's wife apparently was passed around between all these little occult members. Aleister Crowley's protege was Jack Parsons. So they did this.
Is that why they say Aleister Crowley's the true father of what's her name, Bush?
Yeah, I've heard that. But the point,
the
point I was trying to make is, do you know where that location is today in the Mojave Desert or in the desert?
No, sir, I don't.
Area 51.
Get out of here.
That's where they were doing their sex magic and shooting rockets.
Are you serious?
Yes.
So they're probably still doing it today. They built that base and are maybe doing it underground.
Yeah,
and
probably,
using the same area too.
Probably underground Disneyland as well. Wonder why the CIA was involved in digging out putting the foundations in for Disneyland. Why was the CIA involved?
Yeah, that's fascinating. I've never heard that before. I'm glad you told me that.
Hey, you guys know what the most amazing thing is about having a GoPro? Is that with the GoPro, you can see the curvature of the Earth from the sidewalk.
Yeah.
It also kind of tripped me out how this woman was wearing plastic gloves.
I'm sorry, go ahead.
She was wearing plastic gloves and one of those face masks. It's just, I thought that was interesting, the combination of the two.
There's so many Glovers that I've talked to that said, haven't you ever been in an airplane? Haven't you ever been anywhere? You can see the curvature when you're, at cruising altitude at 30,000 feet in a commercial jet, and thinking, I've flown a lot in my life. Not recently, not since after 9/11. I refused to get on a plane, but I never saw any curvature, so I don't know what the hell they're looking at.
Yeah, I'm kind of the same way. I was always suspicious, before 2016, when I first, really found out the Earth is flat. I was kind of suspicious every time I climbed a mountain or flew in an airplane. Like, it looks pretty flat to me. Must be really big, I guess. Whatever.
All right.
What curvature can they see in an airplane, and why can't they see it at 1.2 miles a foot off the ground?
And why didn't anyone ever measure it?
Exactly. Another thing too is you would think at some point you would have to. At no point in our lives do we ever feel any motion of the Earth. Whether it's we're looking up at the sky, really we observe it and experience it as we're stationary and everything is moving around above us. But you step on a car, a bike, a motorcycle, an airplane, you feel the movement. You get on a giant cruise ship that is the size of a skyscraper, you feel the movement as soon as it starts to go. So, how is it possible that we would never, ever feel any type of movement whatsoever? I don't care how big it is. There's been people that have bet that, work every day in skyscrapers, and on really windy days, they can even feel the movement of the building kind of shifting around a little bit in the breeze. I mean, so maybe it'd be possible that you could build a vessel that is so large that you wouldn't feel movement, but I don't think so. Not the way we were built and designed. You always feel any little slight movement. Especially people that are super sensitive to movement like me. When I was a kid, I had a lot of inner ear problems. And so I have constant fluid build up in my ears. So I'm very sensitive to that sort of thing. And so you would think people like me, especially, we would feel an almost motion sickness sometimes, but no, nothing.
Well, since there isn't any invisible force that we know of that would form space balls out in the vacuum of space and contain gas without a container, since there's nothing that can do either of those things, there is no vacuum of space and the Earth is not a ball.
Mm-hmm. Yeah, I need to do better homework and get more versed, because I get so frustrated with some of these arguments to the point where, like, I don't even want to talk to anybody anymore. And I know there's simple logical explanations to all Glober's questions, but after a point, I'm just like, I feel like giving up, because it seems like it doesn't matter what I say, you're not going to listen to me, because they always have some bullcrap go-to image, or it's like the water one, for instance, when you take a cup and fill it up with water, and you see that the water sort of coming over the edge, and they're like, see, water can curve, and you're like, come on, that is not the same thing at all. That one really bothers me. I hate it, because every time you get in a conversation, they'll always bring that up at some point. They always go with that's their go-to image for curvature with water.
Are you talking about surface tension, like droplets holding their shape?
They'll show that. Yeah, they always pull that stupid card and show you that glass with the water curving over the edge.
Yeah, I had a similar one. I had a similar one with gas pressure with a brother of mine, and he's a nanophysicist. Like, this guy, he's a physicist. And I asked him to demonstrate gas pressure without a container. And you want to know what his freaking whack-ass, smart-ass answer was? I said this more than once, too. It's like, oh, dig a hole. And it's basically in his flawed mind or whatever. He was basically saying that if you dig a hole and the air pressure is greater down in the hole than it is up on the grass where you're standing, then that qualifies as gas pressure without a container. Like, no, dude, that's just lower down on the gradient. That's not gas pressure without a container. He's a physicist, for God's sakes, a fucking physicist.
Well, that's what kills me too about these really smart people like that are spent their whole life in school and have all these degrees. When you start talking to them, they're dumb as a box of rocks a lot of times. Like I've always had this joke where like, you know, engineers and physicists, like, yeah, they're really smart, but when you get them home and you tell them to change a light bulb, they don't even know how to change a light bulb, or, you know, do really simple, easy tasks. It's really crazy.
Well, actually, I would say that they can change light bulbs. That's just it. A lot of them, I think. Let's say, I think a lot of them. It's a suspicion of mine that a lot of the smarter normies or more talented globers, you know, the few that exist, I think a lot more of them. This is just a guess, but I'm pretty sure a lot more of them are technicians, and you might find maybe a lot more flat earthers that are engineers. So it's like they can get stuff done. They're good at following directions. They're good at doing that, but that doesn't mean that they're necessarily that smart.
Mm-hmm. Well, it's hard for them to like think outside the box and go off of the directions, and you know what I mean.
It's hard for them to think for themselves.
Yeah. I mean, I'll be the first to admit I don't know any. You know, I'm not that smart at all. I have a high school education, and like when I go over some of these documents that people have given me or that I find on the internet myself, and I download them from NASA and whatnot, and I'm trying to read them, I don't know half of the stuff they're talking about. Most of it's going over my head, but I read it anyway, and I could recognize certain things like word like flat Earth and non-rotation, and you know, I understand what all that means. So why are you, you know, and it just confirms my belief already that if what you're saying is true, that it's a sphere, you don't need to put that language in these, you know, in this paperwork, because you wouldn't even consider it at all ever. And nothing you create should work with those models if your model is true of everything being rotating and spherical. And you know, that's enough for me. I don't need a PhD to understand that.
Hello, guys and gals of the YouTube. All right, this is just a Tesla hairpin circuit. There we go. Oh, it's unplugged. For safe.
Hey, I just want to throw this idea out there. I've said this like many months ago, but it's something I just tried to do now. But I ended up hanging up the phone because apparently it's a repeat. It's not a live show. So I was about to try and call into a radio show that's locally produced here in Portland called the Lars Larson Show. You guys may have heard of that guy. He makes some, good intellectual points. Makes a lot of them, actually. But, I wouldn't exactly politically or socially align myself with this guy. But, he's a decent guy for the most part. And the thing is I was going to call it's Free Speech Friday, or it's supposed to be Freedom of Speech Friday, where you can call in and talk about whatever subject matter you wanted to. So I was going to call in and say, the Earth is flat and stationary, and you can't have gas brush without a container. And, talking with them about flat Earth for as long as I could. But, like I said, it's a repeat, unfortunately. So, he's not at work. Nobody there, just a recording playing. But I just wanted to throw this idea out there to anyone listening. You should really try to call into whatever radio show you can and just mention the fact that the Earth is flat, because you never know who might be listening. I mean, with his show, it's more than 1 million people, I think, is the audience. So.
That is a good idea. I used to try to do that when I was a lot younger, when I first kind of started to get into politics, and I started listening to Rush Limbaugh. And I would try to call into him once in a while and bring certain topics up, like, and not to say that I subscribe to all these ideas, but like one of the things I used to try to talk to him about was, Jewish conspiracy. And oh my God, would he have a tirade? I would immediately get hung up on, and then he'd go on a tirade about, what horse crap it is, and it would never become an actual like conversation to where we could bounce ideas off each other. And even I would try to do the same thing with 9/11 stuff. Like, you would just get booted off the air so quick because there's certain topics that they're just not going to entertain on a big platform like that because they know they can't.
I actually have a similar story with Lars from a couple years back. I don't remember exactly what the quote was, but what's his name? Newt Gingrich. Yeah, Newt Gingrich. I was about to say something different. That guy, he was on Fox. I can't remember exactly what he said, but he said something referring to secret societies on Fox. And I basically, the next day called up Lars, recited to him the quote, and then asked him what his opinion is of it. What do you think he's hinting towards or something? And Lars actually gave a pretty good response. He actually brought up the Skull and Bones secret society and mentioned how a lot of presidents and politicians are, of different sorts are, associated with them. And I didn't even say Skull and Bones. He said it. I was like, oh, cool. You're bringing it up yourself. Good. Educate the public. Why don't you? And, so I just, thought that was interesting.
Yeah, that's there's some topics like that one now that's not taboo anymore, and they can mention because it's all been outed, and they didn't get in any trouble. It didn't stop it. They're still in power. They're still doing what they do, and nobody really cares. Another topic I used to always try to bring up when I'd call into certain shows like Rush Limbaugh was Bilderberg Group, and that again, like I could not get Rush to say the words Bilderberg Group on air. He would just immediately hang up on me and basically recite the whole thing as there's no such thing. There's no conspiracies. There's no group of people coming together to do anything. And that'd be the end of it. And then of course he'd take a bunch of calls from people that agree with him and basically just ridicule anything that I said or the whole topic that I brought up. But yeah, I've been there, man. And even that now, Bilderberg has kind of come out and become mainstream. And now you got the president all the time when they have meetings sneaking away, and the press will be like, well, where is the president? Where is he at? Oh, we don't know. But damn well he's at the Bilderberg meeting, but they can't say that. But that's pretty much out in the open now. It's not a conspiracy anymore. They pretty much, admitted on any station that yes, there are these powerful people that meet in secret, and nobody's allowed to know what goes on in these meetings.
I think the Bilderberg Group is, psychologically speaking, with its effect of its existence on people, it reminds me a little bit of the flat Earth, because I can think of family members of mine that have been told that the Earth is flat by me, and they just simply don't accept the truth. And then at other points of time in the past, I've told them about the Bilderberg Group, and they say, oh, yeah, I've heard about that and everything, but I just simply don't believe it exists. Like, fucking hell is that? And I asked him, like, did you do any research on it? Like, no, I just don't believe it. It just doesn't exist. I don't need to do research on it. It just doesn't exist. And the Earth isn't flat. I don't need to do research on that either. You're just wrong.
Yeah, that's a person not thinking for themselves, or they're just lazy and don't want to put the effort into, research that sort of stuff on their own. It is overwhelming. I remember I used to get these flyers, these like postcards from architects for 9/11 that would point out all the inconsistencies and basically prove how those buildings were brought down by demolition. And I would mail them to all my friends and relatives. And then when I would see them at functions, I got to have a couple of people come up to me and try to talk to me and say, wow, that stuff you sent me, it was fascinating and really interesting. And I was like, yeah, it's, you need to be aware. You need to look into this stuff and ask yourself these questions and realize that we're not being told the truth. And one of my uncles one day, he said to me, yeah, you're right. And that is really good. And then he said, but, I just don't see how it affects me on a day-to-day basis. So I really don't care. So, he didn't understand, how does it not affect you? What do he didn't get that. Yes, it does affect you. Everything they do affects you. And that's a big problem, I think, with a lot of people have. They can't see the big picture, don't see how it affects them on a day-to-day basis, when in reality, it actually does.
Yeah. You're given a choice for president. You can vote for candidate Coke or candidate Pepsi, red or blue. But that Coke and that Pepsi, they were chosen by the Bilderberg group. So you're really just choosing from what they give you. So it's really their choice, or whoever behind the scenes.
Exactly. It's not really a choice at all. It's like wrestling. It's like you're rooting for the good guy or the bad guy. At the end of the day, when they're not in the ring, when they're not on stage and they disappear behind stage, they're all best friends and buddies, and all the outcomes and everything they do on the stage is all pre-planned ahead of time. It's the same thing with everything they shovel down our throats, with everything they show us in the media. And they create a problem. They already have the solution in place, and then they give us a solution. And sometimes they try to give us a choice. Well, you can vote on this or that, but at the end of the day, it doesn't matter which side wins. The game still remains the same.
It really does seem like a clever strategy to, suppress peaceful, intellectual, constitutional revolutions, is to simply present them the illusion of choice. Because I think Mises has actually pointed this out before, that one of the biggest problems with democracy or a democratic republic is that if most people think that their vote counts, and maybe most people do, maybe a lot of people do vote, and a lot of those people think their vote really counts for something relevant, then that puts them behind the revolution curve. It basically puts them in a state of mind where they're like, oh, well, everything's just fine. I have choice, and I don't live in a dictatorship, so there's no reason for me to get angry. There's no reason for me to protest in the streets or anything, or do anything about it, or anything, because it's just that illusion of choice that makes them feel comfortable, makes them feel safe, makes them feel like they actually have control of things, when in reality they have control of nothing of the sort. They don't have any control over who's president or what the president does.
Well, the way society is structured too, it's for a lot of people that have to work extremely long-hour days just to maintain a roof over their head and to feed their families. A lot of people don't have time to really fight and research and try to come up with a plan to get back and try to make a change at all. Some people just don't have the time or ability, that are working their tails off. It's tough. It's really tough to dedicate, because you almost have to dedicate all your spare time to this stuff. And a lot of people just aren't willing to make that sacrifice. They want to get home, relax, turn on the TV, and just be left alone. They don't want to have to come home and do homework and research. You know, that plays a big role too. Seems like a lot of people have just lost the ability to think for themselves and ask questions. They just come home, sit on the couch, turn on the TV, and are waiting for somebody else to tell them what they should think. And then without even questioning it, they just absorb that and then say to themselves, well, okay, that's what I needed to know. Good. Now I can move on with my day. And, you know, now I know who to vote for, or I know what to believe or what not to believe, instead of, you know, figuring it out for themselves and looking within themselves and finding the answer in themselves, which we are all capable of doing.
I think a big portion of this has to do with comfort zones and whether or not people remain in them or not. Because it seems to me like, you know, they're not going to, most people wouldn't do anything, not even bother to vote or anything, you know, not do anything at all in regards to who rules their country if they're in their comfort zone. If they go to work and then they come back home, they drink a beer and watch TV, they're in their comfort zone, you know, they don't really feel any desire to change anything, and as long as they can be kept in that comfort zone and maybe thinking that they live in a ball and a spinning ball in the vacuum of space, you know, thinking that too. The point is it's only when people get out of their comfort zones then they actually rebel a little bit, and that's what I think these you know, strap things on your face mandates may have actually pushed some people out of that comfort zone. And maybe some of the other things or whatever may have done that, but more recently. But you know, it's the point is you know, most people they just stay in their comfort zone.
The mask mandates haven't been about anything to do with that at all, have they? Really? Why would a government put an instrument a policy to make you think more?
No. You totally misunderstood what I said. That's not what I was saying at all. But what I'm saying is that's not. I'm not saying they did that for that reason. I'm just pointing out that would have had potentially that effect. Well, no, it did have that effect, at least with some people. But no, I'm not saying they did that for that reason. Don't misunderstand me. No, that's not what I was saying at all.
I think the sort of people who are on some, and I use the word not in a disingenuous way, it's people who are immobilized or mobilized by the masks are the sort of people who would be immobilized and agitated by a whole range of things before the masks had to go on our faces. You know, I think the masks. I don't think the masks really. If you were watching the news, you saw an awful lot more people very angry. But if you're in a lot of communities, people just got on with it out of courtesy. I mean, I'm in the UK, and we've just lifted mask mandates. And by and large, when they were on, most people were courteous enough to put them on. Because if a doctor could put one on for 9 hours, yeah, to save people's lives, okay, right? The same mask as they're being asked to put you on, okay, yeah, or me, yeah. If you can't put, even if there is only 1% of truth in what they say that it saves lives and it stops contagion when they couldn't control it, yeah. Even if it was 1% as opposed to 5% or whatever they said, yeah. Even if it was just a thing to make you sociologically think and trigger to be more careful when you're out, okay, right, yeah. The fact that people were prepared not to do that says more about those people than it does about the government.
Do you mean that in a cold-hearted sense, like they don't care about putting grandma in danger? The key word in what you just said there was if, as in, you know, if as in it hasn't been validated. The claim that strapping things on your heads helps anyone. Big if, you know, like if the Earth was a ball, then we'd have satellites above our heads. And they tell us that there are satellites orbiting above our heads, falling around the Earth. So it must be a ball, right? If.
Yep, too bad they have no medical or scientific proof for anything they're saying from the very the very basic foundations of the entire lame-ass paradigm. There's no proof for it at all. Actually, proof to the contrary that limiting your oxygen intake is unhealthy.
And outright doesn't feel good. If you're the kind of person that likes oxygen.
Yep, but some people like to replace instead of feeling like a slave, which they are. Oh, they think they're doing humanity good. They're doing something good. They're virtuous. So all they've done is replace their stupidity with with a blind allegiance.
I remember that's what we have to. I'm sorry. Go ahead.
No, you're probably gonna say something better. You go.
No, I was just going to say that's one of the things that we have to try to somehow help our neighbors overcome is that willingness to just believe everything they're told by these elites. I don't know how people got it in their heads that these heads of government really care about us. I don't understand where that comes from and how they feel so strongly. It's almost like religion. It's almost like trying to tell an atheist that God exists or a Christian that God doesn't exist. It's like it's really hard to break through that condition they have where they just believe everything they're told, no matter how dumb it is.
It's literally Stockholm syndrome is what it is. Literally Stockholm syndrome.
How dare you insult my favorite saint?
Yeah, exactly. Right, Trace?
Yeah.
What's the matter? Don't you believe in science?
No, they take it personal. Like they take a personal affront that you're discounting their priest.
This is crazy how they put the word belief in front of science like that. Like, come on, what the hell are you doing?
It's crazy too when you see these voters on election nights and their candidate loses and they're weeping and crying. Can you imagine? I mean, what is wrong with you?
That's how real they think it is.
Yeah, it's really disturbing. It's really disturbing. That's all I can say. I don't know, and I don't know how do you get somebody out of that mindset? It's maybe you can't.
I know. You fake an election and you show to all the world that elections don't matter. That it's not real. That's how you do it.
You mean steal an election?
I was going to say I thought that's happened so many times. I think.
Basically every time.
Yeah. I mean, and I've said this before. I think there's a lot of globers that you could actually, if you could take them up in some sort of spaceship and get far enough away from the Earth, and they could see with their own eyes that it is not round. I think they could still come back down and still not believe and still think that it's a sphere and somehow, it was a trick or they don't believe their own eyes. So they're still gonna. I really think there could be a few people out there that would have that mindset. That no matter what,
Yeah, well, look at all the excuses they make here. So they would just make another excuse.
Yeah.
Well, going really high up,
you didn't go high enough.
That's too easy of a place for someone to have their imagination play tricks on them. So I think a better example would be going to a body of water with a telescope or laser and then making observations or tests with the laser with the body of water. If the glober at that point said, "Oh no, the Earth is still a ball," see at that point, that's when they're truly at the height, the very highest point of cognitive dissonance.
Yeah, that's I like that. I like making them test it with a laser, especially if you get them to test it with two different wavelengths on the lasers. So the follow-up denial can automatically be ruled out.
And when you said spacecraft, I think you meant aircraft, because I mean, there is no vacuum of space. There's no such thing as a spacecraft.
Yeah, you got that. See, yeah, even I do it to myself sometimes. Man, but yeah, it's really interesting that you have these, because what brings somebody to that awakening when you become a truther? Like, was it always something I had in myself? I wonder if did it happen because I sought it out?
I think so.
And I think I think that's what it is too, because I've always had this feeling my whole life that nothing feels right. Ever since I started going to school and being taught all this stuff, I constantly questioned everything, and it seemed like the more questions I asked, the less answers I got, and nothing in society ever makes any sense. And it's crazy to me that other people don't feel the same way I do and are questioning, well, why is it like this? Why are all these things set up like this? And it seems like that just doesn't happen in so many people, and they just go with the flow and they just allow any, it's like you said, cognitive dissonance and Stockholm syndrome. But how come? I mean, I guess I had a touch of it because I believed at one point in time in aliens and that the Earth was round, and it was awesome. I love science fiction movies and stuff. But then when I got awoken to the truth, like, it didn't hurt me either, and I wasn't mad. I was just like, yeah, of course, it's been in front of my face all the time. How did I not see it sooner? I felt dumb, but I was also glad to finally be more aware of who I am and what my purpose is and where I am. So it felt good.
Well, you're certainly not dumb for not receiving all the information you needed to make a decision on whether or not you contended with the heliocentric model. There's lots of things that probably should have been gone over in class when we were younger, but for some strange reason it wasn't. So, instead of being mad at yourself, I'm not saying you are, but for those that, you're getting mad at the wrong person. And unfortunately, the people that are perpetuating this disinformation, who knows who they are. So there's that.
Mm-hmm.
But please continue. I love everything you're saying. It's wonderful.
It kind of reminds me of like when I was a kid and going to Catholic school, and I was told, you need to confess your sins, and for some reason you need to do it with this priest because somehow he's a conduit to God, and that I'm not worthy enough just to confess my sins on my own to God, that I needed another man to do that for me. And that never made any sense to me. It didn't, and I don't want to get on a whole thing about religion and
right.
and all that, but it's just it was just one of those things in my mind that it just never made sense, and nobody could ever answer those questions for me either. Nobody gave me a good solid answer to why that was necessary, other than that, well, this is the way it is. And it's kind of
I hate that.
Everything.
I hate it when people say that.
Yeah.
It's like we're not allowed to ask questions. Sorry, I apologize. What'd you say?
No, that's fine. Yeah. I was just going to say it's the same thing with government. They do the same thing. Like, why am I paying $1 billion taxes? For what? Why? I'm already paying taxes every time I go to the store. There's a tax on every item I buy. When I register my vehicle, there's a tax on that, and then there's a tire tax, and a road tax. And it's like, what? Where is this coming from? And why is nobody asking? Why are we just paying this? Nobody's saying, what the hell is going on here? Why are we? You know what I mean? No, everybody just does it.
It's called, there are too many distractions. You work 40 hours a week. Many times a lot of people work overtime. Then they have barely enough time to pick up their children, make dinner, do a few chores, and if you're lucky, watch a movie or something, and then go to bed and do it all over again. People don't have time to look at these things.
Look at our police force. How, I don't blame our police force for what a lot goes on, but they are responsible in a lot of ways because they don't do a good job of policing who they hire, and their training has become so militarized. That's the wrong way to train police officers. I'm sorry, go ahead.
Well, I think when you're talking, I'm so sorry for interrupting you, and thank you for letting me jump in here. In my opinion, when you're dealing with police, they're just like everybody else. They're just trying to do their job and go home. And I would surmise that a good portion of them could potentially be ignorant to things that are going on. So they're just doing what they think is right. Same with teachers. Teachers unknowingly perpetuate misinformation. They're not lying because you have to know what the lie is before you can perpetuate a lie. I mean, so yeah, it's just a lot of stuff's going on. And, a lot of times people say, well, there was this guy in here the other day, well, flat earth isn't the most important thing going on here. And I'm like, oh, contraire, more frere, I beg to differ. Because if you don't know where you are, how could you possibly know or begin to know who you are?
Exactly. Exactly. And that's one of
So,
the things that lie does to so many people, is it makes them feel insignificant, and they don't have any purpose, and they don't know what the purpose of life is in their existence, because they're told they don't mean anything, and it just all happened by accident.
So
When that's none of
everybody
that's
has to
true.
identify with something, so they identify with what they like, be it movies or, whatever hobby, or, people just get sucked into video games, and there's an endless amount of distraction to take us away from what you were talking about. And if you could elaborate too, that'd be great. Yeah, I love it.
Yeah, I totally agree. But I know it's even hard if you try to, on an individual, small, local level, to make changes in your own community. That's even hard, because even if your heart is in the right place and you try to do all these right things. For example, my father became police commissioner in a small town we lived in years ago. And so there was a big problem in that community with the local law enforcement. They were, I don't want to say they were corrupt, but they were doing a lot of odd, shady things. And there was one police officer in particular that actually was well known that he raped and murdered a girl in the woods. And for some reason, he wasn't fired. He was never convicted.
Oh, well, you
And
know
the
what?
whole hiring process. Excuse me, let me just tell you this real quick. So when my father was a police commissioner and trying to hire new guys to be cops, he'd look at their records and be like, I don't think we should hire this guy. He's got a horrible
Well,
record. And everybody would vote against him and say, no, let's hire him. And
okay, so I apologize. I'm not trying to be rude to you. I just happened to notice that Drace was kind of having an involved conversation about fallacies, and I thought maybe, he could jump in with the person that he was talking to in text. I thought that made sense. Drace, are you available to be on voice or no?
Yeah, sure. His issue is with Joshua currently. He had an issue with a spelling mistake, and then from there went on to make some other claims about what he was saying, what he wasn't saying, and other
Dexter
stuff.
Gordon.
Yeah.
Is he in the voice chat?
He is not. Thank you for that check.
Okay, we have a problem here. Kidding, but sort of not. Alrighty, there we have it. Dems the rules. So unless he wants to get his big man self up on the mic, kick him out. You can't kick people out of the text, though, right? I don't think. Too bad.
I can, but
Well, yeah. We'll see if he wants to. Is he? He's free to join us in voice. Anticipation. See. That's a shame. Yeah, I'm not really sure what this is supposed to mean. I'm just kind of scanning up the voice text a little bit. And Dexter Gordon said, if you can't chuckle at the irony of decrying the cognitive deficiencies of others in a sentence fragment with incorrect spelling, then you missed out. Yeah, that's what you're talking about, Drace. It is so...
He's a
yeah, we ain't
numpty.
got time for that.
He can't respond to the point. All he can do is talk about spelling. He's an idiot.
Yeah, that's... Okay, this ain't our first... Well, he's not in here. That's too bad. I think it should be part of
What's he crying?
I don't know. I mean, do you think it would make any difference if people knew that this server isn't new? You know, that we've been here a long time and no new person, you're not going to slide on in here like Tom Cruise in Risky Business thinking you're going to pull one over on us.
No, they actually think they're going to get away with it. They're retarded.
I think they think they already have gotten away with it.
I mean...
They think they're going to come in here and teach us, help us learn that it's a globe.
I think that they think they've already done that.
Ooh, somebody should make a meme, a copy of the Tom Cruise where he slides into the living room, and somebody should make it a globe head instead, like paste it over, whatever is done with memes now. So then you have a globe head sliding into the room thinking he's all cool and shit. I got this.
I am Mr. Smooth.
Do you think they will ever figure out that flat Earth is nothing to laugh about, and the thing to laugh about is a spinning water ball that has bendy water all over it, while none of the water flies off into nothingness? Do they realize the absurdity of the things they believe?
And they're worried about falling off the edge. Meanwhile, do they not realize from what we're told, we're supposed to be going at these unfathomable speeds, and we don't feel anything. And you got these large plumes of smoke, or what's that picture, you guys? Is that rapid evaporation of water? I mean, above the clouds, how could that be going on? And then people say, well, the atmosphere moves with us. Has that ever been scientifically shown to us about the atmosphere moving with us, that BS?
How could it be? That's not what's happening.
Well, I mean, so in other words, they're just believing some story otherwise.
Yeah, that they have no positive proof for. All they ever have are excuses for why their story isn't actually, demonstrated in reality anywhere.
I think that's the problem too. Is they're not actually asking those questions that you're bringing up. They're told a story and believe it from the start, and then they want to come in here and question us because they don't understand. Why don't we believe the story too? Because they think we're the stupid ones, and they're the smart ones, but in reality, they're not thinking for themselves at all. They're not asking those simple questions.
I just can't believe the lack of self-awareness on them, though. Like, they come in here and they just start making excuses for why we don't experience the Earth as being the thing that they say it is. All they have are excuses. It's crazy.
How do you expect anybody to be able to do what you just said, start from that point, when people can't even not throw their cigarette butts on the ground? I mean, there's some people that think, oh, well, somebody else will pick it up, but how simple is that? That kind of stuff just makes me mad. And people don't know how to drive. How do you expect people to figure out the heliocentric model and figure that out? I mean, I don't think people get way too offended too easily these days. It's like, okay, so somebody gets all butthurt and offended. It's like, excuse me. It's happened to all of us. You're just late to the game, but we're glad you're here. I mean, better late than never, right? So people just don't make any sense. In fact, I was having a conversation about just that with a customer. He said he didn't have any sense.
That comes back to ego, right? Is people can't.
I was like, oh God. People are something else. Yeah. I mean, I think it's a little funny how sometimes, correct me if I'm wrong on this, but no one in particular, I'm not pointing any fingers, but don't sometimes flat earthers get offended that globers are getting offended, and then, it's just like battle of egos and shit?
He's back. Dexter's back.
What?
Did he bring some Earth curvature for us this time?
Show us the curve!
Yeah, maybe he found some while he was gone. Yeah, we've been looking everywhere. Please help. Help us find this curvature. We gotta find it.
And then what we need to do is make some globe maps. We need to keep them in our vehicles.
But first things first, we need that curvature.
I sure hope this person isn't butthurt. There's no reason. All right, what are we going to guess about the reason for filing the report? What would you guys say?
Someone took my fantasy globe away.
Oh, that's great. Well, you know what? I don't want to take anybody's ball away. If they want to believe it's a ball, have at it. Like, go find another rabbit hole. Like, okay, bye, Felicia.
Go find a Santa Claus Discord. I don't mind.
Yeah, that sounds more appropriate.
What does it matter to me if you believe in Santa Claus?
And it's not like you have to throw away the ball. Like, I still have the ball in my head, and I just don't have all the delusions that it's a real thing. Yeah, I just know more about it now than I did ever before.
Isn't that crazy?
I think it's worth pointing out that after that, the question is, well, yeah, believe what you want, yeah, by all means, but don't waste my tax dollars teaching children that they live on a spinning ball in the vacuum of space.
Well, that's where it's the parent's job to, let the child know that there's more information to be had and such, and, a bunch of other stuff along with that. But I think it's really odd that, a lot of times it takes you figuring out the Earth is flat before you figure out the heliocentric theory. I think that's very ironic. Yeah. Aww.
I agree, though.
We should all enlist in Space Force.
Space Force.
What I want to ask a glober is, like, if the Earth is orbiting, why isn't there a Doppler effect based on the orbit exhibited in real life? And if the Earth is orbiting, then why isn't there a pressure differential to displacement? So there should be greater pressure on one side and far less pressure on the other side as
Really?
in its orbit.
Gravity, bro.
Yeah, I can't do that. it can't move things away to equalize the pressure and then attract even harder on the other side to make it look even.
So this has to do with orbital mechanics?
It's just, I was thinking about the Doppler effect and pressure and then orbital imaginations.
Right. Because the only one that's been presented is the 3N. And isn't there 5? Isn't it 5N?
It's just an example of how the globe model is all compartmentalized. And so the more you learn and the more you construct the model in your brain, the less it actually works because it doesn't exhibit any of the things it should exhibit if it were real.
I've heard you guys say that kind of recently. Maybe it was you I heard it from, about literally cherry picking and isolating certain features, but it doesn't work together. And I said that horribly. You could probably say it way better, but compartmentalization of the heliocentric theory. Wow. Okay.
Yeah, you can see this really, really easily when you look into the light. They claim the light is all, the way you see it, all the light appears to be coming from a center point, which we call the sun, and it splays out from that point. And the shadows, like, splay out from the things. So that's interesting. But they also tell us that all the light is also coming together into a point to explain the eclipses, and then to explain day and night and season, they claim all the light is parallel. So now you have 3 different contradicting versions of how the light is coming from the sun, and then on top of it all, they say, oh no, all the light is being bent. It's all being bent into place through refraction. So when you try to combine all this stuff, it just, the whole model breaks down.
So it's either gravity or refraction is what they always go to.
Well, you gotta take each individual part and only use it individually, and then it can appear to explain what you're looking at. But
yes.
When you try to apply that logic to other aspects of the model, that completely breaks down. So you have to imagine the light's doing something completely different when you're looking at that thing. And so they compartmentalize their brains, and they do it with the sciences as well, so that these people, they generally don't encounter these contradictions because they're just stuck within their field learning the things that are put in front of them.
Right. Yes. So you're kind of sort of alluding to that science itself is compartmentalized? Well, quote unquote science.
Yeah, they did this with education in general. They compartmentalized all of it and took logic from being something generally taught to the public in the trivium and the quadrivium to something that was only taught within philosophy if you went into that specific part of philosophy. So it was like it was really shoved right under the rug so no one would find it.
Yikes. Okay, what's the deal with the car? Drace.
Yeah, the car is displacement and pressure. When the car moves forward, it presses against the air, so there's more pressure in front of the car in the air there because the car is pressing against it. But when the car moves away from the back of the car, the gas rushes in to try to fill the space that the car previously occupied. This is what cars use in racing oftentimes. They go right behind the other car to catch the tailwind.
I see. So you're saying if we can experience this in a vehicle, why the heck couldn't we be able to measure or get any indication of this on the larger scale with the quote unquote Earth globe?
Yeah, if the globe were actually moving in an orbit, there would be insane amount of displacement, and the rate of motion that they claim the globe is moving at is 66,600 miles per hour. So the displacement is insane. So they would have to make gravity be like insanely strong on the backside of the globe for the orbit, and then gravity has to slowly change to
That makes it
repel.
way worse for gravity. Oh my gosh.
Yeah,
Gravity's a
and
mess as it is.
it has to repel the gas on the other side to make it even, so it appears as if there's no, like, as if the globe is not moving at all.
What? That goes over my head, but I appreciate, I mean, I get it a little bit, you know what I'm saying? But
It's kind of like with Coriolis, how when you didn't find Coriolis, you had to try to create some kind of excuse for how it works. Like
right.
all the air is moving with it. What I just
Yeah.
explained to you is essentially how I would try to give them a Steelman excuse, how gravity is acting stronger for no explainable reason, because that's how they work, like gravity, refraction. It's just working stronger in one direction. We can't explain why, so it all looks uniform, and it's actually repelling the gas in the other direction. So it appears like there's not more pressure in the direction we're heading in.
Wow. Okay. I know you're explaining it in quite detail because you know what you're talking about because you looked into it, but it sounds like a bunch of gobbledygook. Gobbledygook.
There's no excuse. They don't even address it. So I'm just giving you
Gobbledygook.
A gobbledygook excuse the way they do.
Yeah, exactly. That's exactly what I meant. It's like you're going around in circles. It just okay. I mean, and you were explaining it quite simply.
Yeah, you can make anything. You can make anything match observation. Like, for instance, here's a problem with the globe with the pressure and displacement. So you can just imagine up some kind of excuse to make it appear as if there's no motion, and so we don't need to think about this anymore. So let's just not. That's what they do.
Okay, so remember several years ago, Globers used to come in and, you know, they would use a car as an example. And then we would all, I remember saying, well, is it a convertible? You know, I mean, you have to use the correct example for what you're wanting to make your example for. And I'm trying to remember why it was that they brought up that the example of the car in the first place. Please say you kind of know what I'm talking about, Trace, and pick up where I can't.
Yeah. Okay. You're explaining what I'm talking about in different words.
Yeah.
And the Globers just don't want to face that because they.
But what were they trying to explain by using a car? I forget. It's been a while since I've heard it talked about.
Sorry, what?
Well, what they're saying is that I mean, in one sentence, they're admitting to us that it's an enclosed system, but usually it has to do with feeling of motion, right? So they're also telling us that there's no deviation and you can't feel the motion. Yeah. So what they're saying is it's an enclosed, non-moving, and you can't feel it. That's what they're telling us.
Yeah, because the motion is relative. I remember now. Does that sound right, Trace?
Yeah, but the problem with it is that I'm bringing up the principles of displacement, and the gas would have to rush towards the ground at a faster rate, and we would be able to measure and see effects of this displacement if the globe were actually moving, and they would need to give us some kind of coherent excuse for why that happens.
Which they won't. And that's why we have nobody to talk to in here. Stuff like that.
Don't they assert it's all in the same inertial frame of reference? That's basically what they say, don't they?
I'm glad you guys, I don't know if it's still a topic. I do believe it is about the curved adjacent. You know, a long time ago, probably a good 3 years ago, I remember that when they started talking about using trigonometry And I'm like, wait a minute. And I'm thinking in my head, and this is real simple. You know, guys know I'm a simple girl. So I'm thinking of a triangle sitting on top of a sphere or a circle, like kind of in 2D. That's kind of how I thought of it in my mind. But however you do it, it just didn't make sense to me that was being discussed in the first place. You can't use trigonometry. And it's just so odd that it took so long for everybody to start talking. I don't remember curved adjacent being talked about 3 years ago, and I could be mistaken. Do you remember, Drace?
3 years ago? No,
Yeah.
maybe not.
Are you talking about the bottom edge of the triangle not being curved rather than straight?
Well, if you believe in the globe, it would have to be curved.
Sure.
Well, let's just whistle right past that.
Anyway, I wasn't trying to open up that topic. I mean, I was just saying that I'm glad it's being talked about because in my simple little bitty brain, I mean, I know a little bit about math, not a whole lot, but it just didn't seem, like even from a kindergarten perspective, they could figure it out. I mean, if you put it in simple enough terms, I mean.
What do you think of the implications of the bottom of a very, very tall triangle?
Oh, you know what? I hate to be rude. I'm not trying to be rude, but I gotta go.
Okay.
Okay.
Okay, fine.
All right, till later. Bye.
Yeah, of course.
Peace out. Still no signs of curvature, eh?
Not where I'm sitting, no.
Cripes, what are we gonna do?
Well, yeah, this is it, isn't it? This is the big thing. You look out to the horizon, it's inconclusive.
Seems to be pretty conclusive that it's not curving.
No, that's true. You can't see curve. You can see visual artifacts that can be evaluated to one way or the other. There's no. Pardon?
Definitely can't find any 8 inches per mile squared. I've looked. Just keep finding nothing but flatness everywhere I go. Someone help.
Well,
I gotta find this curvature.
A couple of things. There's a couple of things when you look at distance that don't match the modern conventional model perspective, but that's here or there. I mean, that doesn't prove anything either.
Just a couple?
Yeah. Well, what? No, you may misinterpreting what I'm saying. I'm suggesting that if the Earth was flat, then everything would move off with absolute linear perspective into the distance. But things don't necessarily do that, do they? Not all things, anyway. You can see a very big half sun at the horizon. That's not adhering to the standard perspective model, because it would be if it was, the distance would make it reductionist in both axes as opposed to one. There's kind of things like that. Some things do disappear bottom up a bit. I'm not suggesting that's conclusive proof one way or the other. But like I said, I think looking to the horizon, it's a bit inconclusive at times. And you can make observations one day, and it's patently visually very different on another day, based upon lights, meteorological conditions, who knows what. But there's not always a hard and fast perspective looking at things in the distance.
Have you ever seen the horizon at 1.2 miles, 1 foot off the ground?
1.2 miles off the ground. I don't know how I've ever tried to measure it. No, I've seen things disappear. I've seen things disappear bottom up in a coherent manner.
I can say that it's quite conclusive that the horizon is not at 1.2 miles, 1 foot off the ground. Therefore, no ball with a radius of 59 miles.
You can see. All you can actually say is you can conclude that you didn't observe it at 1.2 miles. It doesn't say it wasn't there. We all know that that what you've seen isn't necessarily what's there.
Well, it's not at 1.2 miles. Have you seen it at 1.2 miles? 1 foot off the ground?
You just completely washed over what I just said, yeah. Sometimes what we see...
Okay, yeah, but we also don't see unicorns. Are they there? We don't see elves or lemmings. Are they there on the horizon at 1.2 miles too? But we just don't see them?
No, exactly.
Why are we invoking things that we don't ever see, that nobody's ever seen? Who cares?
Because
if it's there, somebody will have seen it.
Nobody conclusively established that the Earth was curved by looking at the horizon. That's the whole point, isn't it?
Yeah, but the whole point is that if the Earth were curved at 8 inches per mile squared, the horizon would be at 1.2 miles. That's a geometric fact. You've
Absolutely.
never seen it there. No one's ever seen it there. Therefore, it's not curved at 8 inches per mile squared.
When you say see the horizon, you're talking about things disappearing completely out of view at 1.2 miles?
No, I'm talking about the furthest edge of the sphere that you're supposed to be looking down and over as it curves away from you. And that furthest edge that you could possibly see would be at that 1.2 mile distance, but it's not.
But you're missing the point again. Seeing is making an optical measurement with your eyes through various medium of something a distance away.
So? Yeah, so? Is the horizon at 1.2 miles or not?
If the geometry says it's whenever it is at that distance off the ground, then it probably is, but...
No, it's not. That's the problem. It says that it would be there, but it's not. That's the problem with the geometry that the claims.
And you assert it isn't because you see what you see.
I'm not asserting it isn't. It's not. It's an objective, empirical fact. You can go out and try to find it.
How do you know it's not?
How long have you been around here for? Haven't you seen the Black Swan? Like, I have to go through the Black Swan with you? It says Globe Skeptic on your name. You've got the Globe Skeptic role. You don't know what the Black Swan is?
I know about the Black Swan, but do you know how much do you know about that Black Swan picture?
You're going to say that it's being refracted? How much do I know? I know that the horizon is at 10 miles in that picture, somewhere around 10 miles.
On the occasion that photograph was taken, yes, that's true. The apparent horizon on that occasion.
But here's the deal. There should be no occasion where you can picture the horizon at that distance if it is a geometric consequence of Earth curvature, because it would always be occurring at no further than 1.2 miles, 1 foot off the ground.
Exactly. So let me raise a question with you, okay? Let me raise a point with you and see what you think of this, okay? Yeah. I've seen imagery taken by the same person at that same spot, yeah, which adhere to what would be a coherent visual model of the horizon being where it should be.
That's great.
So correct.
Here's the problem. Yeah, first of all, I would like to see it with the observer height and distance to the horizon mentioned. And I would also, the other problem is that the horizon shouldn't fluctuate at all if it's a physical geometric location. The very fact that it does that one day it's closer, one day it appears way further away, one day it's somewhere else, tells you that it is an apparent phenomenon, not a physical location.
Well,
right? So that in itself debunks the globe. The point, yeah, it is true. The point of the black swan. Point of the black swan is that if there's even one black swan, then all swans aren't white. Therefore, it's not a geometric consequence of Earth curvature.
Therefore,
right?
there are no
you see it even once, it can't be there even once if it's a physical location. You see it. You see it. Yeah,
if you just
that's the point of calling it the black swan.
If you think you're correct by continuously talking about taking breath, then you've got a lot to learn about the world.
Well, you think that there's a geometric Earth curve at 1.2 miles that nobody's ever seen before. So, I mean,
you're just seen it. It's observed. It is observed. It is observed. You can observe things.
Oh, it's observed. Oh, it's been observed. Okay, that's a new one. Citation, please. Let's see it.
I'm not on my computer at the moment. I'm on a phone, but I can show you pictures of.
Yeah, I know what you're talking about. I've seen pictures of the horizon appearing closer.
And I've seen pictures of the horizon appearing further away. So what can we conclude? Perhaps we can't physically observe something properly with our own eyes at the distance. In other words, it's an inconclusive evaluation.
No, it's conclusive as far as the globe is concerned for the reasons that I just gave you. Because the horizon cannot occur at 10 miles if it's a physical consequence of Earth curvature.
You're missing the point.
No, you're missing the point. So I'm trying to tell it to you again.
You are saying that it can't be observed at the distance. There's a variance in the observation process. Okay, there is an invariance in the observation process. Yeah. So if you make an assertion one way or the other, you are being, disingenuous to the reality of the situation.
No, you're being disingenuous to the geometry that the globe claims.
I have a question. What's the variation?
What's the
what's that variance? Please tell us.
Yeah, what's that variance? You made a claim that there's a variance when you measure.
Yeah, there is a variance when you measure. The Earth's atmosphere has refractive properties.
Oh, what's that based off of? What are the refractive properties based off of?
varying densities of atmosphere caused by meteorological conditions.
Incorrect. It's a mathematical formula that includes something called radius. The assertion is built into the formula of refraction. So your assertion is false. There is no variance.
Are you saying there's no variance in the way that the light moves in the atmosphere across the horizon?
There's visibility, and that's it.
Yeah,
there is no atmospheric refraction. Really prove that atmospheric refraction is a thing.
Really prove that atmospheric refraction is a thing.
7 over 6 radius, 7 over 6r, you have to prove that in order for you to assert that. In other words, you have to prove radius to assert the formula for radius to be applied to the Earth. Don't you? Because that's what atmospheric refraction is. You do know this, right?
You do have to assert radius. You have to assert a curve, don't you?
Okay, so you have to assert radius. So what you're doing is you're asserting radius to prove radius. Do you think you're being logical or rational?
No, you're not asserting radius to prove radius.
Oh, okay.
I just said that.
You're applying 7 over 6r at all.
Sorry, you keep breaking up. What are you saying about pi?
How are you applying a radius, a measurement of radius in refraction, if you're not assuming the radius?
Refraction is a distortion of light through medium.
Refraction is the increase of the physical size of the Earth. That is the formula for refraction. It's an increase in radius. The formula for refraction has nothing to do with optics. Optics don't play into it.
Okay. I'll leave it there. You're telling me that the vision.
Snell's law. You are thinking of Snell's law, which has nothing to do with atmospheric refraction. That is when one image passes through a separate medium, like from gas to glass to water, solid, liquid, gas. That is not what we're looking at in the atmosphere. There's only one medium, and that is the air. And when you assert this idea that you have to measure radius in order to find radius, what are you doing?
That's not what anybody's doing, though, are they?
Okay, is an assertion of 7 over 6r. R. There's no optical. Tell me the optical part of that formula. How is radius optical?
What's the equation? What equation are you citing exactly?
The one you keep invoking.
Yeah, when you say atmospheric refraction, you are invoking a formula involving radius.
That's because, well, only in so much as, the refraction is occurring over a curved area of the atmosphere.
How do you know the refraction is occurring?
How do you know the refraction is occurring?
You know the refraction is recurring. I'm asking you.
Because you can shine lights and lasers across the atmosphere, and you can see a distortion when it gets to the other side.
I asked how you know it's happening.
How do I personally know it's happening?
How do you know that you're seeing a hologram of the Earth that just makes it look straight? Because what you're telling me is unfalsifiable. We see the lasers, which means that the lasers must be curving up because we know we're on a ball. That's what you're saying, buddy.
You're invoking.
You are. You're the one saying that the Earth holographically projects in every direction.
You're not winning the argument just by talking continuously. You're just basically making yourself look loud.
You're digging a big hole.
You just invoked the idea that I was looking into reality and seeing some sort of hologram instead of a reality.
That's what you're claiming when you claim refraction.
Can I ask him a question? Where are these lasers that we see distortion? What lasers are those?
You do know that they can do experiments where they put in a lab where they can make light distort. They can
in a lab.
So can you cite that one? Give us that citation, please.
Yeah, I could probably give you a citation.
You probably can, or you already know it exists and you've read it.
I haven't read it, no.
Because it doesn't exist. Because you're making shit up.
Citation, it doesn't exist.
It's a citation because this experiment that you say
I'm sure
has been done has never been done.
I'm sure the community near us poured through the almanacs of academia to find out.
I actually have.
Yeah, I'm sure you have. Yeah.
Well, you haven't, and you just said there's an experiment exists. You don't know what it is, so you can't cite it.
I have, and I found it, but I'm not going to show you. I have, and I found it. I'm not going to show you.
You're a liar. You're a liar.
And
I know what the longest conventional.
No, I lie. I paint on fire.
No, you are a liar because I've read probably every paper written on refraction going back 150 years.
That's bollocks. Do you know how many papers? Do you know how many science peer-reviewed papers are produced in any given field in any given day in this country?
I'm just talking about this particular subject. Terrestrial refraction.
I bet you're a luminary in optics, aren't you?
So in 2010, they did it's called the combat laser experiment, where they did 3 frequencies of lasers across the Hawaiian Islands.
Yep.
So what did they find? They found that there was no refraction. That's what they found. Because they use 3 frequencies of lasers, and refraction is wavelength dependent, right? And they shot them all at the same target and picked them up at the same telescope at the same time. There was no refraction because the refractive model predicts that those beams are separated by 5 meters. But the telescope is only 3 meters. So why was there no separation between the wavelengths if there's refraction?
So what the conclusion did they draw?
That the conclusion that they draw, because there was no refraction, right? That the only thing that changes the position of something is turbulence.
No.
Hang on. I'll post the paper. I'll post it right now.
I bet. All right, post the paper. I'll come and have a look later on. But I bet it doesn't assert that there is never any refraction. The scientists don't make an experiment and then go, "Oh, this is a conclusion like a cast
It's
across."
not an experiment. Number
what they
one,
said, it was not consistent.
India.
What?
Have him define refraction, please.
He doesn't know what it is. He's just making shit up.
Yeah.
Sorry, I just wanted to add that.
Okay.
Come on.
No. If you think I'm making shit up, that's fine.
No, we don't think you are. We know you are. Because you don't know what refraction is.
You just got here. We've already been doing this for years. See, you think we're rookies or something when we're not. You're just like blowing smoke up our ass.
No, I do know. I know what refraction is.
Yeah. So why can't you cite a single paper? Cite any paper on terrestrial refraction that you've read. Because I guarantee I've already read it.
But that's not. Hold on. I haven't. I know what refraction is. It doesn't mean I haven't read any papers though. But I know what refraction is. That's different, isn't it?
Yeah. You know.
No, you don't. What is it?
Refraction that they teach in school. We're talking about terrestrial refraction, which is completely different.
Yeah.
Which is what Morvet was talking about. 7.6R.
Yep. You're equivocating fallacy with the term refraction. That's what you're doing because you don't know what it is.
Yeah, but do you think that they invoked that equation to prove the Earth is curved? Or
yes.
Okay, fine. That tells you all I need to know. Really.
It tells you what you need to know. That's what it's for. It's to explain. They don't see what it is. That's exactly what it's for. It's an ad hoc explanation to try and say, well, we don't see curvature because light bends. It's exactly what it is. Don't be stupid.
No, it's not necessarily the case.
Exactly what it is. That's exactly what it is. Are you dumb?
Things can have R in them, yeah, because they're a reflection of the fact there is an R, or things can be an R in.
What are you talking about? Don't just say things can have R in it. What a vague statement. Be specific. Come on, man.
Okay, all right. Let me talk long enough to be more specific then, okay, right? Equations related to observations we make may have R in them for one of 2 reasons. As you say, they are used to equivocate themselves to the fact that there is no curvature and they're just there to basically just make everything fit the reality of the fact that, the illusion of everything.
Talking about?
Or they're there because that's the reality.
Hey, you're the one who said that. None of us said that. You deduced that yourself.
The R is there because there's either a radius or there's no radius, and people are trying to deceive us there's one.
You deduced that you made this stuff up to fix their model, and you are right. You're the one who figured that out. I didn't tell you that. You figured that out.
No. There are two possible scenarios here. There are 2 scenarios. They either put the R in the equation. They either put the R in the equation to make it look like it was there was a radius when there isn't, just to cajole the reality into what the model, or there actually is an R, and that's a reflection of it in the equation. There's one or two scenarios.
Well, actually, the truth is actually a third one.
Yeah,
because you're wrong about both of them. The R is because if a ray is curving, then the ray has a radius, right? The radius of curvature of the ray compared to the Earth is 7.6 R. This is what they approximate. Okay, so you're wrong both times. You haven't read anything. You don't know what you're talking about. You came up here thinking we're stupid. We're not.
I don't think it's stupid. I've been here long enough to know the people on here aren't stupid.
You don't know what terrestrial refraction is.
Well, then why did you think you could pull one over on us?
I didn't think I'd pull one over. I'm having a conversation with you. This is not.
Sometimes.
Do you seriously think for a second I'm going to convince you of anything?
It's not about convincing. It's convincing us that you know something.
Pardon?
You're trying to convince us that you know something.
Yeah.
You don't know anything.
What it sounds like
about this subject.
Sometimes sophistry.
You know nothing. Literally less than nothing.
This has been a perfect example of sophistry backfiring.
No, I don't agree with what you just said there, Guntarty.
How's what happened? You've come in here and been fairly reasonable sometimes, and today it's like you spent all night looking at some kind of Simon Dan video. I mean, what happened, dude?
I've had a shit day at work. I apologise. I'm a crabby bastard this evening.
Did Vsauce get to you?
You're dead before you even get to R with terrestrial refraction, which you don't know what it is. You must have an atmosphere. You must have curved gases. Can you show us curved gases?
Curved gases? What does that even mean?
So go to 18 minutes after the hour, and we'll have the subject matter expert tell you what terrestrial refraction requires. Requires 2 necessary antecedents. 1, curved gases. 2, radius. It's right there. So show us curved gases when we know that gases don't curve. We have Christy Bodak here. She's teaching first grade level class. I will use this lesson with the first grade class. If an object is in a gaseous state of matter, it will not have a definite shape. So you'd fail first grade. Gases don't have definite shape, so you're dead right there before you get to the R, which you can't get anyway. You didn't even know that you required it because you don't know what you're talking about. Like Indio and Meme was saying.
Oh, I see. You're asking me. Okay. Bye. Where's he going?
Well, if you don't have curved gases, then you can't invoke terrestrial refraction.
So you're
totally like
this whole time.
So
I only like curved gases myself.
Are you talking about? So sorry, I now I think I know what you're saying. You're saying you can't have gas follow a curved surface in the sense that it have an atmospheric profile over a curve. Is that what you're saying?
Essentially, it's very simple, Pazza. So here's the deal: if you're sort of right. If you say that looking over the horizon is inconclusive, you're correct in the sense that you can't measure any curvature, but there is none, right? So if you don't have that initial measurement of curvature, then you can't invoke a radius of any kind, and you can't apply that to gases because there is no curvature, there is no formula. It's all bunk. It's all destroyed from the very beginning. So you can't invoke it. All we know is that we see at very least, we see the horizon 30 times farther than where it should be. That totally destroys the radius of the globe, period.
Yeah.
I'm under the impression, unless maybe someone here can enlighten me to the contrary, I was under the impression that no one has made an assertion about the Earth being curved by looking at the horizon, have they?
Yeah,
not conclusive. Who made a conclusive assertion?
That was how Al-Biruni claimed to have measured the radius of the Earth, by looking at the horizon.
Please go back to school, please.
Didn't the vast majority of people come to a conclusion about the Earth's radius based on astronomy?
You can't pull a fast one on us. I'm sorry. This is not going to work.
I'm not a fast one.
Yes, you are, because we know the schooling involved, okay? We're all smart here. You're not going to pull a fast one like you think you are.
Is that a fast one by asking you if most...
You know that the globe has to be curved, and they are expecting us to believe it. Stop your bullshit.
There's no point getting angry. I'm asking questions, that's all.
No, this is not a question to be asking, you fucking moron. You know that. You know that 100%. We're going to reply in this way. We are sick of it. Stop
I did know that.
doing the fucking bullshit questions. That's a bullshit question. That's an absolute bullshit. You know for a fact that the globe needs a fucking curve. 100%. Stop the bullshit.
And even if we're to grant you your question-begging 7/6R refraction, terrestrial refraction formula, does the does 7/6R equal 250,000?
I've got no idea.
Well, I don't know, because R is 3959. So does 7/6R equal 250,000? Can it equal 250,000?
Sorry, what did you say R was? Is it,
R would be 3959. That's the radius of the Earth that is claimed.
In my, I don't know, what unit is that in? I don't even know what unit it is.
Miles.
Okay, right.
Because for the black swan to be explained as the Earth's radius being displaced and appearing further back than it should be, the geometric horizon being 10 times the distance, that would make the radius of the Earth somewhere around the ballpark of 250,000 miles.
Sure. So the question is, if we, I've seen that photograph, and I've seen photographs of the same spot on the different days, and you get a completely different view. Yeah. So that's the point I was trying to make initially.
Yeah. Okay, but the point is
radically different observations for that.
If
we're both
and it destroys your religion even further, and you don't even realize it. Right. Thanks. Welcome to Flat Earth.
Yeah. If the Earth is dropping off at 8 inches per mile squared, the only way that terrestrial refraction can explain that away, the black swan observation, is if what would the formula have to be then? Like 400/6R or something like that? 7/6R doesn't even get you anywhere close to explaining that. So even if we granted you that question-begging formula, which doesn't work anyway because you can't have curved gases, it doesn't get you anywhere close to the ballpark of where you need to be anyway. It doesn't work on any level.
He was talking about that photo right there. See what he's talking about? Could you go ahead and look at that one at 25 minutes after the hour?
I can't see this. I can't see a screen. But the point I'm making is that
you better not see it.
If I grant you that the black swan picture of the two oil rigs before the horizon, a distance of 10 miles and 9.6 miles, I think it is, just off the top of my head now because I can't see it. Yeah, if that's the actual reality of the situation, then what do you make of the pictures? The pictures on the other occasions when both of them.
I just debunked you. So repeating your same horseshit again, you're already debunked at 25 minutes after the hour. You're finished.
Okay. I
you
asked
don't
a perfectly
know your enemy,
reasonable
man.
question.
Problem.
I asked a perfectly reasonable question.
I've been putting this out for 2 years. Ever since the Black Swan came out, I've had this. I had your bullshit argument covered in spades.
Mm-hmm. Yeah.
It's preposterous.
Yeah. Mm-hmm. The furthest 7/6R, the thing that you were trying to invoke with terrestrial refraction, can get your geometric horizon is something like 1.8 miles. You've got it at over 10?
No. Number one, terrestrial refraction doesn't exist. Number two, even in their fairy tale refraction, there's no effect on the horizon whatsoever.
Yeah, I know, but I'm just saying, even if you let them invoke it, it still doesn't get
even if I grant all of that and I take all that on board, and come to the conclusion that the black swan observation is an accurate observation of reality. Okay, right?
It is.
What is the explanation for the same observations at the same point where both?
Said it's right here at 25 minutes after the hour.
Yeah, he can't tell. This is ridiculous. I mean, the definition of insanity is trying the same thing over and over, expecting a different result, which is exactly what you're doing, Pazzo.
Mm-hmm. So, Crayon Muncher, if you go back here a different day and the horizon moves, does your fairy tale Earth inflate and deflate?
No, of course not.
Well, why not? That's what it's showing us.
Well, no. The point is,
yeah.
Okay, hold on. Let me ask you a question. Do ships disappear over the horizon?
The ships disappear over the horizon. They disappear, yeah.
Okay, is that from a physical Earth curve horizon? Is that because that's the physical edge of a ball?
the observation that they disappear from the bottom up alludes that that's the case.
No, it doesn't.
So the black swan, you just said the horizon is moving around. But if the horizon is what's blocking the bottom of a boat, then it can't be the thing. It can't be getting blocked by an optical illusion, right? Or can it?
Things can get blocked by an optical illusion. You get a mirage can block things, can't it?
Okay.
A mirage.
So you can't say that it's fell over the horizon as it's because it's a physical geometric Earth edge, and that the horizon is completely optical. That is welcome to flat Earth, as Huey said.
Yeah.
Mm-hmm.
Well, the horizon doesn't mirage either. What's a mirage?
Yeah, but, all right, so going back to what you just said then.
No, define a mirage.
No, you're not going back. Answer the question.
Define
you
mirage.
just said. What's a mirage? A mirage is a distortion in what you see based upon atmospheric conditions.
Negative. It's an extra image or images of the mirage object. Do you see horizons like multiple horizons on an object, man?
Do I see multiple horizons on an object?
Yeah. We don't have multiple horizons. Therefore, it can't be miraged, as you just said. You're just making shit up.
Mm-hmm.
I didn't say. I didn't say that the observations of a horizon that we're talking about are a mirage. I said,
you did.
Someone said to me, "Is it possible to have things distortion or diffraction or refraction
in relation to the horizon?" Indio just asked you that.
No, he
and
said no. He asked a general question. He asked a general question. Can things be concealed?
No, he did not.
Okay.
Why do you keep leaving out the horizon when you're making these statements? It's very odd.
I'm not taking. I'm
Well,
not
for
leaving
2,000 years.
Yes, you are.
The point is, for 2,000 years, more than that, since Ptolemy, they've been saying that a proof that the Earth is a ball is because ships disappear bottom first, mass second. Now, if the horizon is an optical effect caused by the properties of light through the air, then it's not proof of that because it's not a physical thing. It is completely optical. And saying the black image changes where the horizon is an argument against the globe position.
Exactly. He doesn't realize it.
You are right in so much as that ships disappearing bottom up could be an optical phenomenon. They could be.
And it is, because we've demonstrated it on flat surfaces. So,
yeah. It's happening over a flat surface.
You want proof that they are optical and not geometric? You want proof of that? I got it.
Yeah, of course.
Yeah.
Yeah, stick it on there. I'll be in on the thing to have a look later on. I'll have a look at it.
Well, check it out. You could look at anybody else that's done this. Zoom in to a boat that previously disappears. How about?
You can't zoom into half a set sun, though, can you?
That means it's not geometric because you can't zoom in beyond a geometric curved horizon because it's a physical block. Do you get that?
No, that doesn't. That's not as coherent as what you said before.
A curvature of Earth is a physical obstruction of your view, correct?
By the way, there are videos of zooming in on half a sun, just for the record.
He can't answer
there are videos of that.
I've seen videos.
He cannot.
I've seen videos.
Ladies and gentlemen, he cannot answer that question.
What question was it again? Repeat the question. Repeat what question? Repeat the question.
So you weren't listening. Okay, great. I'll repeat it. So is a curved horizon a physical obstruction of your view?
If it was caused by geometry of the Earth.
It's a yes or no question. Yes or no. Is it a physical obstruction of your view or not? It's yes or no.
Yes, it would be. It would be a physical obstruction of your view. Yeah.
Okay. Very good.
You got it.
So then, how do you explain the picture I posted in the live stream voice text?
I can't see anything on the live stream at the moment.
Yeah,
my phone.
He won't look at anything we give him. He won't provide us anything either. We know that. But anyway,
no, my phone's really.
So if you can zoom in to something that previously disappeared, like Quantum Eraser put the image at 31 minutes after that everybody else can see except you. If you can zoom back into that boat that previously disappeared, could it possibly still be a curved physical horizon?
If you're zooming in because the resolution of the original picture means it's lost, then there's nothing to do with the horizon.
That's not answering the question, but good way to get away from it. So once again, if you can zoom into a previously disappeared ship on the horizon, are you zooming in around a physical curve?
You would have to be if that's genuinely what happened. Yes.
Oh, okay. Now, do you know
that would be a big problem for the curve model, wouldn't it?
Do zoom cameras zoom around curves?
We've got proof.
Where?
Look in the voice text section. It's got proof in there.
What's the proof?
I'll have to get to the computer. My phone genuinely won't work with the live thing at the moment. I don't know why. I'll have to get to the computer.
So you're able to zoom in around a curve?
You shouldn't be able to zoom in around a curve, no.
Okay. Welcome to Flat Earth.
Well, this other guy thinks that there's proof of us being able to zoom in around a curve. That's interesting.
Yeah, who was that?
I was saying we've posted proof. I've posted a video which is with a P900, and it zooms into a container ships that went over the horizon according to Hazard, is it? And it brings them back into view again. So I'm on your side.
Gotcha. Yeah. Sorry.
He's a flat earther. Yeah.
It went over the apparent horizon, the only horizon there is.
Yeah. It zoomed. If you can zoom in, it's not a curved surface.
Yeah. Exactly.
My bad. Misunderstood you.
That's all right. No worries.
Yeah, when you increase the angular resolution, you see further.
But see, the thing, the elephant in the room is this: like on the Black Swan, how is it possible that if it's a curved horizon, like they're claiming, who cares where it is, where it starts curving? Because we'll never get that answer. But shoot, I lost my train of thought. Happens sometimes.
It happens.
1 second.
I just think it's so funny that they try to invoke 7/6. Go ahead.
Is that cell ship? Is that cell ship that you're zooming into and then zooming away from?
Yeah, that.
Yeah.
Did it disappear over physical Earth curvature is the question.
I don't think that characterizes disappearing over the horizon, does it?
Well, it couldn't be disappearing over a physical Earth.
That's something so far away that when you zoomed out, you haven't got the video resolution to see it. That doesn't mean it's disappeared over the horizon.
What we're saying is that's all the horizon is an apparent phenomenon.
Okay. Yep. I get that.
I've remembered. So in the Black Swan, for instance, you see the 9.41 habitat oil rig, right? 9.41 miles.
Yeah, sure. Sure.
Beyond that is the horizon. What's the location of the horizon? It's further back, right?
Yes.
And what else? What else do we notice about the horizons? Not only further back, but what higher up, isn't it?
Yeah, it's altitude. Its altitude in the image is higher up. Yeah.
Okay, so hold on. I'm not done. Almost done though. Now, if you keep in mind that 10-mile horizon, or it's probably further, we know it is because we can see the islands. That's where I'm going next. The islands are 30 miles, minimally, in the same shot. So the islands off in the distance beyond Hill House and Habitat are further back and guess what? Higher up, just like what? A flat horizontal plane is the only way you would ever see this. You could never see this on a ball where the elevation as it got further away is dropping down. And I would like to question you on your idea of refraction. If the ball is descending in altitude down as it got further away from you, regardless of where the sagitta is not where the sunlight is hitting, isn't it lower elevation than you?
Yeah, listen, I'll grant you all of this because I don't. You know more about this than I do.
Go somewhere. Yeah? Hold on, don't gish-gall me.
Sure.
I'm trying to go somewhere with this. I just need simple answers for that first, and then we can go into further depth. So,
sure.
If the horizon is further back and higher up,
then you anticipate.
Then it cannot.
If you were looking at
it cannot be a ball. You cannot have horizons that the further you go out, it goes higher up.
He was, well, of course he was using refraction to explain that away. And as soon as he answers this, there's something I want to show him about that.
Wait, because I'm almost done. Now, remember what I said about the light hitting beyond the sagitta, which is away from you, right?
Yep.
So where the light is hitting first is where? Lower elevation than you, correct?
The light is hitting first. Yeah, go on. Sorry, yeah.
It's on the other side of the ball. So it's It's on the other side of Sagittarius. No matter how far away that Sagittarius is, it's still a lower elevation. The further out, the lower the elevation. So when the light hits, can you describe to me how your refraction makes it go up above the curved horizon, which is physical, which you just agreed with, and then bounced it back down to the level of the viewer at 1 foot there in Santa Barbara? How does that happen?
I've seen someone describe that. I wouldn't be able to do it myself, but I'll grant you all of that may obviously then be, if you take that as all that observation as it is, okay, right, then obviously it doesn't fit anything anybody's telling you, okay, right. But I come back to the question, and I'm not trying to be disingenuous, right? What about all the other times when it doesn't look like that? What's that all about?
All that tells you is that is exactly what we've been telling you, that it's an apparent location that fluctuates due to optical conditions day to day, which are fluctuating.
Mm-hmm. You have several things. Depending if you're at 1 foot observer height, yeah, the next day at 1 foot observer height, or whenever that next time was, where the waves were really high. The waves were 5 and 6 feet high. The first day they were 2.5 to 3 foot high. Are you taking into account to that? Plus, what about perspective? You guys seem to always forget. As soon as you start talking with us about the black swan, well, immediately perspective disappears. So stuff doesn't get smaller as it gets further away anymore. We totally lose that. You guys forget about that completely. Why is that?
I wanted to ask him, though. So you were kind of trying to say earlier, right, that refraction could make the geometric horizon appear way further back than it actually physically is, right?
There's no fundamental reason why optical distortion of that nature could make it appear anywhere. Really.
Well, there are reasons. I'm going to post something in the live stream voice text right now, because when you say refraction, you're invoking terrestrial refraction, and the formula for that is 7/6r, right? So that's 7/6r, r being the Earth radius, 3959 miles. But to make sense out of the black swan observation using refraction, the radius that you would have to have of the Earth would be like 250,000 miles. Does 7/6r equal 250,000?
Don't the people who advocate that?
I mean, QE already did away with it because you can't have curved gases. But even if you want to go there,
I think they don't. They invoke atmospheric refraction as well, don't they? Not just terrestrial refraction.
Okay, but terrestrial.
They're the same.
Yeah, and
well, they're not, because atmospheric refraction is a factor of many variable conditions, so they won't fit.
Okay, so let me get to the point here. So what they're doing basically with the refraction formula is they are artificially inflating the size of this globe that they say that we're on, so they can explain away these impossible long-range observations. Just in the first black swan, where the horizon is somewhere around 10 miles, to explain that geometrically, the radius now has to be artificially inflated by refraction to something like 250,000 miles. So even the formula that you're invoking doesn't even get close to covering that. You see what I mean? Do you see the problem? I posted.
I don't know what the formula. I think the formulas for atmospheric refraction are quite complex and virtually unusable because they rely on a load of parameters that are basically difficult to measure anyway.
None of which are demonstrated in reality, like QE explained with like one sentence about curved gases, and there's a lot more you could say about it too, but I'm just saying, even if you want to go there, it still doesn't work. Look at the comparison between the black swan radius, the radius of the Earth, what it would have to be for that to be the geometric horizon, to the 3959 mile radius that they claim. It's at 40 minutes after the hour I posted it.
Sure, but the other pictures I've seen from the same location for the same guy, even if you say, "Oh, the water's a bit more choppy," yeah, in the opposite extreme, don't allude to anything at all other than the fact the horizon appears to be a lot nearer. So the horizon moves around from observational point of view.
It moves around because it's an apparent location, and it's just an optical effect, right?
And the apparency of it is because the observational mechanism we use obviously has some variance in it.
No,
it's not just that.
If I look at something if I observe something on two occasions.
Wait a second. If you're at 1 foot observer height, if you have a 6 foot wave in front of you, how much of that can block your view? I mean, it could block the whole thing out. It could block
The pictures that I saw of the opposite extreme observation, they weren't 6 foot waves. The water was a bit choppier, but that doesn't make the wholesale water choppy. That doesn't make the wholesale water 6 foot higher.
Oh my God, I've checked the weather conditions. He's listed them. I've checked it myself. Have you checked that?
No, I haven't checked it. No.
And another thing I want to know whether you've checked is what the distance to the horizon is in that picture that you're talking about, where it appears closer. What's the distance to that horizon, and what is the observer height in that observation? Not that it matters anyway, because it's
he's just the same height and the same location for the 2 photos.
Okay, so it's 1 foot off the ground, but where is that horizon? Where is it? What's the distance to it? We need that in order to claim that it is the physical sphere edge.
I believe he suggested that the second picture aligns more with the notion of it being as close as the obvious equation that comes out of the curvature. But I'm not saying that's the case. But
he cherry-picked observation.
No, it's not cherry-picked. If he's got 2 observations that are radically different, right? Unless we go there and measure it a lot of times ourselves, we can't say which one is a cherry-picked one, can we?
We can, because if it is a physical sphere edge, then it's always where it is, and it's not fluctuating up to 10 times the distance, 30 times, whatever.
I agree with that. I agree with that. Okay.
Yeah, so that debunks the sphere edge, right? It debunks that aspect of it. There are all kinds of other aspects that make up the horizon, but the sphere edge obviously is one of them, because that would be the maximum distance for it to occur at. And plus, refraction doesn't work for all the reasons that we've talked about a bunch of times here already. So that's it. That's it for the globe, man.
No, that was your leading statement there was a little disingenuous. If it's a geometric, I agree. If it's a geometric horizon, it has an inherent consistency to it because it's a mechanical thing. Yeah, it's a physical thing. Yeah,
physical place.
If we see it moving around, and not being in the same spot, then we can draw 2 conclusions. It either is moving around a lot, or our ability to observe it is not consistent.
A physical sphere edge is moving around a lot?
Move around.
Yeah.
How a physical horizon moves around. Explain to us.
No, listen to what I just said again, right? If it's a geometric horizon, and it's a physical thing, and it's invariant by definition because it's a material thing, then observation, it will be wholly consistent at all times at the place where the equations would allude it to be, right? However,
the observations would have to be consistent with the geometry, absolutely.
So absolutely. So I'm not trying to be contrarian here. I'm just literally following this through. So that being the case, if we observe it moving around, there's one of 2 scenarios. It is moving around, or our observational mechanism for observing it is variant. There is a variant in our observational mechanism.
So you're actually saying that the horizon moves in reality, or that we are wrong in the way that we measure it. That's what you're saying?
Those are the 2
All of our methods are not reliable. That's what you're saying. All of our methods.
He's saying that our optics are sometimes allowing us to possibly see 10 times the geometric limit of the ball. Well, okay, if you want to invoke optics are allowed to happen. We already got rid of refraction, so what's left?
But here's the thing, okay, right? You say you've got rid of refraction, okay, right? You say that you've evaluated it.
Yeah, man, weren't you just here?
You, as a community, right? Let me hear me through. Hear me out here. As a community, you've evaluated all the proposed science and the physics behind that's used to describe that phenomena. Yeah, and as a community, you've seen through it. Okay. Do you think that the rest of the scientific community who make all their own observations and aren't convinced of your position, do you think that what makes them different? What makes them come to the opposite conclusion? Do you think?
What observations have they made that would bring them to the? What observations have they made? Bring them here, and how do they explain away the black swan? Because we already tried the argument. We've already gone down we've already dealt with the arguments that you've tried so far. So what else is there? Is what I'm
not. I'm sure you've. I'm not doing more of an. I'm not trying to Please get me wrong. I'm not trying to basically trip you up. I'm just saying, what's the difference between them making all their observations,
well,
out of their
we're being
passion,
empirical,
coming to one conclusion?
Well, we're just being empirical.
Literally comes down to that. You think you're disciplining yourself more than they are. Is that what you're saying?
I don't know. I don't care. I don't even know who you're talking about exactly. You'd have to be more precise. I'm just saying that according to the globe model's geometry, that these observations don't work, and we're giving you the reasons why. If you want to come back with, oh, maybe refraction is doing something weird, so it's displacing that geometric horizon to somewhere where it shouldn't be. We just talked about why that wouldn't work either, and why the formulas that they give us don't even begin to compensate for what's happening there. So I'm just asking, like, what else is there? You're kind of appealing to popularity or to science or whatever, but what specific science, what geometry, who measured it, and how did they explain it away? Let's hear it.
But here's the thing, okay, right? Yeah, is that if you were able to, you could have this all over and done and dusted in 10 minutes, yeah, right? And I mean that genuinely, because it'll be obviously and apparently true, if you were able to actually. If you've looked at everything, and as a community, you've come to this conclusion, okay, right? And a lot of you are very well. I know I've been here long enough. No, there's no idiots here. You're all passionate about this, and you've read a lot about it, yeah. Mm-hmm. If you were able to actually distill that down into a convincing argument as to what everyone else is doing differently and why they're doing it wrong, yeah, but rather than just attacking people, it would all be over, wouldn't it? Surely, you'd literally be dismantling the machinery which creates the, there's obviously, if what you're saying is true, then there's but no, that's not.
I don't see that. Well, no, we're not really attacking people.
You're asking science to have feelings. Science doesn't have feelings.
No, I didn't say that. No, I didn't say that at all. That's
yeah.
I know what you're asking. I know what you're asking. Here's what you're asking. If we are correct, then this argument, even on a large scale, would be over. And the problem is that all of the experts that we do have come in here who have the balls, right? Well, we just knock their dicks in the dirt. All of the people who are your science communicators, the people that are, paraded out in front of the public, they don't come because, number one, I'm pretty sure they know we're right. And number two, it's a matter of getting people to believe things. And that's the problem that we're having with you here today, I think, because you've come in kind of, like I said, hot and, just kind of like, oh, there's no way everything is, it just, inconclusive and yada, yada, yada. But the problem that we face is most people just do not want to let go of their ball. And I think that's my question is for you is like, why today are you've come up against this cognitive dissonance? You don't want to let go of the ball today, I can tell. But everything that you've brought up, we've studied it, we've crushed it. You've brought every argument that everybody else brings, even the subject matter experts, and it's just over. It's up to you to see it for yourself.
Yeah, but for me to, I know what you're saying. All right, that's a wholly sound argument to make, but as a statement of my position, it's tacitly, tacit agreement is true. Yeah, but what I just don't understand is that. Okay, and anybody, I've been here a long time, and anybody who listens to me talk about other things know I'm a real big skeptic about things. Yeah. So I do understand, but I don't understand how it's so difficult to convince people if it's so obviously wrong,
Well, people do see this every day. There are people that just kind of the light bulb goes on, but most of the time it's because they don't have too much attachment to their bias. There's a matter of humility involved in this. People that want their ball have an emotional attachment, an intellectual attachment, a pride attached to the ball, don't want to let go of it only for those reasons. In a very, empirical sense, this is cut and dry. It's over. The ball is over. It had a good run, people, made a lot of money off of it. They got most of the masses to believe in space and aliens and stuff. It's had its day, but it is over.
But why would it be so difficult to actually convince society wholesale then?
That's society's problem. They're brainwashed.
That's their problem. They've been brainwashed from day one. I mean, just think about the imagery. Just alone the imagery that you see on TV. I was watching TV the other day. I hardly ever watch. But they're using the word planet. They're showing galaxies, all kinds of CGI, just reinforcing this idea. And they have to, because if they don't reinforce it, people are just going to look out their windows and go, it all kind of seems really dumb. Even as kids, we knew it was stupid. But someone told us it was another thing, so we believed them. And now we're stuck in this kind of propaganda and indoctrination. But like I said, there's also emotional attachment. People worship space. People worship the idea of being able to go to another galaxy and meet some chick with 3 breasts. Ever watch Total Recall? Okay, the idea of it people love. It's a fantasy. It's a place for them to escape. I can't make them change their mind. If they want to believe in a fairy tale, if they want to believe in Santa Claus or the Keebler elves, I can't stop them. But
well,
nonetheless,
not even God himself didn't change the mind of the people, despite the fact that he could have done it, snapping fingers. But this problem has been prophesied also long time before we have this debate. What I'm trying to say is that the way Paza exposed this problem was why do people believe in these lies? Yeah. Well, you will never get the world more than 33% of the world to actually go with science. Only 33%. That's the maximum you can have. The people which go with the scientific method and sciences. All other 66%, they will be following religion systems.
Yeah, they'll just go with the crowd.
Yeah, but no, it's not that. It's the why. This the reason he's asking why is it not easier to convince people, right? The problem is this:
Yeah.
since you are born and you start watching TV, this is propagandized from a kid. Before my daughter was in school, she already thought the Earth was a ball, and I never taught her that. But it started from TV. Then in school, they teach you 1 + 1 is 2, and they also tell you there's the ball. So if they teach you some facts with some mixed fiction, you wouldn't know the difference, right? So it's a whole indoctrination that we don't even know it happened, but it is what occurred. And so by the time you're in high school, college, they showed you, it's rockets. We're going to space. We're going to Mars. So they're in love with it. So I mean, like they were saying, they're in love with it. So it's hard to break that because hey, I see it all the time on TV. But they don't know they're actually making animations and stuff like that.
And one thing which no man in the world will be able is to take over the whole mainstream media of the world and broadcast like mainstream science, actually real science. They will not allow that. Never.
Yeah, so it's just conditioning from birth. Mass conditioning.
I mean, I know what you're saying, and I am very conspiratorial, but it's too big a conspiracy. They fuck up things all the time.
Oh, okay, you're saying that, but we just showed you that they are in fact lying by looking at the geometry of their claim and comparing it to what the Earth actually is. So it's not too big. Your personal incredulity about what they could lie about, these people, whoever they are, these strangers you don't even know. You're speculating about what possible motives they could have or not. Doesn't matter. They did lie.
Not even 100 years ago. Hold on.
Go ahead.
It's from a conspiracy, but not even 100 years ago, people of color were lesser than people that were Caucasian.
It sounds conspiratorial to you, Paza, but you have to be realistic. Today, if you team up on the street with another 10 friends, the police will call you a gang, organized gang.
Hold on, but he said
that's a criminal term.
Hold on, Gibben.
It's illegal. Yeah.
So you're saying it's too big of a conspiracy, but there was supposedly science and whatnot about that that they were the supreme. Is this not so?
So that you cut out, I believe,
You
in
cut
the
out.
last quarter of the sentence.
Sorry. So, not too long ago, um, the white or Caucasian or whatever was a supreme race, and everybody else was pretty much lower than them. Was this not so?
There was a lot of Arianism in the world. Yeah, definitely.
Right, and this was supposedly backed by science and whatnot.
Yeah, well, I get. Well, all right, we're moving somewhere else now, and
No.
that's a different
What I'm
topic.
saying is,
I mean,
you're saying this.
a lot of Arianism and racial superiority,
Right.
even if it was born of politic, or it's imbued with a lot of religious dogma as well. So
But
let's not
That's what
that's a
but
rich and difficult thing to talk about.
That's what he's telling you,
you're
though.
not getting it. What I'm saying is, you're saying it's too big of a conspiracy, but the whole world thought that way in a way, right? And regardless
Well,
of
the modern Caucasian world thought that way, and the rest of the world didn't.
He's telling you that they've gotten away with conspiracies that, according to you, are too big many times.
yeah, what about Mockingbird?
Well,
Operation Mockingbird, MK Ultra. Do you know any about these?
I've read about them online. Yeah, I've read about lots of conspiracies online. I mean, the point is that the Arianism wasn't so much a conspiracy. It wasn't conspiratorial. It was just a general view. It was a view. It was an altruistic view. It was a philosophy. It wasn't a conspiracy.
Well, it wasn't called a conspiracy, but it was what was accepted as true, was it not?
So you can't call like mechanical systems like slavery
I mean, same thing.
and
This is a conspiracy because it's something that is now being said that it was not true, right? Because we're against whatever the mainstream is saying. Now, back in the days before Flat Earth, this wasn't a conspiracy. It was accepted as true. This was the accepted fact that the Earth was a ball, right?
They had Hollow Earth.
Yeah, but the reason the starting position positive is flat, obviously.
Right, but as of
The foundational observation.
because they're making it as conspiracy. Because a bunch of people like no, this is what is accepted as fact because they told you this was true. And
yeah,
I think you're imbuing these people with far more for far more strategic nous and capability than they actually have.
Okay, well, I think that you're denying reality then, because we've already shown you that their geometric claims of the Earth do not hold true in reality.
Yep.
So it doesn't matter what your personal incredulity is about what strangers you've never met before could get away with lying about. This is the fact.
Well, no, I mean, granted, I came in all crabby and blusterous and was making assertions that I couldn't back up, but you haven't convinced me that what they're saying isn't true. You've told me that what they're saying
let me
is
ask
true.
you about
That's
this.
your
then.
problem.
Okay, let me ask you about this.
That's all.
Can you have gas pressure without a container?
If you believe what they tell you, then yes, you can.
No, not even in science. They're saying that gravity holds gases. So, can you have gas?
Gas pressure is measured by measuring the force effects of atomic particles banging against the surface. That's where you measure the pressure at. Yeah,
it's not
Right.
atomic. It's molecular.
It has to hit. Right. So it's yeah, right. It's not molecular, but it has to hit a wall, right?
Pardon? It has to. Pressure is measured. Pressure is measured by the force effect of atoms or molecules.
The number of collisions with the container, the walls of the container.
If you have a sun, though, like what's the wall? Do you think
right? So
if you have a sun,
yeah.
Well, that's the model that they prescribe for atmospheric pressure on the Earth and the sun are using the same. I'm not saying it's true, but I'm saying they use the same. They use the same theory to posit the both of them, don't they? That gravity is holding the whole thing together.
Yeah.
No, that's the problem though. Where is the citation that says, or the definition that says?
Doesn't the magnetic field have something to do with like holding in an atmosphere as well?
Was I done?
It has a lot to do with the sun's solar rays not stripping it off, I believe. But
So
whether it actually, yeah, I mean, whether you believe the sun is 92 million miles away or you believe
I'm
it's
not
very
talking about
near,
the sun.
it has a huge photonic stream coming off it.
Yo.
Sorry. I'm talking about things we could actually demonstrate. The sun, we can't go up there, test, or do whatever they say. So I'm talking about the Earth, right?
Yeah.
Can you demonstrate gas pressure without a container?
Can I demonstrate it here on the surface? You mean?
Can you demonstrate gas pressure without a container?
There's always a container.
I don't know. Demonstrate it underground or.
No, I can't demonstrate. I can't demonstrate that. I can't demonstrate it on myself. No.
I can't use my hands. That's for sure.
Yeah.
No one can seem to demonstrate it.
I do know that the higher up you go, the more rarefied the atmosphere becomes.
Can you go all the way to the vacuum of space and show that it just thins out to nothing?
I haven't got any of the physical means to do so, no, but that's what they say happens. They say it's a trend, asymptotic trend going off. The further you go, the thinner it gets, and the thinner it gets, and the thinner it gets.
Yeah, like I've been.
That is what they say.
That's what they say. So, and there's nothing mathematically incoherent about that statement. There's an asymptotic.
Mathematics isn't reality, though. We can calculate the flight dynamics of Superman, right?
Mathematics quite often mathematics is proves useful quite often to model physics and model reality.
Yeah, but it's not reality. Models aren't reality. That's the problem.
No, granted, I didn't say it was. I didn't say because there's a math.
Listen, Paza, mathematics shows us, on a paper, when you do calculations, it shows us that we can, every year, our technology increases exponentially in the power of processing information,
For Moore's law.
In 10 years, we will reach a point, where there will be no limitation. We will have infinite processing power.
I work in computing and electronics, so I agree with what you're saying to some degree.
Moore's law states that there is an apogee, there is a maximum.
You're going off into the weeds. You're going off into the weeds, and he's getting away from the point, that which is, even though, like you said, math isn't reality, because I could definitely calculate how much force would Superman need to jump over the Empire State Building to make Superman real, right? So
exactly,
So the thing is, with gas pressure without a container,
right?
You cut out the gas pressure without a container.
Sorry, so gas pressure without a container, it can happen. It hasn't been demonstrated, and it'll be a violation of the second law of thermodynamics. So whenever they tell you there is no container, then they're wrong.
Yeah,
okay.
Correct.
I get that you say that it's a violation of the second law of thermodynamics. The vast majority of the scientific community don't agree with that.
It's not what I say.
Well, I know what you say. I know that there are two opinions that I've heard that it does violate the second law of thermodynamics and that it doesn't. But all I know is there's a physics.
All I know one empirical demonstration of violation of the second law of thermodynamics. Tell me, how can I do that so I don't need tires to my car, so I can hold gas pressure around the wheels?
That's a localized pressurized system. I totally agree with you.
Well, that's what I need it for.
But that's not analogous. Locally. That's not directly analogous to what they're saying happens in the atmosphere, are they?
So what are you saying is what's holding the gas?
Well, right. Let's take a step back, okay? There is a absolute physical, measurable observation that the higher you go in altitude, the more rarefied the atmosphere gets. I don't know if there's an upper limit. I haven't been up there, but I do know that that's the case. Yeah.
Not even with NASA.
You don't know.
No one is ever seen. No one. No, I'm not. There's no one. No one. Listen. You say I'm guessing, but no one I've ever seen has cited an accurate observation that the atmospheric pressure has gone up as they've gone. It's got more. The air's got more dense as they've gone up. All the measurements consistently show that.
But NASA,
Okay.
but NASA itself has sent balloons, Echo 2, supposedly one of the satellites, which is Echo 2, which uses an aerostat, which is gas lighter than air, to float a balloon in quote unquote space.
Yeah.
Right. So why would they need gas that's lighter than air to float a balloon, their satellite balloon, in space?
Well, excuse me. I'm surprised you're asking that question. The rest of the infrastructure of the balloon has a significant enough density that you need a displacement mechanism, don't you?
They're
Do you
using an
understand?
aerostat. You know what is an aerostat?
Yes, but rarefication at the atmosphere at that stage still offers you the same displacement. You can still use the same displacement mechanism you use to get a balloon from 100 feet to 1,000 feet. You just need a shit ton more lift, don't you? Because the air was more rarefied.
No. This was supposedly launched in space. Now, do you understand what happens to a balloon? What happens to a balloon in a vacuum?
A balloon in a vacuum. Well, a balloon. If it was a higher pressure system, then it would collapse on itself.
What is a vacuum, according to them? Is it higher?
It's not. According to them, a vacuum is a lower pressure system than the
It's
one
a
outside of it.
way lower system, almost zero.
Yeah, well, you can have gradients of vacuum, but yes, you're right. It's a lower pressure system.
What they're saying was it's 10 to the negative 17 torr out in space,
Yeah.
right? Where they're
Well,
supposedly sending these satellites, but they're using an aerostat that is lighter than air to float a balloon up there.
Yeah, but you do. Have you ever seen a meteorological? All right, I know what you're saying. Have you ever seen a high altitude meteorological balloon when it's launched initially? It's got a tiny amount of gas in it, yeah, and as it gets up, it inflates and it inflates and it inflates, yeah. So that balloon at that height, wherever height it's at, it doesn't have. It's got an amount of. It's got a tiny amount of gas in it. It's just extremely rarefied. It's taken up a big volume.
This is the issue, though.
With
This is the issue, though. When they turn on their vacuum in NASA or wherever it is, that it goes to what, -10 or -6?
No, 10 to the -6.
What happens to all? How much does it have to be reinforced? How much does it have to be reinforced for the air will come in, and the air still comes in?
Yeah, I don't think that's got anything to do with what we're saying right now.
So the lowest vacuum we can technologically achieve at NASA is 1/1,000,000th of a torr, and that is way far high pressure, way bigger than 10 to the -17. 10 to the -12 is 1/1,000,000th of one torr.
We all understand. It's an exponential scale. We get it.
I'm not sure you can provide me an industrial gauge that can measure that kind of low pressure. Show me a physical instrument.
What's that got to do with any of this?
Well, how? I mean, to even claim that. Listen, to claim that 10 to the -12 torr is possible, you have to show me that it's physically measurable.
Well, and that's like saying you can make so they can't make a claim of the temperature of the sun because you can't have a sensor that would melt before it got there.
No, Paza.
Isn't that
with temperature also? Listen, Paza. With temperature also, there are boundaries. We cannot have millions of degrees. We don't.
Why not?
The maximum temperature we can achieve. Do you know what are the maximum temperatures that we can achieve technologically?
They're like millions of degrees in labs. Where?
Yes, we could do
Yeah.
plasma. We could make plasma.
At the moment, yeah. At the moment, they're trying to get reactors going, aren't they, for electrical fusion reactors, and they have to have huge amounts of energy in place for those sort of things to take place. And that's all it means.
I know you can focus a huge amount of energy into one place, but
that's what temperature is. That's what temperature is a reflection of.
Actually listen. You will never be able to get an accurate measurement of how much energy will be actually really manifesting in that place, and what the highest temperatures we can achieve.
That's a statement. That's an assertion you're making.
It's only just calculation. You don't know what happens with matter at those tiny levels.
And neither do you. But the point is this, okay, right? Yeah, is temperature is only a measurement of how much energy is in a location at any given time. That's ultimately what it boils down to. Yeah, so it's the excitement of a system with energy. That's what a temperature distills down into. Yeah. Now, if they pump a quantity of energy into a certain
matter itself has a limit of energy that it can carry.
Who said that?
Huh?
What do you mean?
Why show me an object that you can put whatever amount of energy in it, a ball, you can throw it at any kind of wall, and that ball is unbreakable, and the wall also will be unbreakable, no matter how hard you throw them.
That's got nothing to do with how much. That's got nothing to do with how much energy is in the system. That's a parallel discussion. But the point it comes back. Listen,
I'm telling you that things, these things you call atoms, they don't hold their state anymore at such high temperatures.
They break
they have
down.
a limit.
They have a
break
limit,
down.
They lose.
But the energy is still. Listen, it's still an energetic system. There's still energy in the system.
But that energy you still put in there, it's already more than you require to achieve that breakdown of that matter. And that energy you put now there, you put it into what?
Well,
you still consume it because your machine, I know, you build this powerful machine that can consume a lot of energy.
This is an interesting conversation, but it's going away from the original point I made, which is there's an
so can we stop real quick? We're about to have ladies' night tonight. Hold on. We're going to have a ladies' night tonight, and we can continue this particular conversation, but you're going to do that with the ladies if you would like. We're going to hand it over to them. One last.
To go back on. So I will be back. Yeah, but I'll come off now. So sorry, I didn't mean to hold anything up. I didn't mean to.
No, it's fine. Okay. You're good. Come back and talk to the ladies. All yours, girls.
Cheers. Bye.
Okay, I already started the event, so I guess I'll start it. I thought you ladies already started it, but apparently not, because there's some kind of marathon session going on with somebody. Who was that you guys were just talking to?
Yay. Hello, Mary Mom. It was Paza.
Paza.
We all had to get our 1,000-word in before you got started.
Oh, and he left. I thought you guys said you were handing him over, but apparently he didn't want to talk to us. That's fine.
He had to leave, he said. Yeah.
Oh, okay. Yeah, I'm sure he'll be back.
It's all Sasha's fault.
Okay, well, then you just for
gas pressure without a container. Go ahead, sorry.
Oh, that's what he didn't. Imagine that, Get He didn't have gas pressure without a container. Imagine that. Yeah. Same old story. Another rerun, different characters, same story. It was a remake, right? Yeah, so anyway, feel free for future reference. If anybody else ever wants to start the ladies' night, I was just cleaning up dinner, so you don't have to wait for an invitation. If it's ladies' night and you're a lady, then go ahead and start it. Because I see we've got several women in here. Huh?
What if I
Happy
identify as
cooking.
a lady?
Thank you. So yeah, we're here at the 24/7 Flat Earth Discord server 2.0. It's Friday, February 18th, 2022. It's time for the Flat Earth Ladies Night. I appreciate Nathan creating the event. See, if you just start slacking off, then other people will start doing stuff. That's what I've learned. Yeah, that's why I had to hold myself back. It's like, slack off, do it. You can do it. Come on, slack off some more. And so I didn't make the event, and Nathan made it. So isn't that cool? Yeah, anywho, the Battle Goddess, a.k.a. Shines, is here. I don't know if she can say hello. Can you unmute?
Oh, yep, I can unmute. I will be in and out because hubby is home tonight and has a few meetings. So, but I will mostly be here for the entire event. So I'm really glad to be here, and it's good to hear everyone's voices. Good to hear from you, Dandelion. Looking forward
You too.
to what everyone has to say tonight.
Glad you're here. You missed last week with Bob User. Since he had a 7-day sentence, he'll probably get out of jail sometime during
Wait a
Ladies'
minute.
Night tonight.
Wait, Bob was here last week?
Do you know Bob? Bob User? I
do
mean, how many
know.
Bobs are there? You think it's the same Bob?
Well, I'm hoping it's the same Bob. Dr. Bob, who likes to, give quizzes with yes or no answers and is always setting people up for failure. That Bob, trying to
I
make
don't know. I think it might be a different Bob. This was the guy that had that common disease that globers have where they can't actually say they live on a spinning globe because they think they're like in this like weird existential reality where they think like if they just don't claim they live on a spinning globe, then we won't be able to hold them to any claims, and then they can kind of weasel out of it. He wanted to talk about everything out under the sun except for any kind of proof of curvature or rotation. But I don't know. It could be the same guy. I don't know.
No,
But
it's not.
You
So,
didn't miss
Drace,
anything.
Yeah, Drace
This
actually
is the short
said
version.
it's not Dr. Bob. It's little mini Bob. So it's a little mini me of Dr. Bob.
Okay, let's call him Mini
I'll have
Bob.
to go back
I
and
like
listen
that.
to it.
That's a good
I'm
idea.
sad that I missed it. I'm sad that I wasn't here
Well,
for it.
don't be too sad, Kat, because I'm sad I was
Didn't
there.
miss much.
But anyway.
Yeah. I get that as well. That's hilarious.
But anyway, yeah. So, anywho, let's see. We got Damsel Medic. Has she said anything yet?
She has not.
Okay, a lot of times she can't talk at the beginning, so maybe we'll hear from her later on. And let's see. If I missed anybody, let me know. KJ's here with her diamond emoji. Hi, KJ.
Hey.
How's it been going around here? I haven't been here much because I've been really busy. How's it been going?
Pretty well, I would say.
All right, good. Oh, and Karma just popped in right ahead of you there. And so now I get to say hi to her. Maybe she's not ready to say hello yet, though. But it's good that Karma's here. We're going to do Karma's going to be helping me out with my part of the Avoid Logical Fallacies presentation. I should share that in the live stream in case anybody hasn't heard of that yet. That is happening in a couple days now. And it should be a good show. So hopefully people can make it.
Yeah, I have not heard about that. So please send a link. I would love to be there for that.
Okay, I'll put it in.
Yeah, I didn't hear about that either.
Oh, okay, cool. Yeah, there's Dancelmatic. Yeah, so there it is. If you want to click on interested, it's on Sunday. Oh, okay, and CB says there's a bunch of EC verified people in here. Struble, Stacy, Burns, Yazid, Andy UK53, and Guy LaDouche. Oh, that's great. So if any of you people have questions about the flat Earth, this is a great night to get them answered. Veronica K's here. Hi, Veronica K.
Hello.
Good to see you.
Hello.
Yeah, who was that just said hello?
It was me, Yazid.
Yazid. Okay, hello, Yazid. How are you?
I'm doing good.
Okay, good. Yeah, we're glad you joined us. So, welcome to the server. Did you just recently join?
I have joined like 2 years ago. I didn't have a chance to have a long chat since my first chat with the people here.
Oh, great. What was the first chat like 3 years ago? You remember?
It was about what we observe, and I had a long discussion about 2 hours with the people here. And they asked me some questions. I asked some questions about what people think that Earth is the shape, whether it's this or that. I gave some observations. They gave me their observations. And we did not come to an conclusion or anything. We just ended the conversation with open questions. I didn't
Okay,
have a
kind of
chance
like a
to come
stare.
back.
Oh, keep going. You didn't have a chance to come back until today?
Yeah, now I'm just finishing my work, and I thought I'd check what's going on here.
Good timing, because this is the ladies' night, so we do this once a week, and not really an affirmative action program, even though some people accuse us of that. It's really just more of a, spotlight or a feature on the women of the flat earth who sometimes have a different approach toward introducing the concept that the fantasy globe model has absolutely zero basis in objective reality. On Saturday, we feature the silver and gold members of the server. That's tomorrow afternoon. So I'll put that event in the live stream voice text too. So in case anybody's new to this event system, Precious Metal Takeover, did I say that is tomorrow? You can click on interested and then you get a notification of the event. Not only that, but the other wonderful feature is that it converts the time into your time zone, which is great because we have a lot of problems with that around here with people all around the world. So anyway, Yazid, what were your observations of the place where you live, the Earth? What are your observations about it?
I see. I like to go on the bike and move around. I live in somehow of a desert area, and there are a lot of mountains. I go around, and I said that I see some curvature, but
Oh
I'm not
boy!
sure.
Wow. Did you do
I'm
any
not sure.
measurements or
Oh
documentation of this curvature, or even photographic evidence? Because nobody else we've never had anyone ever come here with any, for years now, verifiable, testable, repeatable, verifiable scientific evidence of curvature, of this fantasy globe that we're told existed. So where did you see this curvature, Yazid?
I go to mountain heights a lot, and
wow, because I've been out in the Rocky Mountains in the western United States, very high mountains. I spent days climbing and never saw any curvature at all. In fact, the higher you get, the more flat the horizon looks. That's been my experience. So I don't know what's going on there, Yazid, but a person's anecdotal attempt to see something that isn't there, or wishful thinking fallacy, as we call it, isn't evidence. It's not a measurement. So maybe did they tell you last time how we've actually measured the Earth and found that it lies flat, not only in long distance observations, but documented laser tests where the laser hits the target when the target should be hidden behind hundreds of feet of curvature if we did live on a spinning globe with a radius of 3,959 miles. Did anybody tell you about that, Yazid?
Oh yeah, they said something about that. So when I said I went and I noticed curvature, I didn't say that I have proof of the curvature. I said I noticed some slight. Maybe it's just some placebo effect I have just in the back of my head. Maybe something. I'm not here to bring evidence, or I'm just here to discuss. Because I don't have any pictures, I don't have any evidence. I'm just here to answer questions or ask questions.
There is a video in live stream at 24 minutes past the hour at the top of Everest where you can see him go a full circle around, and you can see the horizon is completely flat the whole circle around. So if since you were talking about mountains and such.
Yeah, that might be interesting to see.
Yeah, thank you for pointing that out, Karma. That's good. I like that. I don't think I've ever seen that one before.
Yeah, me neither.
Well, and the biggest point about that is that we see when we look out in front of us, And then we look to the left and we look to the right, that's 180 degrees. When we turn in a circle, we see 360 degrees. We're just seeing in a circle. That circle doesn't equate a sphere. So no matter how high we go, we're seeing a circle. And when people show posts of videos like the one that Seb just posted, they might take like a little section of it and be like, oh, look, here's curvature. When that's not actually land, that's just, that's just the Atmos. And so we will see a little bit of swaying within that, whether it's due to clouds or whatever is happening in one corner to the next, but that doesn't mean that the land is actually curving. So any kind of high altitude, anything that's ever been shown outside of them, with their fake imagery from the ISS, whatever, everything that we know people have actually taken without using a wide angle lens is that we're just seeing in a 360 degree circle of an area. And then there's a boundary around that we can't get beyond because we can't see that far beyond how far we're seeing. It's that easy.
So what is the model that it is you guys think of the Earth right now? So I don't understand the model that you guys are agreeing on.
Why do you need a model?
Because I want to understand how the Earth is.
So why do you need like a model to do that? In order to understand something, do you always need a model to understand what something is? You have to have like a duplicate of it on a smaller scale in order to understand what something is?
No, not a physical model, just an explanation of the model.
Yeah, so you can have explanations. That doesn't mean that it's a model.
Just like a visual aid,
Yeah, just
and
an
so
explanation.
that's exactly. So you can have explanations and you can, give facts to what is going on. That doesn't mean that you need to create an actual model of exactly what it's supposed to be on a different scale.
That's not what
No,
the
I'm not
model
about
means.
it. I'm not about the actual physical model. I'm just an explanation of how it is.
So then we need to start on like simple questions to figure out what things you aren't understanding, and then that's basically it. But we're not saying that we have a model. That there's like some comparison to what reality is to what we can actually say this is exactly what it is.
But the globe people do have a model that works and explains
Who's
everything.
talking right now? I'm so sorry. There's too many people talking right now. Who was that? Who said that there was a globe model? Guy LaDouche. Okay.
Guy LaDouche.
Guy LaDouche. Oh, I'm so sorry for mispronouncing Guy. So no, they don't have a model that actually works, and that's the problem. Is that people buy into thinking that they have a model.
We can make predictions.
No, you have not made any predictions that were not already previously made. What predictions?
We can tell you exactly what time the sun's going to be coming up tomorrow.
That's great. That was already being done prior to the globe model.
We can tell you exactly
post-diction, man.
What the moon is going to look at every time. At every moment,
that was already being done before anybody believed in the globe model, and Karma was correct. Go ahead, Karma. Say it again.
The globe model was way back.
It's not a prediction; it's a post-diction.
Exactly.
Once you've already observed something to happen every day, and then you say, "Oh, that's definitely going to happen tomorrow." That doesn't mean
because I can sit there and tell you what the moon is going to do tomorrow.
Okay, dude, cannot interrupt.
It's based on old observations. It's not a prediction of what will happen next. It's already been. Have you heard of the solar cycle?
I won't interrupt you if you don't interrupt me.
You didn't give her a chance to reply. I'm asking
what I was
you.
saying, and then
I wasn't done my explanation.
What I was asked to
You interrupted me.
No.
You're getting really excited.
Sir, Guy LaDouche.
Settle down a little bit.
Now you've been changed to model Guy LaDouche, model Guy. If you would like to go back and listen to the live stream later to micromanage and analyze your own performance and talk about how wonderful you are and show your family and friends how you never interrupted the ladies, that's fine. I'm here to tell you interrupted them numerous times. And so while someone was giving you the answer to your question, you started talking in the middle of the response. It's possible there's some kind of delay here, but we're not going to spend a lot of time arguing about the moderation. So when you ask a question, wait for the answer and then listen to the response before you continue talking. Thank you.
Well, and furthermore, to expound on that, is somebody else was talking and then you jumped in. So what we usually do on Ladies' Night is we have a one-on-one. and we talk to somebody, and if it's decent conversation, then other people are allowed to join in as well. We try to keep it as respectful and peaceful as possible. So there was somebody else who was talking to us, and I'm not sure what their name was on here, but if they wanted to continue speaking with us, they should get a chance before we move on.
I totally agree. Shines, I'm so glad you're talking about Yazid, who actually came in here willing to actually talk about reality and what he's actually observed, and then this dude just stepped all over it. So thank you for bringing us back to Yazid before he gets stepped all over by Mr. Victim Dude there. And then we can come back to Victim Dude after we're done talking to Yazid, who's been more than polite and understanding and considerate. Great idea.
Thank you.
Yes. If any of you other ladies want to continue talking to Yazid, I think that's a great idea.
So my request was the explanation of the current state of Earth. So if I walk,
I want you to be specific about that. Like when you're talking about the current state of Earth, you're objectifying Earth to mean like, it's this object, right? And so what aspect of that object are you even talking about? We can talk about water, we can talk about land, we can talk about gases, we can talk about all kinds of different things. So if you can keep it specific, then it will be more fruitful.
okay, so let's say I travel on a straight line forward and never come back. What do I find? Do I find myself in the same spot, or do I find an edge, or what do I find?
Well, here's the thing: well, we don't know. We can't go beyond a certain point. And even if you were able to get the paperwork to go beyond a certain point, it's so cold and frigid. We don't know what's going on beyond the 60th parallel, and we don't know what's going on towards the center, towards the north. We're met by military, and no average Joe can just go out there. You would need millions, if not billions of dollars to even try and traverse that, plus get the paperwork and figure that out. So what we usually only talk about is what we can talk about. And that's anything, in between, like, so prior to the 60th parallel and anything farther out than the center, which is north. That's the only area that we can actually discuss. And within that area, we know, number one, we see too far, that level is actually level. Level is not curving. A straight line isn't, we're not going to take Euclidean geometry and then put it into spherical geometry. We know how the geometry actually works. We know that level is horizontal. That's why it's called the horizon. And we know that all horizontals are perpendicular and parallel to each other. Though they might not appear to be, like if you look at train tracks and all kinds of stuff, parallel can look like it's actually merging with things when in fact it's actually not.
So if we say that the Earth is a circle and not a globe, and it is surrounded by military at the edge and whatever it is at the center, and everything is in between the edge and the center, every continent, every land, all the water. Is that what the explanation is?
Okay, I'm so sorry. I was being spoken at and I didn't get to hear what you said. I'm sorry, that's so rude. If you could just repeat yourself, I'm so sorry.
Okay, so the current explanation says that the Earth is a circle and the edge is guarded by military and needs paperwork to check what's on the other side. That's what I picked up from your explanation. Is that right?
It looks like she had to drop out.
She must have dropped.
Okay.
She must have had an issue there, so I'm sure she'll be back.
But yeah, so the South Pole is quite hard to get into because a lot of scientific testing, all that stuff goes on there, allegedly. So I think that's why you can't really go there.
Let's talk about what we're observing.
I'm so sorry. Hold on. My Wi-Fi disconnected, so I just got back on. I swear, I don't know. I'm sure it's a very easy question, so if you could tell me one more time, unless I missed, you guys already gave him the answer.
What I got from an explanation is that there is a center and it is accessible and people might have gone there, and on the edges it is not accessible, and it's hard to get there, and it's guarded by military.
Yeah, so it's not just the edges that are. So basically, the way that the globe looks at it is that Antarctica is at, the bottom, and that is just this little, not little, but this large chunk of ice, and that's it. And then, yes, people cannot get to that. But when you look at like how we're looking at it, so basically it's the AE map where Antarctica surrounds all of the continents like a lakeshore would. Right? We're like in this little puddle, and Antarctica surrounds that. So it's not just Antarctica we can't get beyond. We can't get beyond the 60th South Parallel. And yes, of course, we have, I think it is Wolfie that's in the chat. It might not be him, but who knows? That, people have been to Antarctica. Of course, we know this. I have family members that have been to Antarctica. Really cool stuff. Awesome. That doesn't mean that you get to freely explore Antarctica. You're taken to a ceremonial place with a pole in it, and you get to like hang around in these tiny little bits of it. You don't get to explore all of it. So anybody who says that, I mean, they're being deluded by government and by science and all these things. Their minds just can't wrap around that it's so much larger than the little area that they're being taken to. So yes, we can't get farther beyond the 60th parallel. And we can't get close to what's actually at the center towards the actual north. That's also met by military, and you need paperwork and like all this kind of stuff. And there are certain areas that you can look up where no flights are allowed to travel around them whatsoever. I think it's like 500 miles by 500 miles by like this perfect area where no one's allowed to even do air travel over. So there are mysteries to this world, and everybody's like, oh yeah, we have it all figured out. It's no big deal, when we don't.
Oh, never.
So
Yeah.
we're
We don't
sticking
know.
only to what we can discuss, and what we can discuss is outside of that north center and inside of the 60th parallel. This little prison planet, whatever you want to call it, the area that we are only allowed to traverse, and in that area we are allowed to traverse in, level is horizontal. All horizontals are parallel and perpendicular to one another. So it is not a sphere. It is not an oblate spheroid. It is not a pair. It is not all these other things that they're saying due to Euclidean geometry and how we witness the world that we live in.
A little chubbier. Yeah. Chubby's a good way. It's like pear-shaped. Yeah.
And some government is guarding these edges for some reason. I don't know. Why would they do that? It's weird.
Called a treaty. We have an Antarctic treaty. Longest running treaty that's never been broke either by multiple countries who claim to be enemies. But yeah, they all have navies, and they can run ops on it. It's not that hard.
There must be something precious behind that border, so that they're protecting it this hard.
Might be.
I mean, the fact that we go outside and observe that the Earth is flat, right?
Also, just a random question: Has anyone ever been, or like on this server, been known to convert either way? Like realize differently, Has a flat earther become a globe earther, and a globe earther being a flat earther?
I've never seen a genuine flat earther become a globe earther. Some people have sold out on
Have you
this
seen
little,
a globe
that
earther
little
become a flat
YouTube,
earther?
that little YouTube clown show they got going on there, where you can make money off of lying about the Earth. We have seen many globe earthers become flat earthers. That's the normal thing, because pretty much everyone here started out as a globe believer, because that's what most people are told. Unless they're raised by wolves or they're Ildico. But the rest of us, we usually, most of us were observant, thinking people who decided to disprove this flat Earth for whatever reason, because we were told, it's a psyop. If we were in the truth movement, if we're in the regular world, we were told it's a conspiracy theory, or we were told they were stupid, they were in the dark ages. So we decided to disprove it. And that's occurred to many, many people who set out to disprove it. If they are willing to follow the evidence objectively where it leads, then they are led to the obvious conclusion that the globe has zero verifiable evidence whatsoever. An example of this would be Dr. John Dee, PhD in photospectrometry. Photospectrometry. I got to say that 10 times fast, right? G. Morse Brown until I learn it.
I wouldn't be able to say that.
Yeah, I know. It's hard to say. I think it's easier when you're looking at it. When I try to bring it up from my head, it's easier. I mean, it's harder. But anywho, he decided to disprove it, and he ended up proving it to himself. That's just one example. I usually throw that out there for new people because they love that PhD thing, right? Because they think flat earthers are stupid. Yeah. So I'll put some examples. I'll tag you in the channel. I'll tag you in the channel with some of Dr. John Dee's work. He's a great example of a former glober who became a flat earther. But there's thousands of examples. That's the way people go. It's only if they're stuck in cognitive dissonance or have psychological problems that they are unable to follow the evidence where it leads. Anybody else have an answer for G. Morse Brown? That's a great question. That was kind of like,
it is.
I mean, we don't hear that one very often. So any other women have an answer for him?
Dandelion, I wanted to capitalize on what you said because that's so true that just about anybody that we've ever met, honestly, when it comes to this topic, becomes a skeptic to that globe outer space religion that we've all been fed. There's no such, I've never seen anybody honestly go back to an outer space television fantasy, and the way that Dandelion quotes it is so eloquent. But that's the point. Every one of us used to believe in that magical globe Earth, and that's now there's millions of people that realize it's not true. But yeah, go ahead.
I'm curious, what's going on? Who are you, G. Morse? Because it says that you're a globe birther, and you're talking on ladies. I'm just wondering what's going on here.
I don't know.
Are you a globe birther? I'm confused.
Yes, I am. Yes.
No. So G. Morse. So you're a globe birther.
Yes.
Who was just speaking then? Because I guess you just have a ring around your thing all the time. That's my bad. It looks like you're always speaking because you have a ring around you.
G. Morse is the one that asked if we've seen conversions
That's
happen.
my bad. So my bad was I was looking at his thing and I thought he was speaking and I was so confused. Why is he agreeing with Dandelion? He's a globe birther. So that was my fault.
I shouldn't be speaking anyway. Yeah, this should be for the ladies anyway.
You should change your green ring. Thank you.
Here we go. I think it's fixed now.
Thank you.
I just had voice sensitivity, automatic stuff on.
No worries. Yeah, I was just like, wait, why was he saying that? Because I didn't scroll to look at anyone else speaking. So I just was there and thought it was you. No worries. It was just funny.
Shine, and something you said earlier, though, that they do miss this, and I've realized that you probably have to tell them it several times, maybe 100 times, but when you mentioned that they believe the Earth is an object, that's literally the crux of their belief system. They don't realize that the Earth isn't something that you can put in your hands. It's not an object or a model. Yeah, exactly.
They want to objectify the Earth, which is silly, for sure.
When I asked, they have another question. When I ask around about the seasons to the globe earthers, they have this explanation that the Earth is tilting and it is making the seasons differ from people on Europe. For example, now Europe has like winter or early spring. On the other hand, Australia is like in summer or whatever. So they have this explanation, but I wanted to ask about how seasons work in this explanation that the Earth is a circle. How does the seasons work?
I was typing a really long message, so if nobody else wanted to respond to that, I would need to hear that again. Unless
he wants to know how the seasons work on the flat Earth. So go ahead if you want to, or I can do it. Whatever.
You go ahead. I can chime in.
Okay, so Yazid, are you there?
Yeah.
Okay, so this before I go into possible explanation based on what we actually observe, not based on the fantasy heliocentric model, which fails to predict. It fails to predict, most things. It's a failed model. It does not explain the seasons well either. as well as all the other things it fails to predict. As was mentioned earlier when the Mr. Interrupter was in here, many of the things they claim to predict were already predicted long before the failed heliocentric model came into existence. So in the case of the seasons, but before I went into that, I just wanted to explain. I don't know if it was you or someone else that asked about, a comprehensive model and so on. We don't claim a comprehensive model. We will present possible models that seem to actually match what we observe in the real world. So, we can easily come up with a possible model. That doesn't mean that we are, hold on, I got to finish this message to myself. Okay, there we go. That does, okay, oh, look at that. CB put it in there for you. So there you go. Do you see that graphic at 47 minutes after the hour, Yazid?
Yeah.
Okay, so so apparently Model Guy, you have some listening problems. I just said we don't claim a comprehensive model. We do what models are actually best designed for, which is to present a possible explanation for one certain phenomenon. I'm talking slowly for Model Guy, not Model Gee. I'm sorry, Model Gee, not for you, Yazid. He has listening problems.
The way he even wants it to
Yeah,
be
well, I like it actually that way because it reminds me of this whole Frasier skit about Gee versus Gay. When they went to the ski lodge. Did you see that one? When they went to the ski lodge and the Gee the gay ski instructor. That's what I always think. That's why I like saying it when they're like, "Oh, I'm not Guy Jean, I'm Guy Jean." I'm like, "Oh, yes, you are, Guy Jean."
You gay.
It's so funny.
I did hear you
Okay,
on
I'm
your
gay.
post diction.
I'm sorry, Model Guy. I got to finish my answer, Yazid. You know what I'm a female Model Guy, so I get distracted. Anywho, we don't have a comprehensive model. If you look, Yazid, at 47 minutes after the hour, the sun's path over flat Earth, one possible explanation that actually matches what we observe, aka not a fantasy. So what appears to be occurring is that the sun is making tighter and tighter circles, as you see, and then these circles get bigger and so on. And so at different times of the year, you're going to have more sunshine concentrated on different parts of the Earth. So
The sun slows down.
Hold on. Are you going to make me X out this image just so I can mute you, Model Gee? I'm not talking to you. I'm talking to Yazzie. Did you still miss that? That's been the lesson for the last, half hour? We're not talking to you.
Condescension.
Yep, I got a lot of it. I got more where that's coming from, Mr. Model Gee. Yeah, I'll be happy to talk to you when I'm done. You want some more condescension, Model Gee? I got plenty. I got wells for you. I got deep, deep wells of condescension saved up just for you, Model Gee. But right now I'm talking to Yazzie. Anyhow, the sun is, as you can see, moving over the Tropic of Cancer when you have, more sun and then less warmth in the northern parts of the world, and then it keeps moving differently, and then moving closer to the Tropic of Capricorn when we have winter here. So then it tells you there in the explanation there, this is why in the Northern Hemisphere we get longer, warmer days in the summer, shorter, colder days in the winter. So there's one possible explanation that actually seems to fit the evidence. Oh, you wanted to chime in, you said, Shines. Do you have something to add to that?
No, because I was actually trying to find a GIF and stuff, so I wasn't even paying attention. I'm so sorry.
Does that fit with the observations made in the Netherlands, to the north of the Netherlands, where they have the whole summer where the sun doesn't set? I mean, they have days with.
Are you talking about the Arctic or Antarctica?
No, not. I'm talking about the northern Netherlands.
Yeah, so you're talking about the Arctic, where they don't have the sun setting. That totally happens. Can be documented time and time and time and time and time and time and time again. I have family members who have made videos of that. The issue that we have, and it's not, and we have people that actually even live in that area, and they might even be able to attest to that. But what we don't have is 24-hour sun in the Antarctic. We might have daylight, which can be explained by multiple different reasons, but to actually see the sun 24 hours a day without it setting in the south has never been accomplished.
I was not talking about the Antarctica. I was talking about the Netherlands.
I know,
because
and I was just proving my point.
Yeah, they have days and where the sun like sets for like 3 or 4 hours, and
Yeah.
the rest of the day is 20. Yeah, so when that observation
just like
doesn't,
Alaska. I've been to Alaska, so I know. You're
Yeah.
talking about the 24-hour sun, or what they call the midnight sun. Yeah, we know
Yeah,
about this. It's
yeah.
been documented, just like she said. Whether it be
Yeah,
the Netherlands, whether it be Alaska, it's all the same. That's been
Yeah.
documented. And this idea of the way we're presenting it explains it better than your model does.
Yeah, I don't have a model. I'm a skeptic of both models. That's why I'm asking questions.
Well, you should be, because there shouldn't be a model. There is no model. You
Yeah.
can't make a model if you don't know. And even
Let's
if you
go
did
with
fully
reality.
know it, like still trying to make a model of the world and like all the you just can't do that. So you need to get out of this thing in your head where you keep fighting to have a model. Let that go. What we can do is we can discuss certain things that are happening. We can discuss the minutia of it. But this overarching scale of like everything is explained and placed into a model, it's not going to happen. Not anytime in our lifetime. There's still so much more to figure out. And anybody who says that they actually have a model, like Globers constantly are saying that they have their model.
Well, they do.
Their
Yeah.
model does not. No, they do not. Their model does not work. The second law of
They do have a
thermodynamics.
model, but whether
Yeah,
it works or not,
but it's
yeah,
broken.
that's
It's broken. It does not work. So they don't have a model. So we can go in this loop-de-loop over and over again. Oh, they have a model, but it doesn't work. But they still have one. It doesn't matter because it's broken. Yeah. So therefore, they don't have a model. They don't have a working model.
Let's
So
say
for
they
them to
claim they
claim
have a
that we need to
model.
have one is utterly ridiculous. Let's not play fairy tale and claim that they do have one. They don't. So let's talk about something where we can actually talk about actual facts, not something that's made up, because that's what
Okay.
they like to do. Let's talk about actual facts. That's what we like to do.
Okay. The reason why I brought the 3-hour nights and the 21-hour days is that I don't seem to understand how that fits with the seasons and how the sun is above.
Okay, so have you ever there's tons of explanations for this, and they range depending on whose videos you're going to look at, and of course people are creating different simulations for each one, but it is quite simple. The closer that the sun is towards the north, the warmer that it is in that area, right? And it's in a smaller circuit going, which however it's moving, it's in a smaller circuit towards the north. And then the south is getting their summer. As the sun moves away from the north, then the north is getting their winter and the south is getting their summer. I don't understand how that's hard to understand.
No, that's not my question. My question is that the observations made in Alaska and North Netherlands, where they have the long days and the short nights, does not fit with this rotation of the sun here.
Yeah, because it doesn't work. It doesn't even work on the globe model. So this is why I kept telling you need to get down to the minutia of it. So what we need from you in order to have like this really good discussion, which I know we're right on the verge of having, is for you to explain, this globe model and how they're saying the sun is actually working, and then say like the sun actually works on this. And this is how I think it actually works. And then we can tell you how it doesn't work. And then how it doesn't, or how it doesn't work on, flat earth. Like you need to come up with something. Otherwise we're just kind of just not really saying anything. This argument isn't going to go anywhere if there isn't an actual argument. You can't just say it just doesn't work. Like you have to give us a reason why you think it doesn't work.
Why doesn't it work for The globe Earth?
Why it doesn't work for anything. Whatever your thoughts are, just be honest with them and we can handle it. Like whatever it is that you are confused about, just let us know and then we can, break it down piece by piece. But we need to know what you're actually saying. You can keep saying it just doesn't work, but I need you to explain why you think it doesn't work.
Because in this explanation, it says that the sun's path over the flat Earth, it seems like it is always shining, and there is no time for the 3-hour nights in the Netherlands.
Oh, okay.
I don't see that.
I think I get what you're saying. So what you're saying is that it should always be lit up. So if the sun is close to the north, everything should be lit up all the time.
Yeah.
And there shouldn't be any kind of duration where there is night or day or any kind of anything. Well, there are times where there is 24-hour sun and it doesn't become night. So because at the north, it is very close, right? And so when the sun is going around, the sun doesn't ever set. And it's just a continual daytime. And then as it moves away, then you start getting nights again in the north, right?
No.
I don't understand. Then I don't understand your question.
It doesn't. If it moves away, it doesn't give nights. It seems from this picture that I'm seeing here.
What picture are you looking at?
Could someone send like a GIF of, I don't know, the sun moving around when you're at the North Pole or something, if that exists?
That's already been posted. The sun moving around the north was already posted at 55 minutes after the hour by Drace. You can see the sun. It's moving up and down and up and down, and it's never setting.
Yep.
It just never sets.
Yeah.
It looks like it's moving up and down. That doesn't mean it's actually moving up and down. It actually is because it's getting closer and further away. But to us, it appears like it's going up and down like a bouncy ball. But that's just an optical illusion. It's just simply getting closer and moving farther away. But it's not moving far away enough to provide night. And that's why it's a constant day. Does that make sense?
Is there anywhere where people have taken it where you can look directly up and see the sun rotating around? Well, I guess it doesn't matter if it's not. That doesn't matter.
You mean like from a ground positioning?
Yeah.
If you did that, you wouldn't be able to see the sun moving farther away because it's so up ahead that if you were to just lay a camera flat down on the ground and look up, you would see the sun when it was there, and then you would just see the sun go out of frame.
Okay.
Right? And then come back into frame. So when you were looking as a human being would look standing up, and we're seeing the sun, it looks like it's bouncing up and down, but it's really just perspective of it coming closer, farther away, closer, farther away, but it appears as if it's moving up and down. It's an optical illusion.
I like how they added Mario at the bottom. That's a nice addition.
It's epic. Yeah.
It's probably to show that how the camera is moving.
Yeah.
Anyways, I'm gonna go take my kids to sleep. I might come back sometime later.
Please come back. It was a good conversation. I just really hope that you can come back with I really hope, even if you can take notes, if you watch videos or whatever, make things specific so we can actually answer those specific questions rather than just sweeping generalizations or anything like that. It really helps when there is extreme context to the questions that people ask.
Well, I'm now a scientist, and
neither are any of us. And you don't have to be a scientist to do this. This is you wake up in the world and you look at things. Even artists are sometimes even better at this than scientists because they understand perspective. So
I'm not so deep in this. Yeah, I'm not so deep in these conversations to the point where I take notes, and I'm just on the surface. That's why I can't go deep right now. Maybe if I have a lot of free time, I might do that. So, anyways, good talking to you. See ya.
Thank you. It was good talking to you as well. Is there someone else who wants to speak besides, or that guy leave? Who else do we have in here, ladies?
Hi, I'm Stacy. I'm from Australia, and I'm new
nice
to
to meet
I'm new to this server, but I've been a flat earther since late 2020. And yeah, I thought I'd drop in and join, even though it started at 6 a.m. here, so it was had to wake up early.
You're amazing for waking up early. Good morning. That's awesome. Welcome.
Yeah.
What brought you to Flat
Greetings.
Earth?
Good morning.
Flat Earth started for me. I was doing a TAFE course, which is like in Australia the not so academic version of university, and I had a relief teacher for one session on one day, and then he was like full on conspiracy theorist. I say in quotations because he's more of a truth seeker, and he went on about like a bunch of things, and one of them was the flat Earth, and I listened to him, and I was mature enough to realize he wasn't just like sprouting out stupid nonsense. Whatever he was talking about, even though it was really like bizarre for me to hear because I'd not heard of it before, I could tell he was smart, and he must have, he wasn't just like dumb. He had good reasons for what he believed, but it was still a big thing for me to get my head around, so I kind of just shoved it aside for a few months, but eventually the flat earth thing came back, and I also have been raised as a Christian, so I've like I would read the Bible, and then I'd read in Genesis, oh, God created the firmament, and I think, well, the firmament, outer space, I guess God didn't create the firmament, or like he did, but you kind of just disregarding verses like that as well. So eventually all of that sort of piled up, and I finally looked into it, and I came out thinking an enclosed earth system made more sense. And since then I've been sort of doing some curvature tests and stuff like that. I haven't been too successful yet, but I do like put some time into trying to do tests and stuff for myself. But I've come away finding out like mirages and atmospheric effects are really quite hard to avoid. But yeah, it's the flat Earth has given me a lot of appreciation for nature and curiosity, and I've even got a telescope now, and sometimes I'll track sunspots or look at the moon. So that's about where I'm at.
Okay, I would like to hear more about like what was it that this it was a professor, right? Not just like there was a professor. What was it that like clicked in you that you were like, whoa, this is what's wrong and this is not okay?
Well, I guess the first thing was he seemed genuine, and I guess that's what made me sort of care about what he had to say. But he rambled on about like a lot of stuff, and like sort of saying, like I don't really remember exactly what he said, but when he was saying things, it was confusing to me, so I didn't really remember much of the content he said because it was just so far beyond what I've been taught. But I think it was just in the aftermath of me finally looking into it myself after a few months, and also getting really annoyed that if I'm like, for me, I found that I'm still young. I'm 19, and I was sort of at a place where it's like, okay, I'm now like an adult. I need to figure out what I believe. Am I going to continue and be a Christian or like a Bible believer? Well, if I am, then I need to prove that the whole foundation of the creation story fits in with the Bible. And as I'm reading it, it looks like a firmament. There has to be like some sort of firmament. So I think it was mainly the concept of trying to. I didn't want to disprove my faith, so it was me trying to think Okay, I just need to make sure Genesis fits with. I mean, not to make it fit, but to see if it does fit. And
well,
yeah,
I don't mean to cut you off, but what I found really interesting there is that even if you had that inkling that no matter what my faith thinks, I'm going to go up against it and see what these people have to say and see if there's a good explanation for them getting rid of this firmament in my faith, you would have found that they're wrong. There has to be something because it goes against the second law of thermodynamics to say that there is no barrier, period, that there's nothing, and then all of a sudden there's space. So we're somehow confined, but nothing is actually confining us. Except for we can get into all that, and then there's gravity, which is actually stronger towards the center of mass, but things get to escape in there. Like none of it makes sense. So even if you were able to say, you know what, as much as I believe in what I believe in, and I believe in the Bible, I'm going to stand against that and see if if anything that they say holds merit, and maybe I might be able to argue against it, no matter how much that merit is. They don't hold merit.
Yeah, like
it just they don't.
Coming in like developing my flat earth understanding, it really has taken me into like a whole logical sort of construct of thinking where, you know, you think about things holistically and observably instead of just academic jargon, which is all pseudoscience.
Yeah, I'm really happy you're here. Welcome. I don't know if anyone else wants to welcome to her to the server, but it sounds like you know, I really appreciate the fact that you even woke up early to be here. That's cool. So if you have any questions for us, or if anybody else wants to welcome her, yeah, or anything that you want to talk about, we're here.
I did also want to say she sounds awesome. Thanks for coming by. We're really happy to have you.
Yeah, I'll just say I heard everything you said, and you're spot on. So keep up the hard fight.
And I just want to reiterate, like, don't back down from that. Like, if you ever get in that position of like, oh, like, I don't want to, you know, do anything against my faith or whatever, it just makes your faith stronger. And I'm going to tell you right now that no matter how far you look into this or what arguments you might come up against, your faith will only become stronger if you're speaking about Genesis and like the firmament. There's no possible way that they can explain this away, which they tried to do, but you will quickly find that their arguments are not arguments, even at best. It's not even an argument. They try to manipulate the natural laws of the world we live in, and they do a horrible job at that. So, yeah, stick to your guns and keep coming back. Clap, clap, it works. I'm just kidding. This isn't like an anonymous whatever, but yeah, you're on the right path. Keep walking it and walk it strongly.
Yeah, like the saying goes, the truth can stand investigation. And even in a biblical sense, if the God I believe in endorses truth, then I should seek truth, even if it ends up disproving him, which I hope it doesn't. I don't think it will. But, you know, like the concept, seek truth, and then you'll find it. But yes, as an Australian, I can also help in Southern Hemisphere observations while I'm assuming most of you guys are in the Northern Hemisphere. So we can get some nice data if anyone's ever keen on checking the sun at a certain time, doing logs like that.
I would love that. That's actually something we've been talking about. Well, me and my friends have been talking about is like getting multiple people across the globe. Like one of my friends posted something on TikTok and they were like, I can see the moon right here in the middle of the day. Like who else can see it? And people that should not be able to see the moon at all were able to see it. So like if we could organize things much better to have that like on a daily basis, like, okay, people who are willing to do check-ins, I can see this in the sky at this time, whatever, and like start documenting that, I think that would be fantastic. So yeah, I'm going to send you a friend request. Welcome to the server. We're so happy to have you here, and hopefully we can organize exactly what you're talking about.
Yeah, that would be cool. Okay, thanks for welcoming me.
Okay, thank you to whoever gave her ladies' night as well. That was appreciated.
Yeah, she deserves that. At the
She
very
definitely deserves it.
least.
Taking care of everything.
Yeah, thank you guys. That was amazing. So what else do we have? Is there anyone else new here, or I haven't actually been looking up and down or keeping track? I've been bad.
If that's being bad, I've been horrible. I've just been
I
playing
mean,
TV and listening in. I've not been doing jack shit.
I've been trying my best. My husband is home today, so I'm pretty good about scrolling up and down and seeing who the new person is in the room or whatever. But yeah, I've been totally off my game today. So,
well, you're doing good for being off your game. I'm happy. Letting you take it, girl. Hey, there is somebody that looks like just to be verified. Burns.
Okay. Barnes.
Verified?
Wait, Barnes, like
Can you hear
Simpsons?
me?
Barnes? Oh, Burns. Oh yeah, like Simpsons. What's up?
She said I need to be verified.
Well, you are VC verified, but yeah, so you're coming in here, and then you get further verified by us to know whether you're a glober, flat earther. I
didn't know that was a thing.
No. So this is ladies' night, and so during ladies' night, we just welcome people in, and we get to talk to them and figure out who they are. And you get to talk to the gals, and you're live. Yep.
All right.
So how are you doing tonight?
I'm doing all right. I'm actually a student in college right now. I'm studying electrical computer engineering. But this kind of stuff has just interested me because I am, I guess you would say I am a globe earther, but I don't like to just believe, I don't like to just assume that I'm right about everything, so I like to look at all sides of the argument. It's interesting to me.
So you're in the middle. You're an earther. You're just trying to figure stuff out.
I would say I'm definitely more leaning on the globe side.
That's what I was reaching for. Okay, so you're more leaning on the globe side. So why?
I've definitely had discussions in here before. I think there was something that happened with this server a while ago where it got remade or something. So I'm not necessarily new, I don't think, but I don't really come around here often. My main opinion on that is just things that I observe that have been released from tons of people, which I know you guys think are lying or are incorrect in their studies, which they might be. But there's a lot of things that go into it, so it's kind of hard to. I might have to write a book on that if I really wanted to state my full opinion.
I don't understand. Like, it should be quite simple. I think what you just said was kind of like loose and relaxed, but I think that there has to be a reason. Or if
it's definitely pretty loose.
Well, even if it's loose, what are the reasons that you would prefer it being a globe in your mind? Like, there's some reason that's holding you back from being able to just say, you know what, I'm an earther and I don't know what it is. You are legit claiming that I think it's a globe over an earth, even though I'm not sure what it is. So what are the reasons that are leaning you towards it being a globe?
So, yeah.
Rather than I don't know at all.
First of all, I would say that I would not use the word prefer. I would say convinced.
Okay, that's fine. Whatever words make you feel comfortable.
Yeah.
What are those reasons then?
So there's a lot of reasons. Probably a lot more than I could just list off my head.
With one. Let's just start.
Yeah, I was gonna say I could give you something. I mean, I thought about mentioning this for a while. But as far as I thought I might ask you guys what your opinion on like satellite imagery is in more specific context. Yeah, I know. In more specific context to like meteorology, I guess.
Okay, what about satellite imagery? What kind of satellite imagery are you looking to discuss?
So, I have just thought about like how people use meteorology as a tool to predict the weather.
And they don't do a good job at that, but that's okay.
Well, I think they do a pretty decent job at it.
I mean, yeah, every single
as
year
good as you
these kinds of
can.
things come up. You can tell that something is getting hot, so then therefore there's probably going to be rain right after it. I mean, like Karma said earlier, it's more of a post-diction than a prediction across the board. It's much
Can you
more of a post-diction than a
explain?
prediction.
Sorry,
Things happen.
can you explain?
Yeah, things
Yeah.
happen every single year, and there are patterns to what happens every single year. So when you document those patterns of what has happened, you can probably post-dict, because this thing has happened, this thing will probably happen next.
Okay.
That's not a prediction that, oh my gosh, I know because today is sunny in the middle of summer, tomorrow it's going to start raining. When sometimes it does, and they have no fucking clue that it would start raining the next day. That would be a prediction. Like if they knew exactly what was going to happen all the time, they would be able to predict what was happening. The only thing they're giving us is post-dictions. This is a pattern of what has happened prior, and so therefore we can say there is like a 90% chance of rain. Or, you know, there's a 10% chance of rain or a 0% chance. That doesn't mean that they're actually predicting anything. It's just that they're compiling data and they see how things kind of fit and what could possibly happen. And then they give a percentage to that. So I wouldn't say that they're actually predicting anything. It's like Karma said, it's a post-diction.
Yeah, I think you did just describe what a prediction is, though. I mean, you use data,
No,
you
that's
observe
not.
it with...
No.
Okay.
A prediction would be that tomorrow it's going to start hailing rocks. That's a prediction. And then that thing comes true. I predicted it. I predicted that we're going to have hailstorms in the middle of summer that are the size of cars. Like, that's a prediction.
I understand now.
I would be able to say with 100% certainty exactly what was going to happen in every single area across the fucking world, how the weather was going to be. That would be a prediction. A post-diction would be we gathered all of this data, and because of the basis of this data of what we gathered in these areas due to everything that's happened in the past over all these years, we can say that within a percentage, this might happen or that might happen or that might happen. That's the difference.
Yeah, I understand what you're saying there.
And that's not even a post-diction, because quite honestly, a post-diction is like all this stuff has happened in the past, so we know it's going to happen. We know that this is going to happen. So there has to be a different word for that, Karma, because we know that that's not even a post-diction. A post-diction,
it's a cycle repeat. It's actually a cycle repeat, and that's the thing. All these things have been cycles. When we talk about eclipses, we talk about certain tides. They're cycles. They happen repeatedly within a few minutes of each other. So
well, but that's what I was getting at. So we all know what post-dictions are, and we know that they've gathered the data, so we know where eclipses are going to happen, and we know how the stars are going to move. Those are all post-dictions. We know where things are going to move due to a past pattern. But when it comes to the weather, it's not even a post-diction, because we don't actually know 100% that this is actually going to occur. So it's like a post-guess.
It's a percentage guess.
Yeah, I understand.
It's a high percentage of what might happen versus what might not, because weather is so variable and has so many variables that we don't understand. That you can't accurately say for certain tomorrow there's going to be 80-mile-an-hour winds, which they told me this last week on my area. They're going to be 80-mile-an-hour gusts, and then it turned into 40s and 30-mile-an-hour gusts.
Exactly. So it's not a post-diction; it's a post-guess. We know what post-dictions are. We have post-dictions, which are the eclipses, how the stars move. We know that these stars are going to be in the same exact spot a year later, where they're going to be each and every single fucking month. That's a post-diction. That's just writing shit down and knowing that that's going to happen. What happens with weather is that it's a post-guessing or a post-percentage, right? Like we can say, okay, good.
Yeah, I understand the idea of what you're
the likelihood of it happening or not.
There.
Basically, that's all it is. It's a statistical average.
If I could put a word in, I didn't want to stray too far away from what I was trying to kind of talk about here, which is they do use satellite imagery, or at least they claim to use satellite imagery to make these guesses. And they have weather radars that everyone can look at. And
So
they change over time as they watch it. Yeah.
You said
radar on the ground.
and you're talking about satellites. So that's why I kept asking you, like, what kind of satellite are you talking about? So if you're talking about weather balloons and radar, this has been going on for like a very long time. This has nothing to do with globe Earth. We know that they use weather balloons. We know that they use radar. If you think that there's actual satellites out in outer space, I would like you to show evidence for that. If that's your number one thing of saying, like, hey, you know what? I'm leaning towards the globe, and, you know, I'm an earther that, you know, I question both of them, but I still think that globe is more, you know, of where I'm leaning towards. Show me satellites in outer space. Show me all the satellites that they say are out there.
Yeah, I understand. Honestly, if you're really trying to get at where it turns the tides the most for me, I know a lot about whatever is out there on the internet and in the world about space and technology. I know you guys don't believe in that, and I know that
No. Stop. Okay, we need to take this one step at a time. So you just said that we don't believe in technology.
No, not at all. Technology in space.
Okay, so
I'm
what
just saying
technology is
what
out in
my
space?
side is.
And so I need you to back that up. And I also want you to pay attention to the word that you said, is that we don't believe in.
I know that was wrong.
No, it was right. Because we don't believe. I mean, I can speak for myself. I can't speak for the room, but I don't believe in anything that has to do with the world that we're living in with human beings, right? Like, I don't have faith in that. Human beings are liars. They lie all the fucking time. So I'm going to need facts. I'm going to need proof. And yes, I do not believe that they have tech in outer space, which is correct, but I would need you to show me where they do in order to even sway me. And I'm wondering why you're swayed to believe in the globe over a flat earth because of quote unquote tech in space and us not believing in that.
And I don't consider balloons in space or high altitude airplanes that are taking photos or high altitude balloons. So when you say outer space, keep in mind there's a specific definition for that, and that is quite extreme.
No, I understand. You can assume that whatever I mention here is on the general hive mind idea of what people think globe Earth is, if that's fair. But I'm not trying to say that that's how it is. I'm just trying to say that that's the background, since you're asking my background. But as far as outer space goes, in that context, I was going to say I've actually had long conversations about this on here before, and it always seems to derive into conspiracy, and that's where I no longer feel the argument that anyone presents to me.
What are you talking about? Satellites out in outer space? Like, where are you getting this from? Do you know about the second law of thermodynamics?
I'm not basing it off of that. I'm basing it off of...
What are you basing it off of then? How can a satellite get into quote unquote outer space and record all of, like, even if something got that far away and was able to get out of a barrier that is containing us, right, from this quote unquote vacuum, how would that be able to read all the way down to Earth, through all of those layers down to Earth, and pinpoint what's going on in the sky? Wouldn't you think then therefore we would actually know what the fucking weather was going to be? That we would know with 100% that it's going to rain tomorrow? Because that satellite is like, dude, this cloud is super fucking full. Like, it's definitely going to rain tomorrow. This is definitely going to happen. That's definitely going to happen. Like,
the weather
and
is
how would it even get out there? No. If it was that far away, so listen to what I'm saying. So if we had a satellite that was down here even close and like in the midst of it, it would only be able to track like what was happening, very close by. And things can change very rapidly within that. Something that is very far away, it would have a bigger area that it would be able to track and say, hey, in this area, this is happening at this moment. This is happening at this moment. The further away it is, looking down on us without a bunch of atmosphere to actually get in its way, it should be able to pinpoint Just like how we're able to look up at the moon and see it clearly, but if we took a telescope and couldn't see a stop sign a couple miles away, it's the same shit. We're too in the thick of it down here. If the satellite was that far up, it should be able to look down and say, this cloud is doing this cloud is doing this, with 100% certainty. These are what the clouds are doing. No?
Sorry, 1 sec. Someone's talking to me.
Of course.
I will get back.
I'm just kidding. But yeah, of course they are.
Well, I just would like you to look up the definition of conspiracy. That word has been weaponized against us to make you think certain things. You might want to look up where that came from. Conspiracy theorists.
Well, I mean, it's so obvious. Like, it's a total psyop. And go ahead. Were you going to do the definition, CB?
No, somebody else spoke up. I don't know who.
Yeah, no, I thought it was CB doing, like, here's the definition of conspiracy, and we're going to get the full definition.
Your definition of prediction was quite interesting.
Wait, who is this?
Pazza? It's Pazza.
Pazza. Sorry.
How do you define a prediction?
How do I define a prediction?
What is a prediction? Because Merriam-Webster says it's to foretell on the basis of observation, experience, or scientific reason.
Yeah. So they change the definitions of things all the time. I bet you I can pull out one of my 1800s dictionary, and prediction would say somebody knowing something that's going to happen in the future without any recollection or any kind of knowledge prior, that they are predicting what is going to happen. And they change words like this all the time so that they can say that they are predicting something and seem like magic ball whisperers. That they are knowing what's going to happen next by using data. They changed. It makes me want to pull out my dictionaries right now.
Hang on.
Well, it comes from the Latin word to know beforehand. That's all.
Yeah, to be know. That's exactly what I was saying. The Latin thing.
That's all it means.
You go ahead.
To know beforehand. Latin is to know beforehand, and that's all it means. It doesn't give you any indication of how they did that or what it means.
I'm going to grab my dictionary. I'll be right back.
From the Latin.
I was going to say there are two. Merriam-Webster's got two definitions of the transitive verb. One is to declare or indicate in advance, which is inferring some sort of understanding before something happens. And the second one is to foretell on the basis of observation, experience, or scientific reason. So a scientific prediction is not the same as a colloquial prediction by that definition, isn't it? Really? Do you think do you understand there's a distinction there in the definitions? That's what I'm saying. I mean, you're right. The ancient definition of predict is to know before.
Well, they still say that too with weather. Actually, the definitions also conflict with. They say it works with a forecast of the future, a forecast of anything. Yes, you can use a scientific idea behind it and change the definition to mean we've got enough data, we can actually predict what's going to happen. The thing is, they're still wrong some of the times. So it's not like a prophecy or a true prediction where it absolutely will come true. Absolutely will come true.
You get back to the same position with the word forecast. Forecast can mean either to predict in the ancient term of like soothsaying or estimate. And an estimate is a deduction based upon or surmising something based upon your own personal experience. So in the same sense, you've got two definitions of the word there, even with forecast. Forecast can mean some unknown mechanism for determining what the future is, but it can also mean, by definition, if you're estimating by definition assumes you have some colloquial understanding of some mechanism to predict something. You know, you don't estimate from blind, you estimate based on a personal experience. If you say, someone says to you, can you estimate the price of those apples? You do it because you've got a back catalogue of knowing what apples are. Otherwise, it's not an estimate, it's just a guesswork.
And that's why we call it a post-diction with the other information, because it's actual observation they've written down and it repeats over in a cycle. So it's not really a prediction. Like it could happen or may not, but they're predicting it will. Post-diction is that they actually have the information, they have the data.
Do you guys want to hear what it actually says? Sorry to cut you off, Damsel.
Yep,
so this is my dictionary from I think it's 1840. And what I find very interesting about this is literally what it says. So it says prediction, Latin. So this is where we need to get into. I need to look up etymology next. Is that it is Latin predicatio. I can't pronounce that, but it says affirmation of something or the act of affirming one thing of another. That's literally what it says. It says once again. Wait, hold on. Let me say it one more time because it's very simple, but also very interesting. It says affirmation of something or the act of affirming one thing of another. This is from 1840.
Yeah.
It's also, can I point out the fact that you can't really ignore the context in which this was said? Because he was saying that the globe model predicts all these things that are happening in the sky, when it's actually an explanation after the fact, which is a post-diction, which is what we were correcting him on, because he thought they could probably guess what would happen in the
spot on.
future.
This definition is spot on. You're right.
If
can I ask a
Wait, hold up,
question?
and it gets even further. So when you even go down to like predictive or like anything like that, it's foretelling, prophetic, everything that has to do with actual. And so prediction is affirming that prophecy. Like you're affirming a prophecy over one thing than another. You're affirming it. You're affirming that some people say that this thing is going to happen. And then you affirm that, no, that thing is not going to happen. This is actually what's going to happen. That is predicting.
You're reading between the lines because the terminology they use is
I'm going to take a photo.
Can you read that definition from your dictionary again?
Which one do you want? Predicting, prediction, which one?
Prediction.
So prediction is affirmation. So it's Latin of predictatio. And it's affirmation. It's affirmation of something or the act of affirming one thing over another.
Okay.
So you are literally saying this is going to happen and this other thing isn't going to happen. And then when you scroll down, so that's predictory, right? Actually, so prediction. Oh, wait. I guess that was predictory. Where is prediction?
While you're looking it up, can I read out Napalm's thing? And
no, wait, hold on. And then, predictory is affirmation positive, right? And then the next thing was foretelling, foretold, told before an event, a foretelling, a previous declaration of a future event, a prophecy. This is from, so this dictionary, let me go back to the beginning, is from 1846. And so we can even notice today all of the words that they are constantly changing, whether it's political words, whether it's health style words, all of these words that they constantly try to manipulate into meaning something else based off of what they want words to mean. And they're constantly doing this. And that's why I collect dictionaries to be like, oh, okay, what did people think way back in the day? That's the words mean what our brains think that they should mean. But now they mean something different, so it can fit the fucking narrative. It's ridiculous.
The bottom line is,
that is a good point. I don't want to get lost from the main point, which is, in the context it was used, it made sense perfectly. Using post-diction, is that when he was using prediction, we made the distinction between those words to explain to him the problem with what he was saying.
Are you talking about the first guy?
I just want to... like when the guy was saying
weather,
it was a prediction with
weather.
The globe models. No, I'm talking about the earlier conversation.
Oh, the other guy. Okay, gotcha.
I am back now, by the way.
Words. Yeah. But I really wanted to read out Napalm's comment because it was a really good one. Like Napalm said at 33 minutes after the hour, it's a post-diction because these known cycles have been known well before people started claiming the Earth as a globe. Now the globe pushers are claiming that it's a globe because we can predict these cycles. And I don't see why we're going so far into the definition of this word endlessly. Let's go back to flat Earth. Because
the reason why we went into the definition of it didn't have to do with Paza. We were talking about the guy talking about satellites and weather, and about what you even brought up about post-diction, prediction, and what they're actually doing. So what I was saying is that they're actually pre-guessing. They aren't. It's not even a post-diction for them to say what's going on with the weather. They're just guessing it. And that's why I brought out my dictionary and started talking about what actually prediction means. It means to foretell. We know that looking up at the stars and knowing what the stars are going to do is post-diction. But what they're doing with the weather isn't even post-diction. There needs to be a different word for it. It's like post-guessing, because they don't know what's going to happen. They're literally guessing, and they're not even guessing well a lot of the time.
You're right in so much as the meteorological systems don't have a mechanical linear progression in them. They have a chaotic element to them. Now the question is whether whichever word you're happy to use, or if you're dissatisfied with the evolution of the definition of a word over time, which happens for many words, not just ones associated with this kind of topic. Yeah, I'll ask you this: if in the old sense, in the old world, or in the old terminology, predict effectively was a soothsay, a prophecy, or a pre-knowledge of some higher order. Okay. And in the modern sense, you say they've bastardized the word effectively for their own nefarious purposes, to mean a evaluation of what may happen based upon the past. I'll ask you this: which is a better prediction of the weather? A man in a field throwing stones and beans around and dancing around a fire, making a prediction in the old ancient sense, or someone looking at tons of meteorological information from a whole vast area of the planet?
That's not what we're talking about, though. Yeah, and yes, of course, but that's not a prediction. That's our point of like where, everybody complains that we get in this argument of semantics, but it fucking matters. It matters how they change words. It matters how they say, oh, we predicted that the weather will be like this tomorrow. No, they didn't. They didn't even do a post-diction. They are post-guessing what the weather might be like based off of all this information that they've gathered over years. And they still are not correct. To do a prediction by the actual meaning of the word since its origin was like, we are knowing that this thing is going to happen next. Prediction was like this magical thing. Like, we predicted it. We knew it was going to happen. And so to change that, like, oh, we can predict the weather. No, you can't. You can't even post-dict the weather. You're still guessing with post-diction. It still is like, there's a 10% chance of rain. There's a 30% chance of it. It might happen. We quite aren't sure. They can say there's a 30% chance of rain, and then it's a fucking downpour that turns into a flood because they don't actually know.
No, but you understand. You're being disingenuous. That's not a guess.
No, I'm not.
That's not a guess. They're not.
Yeah, that is a guess. If they don't know, that is a guess.
No, that's not how it works, though, is it? They don't say they know categorically when it's going to rain where you live or where anybody else lives.
That's my point. I'm saying that they are saying that they don't know. And so they're giving you a percentage of what might possibly happen, and then it could be something completely fucking different. So therefore, that would be a guess. Like, they're taking the best information they have. Let's change it then. They're making a bet. They're betting that it might be this, and they're betting that it might be that, and it can be completely fucking way off, but they're taking a bet.
Of course they are.
Does that make you feel more comfortable with that?
Okay, Paza, hold on. Paza, we're not going to continue down this line. So is there anybody, Paza, if you have a question about another topic, that's fine.
Okay.
Can I have a question?
Multiple times. If there's no other new people, I guess, go ahead, Niz, what's your question?
If they convince that the satellite see the clouds, how can they see the shape of the content, actually?
Are you asking Paza? Why don't you guys make a date for, tomorrow night? Are there any other new people that would like to ask a question, or anybody who's spoken before? Like,
I'll tell you what, my polite and
so on. We also have Jacob, who's no, you cannot, Paza. I just said we're passing. Niz isn't getting what's going on here. We're not going to sit here and nitpick what a prediction is. It was explained to you quite thoroughly. Yeah. Okay. Good. Well, hold on. If nobody else is available, we'll go back to you. If the ladies really are dying to talk to you. You could try unmuting Jacob. I'm
with Karma when it comes to like whoever does want to speak and whoever we end up speaking with. Like the 3 rules would be awesome.
Yeah, there you go.
Oh, hi, Jacob. Did you know you were unmuted? He doesn't know he's unmuted. I'll have to mute him again. Jacob.
You can
70
mute me.
something. 7,601. You don't want to talk? Okay, that's fine. Burns, did you have any other questions about the basics of why the world model's a failure? Or anybody else who's new? Snipola. I'll try unmuting Snipola. Am I coming through?
Crystal clear.
Oh, good. Thank you for the feedback. Snipola, are you there?
Yeah, I'm okay. I don't have any questions right now.
Oh, just talk to us for like 2 minutes, then I could give you the VC verified role. Then if you do have a question, you can unmute. So,
oh, cool.
Yeah. Were you, can you just tell us how you found the server?
A buddy just invited me, and he had just been curious about just some of the content that gets posted in here. So I just joined in. I just look at what you guys are posting to try and get both sides of the argument.
Cool. So, are you willing to follow the rules of the server as stated in the welcome channel?
Yes.
Okay, I'll give you a quick summary. Although you said yes, and so ignorance of the law is no longer a defense for you, but it's generally just no trolling, including concerned trolling. Keep the main live stream on the topic of flat Earth. Try to keep the conversation civil. If you get muted by a mod, this is a highly moderated server since we have over 25,000 members, so don't take it personally. For a few minutes, you ask to be unmuted if you. Sometimes it's a misunderstanding or delay and so on. And don't forget to check out the information channels at the bottom, A to Z, which will answer a lot of the basic questions you might have about the flat Earth. But if you even have one question about the flat Earth, Snipola, I'll go ahead and give you the VC verified role. We could answer it, and you don't have to talk if you don't want. We could just answer.
Okay, thank you.
Do you have any questions?
Not this second. I'll try and think of one though. Now that I'm verified.
Okay. Okay, cool. Then you can unmute yourself. Namaste has one for us. Let's see. Okay, Namaste. I'm going to have to unmute.
Hello.
Hello. How are
How's it
you?
going? I'm fine.
Good. Yeah, did you hear my spiel about the server and the rules? Are you willing to follow the rules of the server?
Probably. I mean, I'm here in
Oh my gosh.
now.
Well, if you don't want to agree yet, they're up in the welcome section if you'd rather read them first. They're not real complicated.
To be honest, I'll do something. Yes.
Okay, I'll take that as a yes.
Excuse me, but before I'm gonna tell something, I'm gonna tell something else. I love you.
Oh my gosh, are you gonna ask me a sincere question?
No.
What
Yes,
did you
I'm gonna tell, but I love you.
Okay. I doubt that because yes, I can. If you're going to hold to that, I'll find multiple ways to convince you not to. But
no.
Anywho, what's your question?
I'm gonna say my question. But are you fine? I mean, there's a question for me. I mean, excuse me, English is my third language, and I'm trying to say that. Are you fine? Everything's okay. I mean, are you okay?
Does anyone else want to talk to Namaste? Because I'm not really into the emotional.
Yes, no, it's not emotional. It was the first question. I'm gonna tell my question.
Fine. Yes, thank you.
Yeah,
I just met you, Namaste. Yes.
Okay.
Do you have any questions about the flat
That's
Earth?
cool. Yeah. Listen.
What is it?
I'm flying every day, not every day, sorry. I'm flying, I mean, so much. Like, I'm traveling and I see something while I'm flying and I have a question. Yes, I do agree what means flat Earth. Yes, and I agree with that. I support that. That's why I'm here, guys. And there are a lot of people here. But
Okay, you support the flat Earth. That's what you're saying.
Yeah, of course.
What makes you support it?
That, I mean, my mind, it's my mind, not, I mean, I'm thinking, okay, it's my mind. I mean, what my eyes can see when I'm flying. You know, you can say.
Are you a pilot?
You what?
He asked if you were a pilot.
No, I'm just like I like to fly
Yeah, the
to.
horizon is flat. The horizon is flat when you fly. I agree. Yeah. You don't even need to fly. You can see it just going to the water. I mean, that's my favorite place to observe the
All
flat
right.
horizon is at a large body of water. It's obviously flat. Yeah. There's no curvature anywhere. Never been measured. Can't be observed.
All right.
And we would. The important thing is that we would be able to observe it if it was there, and we would be able to measure it. And in fact, we cannot.
I'm thinking that I'm doing something wrong because you speak like, okay, I don't know what your access or what you are. I don't know you. I don't know who you are. But I'm thinking that you trying to do something that I don't know. Let me speak. Um, can I?
You're just
You have
speaking.
been.
Was someone trying to stop you from speaking? I didn't observe that at all.
All right, but I'm thinking right now that you trying to make something that, yes, I agree, but I don't understand what you're trying to do. Anyway,
Do you have a?
You want to know what I'm personally trying to do? I'm trying to. Okay, I'll explain it to you, Namaste, if that's your question.
you.
What are you trying to do, Dandelion? If anyone else wants to answer, they can. Here's what I'm trying to do. I'm trying to do penance, making up for years of misinforming students about the fantasy globe model because I made the assumption that it had all been checked out and proven somehow. So when I actually started investigating, I assumed that any minute now I'd find that verifiable, testable, repeatable scientific evidence that would show that that was the case. Then when I discovered this does not exist, and in fact the globe is nothing superstition, then I decided I was going to spend some time on the internet. I wouldn't even say decided, Namaste. Every time I try to get away from this place, I have to come back because I'm called. Still difficult. So I'm not even actually here anymore, Namaste. For the people like Model Guy. I used to be here for them. Oh no, what? No, you don't get to, Namaste, because you rambled a long time. Then you made a mistake asking me a question, open-ended, so I could talk about whatever I want. So I get at least another minute. Don't make me mute you, Namaste, because I'm trying to answer your question. I'm not here for Model Guy anymore. I'm not here for people who can't follow logic where it leads. I'm here for the other people in the world who are unfortunately a minority, Namaste. Oh, you're so interested in talking to me and asking me questions until I actually talk. You told me you loved me, but you don't want to hear me talk, do you, Namaste?
This is not
I'm here for the flat earthers. That's why I'm here. Because it's not that hard to figure it out. It takes like 5 minutes. And if somebody wants to ask me a question, I'll explain it to them. And if they don't, or if they just want to go off in some kind of tangent like Paza, I'm just them. So you asked me why I'm here, and I answered ya. Sorry you didn't like the answer.
Can I speak? Excuse me, but you're trying to. Why are you acting like this? I mean, there are so many people here and they want to speak. Why you do this? Like, I mean, why you?
Talk to one of the other ladies, Namaste. I can tell you don't really like me, even though you love me. That's perfectly fine.
Let me just do this right now. Is there anyone else in here besides Namaste that is here to talk? Because maybe we should.
Yes, because I have something to tell you.
Okay, then maybe you should get to the point because before Dandelion, wait, hold up. Before Dandelion came in, wait, let me get my words out. Otherwise, I wish I had muting powers, but I don't. So let me say what I need to say. Before Dandelion came in and started speaking to you again, I was going to literally come in and say, "What is your question?" What are you trying to say? Because you are just like monologuing in this long ass monologue. None of us have any idea what your point is. It just seems like you're here to like talk shit. So if you have a point, get to it. Otherwise, we're going to move on to somebody else. So what is your point? Get to it right now.
Fine.
Thank you.
All right. And excuse me, maybe I'm wrong. Okay, I'm gonna tell you.
Yes, you are.
You're already taking way too fucking
What's that
long.
music? I'm hearing the music and
You're already taking way too long. Somebody mute him. It's already taking way too long. Just mute him. Who else is on here? This is like ridiculous.
This is Burns. I may be interested in continuing our conversation if you like. I know it's been a while. I had some other things I needed to attend to, but
Okay, what's up, Burns? What do you want to talk about?
Burns, you're
we were
looking
talking
mighty
about-
good. Did you bring Namaste in as a ringer just to make yourself look better because it worked? Yeah.
Me?
All right, back to Burns. Yay!
Oh, that's hilarious.
Yeah.
That was actually really funny, Dandelion. It was a perfect intro for Burns. So go ahead, Burns.
I have no clue what was going on there. But anyways, we were talking about satellite things, and if I remember correctly, the last thing that you told me was that if we do have satellites, then they should be able to 100% predict the weather. And I'm using predict precisely there because you mentioned that would be what they should be able to do if that kind of technology that they describe existed, right?
Yeah, they should be able to know exactly what is going to happen before it happens. Correct.
Okay.
100%.
You guys were ignoring
100%
the second law of thermodynamics violation there, because
And
how could
there
you
is
even
that
have
as well.
satellites? Because there can't be vacuum.
Let's just see where
That's
he
kind of
might
another
be taking
argument,
it.
though, because
No,
there's a
because
lot
they're
of
both
stuff.
wait, hold up. They're both intertwined. And so,
I agree.
yes, it would be predicting exactly what is going to happen across the board. You can know exactly what's going to happen before it happens. And Karma is correct that it should not be there. So that's part of this discussion. That's where we started off from. And
Yeah,
we started off from that you wouldn't be able to do this because of the second law of thermodynamics. And then I busted out the dictionary to discuss what prediction actually means. So, yeah. So tell us where
So
you're going
regardless
from
of
that and how we might get around
prediction, sorry, I'll use the word guess because that seems like the most fair word to use there for the weather. But we know that they are able to guess somewhat the weather right now. As far as the prediction goes, you were saying that they would be able to predict with satellites 100%. I don't think I agree with that because weather is in and of itself pretty chaotic, which I think someone said here before I had to step out for a bit. I thought of an example.
System.
What did you say? Sorry.
It is a chaotic system, weather.
Yeah. So, like, I did think of an example. Like, imagine if I took a glass of...
Who just answered that? What's going on?
I think that they're the one who said it earlier. Sorry.
No, wait. Who just answered you? I can't scroll up and down fast enough because there's so many people.
It's Paz. I just said that weather is a chaotic system. That's all.
Okay, so yeah, so you're agreeing with another girl person. Let him do what he wants to do, and then we'll allow that. But right now,
I actually
hear what he has to say.
I called back to him because I remember him saying that earlier.
I don't.
Those were his
I'm telling
words.
you right now, don't call back to people. Let's just have
Okay.
what you want to say.
Yeah. Well, anyways, okay then. I thought of an example for guessing the weather. I guess. I don't think they would be able to do it 100% accurately because it is chaotic. Which, if you imagine, I take a glass of water and I drop just one drop of any kind of water coloring, food coloring, whatever in there. We can't predict where that's going to go 100% precisely at all. And the only point I'm trying to say there is there's no way.
Use the word prediction.
You are getting off a point of prediction, and you're getting off the point of satellites being in a position to even predict anything. You are still the entire question that this was based off of when we first started this conversation was what is leaning you towards the globe, that you think you're claiming, like, you know what, I really don't know what it is, but I kind of think it's the globe more than it's the flat earth. And so I asked you, why do you think that it's more of a globe than it is a flat earth? And you said satellites. And we said, why?
Yes.
Then you start talking
Space
about
in
weather.
general.
And then okay, so now, see, you didn't say that prior. You didn't say space prior. You said satellites and you talked about weather. And so I was
Oh, I
talking
said-
about the definitions of like predicting things and if they are there and like actually in our realm. If you're talking about actual satellites outside, that they're somehow in outer space, which is something it seems like you believe in, then that is a conversation to be had. We can have a conversation about that.
Yeah, that is the
That would never
conversation.
fucking happen. Ever. It's just not going to happen. How is a satellite going to break through some kind of a boundary that is keeping our pressurized system